Welcome everybody to your all-in-one C++ video. This video takes the 100-part video series that I created and combines it all into one video. So this is good if you just want to watch it all of the way through. Now I also cut out the sponsored messages and the ending, so it's a little bit smoother than going through each video through the playlist. Whichever you prefer, it's totally up to you. I just thought I'd put both options up there for you. Now I would like to thank our sponsor of this all-in-one video, Call for Code, which is doing some great things with technology. Call for Code is a global challenge for developers to create open source technology to help in times of natural disaster. Created by the David Clark cause with founding partner IBM, Call for Code is bringing hundreds of thousands of developers together to build solutions using technologies such as blockchain, AI, and IoT. With winning projects receiving cash prizes, project support from the Linux Foundation, and more. Natural disasters are among the world's greatest challenges, with 2.5 billion people directly affected since 2000, and you have the power to help. Will you answer the call? Learn more by following the link in the description. And with that, let's get started, and if you enjoy the content, be sure to subscribe. Thank you.
Hello everyone, welcome to my channel. My name is Caleb, and this series is going to introduce you to the C++ programming language. I'm going to do everything I can to get you from a complete newbie to an intermediate or even professional level. It ultimately depends how much work you want to put into it, but I'll do what I can. So here is a beautiful picture that you can look at that my spouse made while I talk here for a couple seconds. As I'm sure you guys know, there are tons of video series out there on programming, so what makes this one any different than the rest of them? The two main things I have to say about that is, one, my goal is to help you enjoy programming and see the fun in it, so this is going to be a very lightweight, enjoyable series. But the second thing is, I don't want to sacrifice technical correctness, so I'm hoping by the end of this series, not only did you enjoy yourself, but you actually have a really good understanding of the technical detail of a language like C++, as well as just programming in general. That being said, programming can only be so fun, and no matter what series you're going to watch, it's definitely going to take a lot of work. I would even say that C++ is one of the harder languages to learn, but I would say even if you're a beginner, as long as you have that drive to learn, you should be able to pick up C++ and start building some really cool applications. Now before we dive in and start typing away before we know anything, I want to talk a little bit about the concepts of C++, just to give you that foundation so once we start coding you really know what you're doing. So the first thing, C++ is a compiled language, and I promise I'm not going to bore you with like a million slides. So what exactly is a compiled language? Well, as we build complex C++ applications, we're going to have numerous C++ files. And C++ is a programming language that once you learn it, you can read it and you understand it, but a computer cannot read and understand C++ directly. So we need a tool that takes human-readable C++ code and converts that into something the computer can understand. And that process is called compilation, or compiling. So step one, compilation. The second step is linking. Linking is how we get from a bunch of compiled code to one executable file. When we started, we had code over here and code over here, and we can compile those, but they're not entirely useful until we link them together into one executable. The executable is what the user of our application is going to get. An executable is basically just a fancy name for an application. These are the things we run when we open things like Google Chrome, Photoshop. Basically anything that runs on a computer is an executable. Now I would say C++ really set the path for a lot of different programming languages. This is because C++ introduced two concepts that everyone takes advantage of in any modern programming language. These are just two things I thought I would call out, but C++ has done a lot to really set the stage for development today. So the first of those two things, object-oriented programming. And if you're a newbie, this stuff might not make very much sense, but once we get into development, you'll start to see the value of this. The way object-oriented programming works is we're able to basically structure our code around these things called classes. And this would be an example of a class up here. It basically allows us to set the structure of some data, and then this is used as a blueprint to make instances. So for example, the class has name, email, and verified, but we can make two examples of that where we have Caleb, his email, and true, he is verified. Or another example, Amy, Amy's email, and false, she's not verified. So these instances are known as objects, which is the foundation of object-oriented programming. The second thing I wanted to mention is generic programming. With generic program, we're able to use or even create structures that work well with different types of data. So in this example, consider these boxes to be containers or lists. In C++, these would be known as vectors. And what we can do is we can create a container that accepts a certain type of data. So you can see over here, these are all integers. On the right, these are all strings. They just happen to be names in this example, but you could put anything in here like tacos, whatever it is, as long as it's in these double quotes. At first, this doesn't really seem that crazy, like wow, we can put things in containers. But the beauty here is that we can restrict these containers to just certain types, and it allows us to be safer because we know what type we're working with when we're working with these containers. There are generic things that are made available to us already, like I mentioned earlier, vectors. If you're coming from other programming languages, these are very similar to array lists or lists, where you would basically say, hey, I want to make a collection of type integer. If this doesn't really make a lot of sense to you right now, that's fine. Just understand that the two big things that C++ introduced was object-oriented programming and generic programming. And what exactly do I mean by introduced? Well, one of the big predecessors of C++ was the C programming language, and these capabilities were not there in C. So to really understand where C++ fits in the developer ecosystem, let's compare C++ to some of the other languages out there. So the first one is C. There's a lot of confusion between C and C++, and you'll often see things like C/C++, but that doesn't really make sense because C and C++ are two separate entities. There's two separate programming languages. Yes, they have some similarities in nature, but they're not the same thing. They're two distinct programming languages. C++ came after C, and almost everything inside of C is also inside of C++. In a way, C++ is kind of like a superset of C in that a C program is usually an okay C++ program. There are exceptions to that, but that's a general rule of thumb. But C++ is not just C with a couple of added features. It's a whole different programming language and introduced things like object-oriented programming and generic programming, which as we just learned are two pretty big deals. So you might be new to programming, and if so, that's totally cool. I would recommend starting with C++, but if you're coming from a C background, there's probably some similarities in the way you feel when you're coding C++, at least to start. As we get into some more complex C++ concepts, we'll start picking up some capabilities you might see in some more modern languages like the object-oriented programming. How is C++ different than Java or C# or even some of the languages like Python and JavaScript? Well, that's the next thing I wanted to talk about. A lot of these modern languages have capabilities like object-oriented programming, but just like C is different than C++, these modern languages are also different than C++. C++ is a beast because you can do basically anything you want, and it gives you the capability to really optimize your programs, but there's a cost with that. It takes longer to learn, there's a lot more you need to know, and there's more gotchas that can come back and bite you. A lot of the languages like Java and C#, they kind of abstract away the hard parts and just make programming like this really super easy experience, but as a consequence you lose some performance and you're not as flexible when it comes to doing things you want to do. So if you want to build a cute little app, you might want to use something like C# or Java. If you really want to optimize your program and build something awesome, you definitely want to build with C++. It doesn't necessarily mean that C# and Java or other languages are bad, just their purpose is different in nature. Because of these differences, you'll often see C++ used for things like engines, such as a game engine, or a video editing software, or any kind of modeling program. Anything that's extremely computationally heavy and needs to be optimized is probably going to be built in C++. This is exactly why a lot of games are developed in C++. Yes, you can build games in some of these other languages, but C++ really allows you to optimize and take control over the application. So yeah, there's your C++ introduction. I know it was kind of fluffy, it was just kind of conceptual. What we're going to be doing now in the next video, we're going to start getting our hands dirty with C++, get the tools we need, and get our first application running. Throughout this series, I want to make these concepts we've talked about in this video very concrete. We're going to be going through generic programming as well as object-oriented programming, all while trying to be technically correct with C++ because it is a different language in that you really got to know what you're doing or you're going to hurt yourself. C++ is in this nice middle ground where it's not a pain like C, but it's also not really fluffy like some of the other programming languages mentioned here. So you're definitely not going to be wasting your time going through this series, especially since C++ is one of the more in-demand languages and has been for numerous years. And with that, I hope you're looking forward to the series. Please consider subscribing if you've enjoyed this content, as well as check the description for any useful links. Thanks guys, and I'll see you in the next one. Welcome back to your second video in the C++ tutorial series. If you've made it this far, I'm guessing you guys are pretty devoted. Unfortunately, there's still a lot more to go, so stick with it, but I'm going to try my best to make it fun. Before we get started though, we're going to need some tools. Hopefully by the end of this video, we'll have everything installed, ready to go, and we'll write our first application. Now, if you're on a Windows machine, I would recommend Embarcadero C++ Builder. This is going to give you everything you need, which includes a place to edit your code and a compiler. C++ Builder is an example of an IDE, Integrated Development Environment, which I basically already defined. It gives you everything you need to write applications, in this case in C++. With C++ Builder, there are a lot of capabilities that come with it, so if you scroll down on this page, you can see you can design apps with it. You can even do some pretty sweet debugging. You can deploy, and that's what's really cool because you can deploy to Windows, Android, Mac, and iOS. So it's a great tool to get started with, and it's not going to limit you once you want to deploy your apps to these platforms. So check it out. I'll leave a link for you guys in the description. Now, if you're on Mac, we're going to do things a little bit differently. So what we're going to do is open the terminal, and in here say G++. Now, if you get an error, that means everything's set up correctly, which is the funniest thing ever. But if you don't get an error, it's probably going to ask you to install some developer tools. Go ahead and say yes. Now, if you want to follow along as close as possible to this video series, but you're not on a Mac, you can look up something called MinGW, that's MINGW, and that's going to help you get the G++ compiler on Windows. So when you type G++ and you get that installed, that takes care of one of our needs. The other thing is a place to edit our code. There's tons of text editors out there. I'm going to use Visual Studio Code. So I got my compiler, I got my code editor. This should be everything I need to start writing C++. Now when you get in here, I want you to click Open Folder, and we're going to create a new folder, call it C++, and then click Open. And you can see C++ open here on the side. You can X out of this welcome page, and here's where we're going to do all of our editing. So to create a new file, you can click this plus button, and we're going to call this youtube.cpp. So the CPP file extension, let's talk about that for a minute. This is the file extension I have decided to use for this video, but you might see some other file extensions for C++ files. You might see C, CC, so confusing, CXX, and even C++. If you're using an IDE like Embarcadero C++ Builder, just go with whatever it gives you. What you're going to want to do is just find how to create a new project and create a new console application. That'll get you to the same point as where I am here. All right, so how do we actually write code? I'm going to write everything out, and then in the next video, I'm going to explain what everything means, but the purpose of this video is just to get you started to have a working executable program by the end of this video. If you need to zoom in, you can hold Command and hit the plus, and you can hide this Explorer just to get some more room. First thing we're going to do is put # include, and then inside of these greater than less than signs, you're going to put IOStream. Then we're going to say int main and put parentheses. Go to the next line and do curly braces, and then close the curly brace down here. And inside of here, what we're going to do is say return 0. So this is pretty much a useless C++ program. In fact, we could even get rid of this line and it would work just the same, but I'm going to leave that in here because we're going to use that in a second. What's going on here is we're creating a main function, a function called main, and then inside of the function, all we have is return 0, which just says the application works. So if we actually want to do anything, go to this line here and put std : and then put cout. Then use 2 less than signs and put hello world or whatever you would like to put. And at the end of that, put a \n. Make sure you put another double quote, so there's a quote at the beginning, a quote at the end, and then end it with a semicolon. Now, if you're new, all of this might be completely overwhelming. If you've coded before, this is probably pretty simple. If you do already understand all this, bear with me for just a minute. If you're a beginner, what you should know is that all of this is going to come with time. You're not going to get it right away. Main thing is just to type it out, get it working, and then in the upcoming videos, we're going to explain everything. So we wrote our code. Make sure you save it. You can do that by going to File, Save, or I just hold Command and press S. Now to run it, what I do is in here, I open a terminal, and then it just brings it up down here. If you're on a different editor, you might have to do the terminal separate. That's totally fine. You'll just have to navigate to this folder. Once you're in this folder, we need to compile our code. The way we do that is we say G++, and then we put the name of our file, youtube.cpp. You can see nothing happens. Actually, something did happen. It just doesn't give us anything as an output. So what exactly happened? Well, if you go to our files over here, you're going to see a new file, a.out. This file is created every time we compile. When we compile again, it creates a new a.out and replaces the old one. This a.out is the executable program, and we can run it inside of the terminal by putting a // and then a.out. And you can see that it outputs hello world. So congratulations everybody, you just created your first C++ program. Hopefully it wasn't too bad for you guys, but if you get to this point, everything else in this series is going to be smooth ride. I'm totally kidding, it gets much worse, but we'll get through it. So I'm going to close this Explorer again and just focus on what we have here. Ideally, you can go through this and explain what each thing means. That's what I'm going to help you guys understand in the next video, where I'm going to go in person and go through some concepts to better understand C++ programming. That's all I got for you guys. If you've enjoyed this content, please subscribe, as that really helps my channel. And go see the next video, because that's going to really solidify your knowledge. Stick through this series, you won't be disappointed, and I would really appreciate it, guys. Thank you, and I'll see you then.
Hey, welcome back everyone to your C++ tutorial series. Now before we dive in with some concepts here, there's a few things you guys need to know, especially if you're new to this channel. One, I like to split up content from on the computer screen to up here on the board, just so we can go over some concepts, make it real nice and easy, so when we go to code we actually know a little bit about what's going on. Number two, I'm left-handed, so I don't really even know why I try writing up on the board, because it's never readable, so sorry about that. And number three is that I'm terrible at audio and video, so every single video there's at least one thing wrong. So either you can't hear me right now, or you probably can't see me because it's blurry, or I forgot to hit record or something like that. But we'll see. So if you haven't seen these on-screen videos, hopefully you enjoy them, and let's get started. So by the end of this video, I want you guys to understand the basic concepts of a C++ program. Right, so you're probably writing C++ programs because you're in a class, or you have to write C++ programs because you want to develop video games or develop a specific product. But my assumption is that you might have been copying and pasting, you don't exactly know what you're doing or what it means. So let's get started with that, and hopefully by the end you have a pretty good understanding. When you create your first C++ program, it's going to look a little bit something like this. You always have a main function. So this thing right here is known as a function, and it's called main. So main is the name of the function. Think of a function as a machine that does something. So this is the machine, and sometimes it'll have an input, and sometimes it will have an output. The machine's name is main. So when we execute our program, it immediately automatically calls the main function, so it turns on our machine. Most of the time, we're not going to have any input in this case, but we'll likely have some output. The code we have here really doesn't do anything at all, so our machine's pretty pointless. But eventually, we're going to make this machine do lots of cool things. The return is the output. So our function is saying, hey, the output is 0. So what's coming out of this machine is 0. And that doesn't really mean anything to you right away, but the computer understands 0 to mean everything went okay. So basically what happens is we turn on a machine and it says, hey, I'm done, everything went great. So you might see return 0, you might see return exit success. Does that have one C or two? That's another thing I can't spell. No, it definitely has two. And ultimately you could even get rid of this line. If you got rid of that line, it's just going to implicitly return 0. Basically, nothing went wrong, so it worked. Inside of the function, we put what are known as statements. Statements are when we tell the computer to do something. So in this case, we're saying, hey, I want you to return 0. But you can put extra statements before the return. Before you say we're done, I want you to do all these other things. So for example, right here, I could say, cout hello world. That is how we write to the console. And we end that statement with a semicolon, just like we end this one with a semicolon. So this std, which by the way means standard, gosh, :cout, this comes from somewhere, right? We don't just make it up. Like, how did we know to put that there? Well, in order for this to become available to us, we include it in our C++ program. Because of that, inside of your C++ program, at the top, you're going to have something that looks like this. So this IO stream, inside of that, this cout is defined, right? So we can use cout because we're taking advantage of this IO stream, which stands for input to output stream. So this works because of what's known as the preprocessor.
The preprocessor is something that happens before all of the code is compiled, and the preprocessor is basically going to take the content of this file and put it inside of our program to make it available for us. All right, so that's pretty good so far. But one thing we didn't talk about was this right here. This is known as the return type. So here is the return. This is the return type, and they're related. Because if you look at what we're returning here, we're returning a 0. And 0 is an example of an integer. So the return type is int, which is short for integer. By the way, if you don't know what an integer is, it's just a number without any fractional parts. So something like 6.7 is not an integer. 6 is an integer though because there's not 6 dot anything, it's just 6. So when we get into more complex C++ programming, we're going to be writing functions that don't use just integers, but it'll use doubles, it'll use arrays, it'll use all kinds of different things, custom types, and that's where things get exciting, right? Because this is like ground zero. We're building that foundational layer, and we're just going to start layering stuff on there like a stack of pancakes, but instead of pancakes, it's code, and instead of eating them, we have to debug it. And yeah, it's sounding less fun now, but trust me, it's going to be a lot of fun because this is just the basics. So overall, what did we just talk about? Well, we have this main function. Functions are a big deal. We're going to get a lot into those into this series. The main function returns 0 because nothing broke, and that 0 is an example of an integer. Inside of the main function, before we say we're done, we want to output to the console. The way we do that is using cout and then using these alligators, less than signs, and saying hello world in double quotes. And this is going to take this string and put that on the console for us. This is all possible thanks to code that was already created by someone much smarter than us, or at least me, who put it in this ifstream file, which we can include in our project. So this std::, that's something we're going to be talking about in the next video. We're also going to be talking about some other cool stuff which I forget about, so check it out, guys. It's going to be super awesome. That's right. On top of the standard : we're going to be talking about cout and a little bit on object-oriented programming, so it's going to be another conceptual video. After that, we're going to get back on the computer and do some more coding. But before we dive in, I think getting that concept down is important. So thank you guys for watching. Please be sure to subscribe if you've enjoyed this content. Check out the next video, and I'll see you there. All right, welcome back, guys. As if the previous video wasn't boring enough, here I am again to lighten up your day. So thank you for joining me. This video, we're going to be talking about all kinds of things. We're going to be talking about using statements. We're going to be talking about objects, a little bit on input and output. All right, first thing, let's talk about the elephant in the room. What in the world is this std thing here? Lowercase s. Well, this, my friends, is actually an example of a namespace. If you come from a C background, you're probably like, what the heck are you talking about, man? You're not making any sense. But if you come from Java or C#, this is a very familiar concept. A namespace is basically just a grouping of code. So instead of just having all your code in one giant bin, imagine splitting it up into different groups called namespaces. Let's say we got two people. I don't have any names. We got little Susan over here, and she makes a sweet function that she wants to share with all of her friends. And then let's say we got Bill over here, and Bill is like, dude, my function is so much better than yours. All yours does is analyze data and do predictive modeling. Well, mine says, Bill is awesome 1,000 times in the console. Beat that, right? And little Susan, unfortunately, decided to name her function the same exact thing as Bill. I think I'm already forgetting his name. So basically, we have a naming conflict, right? Because little Susan has the same function name as Bill over here, which stinks because Bill has some pretty good credit. People are going to download his code and they're going to start using his function. Susan wants to share her code with her friends too, though, right? So if people try to import both of these people's codes into their project, what happens when they call that function? Right? So we have an issue. Let's just say the function is called cout, just to match the example here. Little Susan and Bill both created a function called cout. This is a naming conflict. The solution to this is namespaces. Imagine we could expand this name just a little bit longer and prefix it with something to identify whether this is Bill's code or Lil Susan's code. Well, it would look like this. Bill, : cout, and then Susan, : cout. Now, it doesn't have to be their name. I just used that in this example. They could have made this whatever they wanted. That is the purpose of namespaces. It allows us to group our code and prevents naming conflicts. So basically, all of Bill's code can be in its own container, essentially, and all of little Susan's code can be in its container. And if you want to say, I want to call Bill's code, you could put Bill : and then the name of whatever you're trying to do. And if you wanted to call Susan's, you could say Susan : and the name of whatever you're trying to do. And if none of this makes sense, that's fine. Basically, what I'm trying to say here is that we need to prefix this with std : to be specific where we want this cout to come from. It's coming from the standard namespace, the std namespace. This is going to make a lot more sense as we go on. We're still in like video 4 or something, so don't feel like you have to have a full 360 understanding of every detail of this. Honestly, I'm not even close to that. All I know is that namespaces are a way to organize code and they help prevent naming conflicts. Now, when you're first getting started, you'll often see code that looks like this. It'll say something like using namespace and then in this situation, std. And what that allows us to do is it allows us to get rid of this. Basically, we're saying we're going to import all of this code and just make it directly available. Then we can just do cout directly. Now, is this a good idea or is this not a good idea? I'm actually going to talk about that in a really soon upcoming video. But more than likely, if you're in a class, they'll teach you that you can do this to make your life easier. But when you read online, people are going to tell you that it's bad practice because of naming conflicts. In general, it's okay to do it when you're starting out because you're not going to be running into these naming conflicts because you're not making very large applications. But for good practice reasons, you might want to just get used to prefixing things with the namespace. And there is another alternative, which I'm also going to be talking about in that upcoming video, where we're going to deep dive on using statements and all that good stuff. The next thing I wanted to talk about for basic applications is object-oriented programming. So I told you guys earlier that cout is, did I tell you guys that? So cout is an example of an object. Objects basically describe things. So cout is basically describing the console output, the output stream. It's a tool we can use to reach the console, however you guys want to think about it. Now, in object-oriented programming, objects are birthed from classes. So the structure looks like this. We have a class, and this class becomes multiple objects, where each O is an object. I didn't want to write object 3 times. So think of it like this, right? A class is a cookie cutter for Christmas cookies. You're going to use that class to make a bunch of Christmas cookies. Every single one of those Christmas cookies that you're going to eat, those are the objects. A class just describes the structure of an object. Each object is an actual thing created from the class. So hopefully that makes sense. I like to just think of it as cout is a cookie. So if cout is a cookie, what is the cookie cutter for cout? You know, cout would be down here. What's up here? Well, it's actually an instance of ofstream. So cout was birthed from ofstream. So ofstream is capable of creating unlimited cookies for all. Cout is just one of those cookies. So does that actually help you at all with object-oriented programming? Probably not, but if you can get in your brain the difference between a class and an object, it's going to make your life a million times easier once we get in object-oriented programming, which, by the way, is ingrained at the core for C++ programming. It's one of the main things C++ programming introduced that set it apart from C. Next thing I wanted to talk about are operators. Now, what do you think of when I say operator? Well, you might think of a doctor, like, you know, doing an operation, or you might think of an operator in math class, like a plus sign. Well, the operators I'm talking about are not the doctor kind, they're the plus sign kind. But in this situation, it's not a plus sign, it's actually these 2 arrows. So just like in math, when you put a plus sign, it means something. It's going to do something. Well, same thing with these arrows. So this here is an example of an operator. Operators work on what are known as operands. Just like if you would say 5 plus 5, the 5s are the operands. In this situation, cout is one of the operands, and this hello world string is one of the operands. Basically, all this operator does is it takes this data and gives it to this object to be printed to the console. C++ is very powerful when it comes to operators. You can custom program them to do whatever you want, so you should be able to later on make this operator understand how to print a custom object that you design from a class, and it's going to be really cool. It's going to be lots of fun. And if you can understand this mess, then I would say you're off to a really, really good start. So stick with it, guys. Don't quit. C++ will blow your brain up in the most beautiful way possible. Thank you, guys. Please be sure to subscribe if you've enjoyed this content. It really, really helped me out. And don't forget to stick through the entire series. I'll see you in the next one.
Hey yo, welcome back everybody to your C++ tutorial series. This code is exactly how I left it from our last on-screen video, I think video number 2. In the previous videos, we talked a little bit more about the concepts of what's going on here, so hopefully you have a better understanding. If you're just jumping in, basically what you need to know is that this main function, it's called main, and this is going to be executed immediately when you run your program. So the first line that gets executed is going to be at line 4, which is the first line inside of this main function. What this line does is it's going to console out hello world. This is possible because it uses the cout object, which is included from this iostream file. After that's done, it says return 0. Which means nothing catastrophic happened. The return 0 is actually optional, so you can get rid of that, and it's going to work just the same way. Now, once again, to compile, you can say G++ and then put the name of the file, like so. And then to execute, you put ./a.out. And it gives you the output. Now, instead of typing that out every single time, you can just use the up arrow keys, and that'll go to the previous executed commands. So when you're first starting with C++, you might see something that looks a little bit like this. Using namespace std semicolon. You might see it here, or you might even see it up here, like this. And if anytime you're unsure if your syntax is right, what you can do is you can save and then compile, and if you don't get any errors, you should be good to go. So what exactly does this using namespace std do? Well, what it's going to do is it's going to take everything inside of the standard namespace and make that available to us directly, so you don't have to prefix it with this std::. So just like that. So now we can compile our program and it runs just fine. The technical term for this is a using directive. So the question is this good practice or is this bad practice? Honestly, when you're first starting out, it's not a huge deal. The issue comes up when you start importing a bunch of different projects or libraries because it can introduce naming conflicts. By prefixing things with the appropriate namespace, you're being very specific about what item you're trying to reference. So in this situation, it knows exactly we're trying to reference the cout object that's inside of the standard namespace. So if you want to prepare for that, you can just always prefix. It'll help you get used to the syntax, and it'll make reading docs online a little bit more easy because you're used to seeing those ::. The alternative is called a using declaration. It looks very similar but works a little bit differently. So you put using followed by the namespace you want to use. So standard. So we got rid of that namespace keyword. And now we want to be specific about what object we want to make available to us. So what we can do is put : cout. And then a semicolon. So now we don't have to put that standard before cout, and it should compile. But the benefit here is that we only did this with cout specifically. So it's not like we're just bringing in a bunch of stuff from the standard namespace. We only want to bring in cout. This is going to extremely reduce any chance of naming conflicts. So which technique you use, honestly, I'm going to leave that totally up to you or whatever your professor or boss says. I'm probably going to use this technique, and on occasion, I will prefix things directly. Now, the location you put this actually matters. So if we put it here, it's going to work for the entire program. If we take it and put it here, for example, let me clean this up a little. Well, now it's only going to allow us to use the shorthand within these curly braces. So our program should still run, and it works fine. But just to show you guys, I created this function here. We're going to talk about that later, and I use cout directly. When I compile,
you can see I get an error. It says 1 error generated. That's because it doesn't have the benefit of this using declaration right here. It's only available within these curly braces. If we take that and put it back up at the top, now when we compile, we shouldn't get that error. And you can see it compiles fine. So yay, that was exciting. I realized that I forgot to mention our sponsor, Embarcadero C++ Builder, so I'd encourage you to take a look at that. What exactly is this? Well, it's going to give you all the tools you need to develop C++ applications, with the huge benefit of being able to deploy them to Windows, Android, Mac, and iOS from one C++ code base. So you are able to reach a much larger audience with a lot less work. Some of the things it calls out on here is that this is a great tool for building connected applications. So think things like Internet of Things. It works great with databases. It has a very strong community. I mean, it says over 3 million developers worldwide. That's kind of a lot of people. And if you go up here into the features, you can get some more details of what it is capable of. So it kind of breaks up the capabilities into these categories. The ones I like a lot are the design. It allows you to really easily work with databases and REST APIs. It also has drag and drop components, so you can easily make user interfaces. It's able to make responsive designs, so you can build the UI one time and have it run on multiple devices, but you're also able to customize for a particular environment. So you can have a specific layout for Windows, or whatever you're trying to deploy to. So this is a pretty intense software with lots of things. Definitely something you might want to consider is the debug options. So if you're like any developer, you're probably going to mess a lot of stuff up, and at some point you're going to want to debug an application. If you don't know, a bug is just when something doesn't work and you're trying to figure out why. One of the things that makes an IDE really helpful is that you can put breakpoints, so it will stop your code at some point and you're able to look at the state of your application at that point. So there are a lot of things you can do with C++ Builder. If you're just doing simple console applications, learning how to code, whether you're using C++ Builder or G++, doesn't really matter. But when you're wanting to build and deploy applications in a company or for yourself, then you might want to consider stepping up your game to something like C++ Builder. You can get started with C++ Builder by starting a free trial. Basically, when you do this, you get the Community Edition, which is a pretty packed out version. You can go to the product editions here and hear more about it. So here are the different versions. Community Edition has the least capabilities, but one of the huge things is that it has limited use for commercial purposes. This means that you can actually build an application and sell it, make a lot of money, before you have to buy the application and upgrade to the professional version. So there really isn't anything holding you back from using C++ Builder. Go check them out. I'll leave a link for you guys in the description. And with that, I'll see you guys in the next video where we're going to be talking about variables. So we're going to deep dive variables and talk about what they are, how to use them, and how to succeed with that. So I'll see you guys then. Thank you for watching, and please be sure to subscribe. Hey, what's going on, everybody? This is video number 6 in the C++ tutorial series. This video, we're going to be discussing variables and how to use them in our C++ programs. The main point of variables is to store some value for us, and then we can use that value throughout our program. So what exactly does a variable look like? First, copy this example, and then I'll explain each piece. Alright, so we created a variable with the name or identifier of slices. Think of like slices of pizza here, obviously. And we assign it the value 5. So this equals symbol is actually called the assignment operator, and it's how we store a value inside of a variable. Last thing here is this int. This is known as the data type. It's an integer. 5 is an example of an integer. Similar to how we had return 0 down here, and the function returns an int here. Well, we're just creating a variable of type integer, and it stores an integer value. And don't forget that semicolon at the end. Altogether, there's 5 pieces: the data type, the identifier, the assignment operator, the value, and then the semicolon. Now, what's going on here is actually a 2-step process. There's the declaration, and then there's the initialization. So we could actually break these up into 2 separate statements, and that's what we're going to be doing now. So to do that, what we could do is get rid of this equals 5 and just put a semicolon. This is the declaration. Then we can do the initialization by saying slices is the value 5. So we assign 5 to slices. Now note, we only use the data type when we define the variable. The declaration says it exists, and then the initialization says it has a value. In this situation, we are assigning a literal value. By literal, I mean it's literally typed out in our code. It's a 5. We don't always have to do that. We could actually use an expression. So for example, we could have 5 plus 1, which is an example of an expression. Now slices is going to have the value 6. And we can actually output slices in a cout by typing the name of the variable like so. And there's no quotes, you just type it plain as is. And when we run this, we get a 6 right here. We can also assign from another variable. So for example, I could have a variable children, and I can assign this the value slices. Now, when we output children, this is also going to have the value 6. There we go. So slices was copied into children, so now they both have their own values 6. They're not pointing to the same thing, so I could set slices to something else, and children is going to remain the same. You can see it's still 6. So that is your introduction to variables. We're going to be using them throughout this entire series, and you're never going to get away from variables in programming. So make sure you understand these concepts. If you have any questions or any suggestions, leave a comment in the comment section below. Please be sure to subscribe and check out the next video, because we're going to be talking about how we can make our output a little bit more beautiful than just this 6 followed by my name. So that's what we're going to be doing in the next video, templatizing our output. So check it out, guys. Hey, what's going on, everybody? This video, we're going to be talking about how we can output variables in a pretty way and do string concatenation. So right now we have this variable, we output it, it gives us the value 5, and then it just continues right on without putting a new line or anything like that. So this is going to be some pretty basic stuff, but it's vital for making beautiful applications. All right, so the easiest way to make more complex strings is to use this operator more than once. So we can put another one after our variable, and we can put anything we want. So for example, we could put endl. Endl is an example of a manipulator. There are tons of other manipulators. We're going to be talking about some in this series, but for now, endl is important because it's just going to go down to the new line. Alternatively, you can put a \n, which will also go down to the new line. But I'm going to go with endl in this situation. We got an error, and that's because we are using this using standard cout. We're not putting using standard endl. So if you want to put another using up there, you can, but I'm just going to prefix this one, just like that. And now when we run it, we get 5 on its own line. We don't have to just print the variable though, we can make a string around it. So for example, we could say, you have, and then it's going to list the number of slices, and then what we can say is slices of pizza. Make sure you put spaces because there's not going to be automatically a space after the variable, so we need a space before the variable and a space after the variable. We don't need a space there though. Now let's run this. When we do, we get you have 5 slices of pizza. Awesome. So what we did is we basically templatized this output, meaning we have this original string, you have blank slices of pizza, and then we substitute a variable slices, which we get from this value up here, right? So we can assign any value here, and that's going to be outputted. That shows the benefit of variables in programs. You have 10 slices of pizza. This is just one simple example. It would be just as easy to copy the value 10 and put 10 right here. You might think the variable just adds another layer of complexity, but as we go on, we're going to be using variables more than once, and we would only have to change it in one location to change everywhere that uses that variable, which is why variables are super important. So I'm going to put slices back in there, just like that. Now, if you're coming from a C background, or if you're just working with other C++ code, you might run into a printf. And what the heck is this? Printf is a function that comes from C, but also works inside of C++. Most stuff from C is going to work inside of C++. So we could do the same thing. We could print slices, and we actually need to say what output format it is. So we can give it a format string and say this is an integer. And then we could put a new line after it. So when we run this, we get 10 and it works. So this might look funny to you if you've never seen a printf statement, and I would have to agree, this is kind of silly. Cout is much better in that it can interpret the variable. You don't have to worry about saying what type it is. Like in this situation, I had to say it was an integer. Cout just knows that this is an integer, so we want to output the value 10. So thank you C++ for making our lives easier. We don't have to worry about that printf garbage anymore. Awesome. So we are using this operator here to print slices, and it works. But later on, when we make more complex data types, if we put a variable here that's like a custom object, it might not work right away. And because of that, we can do overloading and basically teach cout how to print a particular object. Very cool concept. Don't worry about it for now. Just know that this whole concept is very extendable and we're going to get into some pretty cool stuff. So thank you guys for watching. In the next video, we're going to be talking about how to get input. So we've done output with cout. Now let's talk about input. Thanks guys. I'll see you in the next video. Hey everyone, welcome back. This video, we're going to be talking about how to get user input. So far, we've talked about output using this console out, cout. We've also talked about how to use variables with cout. Pretty simple, nothing too crazy, and honestly getting input really isn't anything too crazy either. So hopefully this video is pretty simple and you understand every piece of it. We're hard coding this value in here. So the term hard coding is similar to a literal, basically we're manually typing in the value in our source code, which means if we want to change this value later on, we'll have to change the source code and then the new version of the application will have to be given to our customers. Not something we want to do. So sometimes we're going to want to get these values from different locations. You can get it from a text file, you can get it from a configuration file, which is basically a text file, but it could be an Excel file. You get it from a database, but one of my favorites is to get it from user input. So we actually ask the user what they want to put in. What we do is let's leave this variable declared but not initialized, and then we use cin, which I bet you guys can't guess what that means. It means console in. So this is how we get stuff from the input stream. Now this is part of the standard namespace, so we have the option of putting that up here or prefixing it with standard. So I'm gonna put it up here just to make our lives easier. And then in here, we say cin and we use two greater than symbols. Now I was always confused on which symbols to use until I realized this trick. It's fairly obvious, I don't know why I didn't get this from the beginning, but the arrows point in the direction of data flow. So for console out as an example, this string is going out to the console, so it's pointing towards the console. In cin, we're getting data from the console and it's getting stored in a variable, specifically slices. So this will work when we run this after we compile. It's just going to do nothing. It's asking us for a value, we just don't know it. So if we put a value in there, it's gonna say you have 6 slices of pizza. Very, very simple. The only thing I recommend is to do an output so people know what's going on. Like this. And we run this, it's gonna ask us a question, and then it's going to output the value right there. So in this situation, we are getting this data from the console, but it's very easy to extend this to other things such as text files, and that's something we'll probably be getting into later on in this series. Another thing I wanted to mention is that cin is also an object, just as cout is an object. Cout is an instance of ofstream, and cin is an instance of ifstream. So that's how you get user input. Very simple. Hopefully it was helpful for you guys. Now check out the next video because at this point we have basically the foundation. I'm going to be talking to you guys about best practices, comments, formatting, naming conventions, lots of cool stuff that is very important for building larger scale C++ applications. So check it. It's going to be awesome. See you there, man. Or girl. Sorry. Peace. Hey, welcome back everybody. This video, we're going to be talking about some best practices with C++, including formatting, comments, and a bunch of other cool stuff. A lot of the stuff we're going to be talking about, such as capitalization techniques and just spacing techniques, well, these are often left up to the developer, but there is often conventions out there. A convention is just when a bunch of people agree to do things a certain way. So these conventions are often explained inside of style guides, which are basically these documents that explain the proper way to develop in C++. And these are less about the technical how-to and more about style, technique, and basically how to properly write a C++ program. Now the first thing I wanted to talk about in this video is indentation. So that's just when we tab this thing over. So there's often recommendations. So for example, some people tell you to put 4 spaces anytime you have a curly brace. Some people say to put a tab, so using the tab character. Whichever one you choose really doesn't matter. The most important thing is to be consistent. I usually put a tab, but it looks like my editor replaces it with some spaces here. So when do you indent? Well, anytime you have curly braces, you're going to indent everything inside of it. This is purely a visual thing and it's not required, but it allows us to see what code is part of what. Eventually, we'll get to the point where we have lots of nested curly braces, and if you don't indent right, it's impossible to see where anything is. So if you have a nested curly brace, it might look like this, and you can see that that curly brace as well is going to be indented, and anything inside of this is going to be indented as well. This will come up a lot when we go into if statements and loops, because we're going to have a lot more curly braces, and it's going to be a nested system where there's curly braces inside of curly braces inside of curly braces. If you don't do your indentation right, you're going to have a disaster of a time trying to debug your programs. So make sure you do that right. Don't be an idiot and indent your programs. A good technique to help you write good code is whenever you type an opening thing, such as a curly brace or a parentheses, always type the closing one as well. So for example, if I'm writing a string, I'll do something like, and then I'll type the first one, and my editor actually automatically puts that second one there. That is helpful because then I don't have to worry about closing it later on. I can just focus on my string here and don't have to worry about the double quote there. Then you just gotta remember to put that semicolon. You can put that at first if you prefer, or you can go in and add that later. Same thing when it comes to curly braces. Anytime you open a curly brace, make sure you put that closing curly brace and then start typing inside of it. So you always wanna start with the structure and then fill in the structure as you go. The other thing you need to know is that C++ is case sensitive. What does this mean? Well, it means that if we have something with the same letters but with different casing, it's not the same thing to C++. So for example, I could say slices in all caps. This is something completely different than slices in lowercase. This means there are a ton of variations for variables. So we could do something like this. I'm not sure why that one's blue, but it should work. And you can see it compiles fine. That being said, it's not really recommended to have variables with different casing unless you're following some kind of convention where you need that, but more than likely you're going to just want to stick to having one slices here and not having variables with the same name but different casing. It can get pretty confusing pretty quickly because you can mix up which one you're working with. Next thing I wanted to talk about is white space. So white space includes spaces, the tab character, and enters. These are ignored by the C++ compiler. This means you can space out your stuff however you like. You can put spaces all over the place. And this is still going to allow you to compile, and it's going to run the same exact way. The only thing to know is that you can't split up keywords. So for example, I can't go into this int and put a bunch of spaces there, because then it's no longer the int keyword. To C++, it looks like in, which isn't anything, a t, which isn't anything, and then slices, which doesn't really mean anything here either. So you can't split up keywords, and any kind of space inside of a string is going to be considered. So if we put a bunch of spaces in here, well, this is going to show up inside of the string. So when we run this, you can see there are a bunch of spaces here. So white space is only considered inside of a string. So I'm going to put that back to how it was, like so. Now the next thing I wanted to talk about is comments. You can do a comment with 2 forward slashes. This is going to be ignored by the C++ compiler, so we can go in here and write whatever we want. Now, what exactly do you put in comments? I'm going to say that you should only put stuff that is necessary to understand the code that you're describing. So for example, if it's confusing what exactly the code is doing, I can give a general statement here like so, and that's not going to affect the compilation of our program. Now, don't go over the top with comments because you always got to make sure your comments are up to date. If I go in here and then change this code and forget to change the comment, that makes things 10 times more confusing. And as a developer, that's just annoying, so don't do that. There's so many times I'll write a comment, I'll forget to change it, and then later I'll be confused because the comment will say something different than the code, which means the comment is completely pointless and actually makes things worse. Now, if you're in school, you're probably going to have to put like 400,000 comments at the top saying like, oh, what's your name? What class is it? What project number are you on? How many siblings do you have? What's your social security number? It gets pretty over the top in my opinion. Honestly, you're usually not going to need a bunch of code at the top to describe the program because all of this stuff's going to go into one larger program. It's not really adding anything, especially if you have your name like authored by Caleb Curry. Well, then if you go back and change this in a team project and someone edits it, well, then do they have to go in and say, oh, edit it on 12/12? No, that's stupid. You can use stuff like source control management tools, which will keep track of who wrote what code, who changed what code, and those tools should be used for your tracking, not the top of a code file. You can also do a multi-line comment using a /* and then ending it with an */. So anything between these lines is going to be considered a comment. You can use that if you need to describe things in a little bit more detail. It works exactly the same way as the forward slashes, except it goes over multiple lines. So for example, in this one, if I go down to the next line, this is no longer a comment. Those are your two types of comments. Use them wisely. They definitely can help out and make code a lot easier to understand, but definitely don't use them wrong either, so be careful. So I just covered the basics of best practices and style. If you want something a little bit more in depth, here's what I would recommend. This is the C++ core guidelines, which you can find at this web. Oh, that's pretty long. Just search it up on the internet. This is going to give you everything you need to know, and it has this guy as the author, which I'm not even going to try to say his name, but I heard a lot about him. He's kind of a big deal, but I don't even know what he did. I'm kidding, guys. He is the author of C++, so he's contributed to this style guide, so I'd highly recommend you check it out. So in here, you can find all kinds of different recommendations on how to do things. So for example, we could find naming and layout rules. And then here's an example, prefer underscore style names. If you click this, it recommends to use underscore between multiple words. So for example, if we had slices of pizza, that's how we would do that. And on the topic of variable naming, make sure it's descriptive. Don't do something stupid like S, because no one knows what S is. In 10 years, you're not going to know what S is either. Unless it's by convention, oftentimes you'll see I for a loop variable, K for similar things like that. But overall, you should try to make your variables descriptive, but not over the top where you have to type out 20 words to realize what they are. And avoid abbreviations. They really don't help. They're annoying. Personal preference, but thank you. So that's all I got for you guys on style. Hopefully it was helpful. By following these guidelines, it'll help you become a better C++ developer. Looking back, your code won't be terrible, and you probably won't be ashamed of yourself as much. So thank you guys. In the next video, we're going to be talking about functions and how to call those. It's going to be an in real life concept video. It's going to be a lot of fun, and then we're going to go back and do some hands-on stuff. So check it out. I'll see you guys then.
Welcome back, everybody. This video and the next video are going to be two very simple conceptual videos before we dive into some more details of C++. Throughout this series, we're going to take advantage of functions. And I want you guys to understand after this video and the next one, what a function is, how it works, how to call them, what they're for, and a little bit on how to create our own functions. Later on in the series, we're going to readdress functions, deep dive how to create them and all that good stuff. But for now, I just want you guys to understand the basics. All right, so let's talk a little bit about calling functions. First thing you should know about is the main function, right? We start with the main function. This is the function that gets called automatically. When we type inside of the main function, we're defining that function. We're not calling it. The main function is called when the program is executed. So that is a little bit more on the creating function side. We're talking about calling functions, executing functions, using them for our own benefit. There are a lot of functions that are already created for our use, so we don't have to recreate the wheel over and over and over again. When you call a function, you say the function name, such as pow for power, and then you put parentheses. Now, sometimes you'll have empty parentheses like so. Other times you'll put data in there, or you'll pass data in there is the official technical term. The data that you pass in there is known as an argument. And oftentimes you will need more than one argument. So for example, for power, you could pass in 10 and you could raise it to the second power. In this situation, we would have two arguments, 10 and 2. You may also hear the term parameter. We're going to be talking about that in the next video. That is different than an argument, but very similar concept, so make sure you watch that one as well. Now, there might be some confusion on when you put a semicolon. Should you put a semicolon there? Well, it actually depends on the context and the type of function. So there are situations when you can just call the function, put a semicolon, you're good to go, and you're done. Most of the time though, these functions are going to give an output. So if you remember back to my function machine I was talking about earlier, something that does something for us, we will have an input and we will have an output. The arguments are the input, pow is the machine, and the output is the return. So this is known as a return. If a function doesn't have a return, then it's probably doing something. It doesn't necessarily give us a value directly back. If that's the situation, you usually just call it and put a semicolon. More often than not though, you're going to want to grab that output. So you're not just going to put it like this, plain and simple, you're going to assign that to something. So for example, we could assign that to some variable we declared earlier. So in most situations, yes, there's going to be a semicolon,
but you are able to use this function inside of a larger expression. So 10 to the second power, 10 times 10 is 100. What if we wanted whatever this returned times 2? In that situation, we would have something like this. We have the function call, no semicolon, we're not done. We multiply that by 2. And this expression can be used inside of something else. But ultimately, we're going to need to finish with a semicolon at some point. So if we wanted to figure out what that value was, we could assign it to x. X is now going to be 200. Or we could output that. So we could use cout to output this entire result. So basically what I'm trying to tell you guys is you can call a function by itself. That's usually when it has no return value. It just does something behind the scenes, or it does some logging, does some console outputs for us, whatever it may be. When you don't use it inside of an expression, it usually doesn't have a return value. A lot of times though, it's going to give us an output or a return. In that scenario, you have to use it. So in this situation, we're multiplying it by 2 and assigning it to x. Whatever you decide to do with that value is totally up to you. Be creative, don't feel restricted, because if you think about it, this power function here, I think it returns a double, which is basically just a number with decimal values after. Anywhere you would expect to use a double, you can use this function call here. It's going to happen first, it's going to be replaced with the value 100, and then that is a double, works fine. Because of this capability, you'll often see pretty complex expressions. You'll have function calls as an argument for another function call, as an argument for another function call. Lots of nesting, lots going on. It's kind of hard to read. So if it's simpler for you just to take this, assign it to a variable, and then use it in an expression, that's totally fine. So if you didn't want to do it this way, what you could do is you could take power, put it up here by itself, assign that to something, and then you could just say x times 2. However you guys want to do it. So that's how to use functions. Very simple. Next video, we're going to talk a little bit about creating functions. Thank you guys. Hey, what's up guys? This video, we're going to be talking about creating custom functions. Now this is purely conceptual. The next videos, we're going to get more hands-on, go over some code examples. So this is purely about knowledge and understanding. Previous video, we talked about using functions. Now we want to talk about creating our own functions. When would we want to create our own function? Well, primarily if we have a task we're trying to do over and over and over again and it's multiple lines, well, we could extract that into its own function and then just call that function by name. It's kind of hard to think about if you haven't had experience with this, so let's draw it out and try to understand. So let's say these scribbles are lines of code, right? I don't actually feel like writing code, so let's say we have 6 lines of code. Pretty simple, nothing too crazy. But let's say we wanted to execute those 6 lines of code whenever we needed throughout our program. Well, one option would be to copy and paste every single time we need those lines of code. The issue with that is if you need to change that code, you have to change it in every single spot. More than likely, you might miss something, you'll have broken code, it'll be a disaster, lots of wasted code, don't do that. Instead, what you do is you take this and you package it essentially in what's known as a function. And you give this function a name called an identifier. So the name for a name in computer science is identifier. It's really confusing to explain that, but basically a fancy way of saying what's the function's name, what's the function's identifier, same thing. So let's give this an identifier of do something. Very creative, I know. Well now, anytime we want to call these lines of code, we just gotta say do something. So we could say it up here. We could say it down here. Wherever we want, it works. And then if we want to change that code, we only have to change it in one location, which is in that function definition. So that is the benefit of functions. It makes our code more scalable. Now let's talk a little bit about the how-to part of it. The easiest way to think about creating functions is to think of the main function, because that is literally us creating a function. So when we have the main function, we have int main, some parentheses, some curly braces, and a return with a value. This is how we create a function. We can generalize that for something else. Before we do that though, let's talk about these parentheses. Here is where we get input. Now the way we're going to do this is we're going to store that input in what are known as parameters. So when we call this function, as we talked about in the previous video, we pass in arguments. The data in those arguments get stored in the parameters. So it looks like this. So the arguments go into the parameters. So instead of working with the main, let's create a custom one. It's gonna be really simple. Multiply. And what this is going to do is it's going to take 2 arguments and store those in 2 parameters. We define their types. These are gonna both be integers. We can give them whatever name we want. We could say X and Y. Then instead of returning 0, what we can do is we can say return X multiplied by Y. And there we go, we just defined a function. How would we call this? It would look like this. In some other function elsewhere, we might need to multiply 2 numbers. And what we could do is we could just say multiply and then pass in 2 and 5, for example. Obviously, this is kind of a useless example because you could literally just do what we just did there. But this is just to explain the concepts of arguments and parameters and whatnot. Now the thing to remember is that this has a return. So if we just call it like this, it's going to give us the value 10 and then the value disappears. We're not doing anything with that value. So we would need to do something with this, either give it to cout or assign it to another variable, whatever. If you wanted to multiply a variable by 2, you could do that pretty easily. Let's say we had the variable x and let's say I had the value 5. What we could do is we could say x, multiply that by 2, and we reassign that back to x. So we say x is equal to x times 2, essentially. Now this whole thing is known as the function definition. This is just one piece of 3 important pieces. Number 2 is the calling, when we actually use the function. Now what about the third one? Well, it's actually a function declaration. So if you guys remember when we started talking about variables, you can declare a variable without giving it a value. You can just say int x. That's it. Later on, you can assign to it by saying x is 5. Functions are similar in that you can have a function declaration, but not actually define what it is. This is actually a requirement, but fortunately, when we do the function definition, this can also serve as the declaration, similar to how if you did int x equals 5, you kind of hit everything with one statement. Why am I even bringing this up though? If it's done automatically, why does it matter? Well, the thing is, in C++, the declaration has to happen before you try to execute this function. So if I were to call multiply at some point in my code before the declaration, it's not going to work. That means if we're going to rely on this function definition to do everything for us, we need to put this code first before we call the function. Some people don't want to have the declaration and the definition together, so they will actually create a separate declaration, and it would look something like this. Basically the same thing, we just got rid of the variable names. That is the declaration, and that would have to exist somewhere, probably towards the top of your program, before anywhere in your code tries to call multiply. Then you could put the definition down at the very bottom and just kind of ignore it. So that's one situation. Sometimes people just like to have the declaration up at the top and the definition at the bottom. But another situation is what has to do with header files. Now we're like deep diving into C++ here for a beginner, so I'm not going to go into this a whole lot. But basically, when you're creating multiple filed programs, you'll have header files. The header are where the declarations will go, and then you'll have the code with the definitions. This will get compiled to what's known as object code. Don't feel like you have to memorize all this, by the way. This is just purely informational. In this situation, you're going to split your functions where the declaration is over here and the definition is over here. And then just like at the beginning of our code, we have those include IOStream or whatever, you will be able to include your header file, which will declare your functions. And then you can have your definitions anywhere in your code and it will work. So if you're brand new to functions, this is probably way more than you need to know. But if you're not brand new to functions, then this is probably some good information to stick in your brain. We'll get into that more when we get into multiple file compilation. Definitely a pretty cool topic, so stick around. That's all I got for this video. In the upcoming videos, we're gonna get a little bit hands-on with functions, go through calling some, creating some, and so forth. It's gonna be a lot of fun. Be sure to check them out, guys. I'll see you then.
And don't forget to subscribe, of course.
Hey, what's going on, everybody? This video, we are going to be talking about using functions. We're going to be using the power function, so P-O-W. We're going to talk about how to use it, how to put it inside of an expression, all kinds of cool stuff. Now, if functions are completely new to you, you guys might want to watch the previous two videos. If you've had some experience with functions, then this video should be pretty easy to get started with. So let's just dive in. So the power function looks like this: P-O-W, then you put the parentheses, and inside of here we put arguments. So if we wanted to take 10 and raise it to the second power, it would look like this: 10, 2. And let's just say we want to output this. What we can do is we can use cout, use the arrows, and put pow right there directly, and then make sure we end this with a semicolon. So when we run this, it's not going to work. We get an error. It says use of undeclared identifier pow. That's because this pow function is not made available to us by default. Similar to how we have to include this IO stream in order to use cout or cin, we have to use another include to use math functions like pow. So this is going to be cmath. Now when we compile, it should work. And when we run, we get 100. So this shows us something pretty simple: how to call a function. You put the name of the function, and then you put the parentheses. If it takes any data, you pass that data in. If there's multiple arguments, you separate them by commas. So this is the first argument. This is the second argument. Now we are hard coding those values in, but we do not have to do that. For example, we can pass variables into the arguments here. So let's say we're going to use cin to create some variables, and then we're going to pass them here. So let's say we have a base and we have an exponent, like so. Just make sure I got the syntax right, and you can see that it actually allows us to declare two variables on one line here. Now what we're going to do is we're going to do cin, arrow, arrow, and we're going to get a value for base. So let's just ask the user, like so, and then they put the base in, and then after that we're going to ask them for the exponent. And then we're going to store that inside of exponent right here. So now instead of using 10 and 2 directly, we can put the variables base and exponent. Now let's compile and run. What is the base? Let's go with 10. What is the exponent? Let's go with 2. And you can see it still gives us 100. But now we've just generalized our program beyond just raising 10 to the second power. We can do all kinds of different inputs. Now I accidentally compiled again, but you don't actually have to compile if you haven't made any code changes. So all you have to do is run the application again. The base is 10, but this time let's raise it to the 10th power. And you can see we get a really big number. So this is 1 times 10 to the 10th power. Now the situation we have here, we are using pow directly in cout. But if we wanted to assign it to a variable, we can do that as well. So let's get rid of cout. And what we're going to do is we're going to create a variable. And this actually needs to be of type double. So we can say double, we can call it power. This is important because in this scenario, this function pow has a return value. It returns the result. It's only going to be useful to us if we do something with it. Whether that means storing it in a variable or outputting it directly, it doesn't matter. All we know is that we have to use it. So what I mean by that is if we got rid of this here and just had pow right here, it's going to calculate that value, and then that value is just going to disappear. Not very useful. So we're going to save it to a variable, and then we're going to output that variable instead. It's going to give us the same result, but I just wanted to show you guys how to use a return value from a function and assign that to a variable. Now when we run this, we can put a base in like 4, raise that to the third power, and we get 64. We could definitely customize that cout if we wanted to look any better. So we could say endl right here. Throughout the series, we're going to use a lot of functions, and we're also going to create our own functions, and that's what we're going to be doing in the next video. It's going to be really cool. Definitely step up your C++ game. Check it out, guys. Please be sure to subscribe if you've enjoyed this content. That really helps out my channel, and I'll see you in the next video. Alright, what is happening, everybody? Welcome back. This video, we're going to be talking about creating our own functions inside of C++. Before we get started, please do me a favor and check out our sponsor, Embarcadero C++ Builder, specifically the Community Edition, which is a free version you can get if you are earning less than $5,000 a year from your software projects. This is a fully featured IDE for building iOS, Android, Windows, and macOS apps. This is all from a single C++ code base, so you can make one application that deploys to all of these different applications from a single C++ code base. When it comes to the user interface, Embarcadero C++ Builder has an awesome visual UI designer with drag and drop capabilities for pixel-perfect, platform-specific styling. So don't go wasting your time trying to make user interfaces. Get things done quickly with C++ Builder. Check them out, I'll leave a link in the description. So in the last video, what did we do exactly? Well, we talked about calling a function. Specifically, we called this Pow Function, or Pow, I guess I should say. And this is from CMath. Well, to illustrate creating our own functions, I'm going to create a function very similar to Pow. So what if we wanted to create this function ourselves? Let's say this was not made available to us. Let's go through that process. Now, making functions is not too hard. You basically copy the format we have here for this main method. We have a return type, an identifier, parentheses, and then curly braces. And all of the code goes inside of those curly braces. So where exactly do we define this function? Well, we could either do it before main or we can do it after. I tend to put it before because if you put it after, you're going to have a separate declaration from the definition. And I'll explain that in just a second. So what we're going to do is we're going to make it return a double similar to how Pow returns a double. We're going to call this one power. And then we're going to have parentheses. And inside of here, we're going to have a base. I'm going to make that a double. And then I'm just going to have an int exponent. And then we put the curly braces. So that's the general structure. What I'm going to do is I'm just going to say return 0.0. So now let's change our code a little bit. We're going to get rid of this line and we're going to replace it. So we're going to say double. I'm going to call it my power. And then we're going to call that power function, pass in the base and the exponent, like so. And then when we print that, we're going to name that my power. So just so you have an idea what's going on here, we're calling our own function right here. Here's the usage of our function up here. We assign that to a variable called my power, and then later we output my power. Awesome. So everything else is going to stay exactly the same. So let's run it just to make sure we don't have any errors. You can see we don't, so that's good. When we run this thing, it's not going to give us the result we expect because if we put 10 and 3, for example, we just get 0. That's because the method is just returning 0.0. So what we have to do in here is actually do a calculation. Before we dive into that, I wanted to talk a little bit about declaration and definitions. So this function here is doing two things. It's declaring and it's defining. Occasionally you'll see these as two separate things, and I'm going to show you how that looks. So the first thing is we're going to take this function. More than likely that's going to be at the bottom, and then we're going to have the declaration at the top. So what is that going to look like? It's going to look very similar to this right here. So I'm going to copy that, paste that up here, and then we're going to get rid of the variable names, like so, and then put a semicolon. So this is a declaration, and now we have the definition down here. Sometimes you'll see this in a separate file, like a heading file. So that's something you could include in your other files, like so. If you don't have this function declaration here and you have your function defined at the bottom, it's not going to work out. You can see when I compile, I get an error. And when I scroll up a little bit, it says use of undeclared identifier power. So when we have that declaration up here, it avoids that problem and we can compile. And you can see no errors. Personally, I prefer just to put the definition at the top. That makes more sense to me, less work. There we go. Maybe when we get into separate file compilation, we might make the declaration separate, but for now, I don't see no point in that. Just a bunch of extra work for me to do, so I'm just gonna leave it as is. Okay, so now for the actual calculation part. Well, this might be a little bit beyond what we've talked about in this series, and I think that's okay. If you don't understand all of it, that's fine. Basically, you have to go through an algorithm to calculate the power of something. So in order to do this, we're gonna have a double variable, and we're just gonna call this result. And we're going to set the equal to 1. So basically what's going to happen is we're going to multiply this result by base to increase the value, and we're going to do that each time for however high the exponent is. So if the exponent's 3, we're going to multiply the result times the base 3 times. You'll see what I mean. In order to do this, we're going to use what's known as a for loop. So just follow the syntax here if you've never used a for loop. You put for, and then you put the parentheses, and then you put the curly braces. Inside of the parentheses, you're going to say int I equals 0. Semicolon, I is less than exponent, semicolon, I plus plus. So if the exponent is 3, this is the code you need for this loop to run 3 times. And then all we say in here is result equals result times base. So let's say the base is 10 and the exponent is 3. What's going to happen? Well, we're going to take 1 times 10, which will give us the value 10. That's the first time around. Then we're going to do it again, and we're going to do 10 times 10, which will be 100. That's the second time around. And then the third time it's going to be 100 times 10, which will be 1,000. And that'll give us the value. Finally, at the end, we need to return the result. And that is the output from the function. That's what we're using down here when we assign it to a variable. So let's save, make sure we did our algorithm right. Save and compile. And when we run this thing, we put in a base, let's say 10, exponent of 3, and we get the value 1,000. Oh yeah, we created our first function. So this is pretty cool. Now, if you don't understand all this code in here, that's fine. And if you do understand, just bear with me as I try to explain things. But basically what's going on is we are using this result as a value we're going to continually increase until it calculates the final result. The only way we can do that is by multiplying it by the base, however many times the exponent is. So if it's 3, we're going to multiply it by the base 3 times, which is what this line is doing right here. Finally, we have to return that value using this return statement. Now, a really important thing that I want to call out is that these here are known as parameters. And when we pass in values, these are known as arguments. They are 2 separate variables. That means they don't have to be named the same. So I could say this is called base, and I could basically replace anywhere in this function with that new variable, and it's going to work exactly the same. You can see it still compiles, and it's still going to run. So you could basically disassociate these two things. This function serves as its own entity, and the calling, we can pass whatever we want in here. We can put in a variable name, we could pass in a value, we could say the base is 10, whatever it is. So don't think that the names have to match, it's just convenient that they do, but they're 2 separate variables. So I'm gonna put this back to base instead of base, just to keep it clear. And that, my friends, is how we create functions. Keep in mind that this is returning a value, so in order for this function to actually be useful, we have to do something with that value. Either assigning it to a variable and then outputting it, or we could just output it directly. We could use it inside of an expression, whatever we want to do. So to summarize, we create a function by giving it a return type, an identifier, parameters, and then a body. At the end, we need to return a value that is of the type that we're putting as the return type here. And then we need to use that value in the calling program. So the calling function over here is using that value by assigning it to a variable. The other thing is that these variables are separate than these variables. It just so happens that they have the same name. That's fine to do because they're in different scopes, but if we went down here and tried to recreate one of these variables, it wouldn't work. So if I said int base here and tried to compile, you can see I get an error. And it says previous definition is here. So you can't use the same variable names inside of the same curly braces, but these are separate curly braces, so it works. That's all I got for you guys on creating your custom functions. Hopefully that was nice and easy for you guys. We're gonna do this a lot throughout the series, so if you still feel a little rough on this, don't worry, maybe watch this video one more time, get some practice creating your own functions, and in the upcoming videos, we're gonna do this a lot more. So it's gonna be pretty sweet. Please be sure to subscribe if you've enjoyed this video, and don't forget to check out the next one. Hey, welcome back everyone. This video, we're gonna be talking about void functions. What the heck is a void function? Well, this is a function that's not a void function. And the reason it's not a void function is because it has a return value result, and that's of type double. But we can actually create functions that don't return values, and those are called void functions. They're void of a return, essentially. So let's say we wanted to create a function that does something, but doesn't necessarily calculate a value and return it. Some common examples I can think of are logging. You can call a logging function to go write to some files or something. It's not necessarily going to calculate a value and return it, but it's still going to do something. Or we might want to write a function to easily output stuff to the console. And that's what we're going to do in this video, because if you scroll down in this code here, we have this main where we're doing a bunch of these couts, and it's kind of ugly. And what if we wanted to do this essentially a couple of times? Well, we would have to copy all this and paste it, and it's just really ugly. So we're going to make our own function to do it for us. We're also going to see how you can call other functions from functions, and how basically it becomes this giant chain of function calls. That should be pretty clear though, because we're currently in a main function and we're calling a function in it. So main is like the root of our function calls, then we call another function inside of that. So let's create another one, and we're gonna do that right here because I don't wanna have to put the declaration up top and then the definition down here. So let's just put it up here, and we're going to say void, and we're going to call this print stuff. Very descriptive. Actually, let's call it print pow. For one, it sounds cooler and it's a little bit more descriptive. So what the heck is this going to do? Well, basically, it's going to take a base and an exponent, and then it's going to call the power function and do some pretty outputting for us. So what we need to do is we need to say double base, and then we're just going to have an int exponent. I'm sure you could make a double exponent if you wanted fractional exponents, but it's a little bit beyond my capabilities because I'm terrible at math, so we'll keep it simple. All right, what are we gonna do here? Well, the first thing we can do is we can literally just copy all of this junk, and we're gonna paste that inside of our print pow function. Clean it up a little bit. Now, since we have these parameters that are going to get values passed in as arguments, we don't need to declare these variables here. So we need to get rid of that line. And now you have two options. When it comes to getting the values from the user, do you want to do that inside of the print pow function, or do you want to do that inside of main? I would argue that this stuff would be more appropriate to leave inside of main, at least with how the power function is scoped now, because it's called print pow. It has nothing to do with getting the base and exponent from user input. So that kind of goes with the general rule that functions should only do one thing, and that one thing should be clearly seen in the identifier. So because of that, I'm going to take these out and move that back to main. And this function is just going to take the power and print it. The next thing we're going to do is make this function print this in a little bit more pretty way. So right now what it's going to do is it's just going to print the power. That's it. It's not going to say what it is or anything. So what we're going to do is we're going to add a string in here, and we're going to print that before the variable. Actually, the format for this that I'm thinking is saying, let's say the base is 10 and the exponent's 3. We could say 10 raised to the 3 power is, and then put the value right here. So we actually need to start with the base. So it's going to look like this. Base, and then we're going to say raised to the, and then we're going to say exponent, and then another string that says power is, and then it's going to print the value right there. And then if you want to make it real pretty, you could even put a period at the end, like so. And I'm just going to do the new line there so we can get rid of this, just like so. Awesome. So I can envision this as 10 raised to the 3rd power is 1,000. And you can see that this function is actually calling the power function. So eventually what's going to happen is main calls print pow, and then print pow calls power. Oh my gosh, that's a tongue twister. So inside of main, let's talk about how we call this. Well, we can call it like this. We just say print pow, and then inside of parentheses, we pass in the arguments. Now, do we actually have to do anything with this? Do we have to assign it to a variable or anything? No, absolutely not. When you have a void function, you just call it by itself and you don't do anything in the calling part of it. Well, this doesn't even make sense because print pow doesn't return a value, so it doesn't make sense to assign it to a variable. It's just stupid. Don't do that. Okay, now I'm probably going to compile and get like a million errors, so let's just see what we have to do. Now before this is complete, we have to think about where these variables come from. Originally we had the declarations that we had up in this print pow, but we got rid of them because print pow isn't going to need those. It would have been more appropriate to keep them down here, so sorry about that. So we're going to have a double base and then an int exponent, like so. Alright, so now it should work. Let's see. No compiling errors. Let's give it a run and see what happens. What is the base? What is the exponent? 3. 10 raised to the 3 power is 1,000. Awesome. So that is how you work with void functions. The benefit here is that we could do this numerous times without having to repeat ourselves. So we just say print pow, we could pass in 100, raise that to the 4th power. We could call it again and say, hey, let's raise 4 to the 2nd power, whatever it is. The benefit though is that we can go up here and we can change the formatting, and we only have to change that in one place. We don't have this output here copied in like 10,000 places throughout our program. We just have function calls. So now when we output this, you can see the outputs are very pretty. 10 raised to the 3 power is 1,000, blah, 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 blah. So that, my friend, is void functions. Hopefully that was nice and simple for you guys. By now you're basically probably a function master, so you can probably resign from this series and forever work a 9-to-5 job. Sounds fun. All right, well, that's all I got for you guys in this video. Next video, we're gonna start talking about data types. Oh yeah. So far we've used int and double, and we've talked about void, which is no data type return for functions, but now we're gonna be getting into a little bit more detail. What do we need to know to master data types? That's what we're gonna be talking about. Thanks guys for watching. Please be sure to subscribe if you've enjoyed this content, and I'll see you in the next video.
Hey, what's up my party people? And by party people, I mean you nerds. This video we are going to be talking about C++ data types. Now, what the heck is a data type? Well, every piece of data has to be typed to some type inside of C++. And if that makes no sense, we're going to get into it. When we create a variable in C++, we define a type at the beginning. So you've probably seen int x equals 5 as an example. This here is the data type. In this series, we've also used the double data type, which if you've watched the previous videos, you guys would know that int restricts you to whole numbers, positive, 0, and negative, whereas a double will allow points. So 5.3, 12.1, 0.7, negative 12.7, and you can see how the different data types make a difference. Whether or not you see the value in data types is not the question. Basically, you're so early on in your learning of C++ that making an argument for or against data types doesn't matter. You just have to deal with the fact that C++ has data types. C++ is what's known as a statically typed programming language. And what that means is that variables, such as x in this case, has a data type when you declare the variable, and it's always going to store an integer in this case. This is in contrast to languages such as JavaScript, things that are a little bit more flexible and promiscuous. It's probably not the right word, but anyways, the variables do not have types. C++ they have types, other languages they don't have types. What kind of languages are going to have types? Well, C is going to have types, C#, Java. Most languages, I would say variables are statically typed, meaning they have a type at the beginning when you're writing the code, and that data type is stuck to that variable at compile time. The benefit of data types is that you always know what's going to be inside of that variable, or at least what kind of data you should expect, so you know how to use this variable appropriately. The downside is that it's restrictive. We can only store integers inside of x. There are other pros and cons, and you guys can argue about which is best in the comment section below if you would like. But what I'm going to say is that I actually prefer the statically typed. I like to know what type my variables are at compile time. With a dynamically typed language, you might not have to put a data type with your variables, but every language, the data itself still has a type. So in this situation, if we just got rid of this here on the left, and just looked at this here, what you might say is a literal value. We just typed in the value here. This has a type. There are all kinds of different data types. We are just most used to seeing them with variables. So we often give variables a data type, or functions will have a return type. That is also where we'll come across these data types. So what are some of the other data types besides int and double? Well, I like to categorize things. It helps me learn. So I'm going to categorize it into integral, char, which you can argue might be part of integral, but just follow along. Gosh, quit interrupting. And floating point. You also have bool or boolean. You have arrays, you have structs. We also have classes. And you can see there are a lot of data types. There are also things like vectors, pointers, unions, enumerations. There are a ton of data types. So what exactly do you need to focus on is the question. Well, we're going to start here at the integral data types, and we're going to kind of work our way down in this list. So integral basically means integer based. So it's like int, but there is a larger variety than just int. Char is for characters. So letters, numbers, spaces, special characters, those are all part of the char data type. Floating point, this is like double. Double is an example of floating point. Floating point allows us to store fractional numbers. Bool, very simple, it's just true or false. Arrays allow us to store multiple pieces of data of a particular type. So we could have an array of integers. We could have an array of doubles. So we'll get into arrays in this series. Now, structs and classes are kind of similar in the way they're created. Basically, these allow us to create our custom types. So if we wanted to create a custom data type for like a person, or for a brownie, or for like
type of cleaning supply, or a class, like a school class. Oh, there we go. We could have a class to describe a class. Basically what I'm trying to say is that the sky is the limit when it comes to structs and classes. We can make these into anything. There are a lot of structs and classes that are made available to us already in the standard library, as well as any other libraries we might pull in. But throughout the series, we're going to talk about creating our own so that we can use all of these data types and kind of package them in a system where we can create more complex data types. So hopefully that makes sense, and if it doesn't, that's fine, because we're going to get into that later. Before we move on though, I do want to touch on one more thing with classes. You have probably heard the term object, like object-oriented programming. And now that we're talking about data types a little bit more, let's go into classes and objects just to touch on that for just a minute. A class is like a blueprint in that it describes a structure. So we might have a class for a student. And then an object is an instance of that class. So a particular student such as Caleb or Sally. Inside of this object, we can use all of these different data types to create all kinds of different things. So we could have the student's grades inside of an array. We could have the student's name inside of a string, which I didn't even totally forgot to put up here, but yeah, strings are kind of a big deal. Strings are sequences of characters, and we've talked about strings in this series. We'll get into those too. We can actually define functions inside of this class, which would make that function available to all the objects. So we could have an object such as change student's grade or ridicule student in class. Whatever we want it to be, we can put that inside of the class as a blueprint, and any objects are going to be able to use those functions. So think of these as like the building blocks, and we're going to build so much cooler stuff with all these building blocks. These are the Legos. We got to learn our Lego pieces before we start engineering like cars and stuff, right? So this is your crash course summary of data types. It's very important to understand how they work, especially when it just comes to individual values, literals, like this 5 here. This is going to have a type. And if you don't understand data types, it can come back and bite you, because you might be treating a value as if it's a different type than it really is, get different results than you're expecting. And if you don't believe me, just go through an example with me. Something like 5 divided by 2. Very simple math. We all know how to do this. This is obviously 2. Anybody knows that. Well, not really. It's confusing because what's actually happening is that this is an integer and this is an integer, so it does integer division, meaning the result is an integer. So what you might expect is 2.5, but because we're working with integers and not doubles, we get the value 2. So if you wanted to get 2.5, you would need to add a 0.0 or something in here, or do some typecasting to basically say, hey, yo, I want to do double division. And in that case, you're going to get 2.5. So that's just a very simple example, but the same thing is important as we go into more complex types. Learning data types can kind of be boring and cumbersome, but this is like the foundation, and if you really understand it, it can make programming fun, especially when we get into custom types like classes and structs. Oh, that stuff's fun. So be excited, be sure to subscribe, and I'll see you in the next one. Thanks, guys. By the way, we're going to be talking about integral data types in the next video. It's going to be another onboard video, so see you then. Welcome back, everybody, to your C++ tutorial series. This video, we are going to be talking about the integral data types. This is a conceptual video. If you guys are looking for hands-on stuff, check out the upcoming videos, because that's where we're going to go on the computer and type some junk out. So this video, we're going to be talking about the different integral data types, how they work, also signed and unsigned integral data types, and what that means when it comes to binary, how to interpret that junk, and all kinds of good stuff. The most basic integral data type that we know of is int. Now, this concept of data types is pretty universal, but C++ is unique in that the standards of the language are fairly loose. So if you go to other languages, there might be more structured requirements for implementations of the language. C++ tries to give the bare minimum so that there are a lot of varieties in different compilers, systems, and so forth. What exactly do I mean by that? Well, when it comes to integers, they basically do the same thing from system to system, but the size is not always the same. So what do I mean by size? Well, if we were to do something like int x equals 5, well, what's going on here exactly? Well, you can think of memory This is where all of our variables are going to be stored. And trust me, I don't know crap about memory, so I'm not going to pretend. Basically what I'm going to tell you is that all variables go inside of memory. So these take up a certain amount of space. The less space required, the less memory our application uses. So for example, if you want to create an application that uses a ton of memory like Google Chrome, then you can use large data types because they're going to take up more inside of the memory. The size of an int is typically going to be 32 bits. But it's not guaranteed to be 32 bits. It's actually only guaranteed to be 16 bits. If you're developing on like a Windows machine or a Mac machine, it's probably going to be 32 bits, and I'm going to be talking about how to figure out which one it is in the upcoming videos. But just know that you're only guaranteed a certain size. So what that means is that the size of memory can change depending on the system you're on or the compiler you're using. Is that an issue? Usually it's fine, but the issue is that the size here determines the largest number we can store. So let's say we use a number that fits inside of a 32-bit integer, but it doesn't fit inside of a 16-bit integer. Well then, if we went to a machine that used 16-bit integers, we might have an issue. So this is where things in C++ get a little, mucky, dirty, I don't know, blacky. So you gotta be really careful when it comes to data types. So what exactly are bits? Well, the easiest way to represent them are ones and zeros. Think of a bit as something that can be on or off. 1 being on, 0 being off. You could also think true or false, or high and low, basically anything in 2 states. So something that is 16-bit is going to have 16 ones and zeros. So this is 16 bits, and it allows a certain number of possible values. Because if you think of all the different possibilities of ones and zeros, you could have all ones, you could have all ones and then 2 zeros, and so forth. You can basically flip every single possibility. It gives you a certain number of possibilities of values. This is how we store different values inside of memory. And you honestly don't have to worry about this binary junk. It's all handled for you. If you want to know a lot more about binary, I have videos on binary, check them out. But for this video, I'm just going to give you what you need to know to start programming in C++. If you think of all the possibilities, there's a certain number. And then let's say we add 1 bit. Just 1. That's going to double the total possible values because we have all the original values with a 1 and then we have all of the original values with a 0. So what that means, every time we add a bit, the total possible values doubles. You can see this easily if you look at 1 bit versus 2 bit. If we just have 1 bit, we could have a 1 or a 0. If we have 2 bits, we could have 1 1, 1 0, 0 1, 0 0. So just by adding 1 bit, we doubled our possible values. So the difference between an 8-bit number, a 16-bit number, and a 32-bit number is significant. A 32-bit number does not have twice as many possibilities as a 16-bit number. It has many factors of 2 times more possible values. So I think I'm getting a little bit too much in depth with the binary stuff. Basically what you need to know is that an int is going to be at minimum 16 bits, but usually 32 bits. A 16-bit number is going to give us like 65,536 values, I believe, different possible values, whereas a 32-bit number is going to give us like 4 billion something. Now, what about negative numbers? There is a way to store negative numbers, and that is with a technique called 2's complement. It's basically a way to store negative numbers in binary. But to really simplify, you can think of one of those bits being reserved for a sign bit. So for example, let's say we have a 4-bit number. And we say that this bit here is a sign bit. And basically it's used to indicate whether the number is positive or negative. So if it's 1, we could say it's negative. If it's 0, we could say the number's positive. The benefit here is that it allows us to represent negative numbers. Negative numbers are going to have a little bit of a different value here with 2's complement. If you want to know that, you can look up how to convert a binary number to negative number with 2's complement. But for now, all you really need to know is that there's going to be a sign bit. The benefit is that it allows negative numbers, but the downside is that it cuts the highest number in half. So think of it like this. If this is 0, we can represent so many numbers with a binary number. And let's say this is the max number. This is how much we can represent. With a signed number, we can represent negatives, but the maximum value is cut in half. So this shifts over and part of it's in the negative and part of it's in the positive. So now it's going to look like this. And here is the entire range of the number. So if you're working with something that is always positive, then you want to use an unsigned number. If it's something that regularly goes in the negative, like our bank accounts, then you will want to use a signed number. So when we get into the different types of integer data types, which we're going to do in the next video, we're going to get hands-on with it, there are going to be multiple different sized numbers, and then there are going to be the same things for signed and unsigned. Because of that, it can be overwhelming. There's like 8 different integer possibilities. If you're not sure what to use, just default to using int. It works in most scenarios. If there's a specific edge case where you need a huge number, you might need to use a larger one. If there's an edge case where you need to use only positive, you might want to use an unsigned one. And we're going to show you all those possibilities in the next video. So check it out, guys, and if you've enjoyed this content, please be sure to subscribe. Definitely helps me out, and I really appreciate it. Thanks, guys. Peace out.
Hey, what's going on, everybody? This video, we're going to be talking about the integral data types. It's going to be lots of fun. Oh yeah. So make sure you watch the previous video if you want the conceptual stuff regarding the integral data types. This video is hands-on. We're going to go through some examples, whatever works best for you. But either way, let's get started. Well, let's start with the int that we know. We can create an integer variable like so. Right now we're assigning 5 to this, but what if we do something like this? Yeah. All right, let's see what happens. And you can see we get an implicit conversion from unsigned long, which is a different data type than int. So you can see that there's more to just integers than int. There are different data types that are also integral types, one of which is a long, and we're going to discuss the different options. And if we scroll up a little bit, you can see integer literal is too large to be represented in any integer type. So even the long cannot store this much junk. So let's shorten this out a little bit. And now let's try compiling. Now you can see we only get the warning, which is an implicit conversion from long to int. So what are our options exactly? We have int. We also have another one, which is called short. We're going to call that a. Then we have int. Then we have long. And then we have long. These are the 4 primary integral data types. Now each one of these is going to have an unsigned counterpart. So we can say unsigned short, unsigned int, unsigned long, and unsigned long. So there are 8 integral data types you need to know about. Now the differences between these 4 and these 4, as we discussed in the previous video, is that the unsigned ones only allow positive values. If you need only positive values, you can extend the total max value by using an unsigned version of the data types. The difference between each one of these is about the amount of memory that is allocated for each one of these. Int is at least 16 bits, but usually 32. Long is at least 32 bits, and a long is at least 64 bits. And when I say at least, it kind of implies that it could go pretty high. So the way it kind of works is short is less than or equal to int, which is less than or equal to long, which is less than or equal to long. Now, how exactly do we figure out how much memory each one of these has? So we can see out and say size of, and we can use short, for example, like so. Make sure you prefix it with standard or use the appropriate using at the top. I'm going to prefix it here. And now when we run it, we get 2. So this is in bytes. A byte is 8 bits, so this is actually 16 bits. We can do the same thing for int long and long. So you can see an int is 32 bits, a long is 64 bits, and a long is 64 bits as well. Just because your system gives it these amounts doesn't necessarily mean you can trust any system to do that. So always make sure you focus on the minimum when you're developing apps. So for example, if you're guaranteed that you're going to need a 32-bit number, you're probably going to want to use long rather than int. That's because int is only guaranteed to be at least 16, not 32. But how do you actually know how much you can store in these different memory sizes? Well, that is actually very easy to do. We actually have to go up to the top and include another file, and that is called climits. Make sure you spell things right, okay? Like we're not in kindergarten, Caleb. All right, then go down to the bottom, and what we're going to do is we're going to replace this size of here, and then just say, for example, short underscore max, but there's actually no vowel here, so it's shrt underscore max. And we run this. We get 32767. This is a signed number, so there's also a negative maximum. So what we can do is we could say short min, and that's going to give us the negative. So you can see here we get all the way down to negative 32,768. Now if you wanted to see the unsigned version, just prefix it with a U, and then we could say max here. And you can see this is going to extend the maximum value, 65535. Just like there's a short version, there is an int version, there is a long version, and then there is a long version. You can prefix each one of those with the U to get the unsigned version. So if you wanted to see what the unsigned long version would be, we can run this and we get this huge massive number, which is probably large enough to basically carry anything you would ever need. Unless it's like my number of subscribers or something. That's all I got for the integral data types. In the next video, we're going to be talking about the char data type. Very similar to the integral data types, but it's ultimately designed for characters. Check it out, it's going to be sweet. I'll see you then, guys. Hey guys, what's up? It's Caleb here, and we're going to be talking about the char data type. This is categorized in the integral data types, and you'll see why in just a minute. So the two main purposes of the char data type is to store small numbers or characters. Definitely a useful data type that you need to know about, so stick with this video, it's going to be a lot of fun. So the char data type can actually be used for two purposes. The first is store characters, and the second is store numbers. So we're going to talk about storing characters first. But first, compared to these other data types, if you guys remember from the previous video, I said a short was 16 bits. Well, a character is actually 8 bits. So if we're comparing size here, char is the smallest of them all. That means if you're going to be storing numbers, your maximum is pretty limited, and we'll get into that. But for now, let's get rid of these other data types and talk about how to store a character. So we can create a char variable like so, and then we can assign a character to it using single quotes. So you have to use single quotes. Double quotes are reserved for strings in C++, which is not the same thing. So for a char literal, we need to use single quotes, and then we can put any character in here that we would like. So for example, we could put capital A. Now to output that, very simple, we just cout X. And we run that, we get A. So overall, that's pretty simple. Now how exactly is this stuff stored? Well, characters are actually stored in the same way as integers. The only thing that differs is the way we interpret them. So for example, we could interpret this X as an integer by casting it to an integer like so. So by putting those parentheses with the int before it, it's going to print it as if it was an integer. And when we do this, we get the value 65. And when you do this enough times, you start to associate numbers with letters. So capital A is 65. If we put a B, it's going to be 66. So how do you know the number equivalent for a character? Well, it's based off of something called the ASCII table. This is the ASCII table, and you can see it's a pretty overwhelming chart. So the things you need to worry about here is the DEC column, decimal, and the char column, which is in red. So for example, for the letter A, the capital A, that would be found right here. And you can see the A has a decimal value of 65. So if we convert an A character to an integer, we get 65. So it all really depends on how we interpret this stuff. This means we could, in theory, use the char data type to store numbers. So what if we did store a number in here? Well, going back to the interpretation thing, if we ended up putting something like 65 here, we're saying that we want to store the character with the value 65. So when we output it, we should still get A. And you can see we do. But obviously, if we're trying to store a number, we're going to want to output it as a number. So we might cast it like so, and we get the value 65. So you can see that works, but I am going to warn you guys of something. If you forget to do this cast, it can be a little bit confusing. For example, what if we put the value 55, and then we did not cast it to an integer? Well, now when we compile and run, we get a 7, which that's confusing. The reason we're getting a 7 is because 7 is the character with the ASCII value 55. You can see the 7 right there, 55. So what exactly is the maximum value here? Well, I'll tell you guys right now that the maximum value is 127. When we compile this and run, nothing bad happens. But if we put 128, watch what happens. You can see we're getting a warning, and when we look at the full picture, you can see what's happening is that we're getting an implicit conversion from int to char, and it changes the value from 128 to negative 128. What's going on? Well, this is known as overflow. So basically, when we put a number 1 bigger than the largest possibility, it goes down to the absolute lowest number, which is negative 128. So if we increase this and we did 129, when we compile now, it should go to negative 127. And you can see negative 127. So when we're storing numbers that are too large to fit in a data type, it's just going to wrap around, start at the very lowest number, and then continue counting up. So if we want to store a number in this, it looks like we're limited to 128 as the highest number. That is, assuming we're using a signed char. If you guys remember from the previous video, signed means it allows negative numbers. So we could actually put in here unsigned. And this is going to allow us to store a number such as 129. So when we compile, we don't get any issues. So this is going to allow us to store up to 255, which is a little bit better. So char by default, in our case, was signed. It's actually up to the compiler though. So if you want to be specific, you can even specify signed here. So there's signed char and unsigned char. Now when it comes to characters, you might see on this ASCII table, there is this extended ASCII codes. So you might think if you use an unsigned char, we open up all these different characters here. Yeah, in theory that'd be nice, but it doesn't quite work that way because the extended ASCII codes is not standard with the normal ASCII table. There are actually numerous extended ASCII codes, so what happens is if you try to do one of these characters, it's just going to spit out a question mark to you. So for example, we can go in here, we're going to make this unsigned, like so, and then we're going to put this out as a character rather than an integer, and when we run, we don't get anything in the console. So if you're using a char for numbers, yes, you can go over 127, but if you're using it for characters, you definitely want to limit yourself to any of the standard characters that are in the ASCII table right here. Now obviously this is a lot of characters and can cover most of English, but English is not the only language out there. I know us Americans have a hard time of realizing that we're not the only people that exist in the world, but there's actually a lot of other languages out there, and with that you're going to need something called Unicode. So if you're building an application where you need to support multiple countries or languages, then check out Unicode. I might get into that in an upcoming video, but if you just want to do a little bit of research on that right now, look up char16_t and char32_t. These are char data types that'll give you enough memory to store a lot more different possibilities with characters. So thank you guys for watching. Hopefully this was helpful and a good introduction to the char data type. Main thing you need to know is that it's primarily used to store characters, but with a little bit of perception, you can actually use it for numbers as well. Just make sure you're really clear with your intent. If you're trying to use it for numbers, you have to output it as a number with casting it to an int, like so. So that's all I got for you guys. Please be sure to check out the next video. I'm not sure what we're gonna do yet, but it's gonna be awesome. I think I might either go over the Unicode stuff, or we're going to be talking about the bool data type. So check it out guys, and if you've enjoyed the content, please consider subscribing. Hey, what's going on everybody? This video we are going to be talking about escape sequences. So escape sequences are special characters that mean something when they're used as a character or within a string. So let's talk about it. It's important to understand that there are certain characters that get interpreted rather than just printed. So for example, if we do a \t, this is an example of an escape sequence. You may also have seen \n, that one's pretty common. So what these do is they say, hey, we want to do something rather than just print \t. In this case, it's going to put a tab character. So for example, I could put 2 words here. And what's gonna happen is when we run this, we get hello there. So this \t is being interpreted. There are a lot of other ones, and that's what we're going to be talking about in this video, just so you guys have an understanding of what you can do with these. Another possible one is \b, and what this does is it will actually delete a character. Oh, sorry guys, I didn't mean to. Pardon my language. Some of these I'm not entirely sure the use of, like when would you want a backspace in a string, like why don't you just manually delete it? But there could be situations when you want to do that. So just know that it exists. \n is the one we've been using already. This will go down to the next line. There's the \v, a vertical tab. So that's pretty cool. And then there's another fun one, which is \a. Now, when you execute this inside of Visual Studio Code, nothing's gonna happen. But if you get another console, so let me grab the path here. We're going to travel to this path. So you can just cd to this path here and then run it. You can see there's a little beep. Another common one you might see is actually going to come up a lot later when we talk about strings, and that is a \0. So what is a \0? This is known as the null terminating character. And what this is it'll actually be used later to indicate the end of a C-style string. So by C-style string, I mean strings that were native to C and are still available inside of C++. So this is how we could tell when the string was over. So if we had a string, it would be like this in storage. It'd say hello there, and then there would be a \0 to say the string is done. It's something you definitely don't want to replace. So if you're working with strings and you erase it, functions can accidentally go beyond the end of the string and go into areas of memory they're not allowed to access, which is bad, by the way. Now another one is \. So there we go. So what this does is it allows us to type a double quote, because if you don't put that \, what's going on is it thinks that this one we're typing in here is the end of this first one, and then we just have this one floating at the end, which is not what we want. So if we wanted to quote something inside of a string, like let's say we wanted to have hello there inside of quotes, you can see this is the string part, and then there's just a bunch of extra junk at the end. So what we need to do is we need to prefix these with a \. Now it understands this to be the beginning quote and this to be the ending quote. So when we compile and run this one, we get hello there with quotes around there. You can also do the same thing for a single quote, like so, but this actually really isn't necessary inside of a string. So you can see it does print the single quote, but even if we take off that \, it's going to work just the same. And you can see the single quote prints exactly the same way. Why is it there then? Well, if you're actually doing this with a character instead of a string, it becomes important. What if we wanted to store the single quote character? We might say something like this, and set that equal to a single quote inside of quotes. Well, this isn't going to work because it's the same issue we were having with the double quotes, where it thinks this is the opening quote and the second one is the closing quote, and then we just have this extra one at the end. So if this is the situation you're in, you need to put a \/ here. So the \/ single quote is for characters, the \/ double quote is for strings. Now the only other one I can think of that you might run into in your early career C++ is \/. So what if you actually wanted to put a \/ in your string? Well, if you just put a \/ here, it's not going to work because this is the typical character used for escape sequences. So it thinks we're trying to interpret this double quote, and we're not. We're trying to just write a \. So if that's the situation you're in, you actually have to put two \. Now when it runs, it's only going to output one \, and you can see the \ is right there. Now there are some other escape sequences. If you need a full list, just look it up on the internet. I'm sure you can find a list. The ones I covered are the ones you're going to run into the most often, but there are definitely ones out there for other things like dealing with trigraphs and hexadecimal and Unicode and all kinds of stuff like that. So this is where I encourage some extra study. Go look up the escape sequences and give some of them a try. That's all I got for you guys in this video. The next video, we're going to be talking about bool. Now, I know I said in the previous video we're going to be talking about bool in this video, but you know, I lied. My bad. It was an accident, okay? I misread my notes. Deal with it. Alright, I'll see you guys in the next video, and if you've enjoyed this content, please be sure to subscribe. Hey, what's going on everybody? This video, we're going to be talking about the bool data type. Bool is short for Boolean, which really is just true or false. So the way we create a bool is very simple. Then you can make a statement, essentially, and you can set it to true or false. Now these are keywords, so you don't have to put them in quotes or anything, you just put them as is. So obviously this is going to be true because pizza is life, and if you disagree you can reassign the value false, like so. But obviously no one's going to do that, so we'll just leave it as true. So it's important to understand there is a conversion between bools and numbers. So for example, we can go in here and put the value 1, which generally means true. Alternatively, we could put 0, which means false. Well, actually, it's a little bit more than that. 0 is false and anything else is considered true. So even -1 is considered true. So if we see out this variable, what we're going to get is 1. So that's a little bit confusing. We assign the value -1 and it outputs the value 1. Well, that's because -1 is considered true and true is represented by 1. So no matter what we put in here, it's always going to output 1 as long as we don't put the value 0. So if we go in here and put the value 0, you'll see that output 0. Cool beans. So what exactly is the purpose of a Boolean variable? Well, you can often use it as a flag. So for example, what do I mean by flag? I mean something that indicates something. So usually you can do this for something like a search. So you could have bool found equals 0, and then you could have some kind of search algorithm. And basically inside here, if found, they'll set found to 1 or true. I generally like to use the keywords, so I like to do false and true. So basically you can use it as a flag to indicate if something happened throughout an algorithm. Booleans will also come up a lot more once we start talking about logic with if statements. That's going to be fun because basically everything can evaluate to true or false inside of an if statement expression. So just to show you guys that real simple, it might look something like this. So in this scenario, this is always going to run, but later on we're going to deal with code where there's some kind of condition in here and it only executes sometimes. So that's going to be fun. Look forward to that. We'll be talking about that really soon. But for now, we're just going to worry about the bool data type. So that's pretty much all with the Boolean data type. There is one thing I can think of that might be more useful to you, and that is how do we actually get it to output true or false rather than just 1 or 0. So here we are outputting found, and you can see it outputs as 0. But let's say I want this to say false. Well, we can do that with what's known as a manipulator. No, I'm not talking about your X, I'm talking about this thing here. This N to L is an example of a manipulator. This is just one of many manipulators. Another one allows us to change this from saying 0 to false. So as a reminder, these are part of the standard namespace, so you have the option of putting a using namespace std up here, and then you wouldn't have to prefix anything inside of the standard namespace. Or you can be a little bit more restrictive and just put the using for things you're going to be using very often. Either way is fine, but the upcoming manipulator is part of the standard namespace, so you're going to want to prefix it with standard as well. So the way we do this is we just pass it in before we output any Boolean values. And you just put standard : bool alpha, like so. And then you're going to put another arrow before the next section of the cout. So when we save this and run now, you can see it says false. So that is the easiest way to print false. Alternatively, you can use an if statement. So I'm not going to really explain this a ton in this video, but you can say something like if found, and then output, this is true. So in this case, let's say bool is true, then you could output it this way. Shoot, I gotta put a C out there. There we go. And there we say true. So if you wanted to say true or false, then you'll need to use an else clause. But the easiest thing to do is just use the standard bool alpha. So that's all I got for the Boolean data type. It's pretty cool. It's quite logical. Yeah, logical is about the best adjective I can come up with. So thank you guys for watching. I'll see you in the next video. And in case you're wondering what we're going to be talking about, we're going to start talking about floating point data types and a little bit more on those in depth. So check it out and be sure to subscribe. Yo, what's up everyone? In this video, we're going to be talking about floating point data types in C++, float and double. I'm going to say up front that I am no expert on this topic. This is Caleb's version of how floating point numbers work. I'm sure if you want a really detailed description of the internals, how they're stored, you could find some really intense document online. Maybe read it at night when you can't sleep, it'll help you out. But I'm gonna give you what you need to know to use floating point numbers. So yeah, that is your upfront disclosure. So what the heck is a floating point number? Well, there are three types of floating point numbers. We have float, we have double, and then we have long double. Now these all work similar in nature when it comes to storage, so let's just talk about that. When we're working with floating point numbers, we're going to have basically two sections. We're going to have a number such as 7.7, and this is going to be multiplied by some giant number such as 10,000. So when you evaluate this is going to be 77,000. But by breaking a number up into the left part where we have the significant digits and then some multiplier, we're able to store much larger numbers with a limited amount of memory. The consequence though is that floating point numbers are only trustworthy to a certain number of significant digits. So floating point numbers, they can become huge, but they're only so trustworthy. And you'll see what I mean here soon. So when we are writing out a double, like let's say we wanted to assign a value to one of these variables, we can just put the value like so. But another way to represent this is actually 7.7 E4. Basically scientific notation, something you may or may not have learned in school. Probably not. So you can also think of this as 7.7 times 10 raised to the 4th power. You can actually assign a value to a double using this format. So if we wanted to put 77,000, we could just put 7.7 E4. And then what we could do is we could see out this, and you'll see what I mean. Oh, shoot, I totally forgot to give this a variable name. See. All right, when we run this, we get 77,000. So that might help you understand a little bit more about how floating point numbers are stored. They're stored with significant digits and then some multiplier, 10 to the 4th power in this case. This is actually where it gets the name floating point. It's because you have a decimal point and you float that to the left or to the right. This here is basically saying move that decimal to the right 4 places. So if you think of having 7.7 and then you just basically take that decimal, move it over once to the right, you're gonna have 77 period, and then move it over again, you're gonna have this, and then this, and then this. It's kind of hard to see on a computer, but basically think of it like this. If you have 77,000, you start with a period right here, move it over 4 times, and you get 77,000. So that's where the floating point comes from. All right, so now let's talk about the differences between float, double, and long double. Well, float is the least trustworthy of them all. It has the least number of significant digits that we can trust. So let's go through an example that shows this. Let's get rid of all that junk there. What we're gonna do is we're gonna assign to this 10 divided by 3. And you need to put 0.0 on at least one of these so it doesn't use integer division. What I'm gonna do here is cout A and see what we get. So we get 3.3333. Awesome. And now what I wanna do is I wanna take this number and multiply it by another really big number. So we're gonna take A equals A times, and then we'll just put a really big number right here. Now when we output it, let's see what we get. Well, we actually get this in scientific notation, which I don't particularly want, so we're gonna change that. If you go to this cout and add standard : fixed, that's going to fix our problem. See, because it says fixed. I'm kidding. Oh, you also have to put arrows, duh. All right, so make sure you have those arrows there. And you can see we get this really crazy number right here. I'm also going to put an end line here. All right, so this is the number. You can see at some point, it no longer says 3. It starts going 188608. Like, what is going on there? Well, that is what I'm trying to explain to you guys, that floats are not entirely trustworthy. Doubles are a little bit more trustworthy when we get to a lot of significant digits, but still it has its limitations. So how many significant digits can we trust for each one of these? Well, the way we figure that out is go to the top and include another file, and this is going to be float.h. This file is going to make available to us some constants that we can get values from that say how many significant digits a particular data type is trustworthy to. So let's go through an example. Let's do another cout here. And the first one we're going to do is float_dig for digits. When we run this, we get 6. So what that is saying is that we can trust this to 6 digits. 1, 2, 3, 4, 5, 6. You can see the 7th actually got the right value, but that's not really a guarantee. We can only trust it to 6. It just so happens that it got the right value in this case. Let's try it again, but instead of float, let's try double. You can see that the double actually allows 15 trustworthy digits. So that means if we change this to a double here, we should get a little bit more of a precise result. And you can see we got a lot more 3s, so that is much better. You can see we actually got 16 3s, so it's much more precise. Lastly, let's try this with long double, and you can see we get 18. So you can see as you go from what was float to double to long double, we get more precision and the number becomes more trustworthy when it comes to significant digits and what is actually correct. I recommend going with at least double. I don't see a reason to ever use float unless you're really restricted on memory. Doubles can hold huge values, so this is going to meet most of your needs. But if you're working with something that has to be exactly precise, these data types might not do the trick. If that's the case, such as if you're working with money, you are going to want to look up how to do exact precision in C++. So there are libraries you can import that allow you to use a data type that you can trust every number in that number. So if you're in the scenario where you need numbers after a decimal, but you need them to be 100% trustworthy, then make sure you find the appropriate tool to do that. Don't use double or float. You're asking for trouble. Most of the scenarios I'm going to be using, float and double will do just fine because the up to 18 digits of significant digits is more than enough for me. Before we go, I did want to give you an extra tip, and that is, when would you want to use a floating point number over an integer? Well, obviously, if you need a fractional part of a number, you need to use one of the floating point types. But oftentimes, you can use integers instead of floating point numbers to represent something that would normally require a fractional part. So like, let's say you're in the situation where you're working with money, and you might have cents, which is a fraction of a dollar. Well, instead of using a floating point number and having fractional parts, what you could do is just have an integer and have it called cents. So rather than having $1, you could just have 100 cents. So if you keep everything in cents and you don't have fractional pennies, then you basically mitigate the problem of an untrustworthy data type. And if you're working with a lot of money, then you could definitely use a larger data type than int. So that's my first tip. The only other tip I have is that you should generally use double. So the only reason to use float is mainly memory. Or should I say, main memory. That's all I got for you guys. In the next video, we're going to be talking about constants in C++. It's a pretty good topic to know about, so check it out. There's lots of things you can do for constants, and it's a little bit more complicated than you might expect. So I'm going to try to break it down for you. What in the heck is happening, my home dogs? This video, we're going to be talking about constants. Now, let's get back to constants. When we create a variable like so, int x equals 5, this value here is known as a literal. You may also hear constant. So this is a literal constant. Constants are very important and they're fundamental in any programming language. We need them in order to assign values to variables and to use inside of expressions. But that's not exactly the constant we're talking about here in this video. So what exactly are we going to be talking about in this video? We're going to be talking about what's known as a symbolic constant. And what that is when we prefix a variable with the keyword const. So now it's not really a variable now, is it? Ooh. Well, it's still usually called a variable, so people usually say a constant variable, which just kind of sounds dumb when you say it out loud. But anyways, what we're going to be doing now is we're going to be talking about symbolic constants. So I think the naming here isn't entirely 100% clear. There's a lot of confusion out there. So try not to be too uptight with the naming. Basically, when people say constant, they could refer to this type of constant. They could refer to this type of constant. So now that you understand the naming, let's talk a little bit about what this means here. All right, so first thing, this creates a read-only variable. So what do I mean by read-only? Because we're actually writing to it here. Well, it's only read-only after you declare the variable. So here we're assigning a value to it, but if we wanted to later change that value to say 10, that's not going to work. We're going to get a compiling error. You can see, if I scroll up just a little bit, you can see it says error, cannot assign to variable x with const qualified type. So what does it mean by const qualified? Well, anytime you hear the word qualified, it means to basically prefix something with a more descriptive term. So we're prefixing int with const. This is similar to how we can do something like standard : cout. What we're doing is we're qualifying where this object is coming from. It's coming from the standard namespace. So similar thing when it comes to const, we're qualifying the type int with the keyword const. The point is we can't change the variable value. Now when it comes to the name of a constant, there are a lot of conventions out there. Some people will capitalize the first letter, so like if we had xylophone. Other people will prefix with a K, so you might see K underscore. Personally, I'm not a huge fan of prefixing things with a type identifier. That's the basis of a type of Hungarian notation, which basically is when you embed the type of a variable in the name. I'd say it's generally frowned upon and it's not widely accepted to use that type of Hungarian notation. So what exactly do I mean by that? Here's an extreme example. We could do something like int age and set that equal to 5. Well, we're basically redundantly putting int here, so when people use age, they know it's an integer. This doesn't add a lot of information. For one, C++ has static type checking, so usually when we use a variable, If it's of the wrong type, we're going to get an error. And 2, it's just extra information we have to type out, which makes our variable names longer. So I'm not going to go with the k prefix for constants. What I'm going to do is I'm just going to leave them as is. All right, so enough jibber jabber. What else do I have to say about constants? Well, their purpose is that we can create a constant and we can use it throughout our code, and we don't have to worry about the value being changed. I have read online that there are ways to change constant values, so I don't know if it's 100% foolproof, but for most practical purposes, we can trust that this value is always going to be 5. The value of this variable will be 5. So we might want to use a value throughout the entire program. For example, we could have some setting that has a possible value of 3, and then anywhere throughout our code, we can get that value. One thing you should know is that if you don't assign to it with the declaration, you're not going to be able to do it after either. So even if we haven't assigned anything here yet, if we try to assign it here and compile, we still get an error. So that is one way to create a constant. Another way that you might see is up here, and it looks something like this. Pound define, and you could create a variable, let's say x, and give it the value 10. Typically you'll see this in all uppercase letters. This was the way it was done in C programming, and it's also valid in C++. Of the two options, I would say the previous const keyword is preferred, mainly because you can put a type with it. So you can go with this technique if you want. I'm going to prefer the const technique because this is going to be scoped to a particular block. So in this case, it's only going to be available to the main function. And anytime you can kind of restrict the scope of something, it's generally a good thing. There is a third type of constants you might see, and those are enum constants. What you can do is say enum and then put curly braces, and inside of here, create your constant. So what we could do is say y is equal to 100, for example. And this is good because we're not going to be able to change it. So if we do y is equal to 50, we're going to get an error. And you can see it's not letting us reassign that value. So when we try to assign another value to y, we get an error. So to conclude, there are 3 types of constants we talked about. We talked about prefixing a type with const. We talked about what's actually known as macros, using the define directive up here. And then we talked about enum constants down here. Which one to choose? That's a research project for you. Most scenarios, they're all going to do basically the same thing. Just choose one you like and go with it. That's all I got for you guys in this video. Please be sure to check out the next video. We're going to talk about something new. It's going to be a lot of fun, so please be sure to subscribe, and I'll see you in the next video. Hey, what's going on, everybody? This video, we're going to be talking about numeric functions, going through some of the most common examples of what you're going to be running into as a C++ developer. Now, the first function we're going to talk about is square root. So you can call it using sqrt and then pass in a number inside of the parentheses as an argument. Now, we can output this using cout. And I'm also going to do an end to L here. Now when you compile this, it's not going to work because we actually have to do an include statement. So go up here and put include cmath, and that's going to give us access to the square root function. Now when we compile, it should work. Awesome. So when we run, we get the value 5. So 5 is the square root of 25. The reason I wanted to start with the square root function is to actually show you guys a special value of the floating point data types. Now, what exactly do I mean? Well, there are special values that you should know about. The first one is not a number. So if we do the square root of a negative number, it's going to produce an imaginary number, which in programming is just represented as NaN, which is short for not a number. So when we compile and run this, we get nan. So that is one of the special values. The other ones are infinity and negative infinity. So how can we get one of those values? Well, we can actually use the power function, and if we just create a large enough number, it'll be infinity. So what we could do is we could take 9 and raise that to the 999th power, and this is just going to print inf. And you can see it's right there. So this is the second important value that you should know about when it comes to floating point values. We can also have negative infinity, so if we took negative 9, you can see that prints negative infinity down here. And these are actually values that are available through constants. So if we don't want to calculate them to get the value, we could actually just use the words not a number in capital letters. And you can see it prints nan. We can also use infinity, the full word,
and that gives us inf. And then lastly, we have negative infinity by prefixing it with the negative sign. The next function I wanted to talk about is actually the remainder function. So what this is going to do is it's going to do division and return the remainder. Now, when you study arithmetic operators, which are used to do math, there's one that's going to be called the modulus operator, which is very similar, but the difference is that the modulus operator is always going to give us an integer value. The remainder function can give us a floating point value. So let's go through an example. Let's say we have 10 and we divide that by 3. Well, the value we should expect is 1, because 3 goes into 10 3 times with 1 left over. And you can see we do in fact get the value 1. Now, if you wanted to use the modulus operator, it would look like this: 10 modulus 3. Now when we compile and run, we get the same exact value. So the modulus operator will work in some situations, but let's go through an example where it's not going to work. What if we wanted to divide by 3.25 and get the remainder of that? Well, the remainder should be 0.25, because 3.25 goes into 10 3 times to give us 9.75, and there's 0.25 left over. Well, but if we compile here, we get an error. In order to do the remainder with a floating point value, we can throw this inside of the remainder function as arguments, like so. Now we should expect the value 0.25, and you can see it works. You may also see fmod, which works similar in nature, and in this situation it's going to give us the same value. There are some minor differences between remainder and fmod, but for most cases it's going to do the same thing. It has to do with rounding versus truncation. Check it out if you want to know more details. I'm just going to stick with remainder for now, as that's working for me. Now the next function I wanted to talk about is actually called fmax, and what this is going to do is it's going to give us the highest of the arguments passed in here. So in this situation it's going to give us the value 10. Compile and run, and we get 10. So that can be useful for some simple comparisons. There is also fmin, and in this case we get 3.25. You can do this manually with comparisons once we talk about comparison operators, but this is very concise, to the point, and very easy to read. So if you're just comparing some numbers like this, this should do the trick. There are also a lot of functions used to basically either crop or round a floating point value. So for example, we could do ceil, and what this is going to do is going to give us the ceiling. So if we have 3.25, it's going to give us 4, and you can see the value here is 4. There is also the floor equivalent, which is going to give us the 3 here. Basically, this will just crop off the decimal values, and you can see we get 3. A function that works similar is trunk, and what's going to happen here? Well, actually the same exact thing. We're going to get 3. If you want to see the difference between floor and trunk, I'll show you a really simple example. Let's say we have the value negative 1.5. If we truncate this, we get the value negative 1. It just crops off the 0.5. If we use the floor function though, let's see what happens. We get the value negative 2. So the difference between trunk and floor is only obvious if we're in the negative numbers. Floor is going to lower the value down to negative 2, whereas trunk is just going to crop off whatever comes after the decimal. So when we're working with negative numbers, ceil is going to give us the same value as trunk. So you can see here, now we're getting negative 1. So trunk is always going to crop right after the decimal value, ceiling is always going to go up, and floor is always going to go down. The next one I have for you guys is round, and this is going to round the value. In this case, it gives us negative 2 because we have 0.5 here, but if we had something like 0.49, what's going to happen is it's going to give us negative 1. So basically what happens, the round function will put it to whatever's closest. Anything under 5 is going to go to this value, and anything over 0.5 is going to go to the next value. So round is basically just going to go to whatever is closest. If we have 0.49, negative 1 is closest. If we have 0.5, then negative 2 is considered closest. That's the dividing point. So 0.49 is the equivalent of cropping, but if we have 0.5 or higher, then there will be rounding to the next whole number, which in this case would be negative 2. Now there are different types of rounding that are possible. If you want to look up some of the different types of rounding, I would encourage you to do that. There is another function, nearby int. And this nearby int function can take into account these different types of rounding.
So if the standard rounding technique is not enough for you guys, nearby int is the tool for you. Go look that up if you want to do a little bit more research. Overall, I covered some of the basic functions and you should be pretty good, but let me tell you guys, there are a lot of functions. Here is an entire list, and you can see it's an overwhelming number of functions. A lot of these do similar things, and some of them are for backwards compatibility with C, so you don't have to worry about all of them. We covered the main ones, including absolute value, remainder, power, seal, floor, trunk, round, and so forth. So yeah, if you want to know more, you can go to this reference here and read through this, but I think that's probably good for now. With that, I'll see you guys in the next video because we're going to start talking about strings, and that's going to be really cool, so I'll see you guys then. Thanks, guys. Hey, what's going on, everybody? This video, we're going to be talking about strings and the string class. It's going to be a lot of fun. There are basically two ways to use strings inside of C++. One of them is basically a backwards compatibility with C, which is usually called C-style strings or just C strings. And then there is the string class, which is the C++ way to build strings. We're really going to be focusing on the C++ way of doing things, but you're probably going to see C strings, so you should probably know that they exist at least. So I'll try to call out any differences between the two, but the main thing you guys need to know is that the string class is superior in all ways to the C style of strings. So don't go down that route even if you're more familiar with it. If you're coming from C, you need to learn how to use the string class of C++. So if you haven't used either and you just need to get started somewhere, then this is the video of choice because we're going to be teaching you the right way to do it. First thing you need to do is include string. So it's going to look like this. That's going to give us access to the string class. So we can create a string by saying string, giving it a name, and then assigning it a value. So this here is a string literal, and we are allowed to create a string object using string literals. So this greeting is going to be of type string. This means it's an object of the class string. So someone built this string class, which has a bunch of capabilities for working with strings, and we're just utilizing this class by creating an object, an instance of this class. So greeting is an object that we can now use inside of our program. Now a string is basically a sequence of characters. It's literally characters strung together, and we can access the individual characters using an array-like syntax. So if we wanted to access one of these characters, what we could do is say greeting, and then inside of square brackets we can put a number such as 0. Now when we compile, we actually get an error, and that's because you have to prefix string with standard. So string is part of the standard namespace. If you don't want to have to prefix that, go up here and say using standard : string, like so. Then you don't have to prefix string here. So now when we compile, it works, but in general, I'm going to be prefixing things over using the using statements. So I'm going to go down here and prefix this with standard. Now when we compile and we run, what happens is we get H. That's because this 0 is telling us to grab the first character, H. It's 0 based, meaning H is 0, and it counts up from there. So E is 1, and so forth. Now another thing you should know is that the default value for a string is an empty string. So if we declare the value, and then let's just say we output the entire string without the square brackets there, when we compile and run, all we do is get an empty string. An empty string, by the way, is this here. 2 quotes, nothing in between them. This is in contrast to other languages where if you declare a string and you fail to initialize a value to it, if you try to use it, you might get a compiling error. C++, on the other hand, just defaults it to an empty string. The next thing you should understand is there is string concatenation. So when you use a plus sign with strings, it does something known as concatenation, which is just combining strings. So I could add another string in here, such as there. And what this is going to do is just combine these strings together. So let's say this one is hello, and then we concatenate there to the string, and it says hello there. We're doing that inside of an expression here, but we could assign that to another string. So for example, I can cut that, go up here, create a new string and say complete greeting, and assign that greeting plus there. Then when we output it, we could just say complete greeting, like so. And you can see it gives us the exact same result. We can also append to a string, which is very similar to concatenation, but it's just going to append to the original variable. So what we could do is say complete greeting plus equals, and then put an exclamation mark, for example. This is going to append this exclamation mark to the end of this variable. So now when we compile and execute, we get hello there with an exclamation mark. Now because string is a class, it has members. When you build a class, you put things inside of it that allow the user to work with the class when you create an object of the class. So in this case, we're creating a string object, and that object is going to have members inside of it. What exactly do I mean by members? Well, we can have functions that are tied to the string class. And we're going to go through an example of that. So if we go down here and do another cout, what we can do is we could say complete greeting dot, and then add a function here such as length, and then we'll just put a new line at the end. So what is going on here? Usually when we have a function call, we just leave it by itself, but here we're actually attaching it to an object. That's because length is a member of the string class. And that's going to become a lot more clear once we define our own classes. You can see how that works. But for now, just understand that functions can actually come from classes, and we call them by using the dot operator on an object and then putting the function name. So let's run this, see if it works. I got an error because I forgot to put an L there. Awesome. Now when we run, we get 12. This is the number of characters inside of the string. We got 5 here, a space, and then another 5, that's 11, plus an exclamation mark, that's 12. So now you understand that we can call functions attached to objects using the dot operator. Now there's another term you should understand, and that is method. You can think of this as a member function. So when a function is a member, we're just saying that it is part of the object because it was defined in the class string in this case. So methods are just functions attached to objects. You'll often hear the terms used interchangeably. Functions are just by themselves. Methods are attached to objects using the dot operator. Now, if you're new to object-oriented programming, this might be a bunch of junk that you don't understand, and that's totally fine. Right now, just start familiarizing yourself with the syntax of calling functions attached to the objects, and later on when we talk about object-oriented programming, I'm going to clear all of this up. Yes, this can be complicated, but it's still significantly easier than the way you have to deal with strings inside of the C programming language. So if you wanted to see a brief example of a C string, what you have to do is you have to say char and then give it a name and use square brackets, and then you can assign it a literal value such as Caleb. This square bracket thing means it's actually an array. So a C style string is just an array of characters. This works, but there's a lot of limitations. For example, the string size is not easily changed. When we assign a string literal such as Caleb, the size of name is going to be 6 characters, and those 6 characters are going to be C-A-L-E-B and then \0, which is the null terminating character. That means the amount of memory that this name has is limited to 6 characters, and we can't assign it another value that's larger than that. So if we try to do something like name is equal to Taco Bell, what's going to happen is we're going to get an error when we compile. And you can see array type char 6, it's size 6 characters long, is not assignable. So we can't even change the value of these, even if it's shorter. If we just give it the value t, nothing. It's not going to let us. So that's one of the downsides with the C style strings. C++ strings with the string class are not like that. So for example, we have this complete greeting here. We can actually change that if we want. We could say complete greeting is equal to go away. And if I comment out this error here, you can see we can compile with no problems. Awesome. So you can see that C strings are a little bit more complicated and not as easy to work with. The string class is much more flexible and is the recommended way to go. Now what happens if you want to get a string from user input? Well, let's clean all this up. Let's just go back to our one string called greeting. And we'll just get this from cin. So let's get rid of this assignment and we'll just declare it. So we're going to have standard cin and we're going to store that inside of greeting. Then what we're going to do is we're going to output that like so. When we run, we can put a value in here. Let's say hello there and press enter. What it outputs though is only hello. What's going on here? Why is it just saying hello when we clearly said hello there? Well, that's because the cin object only grabs the first word. So it basically looks for a space. Once you put a space, it stops. How do we fix this exactly? Well, that's actually the subject of next video, which is going to be how we get user input for strings. Definitely check that out because if we can only get one word at a time, that's going to be very limiting. You'll definitely need to watch the upcoming video if you want to strengthen your C++ development. So thank you guys. If you've enjoyed this content, please consider subscribing and I'll see you in the next video. Hey, what's going on everyone? Welcome back. This video, we're going to be talking about how to get user input for strings. That's because when we use the cin object, it only grabs the first word, which is very limiting. So we're going to talk about how to get around that. So to review, let's try to get user input using cin. And let's say we store this inside a greeting. Well, when we output this, what's going to happen is it's only going to have the first word. So we run this and let's say, hello there. But it only prints hello. That's because hello there is not being stored in the string, only hello is being stored in the string. That's because the cin object needs to know when to stop. How does it know when to stop user input? It could stop on a period. It could stop on the null terminating character, or white space. Obviously they chose white space. So if we put in a space, a tab, or a new line, it's going to end. So let's try another example where I say hello, put a tab, and then say there. And it still only stores hello. So what happens to this other word there? Well, this is actually still waiting to be stored somewhere. It's still in the input stream. So what happens if we try to get another string, it's just going to get there. So let's try that out. We're going to create another string and we're just going to call it leftover. And we're going to get this from console in, like so. And then after we put out the greeting, we're going to output the leftover, like so. So we say hello there. The first time it prints hello, and then the next time it prints there. So when we did that second console in, it didn't even ask us for anything. It just automatically grabbed what was already there, which is actually there. So how exactly do we get multiple words? Well, the appropriate way to do it is actually with a function called getLine. So it looks like this. GetLine, and then we pass in console in, and then we pass in the variable greeting. Make sure you prefix that with standard. And then what we're gonna do is output, like so, and then compile and run. Now it's asking us for input. We're gonna say hello there, and you can see it prints the entire thing. There is another getLine you might see, and it looks like this, cin.getLine. This is a little bit different, and you use this version if you're trying to get strings. You can use this version if you're trying to get numbers, for example. The reason is because this getLine was created before the string class, so it understands how to get ints and doubles and so forth, but when it comes to strings, we actually use this other function getLine up here. So that is how to get an entire string from user input, not just a single word. There are a lot of variations of how to get user input and different functions you can use. This is just one simple one you should know, but if you want to know all the others, you can look up all kinds of different input stuff. We might deep dive on user input later, but for now, we know how to work with strings and we're going to go on to something new. What exactly are we going to be talking about next? We're actually going to be talking about string methods, or member functions, as I mentioned in the previous video. So that's going to be a lot of fun. Encourage you guys to check it out, and please be sure to subscribe if you've enjoyed this content. Hey yo, what's going on everybody? This is Caleb. In this video, we're going to be talking about string methods. Now the first thing I wanted to talk about in this video is a method we already talked about, which is string length. So we can go in here and put .length with the parentheses. This is an example of a method. It's basically just a function attached to an object. The object in this case is greeting. Now this is going to give us the number of characters in the string, which in this case is 0 because we didn't assign anything. There we go. Now we have 5. So you might see length inside of C++, but another one is size. And these do exactly the same thing. I think it's just a naming thing so that if you're used to using size, you can use it here, but if you prefer length, such as other languages might use, then you can use that instead. So those are your first two methods, length and size. They don't do anything too crazy, but they're a lot of fun because they give you back the length of your string. Now the classification of methods we're going to be talking about in this video are known as modifiers. They modify the string that we're working with. The first one we're going to talk about is append, and we're actually going to do it up here so we can output it here. So let's just output greeting and just go through some examples. So we can do greeting plus equals and then put another value here. And this is going to append to the original string, meaning it changes this variable here. So we don't have to assign this back to greeting or use it in another variable. We can just do it like so. And you can see when it outputs, it keeps there inside of that greeting variable. So that actually modifies the string variable. Now there is another way to do that, and it's with .append, like so. And what we can do is just put a value in here like so. When we compile and run, it works exactly the same way. So which you prefer is totally up to you. I like to use the plus equals. I think it's a little bit more universal. So that's what I would recommend. The next one is insert. So what we do is we give it a position. So let's say we want to put this at index 3, and we're going to input the value. Let's put a bunch of spaces so we can easily see it. So index 3, 0, 1, 2, 3. So everything at index 3 and on is going to be pushed over. So the string should be inserted between the two L's. So basically what this is saying is that at index 3, we want this string to be there. We can put a semicolon there. Now let's compile and run. And you can see the first letters are here. There's a giant space, which we inserted, and then there's low. The next one is erase. So if we wanted to erase that, what we would do is say greeting.erase, give it a position, so let's say 3. Then the next argument is actually the total number of characters to remove. So I can't really see that too well, so let's just make it easy and get rid of some of them. So there's one space here. So if we wanted to remove one character, we would put a 1 in there. Now when we compile and run, it should just say hello. And it does. These might be useful if you're going through some data and you want to modify it in some way. For example, if you want to insert some kind of delimiter in a string to separate things, or if you want to get rid of a delimiter, you can do that with these two functions. Now, if you want to delete the entire ending, you can get rid of that length there, and what's going to happen is everything after that position is going to be removed. So we're just going to have HEL. And there you go. Now let's say you wanted to remove the last character. What you could do is actually use the string length in here. So we could say greeting.length and then do -1. So that's going to get us the last index. The reason we have a -1 is because length does not start from 0, whereas indexes do. So the string length of 5 means the highest index is 4. Before we run this, I want to get rid of this insert here. So let's just work with this hello. Let's say we want to get rid of that O. We compile and run this, and we get a little bit of a, bad word here. Sorry about that. But that is how you remove the last character. This must be pretty common or something, because there's actually a dedicated function for removing the last character. So if you wanted to do that, you just say pop_back with nothing as an argument. When we run this, it works just the same way. So that's a little bit prettier. The other one's a little bit more customizable because you can start at a different position, but pop back's pretty simple if you just need to remove that one character at the end. Now this is a little vulgar, so let's change this up a little bit. We could use the replace function to change a string. So we could say greeting.replace. The first argument is the starting index. The second argument is the length. So we could change the first 4 characters. And then the next argument is what we want to replace it with. So we could go in here and say heaven. So what this is going to do is it's going to delete the first 4 characters and replace it with heaven. Obviously this is kind of silly because we could just completely erase the string, but this allows us to be specific if we have a word inside of another string. So I'll show you what I mean in just a couple of seconds. Let's run this, make sure I got it right. Yeah, definitely make sure you spell it right. It's kind of important. Now when we run, we get heaven. Now, I'm not usually one to use language in my videos, but I want to illustrate something. If we had a string that was being used, let's say we were making some kind of social platform, and we wanted to implement some kind of censorship, well, we can use these functions to do such a thing. So first off, when we're working with these strings, we're not going to know the position of any kind of language that we want to censor. In the next video, we're going to be talking about how to search a string for particular words. So if you wanted to build an application to basically censor strings, you could do that very easily using a combination of these functions. So in this situation, let's just assume we already have that index, we found it, we can replace it. So the H is actually at index 9, and we can replace it like so. And there we go. That sounds so weird. But you could do something else. For example, you could replace it with asterisks. So this is good, practical, useful information for when you want to create an application. This stuff might actually come up, especially if you're building a game where there might be younger people involved. Or you might have settings to turn foul language on or off. So now we understand how to replace parts of strings. In the next video, I'm going to be talking about how to find a particular string inside of another string. So it's going to be a lot of fun. These are going to go into the functions that don't modify the string directly, but instead return some value or a modification. A little bit different than the ones we've been talking in this video, which are modifiers. They change the original variable value. So check out the next video if you've enjoyed this content. Please subscribe. Once again, sorry for my language, but this is practical, useful information. So thanks guys, I'll see you in the next video. Hey, what's going on everybody? This video, we're going to continue our discussion of string functions. Specifically, we're going to be talking about how we can censor strings, essentially, because as you can tell, I'm using very vulgar language. And these functions are very useful for all kinds of different things. So even if you're not doing this exact thing, you can think of them more generally because I know they're going to come up in the future. So the first thing, I'm going to get rid of this pop back call. That's going to delete a character, which we don't want. And now what we're going to do is we are going to search for this language here. What we're going to do is say greeting.find and then put a string in here such as hell. Not hello, hell. Okay, so what this is going to do is it's actually going to return an index, meaning we have to do something with that value. So what I'm going to do is I'm actually going to cut this and replace this 9 with this function call. It should return the value 9, so it should work exactly the same way. So let's save and run. And you can see it worked. Awesome. So that is the basis for building a replacement system. You could make this a little bit more complex. For example, you could search for other words, and then you could basically extract it into a function saying clean language, and then throw in the string you're trying to clean. Bada boom, bada bang, you got the end result. Obviously, there might be more than one use of a foul word inside of a string. So if you're trying to replace multiple, you're going to need loops, which we're going to be talking about pretty soon. But for now, I want to go over some other functions you're going to run into. So instead of using this foul language, let's just say, what is up? It's a little nicer. The next method I wanted to talk about is substring. So it's substr, and then inside of the parentheses, we are going to pass a position. So which index we want to start at. Let's say we want to grab the word is. That is at index 5 and it's 2 characters long. When we run this, we get the word is. This method is useful if you want to extract part of a paragraph, for example. Rather than taking an entire paragraph or an entire string, we can just get a part of it. There's another function you might want to know, which is similar to the find function we just talked about, and that is find first of. The difference here is that find first of is going to search for any character in the string we give it. So let's just go through an example. What we're going to do is use find first of, and then we could pass in a string in here such as the vowels. So any vowel that is in here is going to be found. So when we run this, we get the value 2. That's because A is at the index 2. If whatever we put in here is not found, let's say an exclamation mark, we get this huge number. And what the heck does this mean? Well, this can be a little bit confusing, but I'll try to explain because you might run into this in the future. This number here is actually the equivalent to what's known as NPOS, which means it wasn't found. The reason NPOS gives us this huge number is because NPOS is actually -1. When we call this find first of, it's going to return us the index, but this number is actually an unsigned long. So if we create a long variable and set that equal to -1, but the thing is it's unsigned, and an unsigned value can't store negatives, it's actually going to wrap around and give us 1 lower than the absolute max value, which is why we get that weird giant number. So you can see here I'm going to output x, and when we run this we get 2 exact values. The first one is this NPOS that's here, and then the second one is an unsigned long assigned -1. So that explains why this weird number, but what exactly is NPOS used for? Well, it's actually used for testing. So later on we can do if statements such as searching for characters and then see if that equals -1. Like so, we're checking to see if it's -1, and if it is, we say not found. When we compile and run, we get not found. So that is how you use the NPOS. We just see if it's equal to -1. If it is, then it's not found. So later on, you're going to want to do string comparisons, and we're often going to do that inside of an if statement. So you might see something like greeting equals equals, which is going to compare, and then some other string. What I'm going to do is I'm just going to do this all in one line, do a cout that says equals. So when I run this, nothing happens. But if these are equal, like so, we should get the output equals. So you can see this double equals is used to compare the value of strings. The reason I'm bringing this up is because you will often see another way of comparing strings, and that is the dot compare method. So it looks like this. and then you put the other string inside of the argument, like so. If we output this, nothing happens, because what actually happens is this is going to return 0 if it's equal, so we have to see if it's equal to 0. Yeah, it's confusing, I know. So now when we run it, we get equals. Okay, so let me break this down a little bit. There's two ways to compare strings. One is using the double equals operator. That's the best way to do it, and that's what I recommend. The other way is to use this compare method, which will return 0 if they're equal. There are reasons you might want to use the compare method because it'll actually tell you which string is considered first in the comparison by like the alphabet. But most of the time you're not going to need that capability, so I recommend just using the equals equals operator. The other reason I bring up the compare function is because you might see this in other languages such as Java. In Java, you need to use the .compare method, and you don't want to use the double equals operator. In C++, when we use the double equals to compare strings, it's actually comparing the value, but in other languages, particularly Java, it compares the object to see if they are the same entity, which is different. So don't worry about it in C++, I'm only throwing that out there if you come from a Java background or if you think you'll be using Java in the near future. .compare is really important for Java, it's not super important for C++, and I would say the recommended way is just to use the double equals like so. Now this did go into some other stuff like if statements and comparisons that we haven't really talked about, so if you don't know what those are, don't worry about it, we're going to be talking about it soon. But just thought I'd throw that in here for completeness if you guys are jumping in this after you understand all that stuff. That's all I got for you guys for string methods. In the next video, we're going to be talking about literals. It's a very good video, so please be sure to check it out and consider subscribing as it really helps out this channel. Thanks guys, I'll see you in the next one. Hey, what's going on everyone? Welcome back. This video, we're going to be talking about constants, specifically literal constants. So previously we did a video over constants and the different types. There are literal constants, symbolic constants, and macro constants. So the ones we're talking about are literal constants, which are literally just values, things that are hard-coded in our code. So why exactly do we need an entire video to this? Well, there are actually a lot of different types of constants. Usually, most of the time, we don't really have to worry about it because it's going to work automatically, but you should definitely know that these things exist because you're probably going to run into them in your C++ development. There are also constants for different bases. So for example, there are constants for hexadecimal numbers and octal numbers. It's important to familiarize yourself with these things, so we're going to go through it and see what we can come up with. The first type of constants that are very simple, we're not going to spend much time on this, is quoted constants. We have characters, such as a C, and then we have strings, which have double quotes, such as C. Now there are three other quoted constants that we haven't talked about in this series, but you might want to know they exist. That is wchar_t, char16_t, char32_t. These are constants used for Unicode. Unicode allows us to create applications that support multiple languages. You definitely want to research those if you're interested. I'd recommend char32_t. This will allow you to make more universal applications. Most of the stuff we're doing in this series really isn't going to be doing anything with different languages, so we're not going to be covering those, at least not yet. For now, we're just going to be using the basic char and string, which will cover everything we need. Now, when it comes to numbers, there are actually a ton of different data types, as we have learned. So for example, when we have the value 5, this is an integer, but there are a lot of different integral data types. Sometimes you're going to want to specify what data type you're trying to use. So for example, we could put a u at the end of this to say that this is an unsigned integer. When would you do something like this? Well, for example, you might be using a special keyword called auto, like this, and in this case, what's going to happen is it's going to determine the data type of this variable based on the constant value over here, the literal value that we're assigning to it. Now this is actually a C++ 11 feature, so what you actually have to do when you compile this, you need to say g++, the name of the file, and then put hyphen standard equals C++ 11, like so. When we compile, it works. If you don't put that on there, we're going to get an issue. You can see it says auto type specifier is a C++ 11 extension. So yeah, definitely make sure you compile with that C++ 11, but if you guys are in a class for school, make sure this is okay with your professor, because no kidding, I used a C++ feature in one of my C++ classes, and I got a 0. So I had to go through a really long conversation with the professor about how what I did was fine. He didn't like it, but
Eventually he ended up giving me credit, but definitely make sure that you are in the okay to use C++11. I think part of the reason is that he just had TAs grading it and they were just compiling it like normal and it wasn't working, so then they just gave me a 0. So the way the auto works is that it looks at the constant value and makes that the data type of X. Things are still statically typed, so X still has a data type and we're still restricted to storing that data type in X later on. So just because it has auto doesn't mean we can do something like this. This is still breaking the rules because X is going to be assigned an unsigned integer. That means X is typed to an unsigned integer and we're restricted from putting something like a string in this variable. The different constant types can also come up when it comes to method overloading. So for example, if you create a method which is just a function attached to a class, you can have different versions of this function that gets called differently depending on the data type of the arguments. This is like really specific stuff and probably isn't going to come up until we talk about method overloading. So if you don't really understand what I'm talking about, don't worry about it now. Just understand that there are different data types when it comes to constant values, and sometimes it's important to be very specific on what we're trying to do. If not for a technical reason, maybe it's just for clarity for the people reading the code, which is also very important. So not only are we limited to the U for unsigned, but we can also put L for a long. So now this is going to be an unsigned long, and then we can put 2 L's for unsigned long. You can also append letters for floating point values. So for example, we might have 5.0. Well, we can append an F to specify, hey, this is a float. If we do nothing, it's a double. And if we do an L, it's a long double. The actual value here is not necessary. So for example, you could have 5 point, that works just the same, but you will often have stuff after the decimal, such as 5.5. Now, let's move on to the next section and talk about hexadecimal and octal. Now we're going to be talking a little bit about hexadecimal and octal. If you're new to this, don't worry, don't feel like you have to be an expert. Basically, hexadecimal and octal are 2 different ways of counting numbers. We are used to counting in groups of 10, so multiples of 10. We count all the way from 0 to 9, and then once we hit 10, we add a new position, and we have 1, 0, 10. Then we keep counting, and eventually we get to 100. And then 1,000, and then 10,000. Every time we add a new number, it's a new multiple of 10. Well, octal and hexadecimal work similarly, but the numbers are different. So let's look at this column here, hex first, and then we'll worry about the octal column. So let me zoom in here. Hexadecimal is base 16, meaning there are 16 different possibilities, and every time we add a new position, it's a multiple of 16. So for decimal, we count from 0 to 9 and then add a position. Hexadecimal, we go from 0 to 15, which the numbers 10 through 15 are represented A through F. Then when we want to represent 16, we add another position and go back to 1, 0. And we repeat that process, we count another 15, and then we go to 2, 0. Octal works in a similar nature, but it's base 8, meaning we go from 0 to 7, 8 different possibilities. When we hit the value 8, we go to 1, 0. Then we keep counting and eventually we get to 2, 0. Basically, when we go to a different base, each position represents a multiple of a particular number, whatever the base is. So in decimal, it's 10. So for example, if we have the number 24, it's 4 times 1, 2 times 10 to give us 24. In hexadecimal, it's 8 times 1, and then 1 times 16, which would also give us 24. In octal, we just have 3 times 8. Yes, I agree, it is a bit confusing at first. Basically, it just takes a lot of practice going from one base to the other and starting to become familiar with how to work with these bases. I have videos dedicated to hexadecimal and octal if you want to know the deep dive, but that's really all I'm going to give you in this video. Now what I want to talk about is how we can create literals for these different bases. Let's go back to our code here, and what we're going to do is we are going to create a new number, and we're going to set that equal to the value 30. And this is in base 10. So this literally represents the value 30. So let's compile this and run this now that we're doing an output, and it prints 30. Now if we wanted to make this a hexadecimal number, we prefix it with a 0x. So now what we're saying is that this is a hexadecimal number. It's no longer 30, it's actually 16 times 3, which is going to be 48. Now when we output this, it's going to output it in decimal, so it should be 48. And you can see we get the value 48. Lastly, if you wanted to do octal, you just prefix it with the 0 and get rid of the x. So now we're basically saying this is 3 times 8, which is going to be 24.
It'll also print in decimal, so it should be the value 24. And indeed, it is. So that is how we can convert from hexadecimal and octal to decimal. If you wanted to print the number in octal or hexadecimal, we can actually do that. So let's say we wanted to go from decimal to hexadecimal. Well, we start with the value 30, and what we do is in these arrows, we just say hex, and then put another 2 arrows. This is from the standard namespace, so you need to prefix it with standard. And when we run this, we get the value 1e. E is 14, and then the 1 here means 1 times 16. 16 plus 14 is 30. So 30 is represented as 1e in hexadecimal. We can do the same thing with octal by replacing hex with oct. Oh my gosh. And then we get the value 36, which is 30 in octal. So this is just 6, and then the 3 is 3 times 8, which is 24. 24 plus 6 is 30. So that is a little bit of an introduction to conversion between different bases. Hopefully this video wasn't too much, and hopefully it wasn't super boring. Basically, this is just some information you might run into later on. C and C++, it's actually pretty important to know this stuff because often these programming languages are used for lower level stuff. So you might be using these things for memory addresses and so forth. Keep it in mind, maybe go through this video and practice a little bit, converting between one base to the other, and have a little bit of fun with it, guys. Don't forget to check out the links in the description, and I'll see you in the next video. Peace out.
Hello, humanoids. Hello, everyone. Welcome back. This video, we are going to discuss the topic of expressions, operators, and operator precedence and associativity. Bunch of fancy words means really simple stuff. So we're going to go over it. It's going to be lots of fun. Now, what is an operator? The very simple example is doing addition. The plus is an example of an operator. I think we talked about this already in the series, and this stuff's pretty basic. The fives are an example of operands. So what an operator is it'll do something on operands. In this case, it'll add them together. Another operator you've seen is the assignment operator. So if we do something like this assignment operator will assign 6 to the variable x. Well, there are all kinds of operators inside of C++ and in programming in general. You can go through all of them if you desire. Just look up C++ operators and learn every single one of them. What we're going to be going over in this video is we're going to touch on some of the arithmetic operators, which is really simple, should only take just a minute. And then we're going to be talking about operator precedence and associativity, which is a very important piece of C++ programming and basically every programming language in existence. So first off, let's go through creating a variable. We can still name it x, and we can assign it a value, but instead of putting a literal, what we're going to do is we're going to put what's known as an expression, such as 5 plus 5. So an expression is basically when we use these operators to evaluate to a single value. In this case, 5 plus 5 is going to evaluate to 10, and 10 is going to be assigned to x. Well, the plus operator is just one of the operators you should know about. There's also the minus operator, which will give us 0. There's the multiplication operator, which will give us 25. And there is the division operator, which will give us 1. Now, the very important thing to know with the division operator is it's going to use integer division if you're dividing with 2 integers. So what exactly do I mean by that? Well, let's say we had the value 10, and we wanted to divide this by 4. Well, you would naturally think this would be 2.5, but it's not. When we output this, watch what we get. You can see we get the value 2. So originally we had 2.5, but this is a floating point number, and it's not going to work when we're using integer division. So it basically crops that to 2. I'll show you how to fix that, but I just want to show you guys that even if we store this inside of a double, we're going to get that same result. We still get 2. So in order to fix this, we need to put a dot on one of these, or a .0, to say that this is a floating point value. Now it's going to use double division, and it's going to be stored inside of a double, so it's going to maintain that double status. So now when we compile and run, we should get 2.5. So you can see here the importance of understanding how the operators work to make sure we get the correct results, you know what I'm saying? Last one I wanted to talk about is the modulus operator. So the modulus operator, the way this works is it's going to do division and keep the remainder. So 10 divided by 4, what is the remainder of that? Well, 4 goes into 10 2 times with 2 left over, so we should get 2. And indeed we did. Now this operator is one of those magical operators where it seems kind of simple and not that useful at the beginning, but there are tons of algorithms that take use of the modulus operator. So make sure you get some practice with, oh my gosh, Claire, really? hitting up my Instagram, kind of slide into my DMs. I don't even know what I was saying. Basically, you should understand the modulus operator. Now let's talk a little bit about operator precedence. This is the order in which things get evaluated. So here's this big chart you can look at and bore yourself with, but basically everything is grouped into these precedence containers. So the very first precedence is the scope resolution operator, then the next group, and then so forth. So the ones we're working with are right here. So we have multiplication, division, and remainder, and then addition and subtraction. So multiplication and division happen first. As you guys know from math class, they have that PPMDES, or what is it? Parentheses, powers, multiplication, whatever. Basically the order of operations. So if we go in here and make this 10 plus 4 divided by 3, the 4 divided by 3 is going to happen first. And you'll definitely want to make sure you have one of these as a double if you want to use double division. So if you wanted to visualize this, you can put parentheses around this, which is legal, by the way. So you can compile, it's going to let you do that. So if you want to be very explicit on what you're trying to do, make sure you throw them parentheses in there, not only for your sake, but for other developers' sake who are going to have to read your code. Because sometimes you get these crazy algorithms and when you make them, it makes sense, but then a year down the road, you have no idea what they're doing. So that's the concept of precedence. The next one is the associativity, which is the direction that these get evaluated in. So for the example of the arithmetic operators we've been using, it's left to right, meaning if we have two that are in the same precedence group, then it goes from left to right. So let's go through an example. If we have 10 times 4 times 3, it's going to automatically be grouped like so. The 10 times 4 is going to happen first. Now that only happens if they're in the same level of precedence. So it's kind of like a tiebreaker. When two things have the same precedence, we either let the one on the left go first or the one on the right go first. The associativity we're most familiar with is left to right. It's the most natural, but some of these are right to left. So for example, the assignment operator. This one is right to left. This can be a little bit confusing, and honestly, most of the time you're not really going to have to worry about associativity. If there's ever a point where it's not clear, just be explicit and add those parentheses in anywhere you want things to happen first. But let's go through an example with the right to left associativity with the assignment operator. Let's say we have a double x and we have a double y. And let's say x is equal to 10. Now what I'm going to do is this. Here, just copy this here for a second. There we go. So what exactly is going to happen here? Well, let's do some output and see the results we get. So we're going to output x, then we're going to put a tab, and then we're going to output y. Well, I can tell you what's going to happen. Because the associativity is right to left, the grouping is going to look like this. So 100 is going to be assigned to x, and then that value is going to be assigned to y, so the values are going to be 100 and then 100. We run this and we get 100, 100. Awesome. Let's say in theory it was left to right, the grouping would look like this. And in this situation, y would be assigned the value 10, and then y would be reassigned the value 100. So it would be like this. Y is assigned x, and then y is assigned 100. If we broke it out into two separate statements, these are the two statements it would produce. So in this situation, x doesn't actually get reassigned anything, so it should remain the value 10. And you can see we get 10 for x and then 100 for y. So that is how we can see associativity in its importance. Most of the times, the things we're going to be doing is left to right, but you should understand right to left as well. And if you ever need to force a certain evaluation order, you can use parentheses to do that. Such as in this situation, I made the left one happen first using parentheses. So that's all I got for you guys on operator precedence and associativity. Hopefully this video was super awesome. Check out the next one because it's going to be even greater because we're going to be talking about probably typecasting and type promotion. But we'll see when we get there. See you guys in the next one.
Hey, what's up everyone? Welcome back to your C++ tutorial series. At the end of the previous video, I said I was going to talk about casting, but I changed my mind. So this video, we're going to be talking about just some review of what we've talked about and what is going to be coming up in the next videos. So this is a pretty good section ending point where you can kind of review everything you did and prepare yourself for the upcoming content because it's different in nature. We spent a big section of our time on understanding the basic data types, and there are a lot more data types. For example, just arrays and vectors are very important, as well as custom classes.
We are going to get into that, but we're going to take a break from types because it's honestly kind of boring, but other reasons too. We need to understand some fundamental programming concepts that are different than just data types. So it's important, but we're taking a break. So if you want to get back into types, make it through this section of content and then we'll go into custom types, arrays, and all that good stuff. So one of the first things we talked about is what a function is, because we start with the main function. The main function has a return type of integer, which helped introduce the concept of types. What does it mean by returning an integer? Well, we give a return statement at the end of our functions, which return a value of type int. The main function is special because we define it, but it is called automatically, so we don't have to call it. It's called when we run our program. And how do we run our program as a little reminder? Well, we use G++ to compile, which will create a file which is called a.out, and then in the console you just put ./a.out. You can customize the name of that there using different flags for the compiler. You can look that up if you really want to make an official app and you don't want it to be called a.out. Even though a.out is a sick name, totally unique. Then we touched a little bit on input and output with cin and cout. These were objects made available to us in the standard namespace. So we have to prefix it with standard or use a using statement, which we talked about those as well. For cin, we have to use the greater than signs, which will direct from the input to a variable. So we put a variable name right here. Cout is different in that we use the arrows towards the console and we give it a value to print here. When we first start, we just have a very simple main function going through examples, but as we go on, we basically use this main function as a starting point and call other functions in our program. Especially when we have custom classes, these classes can have functions attached to them which become methods. So a little refresher on object-oriented programming. We have a class. Inside of that class we have methods. So when we create an instance of this class, we create an object, and this object is going to have that method available to us. Once again, we're going to deep dive object-oriented programming soon, but not quite yet. When we're working with functions besides the main function, we'll typically have three parts. Okay, I got tired of writing. Declaration, definition, and the calling. Now, the way we've been doing it, we've been doing the declaration and the definition in one, and the way you do that is you define your function at the top of your code, so that way it counts as a declaration and a definition. You may see those separated out where the declaration's at top and then the definition comes later on somewhere in the code. Or the declaration is in a different file and the definition is in its own file. When we have a function, we put parentheses here. When we're defining it, the variables here are known as parameters. When we're calling it, it's known as arguments. So when we define it, it's going to look something like this, such as int x, and then when we call it, we can pass in a value such as 5. This is an argument. That argument gets stored in the parameter for the function. That's how arguments and parameters work. We went pretty deep on types. I'm not going to go over all of that again, but basically we have integral types, then we have floating point types, and then we have the char and string types. Floating point numbers allow for something after the decimal, but they can only be trusted to a certain level of precision. Float is the worst, double is better, and then long double is potentially better than just double. Then we touched on constants and learned about 3 types of constants. There's literal constants, such as a value such as 5, 5, and then there's symbolic constants, which we prefix a variable with the keyword const, such as this. So x here is a symbolic constant. Then we even touched on macro constants, which are defined at the top of your code outside of your functions. Those work as well, but I think in general it's preferred to use the symbolic constants. We actually talked about a 4th type, which is to use an enum to enable us to have a constant. Lots of different ways to create constants. The one I'm primarily going to use is right here. So make sure you go refresh on your constants and understand how to do those. And then we touched a little bit on operator, precedence, and associativity. I think we literally just talked about that, so I'm not going to go over that a whole lot, but basically everything has a precedence group, and if 2 things with the same precedence are in the same expression, it's either evaluated left to right or right to left, depending on the associativity. So that is kind of like a crash course review of everything we talked about. You'll definitely need to go refresh if any of those are like completely new to you. And then for what's coming up, we're going to be talking about control flow, which consists of branching and looping. It's going to be lots of fun. Then I would like to get a little bit back into types with arrays, vectors, and custom classes. There's a lot coming up, and once we get into the object-oriented stuff, it gets a lot of fun. So stick with it, guys. Don't quit. Don't be lame. I'll see you in the next video. It's going to be a lot of fun. And yeah. That's about it. Hey, what's going on, everybody? Welcome back to your C++ tutorial series. For those of you who have been around for numerous years, you might realize that this is my classic setup. So this is where it all began. So I'm going to be using the studio for some of these in-person videos. It should be a lot of fun. And what are we going to be getting into? Well, we're actually going to be getting into a lot of new stuff, specifically with branching and loops, control flow specifically, and how to take all these concepts and apply them to a real-world application. So we're going to be creating a very simple application that takes these concepts and uses them to make something pretty cool. We're going to make a little bit of a game. I mean, it's going to be console-based, so it's not going to be like Call of Duty or anything, but it's going to be pretty sweet. So I'm pretty excited, and I hope by applying these concepts, it helps you learn them a little bit better. So what are we going to be talking about in this video? We're going to be starting our discussion on control flow. This is one of the coolest topics in C++, and not just C++, because these concepts are going to apply to basically any programming language. I'll try not to keep it too general though. I'll give you some key tips that I have to tell you guys about C++, and we'll keep the concepts generally thin, and we'll go into the hands-on stuff really soon. So in these next upcoming videos, we're going to go over the main control flow structures and just get them down, and then we're going to apply those to an application. So where do we start? Well, there are two main categories of things you need to know. Well, these are both within the bigger category of control flow. Now within control flow, we have what you could call branching, I guess, and then what you could call looping. So branching is where you do conditions, and you'll branch your application to do different things based on the result. Looping is similar, but what it's going to do is it's actually going to repeat the same thing and basically loop through a section of code a certain number of times. And these are basically the fundamental pieces to make more complex applications, right? Because putting some input and doing a calculation and getting some output, that's cool. But what we really want to do is we want to make an application that will be able to run indefinitely, will be able to basically interact with the application. And that's only made possible with control flow statements such as branches and loops. Now when it comes to branching, the main things you guys need to know about are if statements and switch statements. And we're going to be talking about both of these. Now when it comes to looping, the ones you should know about are while loops, for loops, and do while loops. So we're going to talk about two main branching techniques and three looping techniques. Those will be the concepts, and then we'll take those and we'll apply those to an application. So where we're going to start? We're going to start with branching. So this video is going to be about if statements and switch statements. Very brief, we'll get into the concept here, and then in the next video we'll go through coding an if statement, and then we'll go into switches. So very simple. The way this works is you say if, this is a keyword, so you type out if, and then you put parentheses. And here you put some expression. And I'll explain what I mean there in a second. Then you put curly braces. So you open the curly braces and you close the curly braces. Just to make sure I'm in screen here. I think I am. Now here is where you put your code. So what's going to happen is this expression will evaluate to true or false. So this is going to be true or false. If it's true, this code inside of these curly braces will execute. If it's false, it'll jump over those curly braces and go to the line down here. So this is basically a condition. If this is true, we'll execute this. Otherwise, we'll skip it. Now, there's also a variation with an else. So you could say else, put some more curly braces down here. I think I'm running out of room there. And what the else will do is you can give it a section of code, and it will evaluate if it's false. So you basically have two options here. You could do it without the else, and then if it's true, it'll do something. If it's false, it'll do nothing. Or you can use the if else, and then if it's true, it'll do something. If it's false, it'll do something else. So it's totally up to you, whichever one you want to use. There's a third variation known as the if else if, and what that's going to look like is this. So we first have that first if, and then we put our code in here. Then what we can do is we could say else if, and put another expression, and then we'll put more code here. And then lastly,
we can have that optional else on here. So this is the structure for an if, else if. That else if section, you can have multiple of them if you want. That else section is optional, so you can get rid of it, but you can only have one else. So if this is all new to you, maybe it's really confusing, it's very surreal, but once we go into the code in the next video, it'll be very simple. But basically, this is just the structure. You can think of this as branching. So we're going in our code, we're going straight. We hit this structure here, and we have to branch in 3 different ways, essentially. The first way is if this expression is true, then we hit this code. The other way is if this is false, but this is true, then we go that way. And then lastly, if neither of those are true, then we'll go the else path. So that is how we can branch in 3 ways. Now, what do I mean by this expression here? Well, this is going to be some sequence of code that will evaluate to true or false. So this is known as a Boolean expression, Boolean meaning it evaluates to true or false. So for example, we could do something like this. Age is equal to 17. This is only going to evaluate as true if some variable named age has the value 17. So this is an operator that'll see if these 2 things are equal. So this is a very simple expression, and we're going to be getting into more complex expressions as we go, but this is just a very simple example. So if you had some variable age, let's say int age, and you can get that value from user input, so you could say, hey, what's your age? But just for example, I'm going to assign it a value, let's say it's 17. Then we take this and put it inside of this expression here. We say age is equal to 17. Well, this will evaluate as true, and then this code will be executed, whatever we put right here. So that is how an if, else works. Very complicated name, but you can just call it an if statement in general. So you don't always have to say if, else, just say, hey, we're working with if statements. All right, so how is this different than a switch statement? Because a switch statement also allows us to branch in our application, but it's a little bit different. Let's talk about it. So a switch looks something like this. You say switch, and then you also have parentheses, but instead of putting some expression in here, you're just going to put a variable. So what we could do is we could put age. And then inside of the curly braces, you're going to have what are known as cases. So you could say case 17 and put a colon, not a semicolon, and then our code will go right here. And then when you're done with the case, you can indicate that by putting the break keyword. So that's how we say we're done. You can also have other cases. So for example, we could say if your age is 18, we want to do something else. So we have different code, and then we have break. And then there might be a situation where we want to grab all ages besides 17 and 18, and with that you use what's known as a default. So this is kind of like the catch-all. This is equivalent to else in the if-else. So we can say default, throw some code in there, and then we could also put break. So this is a switch statement. The syntax can be a little bit new if you're new to this stuff, if you've never seen a switch before. Now the thing I have to say about a switch is that it can't do anything that an if statement cannot do. So if you're overwhelmed with things to learn, don't worry about the switch for right now. It's nothing revolutionary. It's actually much more limited than an if statement. How exactly is it limited? Well, for one, this variable age, it has to be an integral type. So it has to be like an integer or a long or some integral type. That really makes the switch not very useful because we're often going to be using other types, and switches can only use integral types. That's not the case in some other languages, so if you're using a more modern language besides C++, you could probably use strings, but in C++ that's not the case. So only integral types. That reduces the usefulness of this a lot. The other thing, once we get into comparison operators, you can't really do those inside of a switch. So you can't do something like age is less than 17. That's not a possibility. This is only exact values. So 17, 18. So it's not for ranges. So when would you want to use a switch with all of these limitations? Usually you'll see switch when there are a few options for a particular variable. So let's say you have some kind of menu and you ask the user to select an option, and the options are 1, 2, and 3. That would be a perfect ideal time to use a switch because you can branch very easily based on those different values. You also have this break keyword. We're going to talk about that a little bit more when we go hands-on with the switch statement, which will be here in a couple videos. So thank you guys. Hopefully that was a good introduction to branching inside of C++. Lots of general concepts, so if you go to any other programming languages,
This is probably going to be about the same with the exception of this needing to be an integral type. So that's all I got for you guys in this video. Thank you for watching. If you've enjoyed the content, please consider subscribing as that really helps out the channel. Thank you, and I'll see you in the next one.
Hey, what's going on, everybody? Welcome back. This video, we're not going to be talking about anything too crazy or revolutionary. We're just going to be talking about how to go through the if statements inside of C++. So if you're new to if statements and logic, this video is for you. So basically how things are going to be split up is we're going to talk about if statements. Then we're going to do a video over logical and comparison operators. So those will come in inside of our if expression. So when we have an if statement, we have an expression here. And I'm going to be talking about how to make complex expressions in the next video. And then if you're looking for switches, we'll talk about those after that. So this is just going to be talking a little bit about the if structure, and we're going to go through a very simple example. So let's create our if statement. It's going to look a little bit something like this. We're going to say if, and then we'll put the curly braces. And inside of here, we're just going to use the same example we used in the previous video. We'll say something like if age is less than 13 in this example. So we'll create a variable age, and let's give it the value 17. Now, if it's less than 13, what are we going to do? We're going to output, and we're going to say you're not old enough. And we'll do a new line at the end, like so. Now, because we're doing output, we need to make sure we include IOStream. I started fresh, so I didn't have that on here. Like so. Now when we do a compilation, and when we run, nothing happens. And that's actually what we expected, because this here evaluates to false. Because if you ask it as if it's a question, age less than 13? No, it's not, so it's false. If we did greater than 13, well then when we compiled and ran, we would get that output. So that is how an if statement works. Now anything after the if statement is going to run all the time. So we'll say always here. And there is an exception to that. I'll show you guys in a second. So we're going to get this always all the time. The exception to that is if you decide to do a return inside of this if statement, that's actually going to end the program. So for example, I could return -1 to say something went wrong, and then that will end the program. So now we get you're not old enough, and then anything after that is restricted only to those, which this is funny because I kind of messed up the aging here. Let's put this back to less than 13, and let's just say we're 11 years old. Now it makes a little bit more logical sense. So when we run this, we get you're not old enough. It returns from the application, and we don't get to see what comes after that. So that's one way you could do it. You could just end the program or do a return. An alternative is to use the else. So else's are usually if you have a separate section of code you would like to execute in case it's evaluated as false. So that's going to look like this, and this is going to say something like false. Now let's do a compilation and run. And you can see it says you're not old enough. That's because 11 is less than 13, but let's say our age is 111. Now it should say false. The reason it says false is because this evaluates to false and the else condition is ran. The last scenario is the else if, and the way this works is we can put another expression in here. So let's say age is less than 13. We'll say age is less than 19. So let's say we're somewhere in between 15. In this case, we can do something else, so we'll output something different. Now let's do a compilation. And you can see we get that middle one. You're almost 19. That's because this one evaluated to false, so it goes down to the else if. This one evaluates to true, and then it just ignores the else. So only one of these is going to get executed. So you'll want to use the if, else structure if you're looking to branch in one way. This isn't going to be able to do all of these. So hopefully that was pretty clear. There's nothing too crazy about the if statement. If you're having struggles with it, just go through some practice. Try to make an application where it asks you a question, and then go through different cases. Now the beauty in this is it's used for making dynamic applications. Right now it's kind of useless because we know what the age is. But at some point we're going to want to get that from user input. So if we wanted to do that, it would look something like this. We would say standard cin, and we're going to store that value inside of age. Before we do that, we could output, how old are you? Like so. Now let's give it a run. It asks us how old we are. Let's say we're 17, and it says you're almost 19. So that's cool. Now we made our application dynamic, and that's the magic. So thank you guys. In the next video, we're going to talk a little bit about logical operators and comparison operators. Basically, how can we make these expressions a little bit more exciting? All right, thank you guys. I'll see you in the next video. And if you've enjoyed this content, please be sure to subscribe. Hey, what's going on, everybody? This video, we're going to be talking about logical and comparison operators. These are like the magic that makes expressions useful inside of if statements and loops and all that good stuff. So definitely make sure you pay attention and got this stuff down. Now let's get started. So we're going to create basically a stupid game where you have to guess my name. So what we're going to do is first we need to include string because we're going to store it in a string. So you always have to make sure you include the important stuff. We're also going to include ifstream and make sure you type very badly like me. All right, there we go. That should be all the includes we need. And we're going to say string name. We're going to set that equal to Caleb. And actually, since this is going to be a guessing game, we're going to make this the answer. And you have to guess it. So what's this going to look like? Well, we're going to create another string, and this is going to be the guess. And we're going to get that from user input and store that in guess. But they definitely need to know what they're being asked for. So you could say something like standard cout, guess my name, like so. Now, they'll guess the name, and then that'll get stored in guess, and then we can do a comparison to see if they are right. So we will get to logical operators and comparison operators here soon. Just give me a minute. We got to build out this application here. So now let's see out and say that they got it right. So the first comparison operator we're going to talk about is the equals operator. So if you say guess and then two equal signs, answer, this is the comparison operator. This will return true if both of the operands have the same value. So what's going to happen is we're going to compile this, see if we got any errors. Nope. Run this thing, guess my name, we'll say Caleb, and it says you got it right. If you get it wrong for some reason, let me just run it again, guess my name, it does not say that. So that is your first comparison operator, the equals operator. Very simple. Now I want to talk a little bit about logical operators, and we'll get back to the comparison operators in just a minute, but I want to make this application a little bit more complex. So not only do you have to guess my name, but you also have to guess my age. So what we're going to do is we're going to say int age answer and set that equal to 63. Yeah, I'm a little old. And then we're going to basically do the same exact thing. So we're going to do an output, guess my age, and we're going to store that inside of a new variable, which is going to be called, it's going to be an integer, and we're going to call it age guess. So this is going to be stored in age guess. Now, the way logical operators work is they allow you to do multiple comparisons inside of one expression. So let's say you have to get both of these right. You can use the AND logical operator. So we could say guess is equal to answer, and then we could say age guess is equal to age answer. So now you have to get them both right. So let's run this, make sure I got everything set up correctly. Guess my name, Caleb. Guess my age, 63, and it says you got it right. So this AND operator, what it's going to do is it's going to evaluate both of these. So if this is true and this is true, then this will be outputted. So both of them have to be true. Another operator that is a logical operator is known as the OR operator. And it's two pipe symbols, which is right above the enter key on your computer, on your keyboard. And now this is only going to require one of these to be true. So either you could get the name correct or you could get the age correct. So just to show this in action, what I'm going to do is I'm going to put the wrong name and then I'm going to get the right age, 63. You can see you got it right. But if we get them both wrong, you can see nothing happens. So those are the two primary logical operators that you need to know about. There's actually one more that you should know about, and that is the NOT operator. And that's going to basically invert, either take something true and make it false, or take something false and make it true. It's going to invert whatever the truth value of something is. So let's say, for example, you have to guess any name except Claire. So how would we do that? Well, we find this is the one for the name, so maybe we want to make our variables a little bit more clear, let's call this name answer and name underscore guess. We're going to store that in name underscore guess. Okay, just for our various variables to be a little bit more clear here. It should be the same exact thing. And if we want to make it to where you have to guess any name except Claire, you can put this entire expression inside of parentheses and prefix it with an exclamation mark. So this is the not operator. And what this does is it's going to negate the truth value. So right now, if you guess Claire, this is going to evaluate to true, but it's going to be inverted to be false, which is going to be good. So originally the name had to be exactly the same in order for this to be true, but since we put that exclamation mark, it has to be anything but that name. So it'll basically flip the truth value there. So let's just do that by itself just to make it really crystal clear. Now let's do a compilation and a run. All right, guess my name. If I say Claire, put anything for the age there, you can see that you got it right was not printed, so this actually evaluated to false. So that means we can put any single name that's not Claire and will be evaluated to true. So let's just do a run of this thing and we'll just put Caleb, any age we want, and you can see we got it right. So that is how you can be very selective on names and guessings. So that is how you can be very selective. You have the OR operator, the AND operator, and the NOT operator. This NOT operator can make a little bit of sense if you know how to read it inside of English. So this is basically going to be read if the name guess is not equal to the name answer. That is how you would read this. But there's actually a clearer way you could put this, and if you actually get rid of this exclamation mark and put it as the first equal sign here, you have not equal to. And that is another comparison operator, works exactly the same way, and it's very simple. So when we do a compiling and run, it should work exactly the same way. So as long as the name guess is not the name answer, then we should be good. So we could put anything in here and we'll be right. John, and you see we got it right. Okay, so lots of information. It's kind of hard to see it all when we're going through all these stupid examples. So what we're going to do is we're just going to write down the possibilities. So inside of a comment section down here, we're going to go over the logical operators first. So we have and, or, and not. And then for the comparison operators, we have equal to, not equal to, less than, equal to, and then we have less than or equal to, and greater than or equal to. So here are all the operators you need to understand. The logical operators allow us to make expressions that are complex, multiple comparisons, as well as negate things. Comparison operators allow us to compare things, as well as see if things are not equal, see if things are less than each other, or less than or equal to each other, greater than or equal to each other. So those are the comparison and logical operators. Make sure you get some practice with those, see what kind of cool applications you can make, and leave them in the comments section below. Now, one more example I wanted to go through. First thing I want to show you guys is that these parentheses are not necessary anymore. So you can just leave it as that. That works just fine. An alternative to logical operators is actually nested if statements. So for example, let's say we have to guess the name, and the name is Caleb, and we have to guess the age. Well, what we could do is we can actually make another if statement inside of here if you would prefer, and say if, and put the result right here. And then inside of this if, you could say if age guess is equal to age answer. This should work exactly the same way. So we can run, give it a try. Guess my name, Caleb, guess my age. I think it was 63. And it says you got it right. So that is an alternative way if you want to visually see how these things are getting evaluated. That is how you would do the AND operation. So this has to be true, and this has to be true. If you wanted to do the OR operation in this manner, what you would actually do is use an else if, and then inside of here we would put this expression. So cut and paste that here. And then this result needs to be on both of these options. So we're going to copy that. So one of them is going to go here, and the other one is going to go inside of here. So now if either of these are true, this will be executed. So definitely not as pretty because there's more code, there's some duplicate code. It's not the ideal solution, so I'd highly recommend you understand the logical operators. So that's all I got for you guys in this video. Hopefully that was helpful for you guys. If you've enjoyed the content, please consider subscribing. All right, I'll see you guys in the next video where we're gonna be talking about, I think we're gonna be talking about switch statements. So that's gonna be boring. I'm just kidding. I'll see you guys there. Hey, what's going on, everybody? This video, we're going to be talking about the switch statement inside of C++. You know, I thought I'd switch it up a little bit. So when it comes to creating a switch statement, what's going to happen is you're going to say switch, put parentheses, and then put curly braces. So it's the same exact structure as an if statement, which looks like that, but the actual functionality is a little bit different. So what's going to happen is where you would normally put an expression inside of an if statement, we're actually just going to put a variable. The example I gave in an earlier video was age, so we're just going to say int age. And what we're going to do is we're actually going to get that from input. So we'll get cin and store that inside of age, and we'll just put an output just so people know what to do. So let's ask the audience what their age is. So we can put that variable name here in the switch. And then inside of here, we have case labels. So we make a label for different values. So we can say the case where the age is, I don't know, 13. And what we're going to do is we're going to do a cout here. And I'm just going to be very informative and tell them that their age is 13. I know that's really helpful, but you guys get the pick. Once you understand how the functionality works, you can use this for different things. This is just a silly example here. And then what we're going to do is we're going to say break, which says we're done with this case. And we're going to talk a little bit about that break keyword here in a minute. Then we'll say case 14. Yep, so the reason I don't like switches is because they're not super useful or versatile. Like, if you're going to have more than a couple of options, you have to put every single option as its own case, and then you can do a catch-all using a default. But overall, it's kind of complicated, and I'm not the biggest fan of switches. I think they are pretty to look at when you have a few options. So if you have a menu selection, for example, you could basically say case 0, case 1, case 2. That would be nice and pretty, and we're actually going to be using a switch statement later for that, I believe, so you'll see it later on for that example. But for the general purpose use, switch is not the most useful thing, and you'll see why. The first reason why is it has to be an integral type. So first let me compile just to make sure I got everything working, got all the code working. What is your age? I need a semicolon, and there we go. So it seems to compile, but that's because age is an integral type. It's of int. But if we do something such as make this a double, well, now it's not even going to let us compile. So that's just really not useful that the type has to be an integral type. It makes it very limited, but we'll deal with it. We'll go with an integer and we'll give it a try. So let's compile and run. What is your age? Let's just say our age is 14. You can see we hit the case 14 and it says you are 14. Thank you, computer. You're very helpful. So that is how a switch works. Now let's first talk about this break keyword. This is actually not a required keyword, so it's silly because if you don't put it there, we're going to have an issue known as fall through, which is bad. It's not a feature, it's an unfortunate occurrence. So if we compile this and run, and let's say our age is 13, what's going to happen is it says you are 13, you're 14, and then catch all. So it actually falls through and hits all of these print statements. So when you don't have a break statement, it's going to fall through and hit all of the cases until it has a break or a return. So if you don't want to use a break, you can use a return, such as in the case of main, we can return -1, or we could return 0, whatever number you want. 0 means everything works fine, -1 means something went bad. So a return should work as well. So in this situation, if we say our age is 13, it's fine. So that is one way you can do it, but generally you're going to see the break keyword here. So you're always going to want to make sure you put that break keyword in there, even if it's the last one, just as a best practice. In other languages such as C#, the break is actually required, which I personally like because there's not very many scenarios where you're going to want to leave that break off of there. The only situation where you might not use a break is if you combine cases. So for example, if you want to combine 13 and 14, you can get rid of all of the content of case 13 and leave it like so. And then you could say you're 13 or 14. So in this situation, if you put the value 13 or 14, this will get hit.
So just to see that, let's go in there and we'll put the value 13. And if we run it again and put 14, you can see they both hit that output. Now, one thing you might find interesting with the switch statement is you can actually use it for an enumeration. Now, if you guys remember what we did with enumerations, we talked about them briefly when we talked about constants. Some people use them as an alternative to a constant. Other people use them when you just have a series of potential options. So let's go through an example of creating an enum, and we'll use it inside of a switch statement. Why exactly can we use an enum? Because behind the scenes, an enum actually stores possible values as an integral type. So it's basically the same thing as using numbers. It doesn't look like we're using numbers, but we actually are. So it's pretty cool. So if you haven't worked with enums, it's nothing too crazy, so don't freak out, just follow along. So what we're gonna do is we're gonna say enum, and we'll just say, let's go with seasons. And in here, we're going to go with summer, spring, fall, and winter. And let's just get rid of all of this information here because we're just going to work with the seasons directly. What you can do is you can actually create a new season and call it now and set that equal to winter, for example, which yes, it's winter, it's freezing. And then what we can do is we can switch on that variable now, and we're going to have completely different case values. So let's just get rid of all this stuff. We'll leave that default in there and get rid of these cases. So we can say case and have the different possible case values. So we could say case summer, case spring, case fall, and case winter. Now, because we have a very limited number of options here, we're actually not going to need that default because it's not possible for now to have anything else than these 4 options. So let's compile, see if I got anything completely wrong. Yes, I forgot to put an S on here, so it would actually be better to probably make this singular. So we'll just call it season. Now before we run this, we actually want it to do something, so we'll just go through the case of winter and we'll do an output. Just keep it nice and simple. And you could do that for all of these, but I'm just going to do it for winter because I know that's the one that's going to be hit here. And when we run it, you can see it says stay warm. So that is how you can use a switch statement with an enum, nice and simple. Now I'm also going to try this with what's known as an enum class. It works very similar, but it's a little bit different. I'll typically just put a capital S instead of a lowercase s when I'm using the class type. And then you need to prefix these with season, like so, with the double colons. And this just allows us to scope our enum to this season so it doesn't just pollute the entire area that it's defined in, if that makes any sense at all. And then we also need to do that here. So we can say season, : winter. Last thing is we need to capitalize this S. Sorry guys. Also when you compile, this class enum is a C++11 capability, so you might need to say standard equals C++11. Alright, that should be everything. We should be good to go now. Now when we run it, we get the same exact thing. So this is a little bit different, and I know this video wasn't a tutorial on enums, but it's definitely something I wanted to squeeze in here somewhere. The class enums are just a little bit better just because this summer is only available when we prefix it with season, so it doesn't just make this summer available everywhere. So you can look up the pros and cons of whether to use class enums or just standard enums. That's not a topic for this video, but here you can see the use of enums inside of the switch statement. So hopefully that was helpful, guys. My dog's whining, so I should probably go give him some attention. And thank you. If you've enjoyed the content, please be sure to subscribe. It really helps out my channel. I'm trying to take over the YouTube. By trying, I mean I am.
What's up everyone? Welcome back. This video we're going to be talking about loops, which are when things are repeated. So if you've been through loops before, maybe they're confusing, maybe they're complicated, or maybe you have it down. Whatever it is, I'd recommend you watch this video because I'm going to try to take the concept and make it very nice and simple. So it's so simple that I went to check my notes for this video and I had like 1 sentence. So apparently when I was writing this, I was like, I've done this 1,000 times, just do it from memory. Either that or I was like, I don't feel like it, and I just moved on to the next one. The core pieces are very easy to memorize once you have this acronym down, ICU. So this is how I remember the structure for a loop. So an example of a loop is, let's say you want to say something to a user 10 times, or you might want to ask the user something until they get it right. Or you might want to use a loop to go through a collection of items. Loops are super useful and fundamental for building complex applications, so make sure you get this information down. So let's go through a simple loop known as a while loop.
So the way this works is we're first going to initialize a variable. And this is kind of going to keep track of where we are in the loop. You know, how are we going to basically make progress in our loop if we don't have some way to keep track of where we are? So that's where this initialization comes in. We start with a variable. It's usually something like a variable named I. So we'll say int I equals 0. Then what we do is we say while, which is a keyword, so we just type it out, and we put the parentheses and we put the curly braces just like an if statement or a switch. This is the general structure. Now in here, we're going to do a condition. This tells us when the loop stops. So basically we're going to start, let's say here, we're going to progress until that condition is no longer true. So we start here, this is the initialization, and we progress through this loop, and at some point we stop. And that stopping is defined by that condition. So a very common one you're gonna see is I is less than 10, for example. So this loop is going to run while this is true. Then inside of here, we have that last piece, the U, and it's the update. And that usually looks something like I++, which will increase I one number. So the way this is going to work is we start with an initialization, in this case a 0, and we go until the condition I is less than 10, so as long as that's true, and the update is like the progress, how we get there. We start at 0, we update by 1 each time, and we keep doing that as long as I is less than 10. Once I is 10, we're done. So the stopping point, I is going to be equal to 10. How many times is this loop going to execute? It's going to execute 10 times. 1 for 0, all the way up to 9. So it's going to be 0 through 9, and then once I is 10, it's done, it's not going to be executed again. So that, my friends, is the functionality for loops. All the other loops work in a very similar way. They have an initialization, a condition, and an update. So this doesn't really do anything, it just counts. So what's the purpose? Where do we put our code? Well, our code actually goes right here. So for example, one thing you could do is you could output I. And I'm running out of space. Yeah, you guys get the point. Basically, right here I'm outputting the I variable, and what this loop will do is it'll actually count from 0 to 9. And that's basically what we're going to be doing in the next video, so you're already a step ahead. So this is the while loop. There are two other loops you should know about, which is the do while loop and the for loop. The difference between a while loop and a do while loop is that the while loop, the code happens after the condition. For a do while loop, it's going to execute at least once. So the code's going to be executed and then the condition will be checked. So if you want to do something that executes at least once, maybe you're asking the user for a password, or you're showing a menu, and you want to do it at least once all the time, then you might be interested in the do while loop. Generally, you can use any of the loops to get the job done, but there's usually one that's more fitting. So for example, if you want to do something at least once, use a do while loop. If you want to do it 0 or more times, then use a while loop. So we'll talk about the do while loop, we'll get some practice with that, but for now just understand the while loop, and now we're going to talk about the for loop. The for loop works exactly the same way as the while loop, it's just positioned a little bit different, the syntax is a little bit different, but the functionality is essentially the same. So with the for loop, all of these pieces are going to be set up front, so it's going to look like this. Same thing, we got the parentheses and then we have the curly braces. We have the initialization, so we could say int I is equal to 0. Then we have the condition, we could say I is less than 10. And in between these we have semicolons. And then we have the update I++. And then we could put our code in here. So that is the same exact thing, but now it's a for loop. Works the same way, it's just syntactically different. Personally, I like for loops, but generally, I'll use for loops when I know the number of times something is going to be executed. I'll use while loops when I don't necessarily know ahead of time how many times it's going to be executed. What do I mean? Well, you can actually make something known as an indefinite loop. And the way an indefinite loop works is it's basically just going to keep running indefinitely until it's told to stop. So instead of stopping at some condition, we're just going to say while true, for example.
So the condition is always true and it's just going to keep executing. And once something happens to stop the loop, we'll just break out of that loop, which we'll talk about here in a couple videos. So that is your summary for loops. In conclusion, there are 3 main loops. We have the while loop, the do while loop, which we didn't really go through the syntax on that, but we'll get into that later. And then we have the for loop, which works exactly the same as the while loop. It just comes down to personal preference and when you might want to use which. Like I said, I'll use for loops when I want to go through it 10 times, for example, and I'll use while loops when I want to go through it indefinitely. So yeah, that's the concepts for loops. Now we're going to get hands-on, go onto the computer, type some loops out, and it's going to be lots and lots of fun, so definitely check it out. And if you've enjoyed this content, do me a favor and subscribe, because how else am I going to take over the internet? Not without your help. Definitely need that. So go click that subscribe button and I'll be very grateful. Thank you guys.
Hey, what's going on everybody? Welcome back. This video we're going to be talking about the for loop. Once you got the for loop down, taking on the while loop and the do while loop is a super piece of cake, so no worries at all. This is going to be fun. Once you got loops down, you can start making some really cool applications, so I'm pretty excited, and I hope you are as well. So now let's get back to loops, and what we're going to do is we're just going to go through some simple for loop examples. So let me zoom in just a little bit for you guys. What we're going to do is we're just going to say for, get that structure built, and we're just going to count to 10. So we're going to do the basic loop. Int I equals 0, I is less than 10, I plus plus. And in here, we're just going to output I. Like so, right there. And we're going to compile and run. And you can see it gives us an output from 0 all the way up to 9. Now, if this syntax is completely new to you and you didn't watch the previous video, I highly recommend you go check that out because that's going to give you all of the background on how loops work. Basically, there's an initialization, a comparison, and then an update. And that's how we progress through the loop. You can use this variable inside of the loop to basically tell us where we are in the loop. So for example, on the first iteration, we have the value 0, the second iteration, we have the value 1, and so forth. Now, if you wanted to shift these up 1 because it starts as 0 and you wanted to say, let's say 1 through 10 instead of 0 through 9, it's very easy. All you have to do is say I is equal to 1, I is less than 11, like so. Now, when we output this, it's going to start at 1, but it's going to count all the way up to 10. So the end result is that we still get 10 iterations, but now the I value starts at 1 and goes to 10. More often than not, you're probably going to see this start at 0, and this is going to be 1 less. That's because a lot of the things we're going to be using inside of programming, such as arrays, are 0-based, meaning the first element has the index 0. And we'll be getting into how to iterate through arrays and all that stuff here pretty soon. But for now, just know that we're often going to see this start at 0. Another thing I wanted to mention is that this condition could be basically anything. So for example, I could say less than or equal to 10. In that situation, it's actually going to iterate 11 times, printing out 10 as its last value. So now it's going from 0 to 10. So should you use less than or should you use less than or equal to? Well, it's ultimately up to you, but as a personal preference and what I think is most common in the industry is to try to stick to less than. If you keep it consistent, it's pretty easy to figure out how many iterations you're going to get. For example, if you start at 0 and go less than some value, whatever this value is, that's how many iterations there's going to be. So in this situation, there's going to be 10 iterations from 0 to 9. Now you could also count down. So for example, we could say I is equal to 9, and let's just go from 9 to 0. So let's say as long as this is greater than or equal to 0. And what we're going to do is we're going to decrement I. Make sure you decrement, because if you increment, we're going to have an infinite loop. And just to show you guys that, let's do it. When we run this, you can see it just counts forever. The way to get out of this is to hold Control and press C, but you can also just see how long it will run before your computer explodes. That would be cool too. So we're going to make sure we decrement, and now we should get a countdown. There we go. It goes from 9 all the way down to 0. So you can see that you can customize these loops to do a whole lot of different things. We counted up to 9, we counted down from 9, and we can even make some more complex stuff. So for example, let's say I wanted to do something similar to this to calculate a, what's it called, factorial. So if a factorial of a number is like, if you have a factorial of 5, it's going to be 5 times 4 times 3 times 2 times 1. So let's go through an example of that. So what we can do is we can start with some number, what we're trying to calculate the factorial of, and we'll say we're trying to calculate the factorial of 5. What we're going to do is we're just going to start I at 1 less than that. So we'll just say factorial minus 1. And as long as this is greater than or equal to, we'll just say greater than 0. So we don't want to hit 0, we want to stop before 0 when we're at 1. And then we're going to decrement. Now what we're going to do is we're basically just going to store the new total in this factorial here. So what we could do is we could say factorial multiplied equals, and if it's easier to see, you could just say factorial multiplied by I. So at first this is going to be 5 times 4, and then that new value 20, it'll be 20 times 3, which will be 60, so then 60 times 2, 120, and then 120 times 1. That last one doesn't actually change the value, so you could say greater than 1 here even. Now let's compile and see if we get that output, but we definitely want to make sure we output it at the end. So we'll say factorial, and then we'll output that value, and then we'll do an end line, so like so, right there. Compile, run, and you can see factorial is 120. Now if you wanted to keep that original variable, you could. So for example, we could say int fact and set that equal to 5, and then assign that to factorial. And now we're going to have a reference to that original value. So what we could do is say factorial of, and then output the original value by saying fact, and then inside of quotes, we could put the colon there. Now let's compile and run. Factorial of 5 is 120. So maybe you're looking at this and you're like, what the heck is going on? Or maybe you're like, wow, dude, this is super easy. Why are you wasting my time? Honestly, there's going to be a spectrum of people watching this video, so it's hard to say where you are in that spectrum. But wherever you are, you can easily see that using these loops allows us to build more complex applications, something that would be much more difficult to do without loops. Doing something like this without a loop, yeah, good luck. Let me know how to do that and make sure it's able to do with any value. So let's say we can throw in a 7 in here and get another value. We're basically able to generalize our program and use any value as an input. That's what loops are for. That's why they're useful. If this is too hard, don't worry about it. You don't have to know how to calculate a factorial right now. If it's too easy, that's great. Go find a harder loop and try to understand it. The point of this video is not to show you guys how to do a factorial. It's how to use loops and how to see their value. So thank you guys for watching. If you've enjoyed this video, be sure to subscribe so I can take over the internet. Really appreciate it, and of course, I'll see you in the next video. Hey everyone, welcome back. This video, we're going to talk about while loops. I would highly recommend you check out the previous video where we go hands-on with a for loop, talking about counting up, counting down, and how to do something a little bit more complex like a factorial. This video is going to basically be a copy of that video, but now instead of using a for loop, we're going to use a while loop, and you can see how similar they are. So I'm going to keep some of this code for reference, but I'm just going to comment it out and kind of just scoot it down to the bottom as if it doesn't exist. Also, I want to show you guys something cool, that this return 0 is actually optional. So if I got rid of this, the application should still compile. Basically, it's going to return 0 implicitly. It's basically one of the only exceptions where you don't have to use a return, even though it says there is a return type of integer. But that is totally off topic and really not what I wanted to talk about in this video, but just thought I'd throw that out there. Alright, so let's talk a little bit about while loops. Okay, so first, the initialization happens first. So we say int I equals 0, then we do the while, and inside of here we have the condition. So we can say I is less than 10. Now the update happens at the end of the while loop. And you'll see why I put it at the end in just a minute. This is an important thing to remember, is generally you're going to want to put the increment at the end. And then in here, we're going to output I, like so. Now let's do a compilation and run. And you can see it counts from 0 to 9. This same code inside of a for loop would look like so. We would have int I equals 0, I is less than 10, I++. So all the pieces are the same, they're just in different locations. Now if you put this I at the top of the while loop, that's going to change the structure, so it would no longer match the for loop. And that is the reason you want to put the I++ at the bottom. It's because in order for there to be some kind of coherency between for loops and while loops, you need to match the way they operate. So when you're doing a for loop, the initialization happens first, then the comparison, and then the body is evaluated, so our code is ran, and then the increment happens at the end of this body being ran. So it actually follows this structure, even though it looks like that I++ happens at the beginning. It actually doesn't. It happens at the end, after our code is executed. That's why if we output I here, it outputs as 0, not as 1. To match that with a while loop, we need to output I first, and then increment I. So that is the magic as to why you put the I++ at the end. Now, if we wanted to count down, it's very simple. We start at 10, for example, and we could say as long as I is greater than or equal to 0, and then we can output I and make sure we decrement. I'm going to comment out this for loop too. Actually, I'm just going to get rid of it. We don't need it. So I save that. Now let's compile and run. And you can see it counts down from 9. Oh, actually counts down from 10. So this is actually doing 11 iterations. If we want to do 10 iterations, we can start at 9. And then go down to 0. Sorry guys. So now when we compile and run, it goes from 9 right there all the way down to 0. So 10 iterations from 9 to 0. If we wanted to start at 10 and go to 1, very simple, just change the numbers. 10 to 1. Now when we run, it goes from 10 down to 1. It's kind of hard to scroll. It would probably have been better if I did a tab or something here, so you could just do like a tab there, and then at the end you could do an end line, so like so. Now it might be a little bit easier to see. It goes 10 all the way down to 1. Wish I did that from the beginning, but oh well. Now what I want to do is I want to do the same thing that we did in the previous video, which is calculating a factorial. So let's do that. Let's not look at this code. Let's just start from scratch, and then we can compare to make sure everything looks the same. So what we're going to do is calculate the factorial, and in order to do that, we can start with some number. We'll call it factorial, and we'll just set that equal to 5. So we want to calculate the factorial of 5, and we're still going to need that I variable. So we'll just set that equal to 0. So if we want to do the factorial of 5, it's going to look like this. 5 times 4 times 3 times 2 times 1. We don't want to go any farther because if we multiply by 0, that's going to reset the whole thing. We also don't need to multiply by 1 because it doesn't actually do anything. So we actually only need to do this sequence right here. So we can actually set I to factorial. That'll give it the value 5 in this situation. And then what we want to do is we want to count down to 2. So as long as this is greater than 1, it should work. You could also use greater than or equal to 2. Whatever you prefer, it should do the same thing. I'm going to use greater than 1. All right, so we start at 5. We count down to 2. And then we need to basically keep track of the value in this factorial variable. So what we're going to do is we're going to say factorial. Use the multiplication equals, and what this will do is basically it'll do factorial equals factorial multiplied by something, but it's just a shorter way of doing that. So factorial multiplies equals, and then just putting whatever we want to multiply it by. So in this case, we're going to multiply it by I, and then we need to decrement I. And then when we're done with the loop, we need to output that value. So what we're going to do is we're just going to output factorial, and then a new line. Now when we compile and run, we get the value 600, which is not right. And the reason it's not right is because we actually need to start with factorial minus 1, which basically what was happening that was incorrect is we started with 5, and then we did 5 times 5 times 4 times 3 times 2 times 1, which is not what we want. So we basically start with a value 5, and then we multiply this sequence with it. So sorry about that, guys. That's actually exactly what we did correctly in the previous example where we set I equal to factorial minus 1. So hopefully you guys are watching the previous video and you caught that, but I decided I wasn't going to redo it because, you know, mistakes happen. So that is a valid mistake. So we start at 5, then we multiply it by 4, and then that new value, which is going to be 20, is going to be multiplied by 3, which will give us 60, and then 60 is going to be multiplied by 2, which will be 120. So now let's compile and run and see if we get the right answer. And indeed, we do get 120. But now this is generalized, so we can make this whatever value we want. We could do a 10, for example. factorials will get pretty huge pretty quickly, so we can't go much higher. And what the heck, let's just put some huge value. And you can see we get 0, so that's interesting. So that's how you use the while loop. Pretty fun. Next video, we're going to be talking about the do while loop, but the only way you're going to be able to see that is if you subscribe to this channel, because, you know, that's how YouTube works. I'm kidding, but I would appreciate a subscription, especially if you guys want to help me, you know, take over the internet. Okay, guys, I'll see you in the next video. We're going to talk about the do while loop. Hey, what's going on, everyone? Welcome back to this video. We're going to talk about the do while loop. I have a bunch of code here from previous videos. Because the do while loop is usually used for different purposes than the while loop and the for loop, I'm just going to get rid of all this stuff, and we're just going to start from scratch with a new program, a new idea, and new levels of excitement. So what we're going to do with a do while loop is we're actually going to show when it would be useful. So when do you usually use a do while loop? Well, you use a do while loop when you want something to happen at least once. So for example, let's say we're making some kind of application where you have to guess a username or guess a name or guess a password, or basically input some value, and if it's incorrect, it's going to ask again. But up front, it's always going to ask at least once. And this is pretty common for applications. You know, when you go on a website and you put in your user information, if you get it incorrect, it asks you again. Similar structure, but it's just going to be in this text-based console. So nothing too crazy complicated. We're mainly just focusing on how the do while loop works. So the structure for the do while loop is slightly different than the other loops and the other control flow structures. So pay attention here. We're going to say do, and then put the curly braces. I'm going to get rid of this comment here, and this return 0 is implicit, so I'm going to get rid of that as well. So we put the curly braces first, and then we say while, and put the parentheses, and end it with a semicolon. This is actually required. If you don't put it there, you will get an error, so you don't have to worry about it too much. Let me put an expression in here. So we'll say while true. When we compile here, we get an error. It says expected semicolon. So that's good. It reminds us. But on the opposite, the flip side, if you do a normal while loop, like so, and you do put a semicolon there, well, that's actually allowed, but it's not the way a while loop would typically run. So when you compile this, you're going to get a warning, but it's not an error, meaning you can still run your application. What's going to happen is it's going to consider this semicolon to be the loop body, meaning it's just going to run this semicolon forever. What do I mean when I say run a semicolon? Well, a semicolon is just an empty statement, so it's basically just going to do an eternal loop. It's never going to stop, and it's going to break your application. So if I go down here and do an output, like done, like so, and then we compile and run this thing, what's going to happen is it's just going to run forever. It's never going to get to this done. It's going to hit this while true, and then it's going to be an infinite loop running this empty statement forever. So to stop this, hold Control and press C. That'll get out of the application and get rid of all this junk. Just make sure you don't forget to put the semicolon here, and make sure you don't put it here. So very confusing. Make sure you get that down. All right, let's get back to what we were doing. Do while. So what we're going to do is we're going to say, we're going to basically have a password, and it's going to be a string. So we're going to set that equal to hello tacos 123, which by the way is not my YouTube password, just saying. And inside of the do while loop, we're going to guess that password. So we're going to get a standard input and store this inside of a variable called guess. So we'll do it string guess, like so, and we're going to store that in guess. And we're going to do an output to tell the person what to do, like so. And this while true is not what we want, because that's going to be a loop that runs forever, an infinite loop. So instead what we want to do is we want to say while their guess is not equal to the password. The loop will keep running as long as these are not equal. So when we compile and run, guess the password, we could say tacos, we could say hello, we could say hello tacos. But as soon as we say hello tacos 123, you can see the loop ends. So that is how a do while loop works. When you run the application, it's always going to say guess the password at least once. This expression here does not get evaluated until after these two things happen. So even if you do something like while false, well, if you say while false on a normal while loop, it will not execute. But in this situation, it will execute. So when we compile and run, we'll get it to execute at least once. Guess the password. If we put something incorrect, it's just done. It hits that false and it's like, no bro, I'm not running anymore. So that's how a do while loop works. I'm going to go back to that original expression. So we're going to say while guess is not equal to password. And there's a couple other things I wanted to talk about. The first is that we reference this guess variable and this password variable inside of the while expression. The reason we can do that is because we defined the variables outside of the do curly braces. So for example, if we decided to take these and put them inside of the do section, let's say right here, well, what's going to happen is we're going to get a compiling error. And the reason we're going to get a compiling error is because when we define a variable inside of these curly braces, it only exists inside of those curly braces. So as soon as we're done with all these lines of code, this while loop no longer knows what guess is or what password is. So in order to access it outside of these curly braces, we need to declare that variable outside of the curly braces, which is why we take that and we put that up here. So now the scope that these variables are available is within these curly braces, line 5 to line 13, which does include this section right here. So anywhere inside of these curly braces can access the variable, and this while condition is in fact inside of those curly braces. So that's how it all works. So yeah, nothing too crazy, but that's just a little bit on variable scoping. So that's all I got for you guys for the do while loop. Very fun, very cool. You're probably not going to use it as much as the while loop and the for loop, and that's totally okay. You can actually do similar things with the other loops. You just have to rearrange your code a little bit. And sometimes you'll see a little bit of code repetition when you're trying to do something that looks like a do while loop, but you're actually just using a normal while loop. So if you wanted to see that, it looks something like this. You get rid of that do, you take this block of code, cut that and paste it after the while loop, and then you just take this code and you paste it up here, like so. So basically we're repeating this section of code, and then we're doing the evaluation after. So let's see if this works. Guess the password. I was trying to say baloney. Bologna. There we go. All right, and then if we say hello tacos 1 2 3, boom, we got it. So often you'll see this structure as well when people are trying to mimic the functionality of a do while loop without actually using a do while loop. Why you would want to do that, I'm not entirely sure. I think it's just partly because some people are not very comfortable with the do while loop structure. So whichever one you want to use, that's up to you. Just don't get fired. And my phone is ringing. Okay. Why is Claire calling me right now? It's like, why is she calling at all? Hey, hon. Hey, what's going on everybody? This video, we're going to be talking about the return and break keywords. These are two very important keywords when we're dealing with loops, and they're going to come up a lot. So make sure you understand these, and I'm going to try and make it nice and simple for you. Okay, so let's create a little bit of a loop here. And let's just say something stupid. We want to go through a string, so we're going to have a string here, and we'll just call it, I don't know, something really creative like sentence, and just make it whatever. And you can actually iterate through each character here. So that's one of the cool uses of loops, is to iterate through structures such as strings or arrays. So we can say int I equals 0, and the condition is going to be I less than sentence dot size, or I think you can use length, I++. And then let's just output each character individually. So the way we can do that is doing sentence and then using square brackets and putting I. So when we put any number inside of these square brackets, that's the index of the character we want to grab. So this is 0, this is 1, this is 2, oh, my bad, this is 2, 3, 4, and so forth. So if we start at 0 and count up until we go through the entire size, then we'll print every single character. Now notice that this is less than size, so it's going to get 1 less than the size. So if the size is 20, it's going to go up to 19. So I will only reach 19, which is important because this is 0 based. So H has the index 0, and B has the index size minus 1. So that's how we make sure we don't go outside of the bounds of the string. So just be really careful with that. Then I'm going to do an endl, like so. Now when we compile and run, we get the entire string 1 character at a time. What we can do is we can actually make a condition in here, and we can treat certain instances of this loop differently. So for example, if we might be looking for a certain character, let's say we're looking for the character O. What we can do is we can say sentence of I equals the character O, and what this will do is it'll evaluate to true if any of these characters are O, because we're going to go through each individual character and each time this if is going to run. So if at any point we hit an O, it's going to evaluate to true. So let's just do an output here and say found O. So we should see it here, and then it'll continue to do the rest. And we'll also do a new line here. Cool. So let's compile and run. So if you scroll up, you can see that it actually says found O right after it hits that O character. So we can actually treat this O specially using the break and continue keywords. So if we're just looking for O and we want to know if it's there or not, what we could do is we could break and stop our search. So now it's going to only go up to the O and stop. So the break keyword is used to break out of the closest loop that you're in. So it's going to break out of this entire for loop, no more iteration. So it's done. It's just going to go on to line 16. So we'll just do an output here, done. When we do a break, it's going to exit whatever loop we're in. So you can see when we run this, it finds O and then it says done. So that's how the break statement works. The other one is continue. And what this is going to do is it's actually going to stop the current iteration and go to the next iteration. So when is this useful? Well, in this situation, it's not very useful because this is basically the last thing that happens. But if you wanted to basically output all of the characters except O, well, what we could do is we could put this continue as the only statement inside of this if statement here. And then what we can do is we can take this if statement and move it to the top. So now what's going to happen is if we hit O, it's going to continue and it's no longer going to execute this line here. That's only if we hit O. So what should happen is it'll say HELL, which is a naughty word, and then it will go on with the rest of the string. So let's try it, make sure we got everything right. You can see that in fact it does not print the O just like we wanted. So you can use this kind of concept to alter strings. So for example, if we wanted to get rid of spaces, well, we could just do that. Now it'll just print all of the characters. So let's run this and see what happens. And you can see scrolling up, it just prints every single character. So we basically use this continue keyword to basically skip all of the spaces. So whenever you want to stop a loop when you're in a certain iteration, or if you want to treat a particular iteration specially, you can use break and continue respectively. So break will get out of the loop, and continue will go to the next iteration of the loop. These will come up a lot, so make sure you get a little bit of practice. Maybe try searching for some different characters, or breaking out of the loop, or treating a particular part of a string special. So hopefully that was helpful for you guys and you have a better understanding of break and continue. Let me know if there are any concerns or issues or questions in the comments below, and please be sure to subscribe as that really helps out this channel and I could really use your help. So thank you guys, I'll see you in the next video. Hey, what's going on everybody? Welcome back. This video we're going to be talking about the conditional operator. You may also hear it as the ternary operator, and basically it's the only operator that has 3 operands. It's really funky looking at first, but it can be very useful and you'll probably see it in your coding career, so make sure you get it figured out. So basically, we're going to go off the example of some kind of guessing game. So there might be an answer, so let's just say an answer is 11, and you have to guess this number, and this may or may not come up in a future video, so we'll see. And then basically what's going to happen is we're going to have some variable points. And this can get some points if you get it right, or it can be 0 if you get it wrong. So we'll just leave it declared right now, and then we're also going to make a variable guess. And let's just say we get that guess from user input. So we'll do standard cin and store that inside a guess. Which, you know, in order to do that, we're going to have to declare the variable first, like so. And then we'll also ask the person to guess the number. If they get it right, I want to give this person 10 points. So what you could do is say if guess equals answer points equals 10. And then when we're done, we could output it. So we're going to output the points when we're done. And let's just compile and give this a run. Guess the number, we'll say 11. And you can see we get 10 points. So yay, we have 10 points.
But there is a different way you could do this using the conditional operator, which you might see. And it looks a little something like this. Let's get rid of this if statement. And we're going to assign a value to points. And what are we going to assign? Well, first we need to ask if they got the guess correct. So we're going to say guess equal to answer, similar to the if statement. And then we're going to put a question mark, almost as if it's a legitimate question. Is guess equal to answer? If it is, they're going to get 10 points. Otherwise, use a colon and say they get 0 points. And that is the syntax of the conditional operator. So we have some expression, a question mark, the value if true, a colon, and then the value if false. It's a little complicated at first, but it's very concise and saves some typing, so you'll probably end up seeing it. When we compile and run, we guess the number, say 11, and we get the value 10 as our points. So the end result is exactly the same, but the code is different. You don't just have to use this for assigning values, although that's what you'll usually see. You can also use statements. So for example, we can just get rid of these points here altogether, and we'll just give a good or bad answer. So if they got it right, we'll just say, good job. Otherwise, what we'll say is bad job. That's going to work in a similar nature. If this is true, this statement will get executed. If it's false, this statement will get executed. And we're actually not going to need to output the points anymore because we don't have such a thing anymore. So we can just save this and run. When we run this, we guess the number 11, and you can see it says good job. If we run it again and guess the number and get it wrong, you can see it says bad job. So that, my friends, is the conditional operator. It's pretty lame. I'm just kidding, it's pretty cool. Hopefully you guys found this video useful, and please be sure to subscribe if you enjoy this content, and I'll be sure to see you guys in the next video where we're gonna start building our more complex application. So we've gone through all the theory, we've gone through the concepts. Now I want to take all these different control flow structures and start piecing them together, pull in some arrays and vectors and other cool stuff to make a serious game application where we're going to generate a random number and make the user guess that random number and keep track of their score and everything. It's going to be a lot of fun, well, at least for me, so I'm excited. Be sure to check out the next video, and I'll see you then.
Hey, what's going on, everybody? Welcome back. This is number 42 on your C++ tutorial. I'm actually really excited for this video because this is where we take all that concept, which honestly kind of bores the crap out of me, and we're going to start applying that because we're going to build a little application. It's going to be a little bit of a game, if that's what you want to call it. Should be pretty fun. I'm pretty excited. This video, we're going to be talking about the pieces that go into that game, and then in the upcoming videos, we're going to build that game piece by piece. So this will use all the knowledge we've talked about from the beginning of this series, most of it, not everything. And I'll also talk a little bit about arrays and vectors and some other cool stuff. So I'm really excited. It's going to be a lot of fun. So let's start talking about this application and what pieces are going to go into it. So what's going to happen is when you run the application, let's say you call it a.out, you can actually change the output name so it doesn't have to be a.out. I know that's all we've used up to this point, but if you want to change the name of your application, you can put a /o followed by the name of your application when you compile. But we'll get into that another day. Basically, now that we're building an actual application, you might want to name it something, such as my awesome application or something really creative, you know? Basically, what we're going to do is we're going to create an application. When you run it, it's going to give you a menu and you can select from a list of options. Right now at the beginning, it's just going to basically say play game and quit. So it's not very complex, very simple, but the idea is that as you start building more and more in C++, you can basically expand on this menu and maybe say, play guessing game, play this other game, play some other game, or read top scores, and then quit. So I'm going to give you the foundation, and then hopefully you can expand on it with more cool applications. Building this application is going to use a lot of the control flow structures we talked about. So for example, to do the menu, we're going to use a do while loop. You can make a selection from this menu that's displayed, so you could say 0 to quit or 1 to play game. Very simple menu to start with, but it's a good basis. And to operate that menu, we're going to use a switch statement. So we talked about how switches were ideal for, well, not ideal, they're only useful for integral data, which a menu is a perfect scenario because you have menu numbers, 0, 1, 2, 3, and so forth. So in the menu, one of the options is going to be to play the game. What is the game going to be exactly? It's pretty boring probably, but basically it's going to generate a random number. So we're going to talk about random number generators and how to do that in C++. And then the user has to guess that random number. The goal is to see how fast you can guess that number, so the fewer guesses, the higher or better the score is. So to check to see if you got the right answer, that's going to use a while loop. I think what I'm going to do is make this an infinite loop, so it's just going to keep running until you get the right answer, and once you do get the right answer, it's going to break out of it, and we're going to do that using an if statement. So basically it's just going to say, hey, if the answer is correct, break out. I think that's what we're going to do, but there's lots of different ways you can structure this application, so don't feel like you have to follow this exactly. These are just tools. These are basically the Legos to build a bigger project. You can rearrange those Legos however you need as long as the output is correct. Eventually, I'd like this to keep track of what guesses you do to try to get that right number, and I want to store those inside of an array and go through those and print them out using a for loop. So I think about every control flow structure is in this list. I'm going to try and get them all, but if not, I'm sorry. But hopefully this will give you a lot of practice using these control flow structures. So that's all I got for you guys in this video. I know it's very simple, but basically just wanted to talk about what this application is going to do. In conclusion, we're just going to make a really fun guessing game, and it's going to be part of a bigger menu where we can put more games. We want to keep track of them guesses and print them out when the user is done. So that's the application. Now let's get to coding this thing. All right, see you in the next video, and if you've enjoyed this content, please be sure to subscribe.
Hey, what's going on everybody? Welcome back. This video we're going to be talking about how to create a menu inside of C++. And this is all part of our bigger application, which I talked about in the previous video. We're basically going to create a menu where we can select from a list of games to play in the console, right? It's not going to be anything too crazy, but it's basically the start of that. So we're going to create a menu that's going to say play game and quit. Very simple. So when it comes to creating a menu, basically we're going to type out the menu. So we're just going to do an output. And what we're going to do is we're going to say 0, which will be quit. And then you can do a new line, and 1, which will be play game. So just looking at this output here, we get 0, quit, and 1, play game. Now, if you don't like how this is in the code, you can definitely change that. You can make 2 cout statements if that's prettier for you, whatever you want. Another way you could do this is to basically split up the strings, and you could do an endl in here. So we could say endl just like that. And now it's a little bit easier to read, but it should come out just the same. And you can see the result looks exactly the same, but now we can see the strings a little bit more clear. Now what we want to do is get the user to select one. So what we're going to do is we're going to create a variable to store a choice, and that's going to be an integer because these are integer values. And we'll just call it choice, and we're going to get that from input, like so. And now I want to do different things depending on if they select a 0 or a 1. And the easiest way to do that is with a switch statement. So what we're going to do is we're going to switch on this choice variable, and we're going to have 2 cases. So we're going to have case 0, and then we're going to have case 1. And we're going to have the break statements for both of these, like so. The break on the last case is not technically needed, but it's still recommended to have it. Now what we're going to do is we're going to output here, so we can basically tell the user which option they chose. The first one we'll just say, yo, let's play. Oh wait, that's actually the quit case, so I'm going to put that on the bottom. And then up here we'll have a different output. So we're going to be really rude when people want to quit. All right, so at this point, if you put 0, the thing will end. But if you have additional code down here, and you just want to end completely, and you don't want that code to execute, we could actually replace this break with a return, and we'll just put a 0, because nothing actually went wrong, so we want to use a 0. And that'll actually break out of the main function here, so then the program will be over. So let's compile as is and see how it goes. I'm going to zoom out just a little bit on the code just so we can see the whole picture here right now. So we compile. When we run, if we push a 1, we get the output that says, yo, let's play. If we put a 0, it just says thanks for nothing, and it ends. Now eventually what's going to happen is you can play the game, and when the game's done, I want it to come back to this menu. So this menu needs to be displaying over and over and over again, which indicates that we want to put it inside of a loop. And generally when there's a menu, you're usually going to want to use a do while loop. So this is what that's going to look like. We're going to say do, and then inside of these curly braces is where we're going to get that choice. So I'm going to declare the choice outside of the do, but everything else is going to go inside. We talked about why you want to declare your variables outside of the do and in the video dedicated to the do while loop. So I'm going to put both of these in here, and then clean up the spacing, like so. And then I'm going to say while, and put the semicolon. And this entire switch, that's also going to go inside of the do section, right here. Tab everything over correctly, like so. So basically we just took exactly what we had with the exception of the declaration. We put the declaration of the variable on the outside of the do so we could access it inside of this while portion. So inside of this while portion, we're just going to say as long as the choice is not equal to 0. So it's basically going to keep doing this loop unless we select 0. So let's try it out. Let's do a save, compile and run. And when we press 1, you can see it says, yo, let's play, and then it asks again what we want to do, which is actually what we want. Because if you think, yo, let's play, let's say we replace that with the actual game, this could be a long conversation with the computer, and then it goes back to the menu once the game is over. So that makes sense. You know, when you play a video game and you open up the game, it's going to ask if you want to play the game or load the game. If you click play game or whatever, and then you're in the game and you stop playing, it doesn't just turn off. It goes back to that main menu and asks if you want to play, load, or quit, or what you want to do. So there's more than just playing the actual game. You have to think about the surroundings of the game, which includes the menu. So hopefully that makes sense, guys. So the next step is I actually want to replace this case 1 where we play the game. I want to replace that with the actual game. So that's what we're going to be doing in the next video. We're going to be making a simple guessing game. And as we go through these videos, it's going to get a little bit more complex each time, and it's going to be a lot of fun. So be sure to check out the next video, and if you've enjoyed this content, please be sure to subscribe, as that super helps out my channel. Thank you guys, and I'll see you in the next one. Hey, welcome back everybody. This video, we're actually going to do something pretty cool. We're going to make a guessing game where you have to guess a randomly generated number. It's going to be pretty fun. I'm pretty excited, so hopefully you guys are looking forward to it. Alright, so where do we even get started with this application? Well, first, this is kind of built off of a menu from earlier. So basically, when you run this application, you get asked if you want to quit the game or if you want to play the game. You could expand this menu to add different games or different options, and that's totally up to you. Right now, when you click play game, all it does is say, yo, let's play. But in theory, we could just replace this output with the actual game functionality. Now, when you're going to do some kind of big piece like that, you might want to consider breaking that out into its own function so you don't pollute your code. So what I'm going to do is I'm just going to say play game, and there you go. Our game is complete, and that's all you got to do. Not quite. You actually have to implement this function. So up above main, what we're going to do is we're going to say void play game. Now this is our function, and in here we can do an output just to make sure everything's wired up and it's good to go. All right, so here's what's going to happen. The person selects play game, it jumps down here to case 1, the play game function is called, this is outputted, and then once this function is done, it's going to do the break. So let's just give it a try, make sure it's working, compile and run, and when we play the game, it says game is being played. Cool, so the function is set up. All we have to do now is actually make the game do something. So we're going to need a random number, and I'm going to teach you guys how to do that, but first you might want to include a couple things here. First thing is we're going to include C standard library, and we're also going to include C time. Now I think in this situation, the includes are unnecessary because I think they're being included from one of these other files, but it never hurts to have them there. And if you're ever going to be working with random numbers by themselves, you'll definitely want to make sure you include C standard library and C time. Now to generate a random number, we're going to create a variable, we're going to call it random, and we're going to set this equal to a function call. So this function call will return a random number. Now, you can make a random number within a certain range by using the magical modulus operator. So basically, we're going to divide by some number, and whatever the remainder is going to be the random number. Let's go somewhere, maybe 250. So in order to do it 0 to 250, you actually need to divide by 251 to get that remainder. So when we do division by 251 and get the remainder is going to be somewhere from 0 to 250. It'll never be 251 because that means there wouldn't be a remainder, because that would be a perfect division. Because if you divide by 251, there will never be a remainder of 251. So this should give us a random number, but there's one thing about this, and that is it's going to give us the same sequence of random numbers. Now, if you want to know a little bit more about random numbers, I have a video on my C programming tutorial series. It's, I think, number 50, where I talk about a similar thing where we create a guessing game like this. But Crash Course version, when you create a random number, it's going to give you the same sequence every time. And to fix that, we need to seed our random number, which is basically changing the input of this random number generation. So to do that, inside of main, we're going to call a function srand, and we're going to pass in a function call to time. And then inside of the time function, we're going to pass null. So this srand is going to seed our random number once when the application starts. We only need to do this once, so we don't need to put it inside a play game. The number passed into srand is known as the seed, and it's going to change every single time we run this application because this is getting the number from the system clock. And the clock time on your computer is always changing. So this is the perfect way to generate a random number. Now granted, it's not perfect, but if you're just playing a stupid little game, it works perfectly fine. Don't use this simple method for crazy encryption or anything like that. This is just for fun. All right, now what we're going to do is we're going to output that random number. There we go. And compile and run. And each time we play this game, we get a different number somewhere between 0 and 250. Right now we got 204, 65, and so forth. If we quit and play again, meaning you actually exit out of the application and run the application again, when you play a game, you're going to get a different starting number, so there's no repetitive sequence. Now, just as a reminder, to get out of a never-ending loop, or basically to exit the application, you can hold Control and press C. So we got the random number. Now we need to create some logic to see if the person can guess it. So what we're going to do is we're going to tell the person to guess a number, and then we're going to have an indefinite loop, which is basically a loop that will go on forever until we make it stop by breaking out of it. So to do this, we can say while true, and then inside of this loop, we can get the input and see if it's correct. So this is going to come from cin, and it's going to be stored in a variable. We can just call it guess. Store this input into guess, and now we can do an if statement. We'll start with the structure. It's going to look like that. And then we'll just say if guess is equal to random, which means they got the guess correctly, what we can do is we could say you win. Now we have the option to say else you lose, or we could do an else if and say, oh, the number was too low or the number was too high. That's going to be cooler, so let's do that. We're going to say else. Then we need a new comparison, so we're going to say guess is less than random. And in here we're going to output too low. And then else will catch everything else, which means it's too high. Awesome, so that should work. Now the only thing is we need to break out of this while loop, because right now it's just going to go forever, right? Because it says while true, which is always true, and there's nothing breaking out of the loop. So when should we break out of this? Well, if the person wins, of course, we want it to keep going until they get it correct. So in this case, we could say break. So let's give it a try, make sure we got everything working right. And we have an issue. We need to say else if. Sorry guys. Now we can compile and run. Play game. Now we have the output telling us exactly what the number is. That's more for our testing sake, not going to be there in the official application. But you know, it's hard to actually guess a number out of 250, so we'll start with printing it out. So we say 180, it says too low. We say 185, too high. And then maybe somewhere right in the middle, 183, you win. So that is the game. Now throughout the next videos, I want to beef out this application. Basically, I wanted to say what guesses you had, as well as how many times it took you to get the right answer, and all kinds of cool stuff like that. So this is just the basics. Hopefully it was exciting and got you a little bit more practice with while loops, as well as if, else if, and else. Thank you guys for watching, and be sure to check out the next video and subscribe.
Hey, what's going on everyone? Welcome back to your video series on C++. Now if you've been following along, you might know that we've been building this little guessing game where, you know, we create a computer-generated random number, and then the user of the application is assigned the task of guessing this random number. It's like a game, except not very fun. That's what we're doing, but there's a couple of complications when it comes to the things I want to do with this application that we haven't quite talked about yet. Specifically, I want to keep track of all of the guesses, and then at the end of the game, once the person gets the guess correct, I want it to output all of those guesses. So basically it keeps track of the guesses during the gameplay. So that's what we're going to be talking about in this video, how to keep a collection of data, specifically with arrays and vectors and all that good stuff. Alright, so where do we even begin? Well, let's say we wanted to keep track of someone's guesses. You might have something like this. I have a random line there. Int guess 1, and then assuming they don't get it right on the first time, you might have another variable. Guess 2,
And you just keep doing that. Basically have as many guess variables as there are possible options. Obviously, you can tell that's a pretty stupid solution. It's not scalable. What if, in theory, we could have some data type that could store multiple guesses? So instead of having int guess, we could have something guesses. Kind of like a basket where we can just throw our guesses into it. Well, what is this video about? Well, that is where arrays and vectors come in. So there are two things you really need to know about. And there's actually three. So we have an array, and then we have a vector, and then we have a templatized array. So arrays and vectors, and then a special type of array. And we're going to talk about these three things. And then in the upcoming videos, we're going to build a system to keep track of our guesses. So what is this going to look like? Well, if we're going to go with an array, which by the way, array is kind of like the basic standard type. It's something that was available in C programming. C++ introduced vectors and templatized arrays, which are definitely better, but it's still vitally important to understand this basic array. So we're going to be talking about all three. So to begin with, let's talk about the array. Overall, they're all three pretty similar, so don't get too worried about learning the wrong one or anything like that. So if we wanted to create an array, it would look like this. We're going to store integers, and the variable is going to be called guesses, but we're going to end it with square brackets. And then what we can do is we can put a size for this inside of here. So we could say, hey, we want to be able to store 100 guesses. You can think of in memory, it might look something like this. Whereas originally we might just have a guess, and then we might have a second guess variable and another guess variable. Instead, we're going to combine these boxes into one giant box, and they're all going to be connected. And you can have as many boxes as you want. I mean, I'm sure there's a limitation, but you get the point. So you can put your guesses in here, and then when you're done, you can basically go through this array and reach into it and grab all of these elements and output them to the console. So this number here is known as the size. There's another important term you need to understand, and that is an index. Each element has an index. It basically tells you where in the array that element is. And an array is zero based. And what that means is that the first element has the index 0. The second item has an index 1, and so forth. So let's shrink this size just a little bit. Let's go with 1, 2, 3, 4, 5, 6, 7. Let's say we have 7 elements. And we can just put more numbers in here. The indexes are going to be 0, 1, 2, 3, 4, 5, and 6. So that last element there, it's going to have the index of size minus 1. Because size is 7, 7 minus 1 is 6. So keep that in mind. If you're going to go through this array, you don't want to go all the way up to size. You want to make sure you stop 1 before size if you're working with indexes, which in this case we have 0 through 6. The thing with arrays that you need to understand is that they are statically sized. What does that mean? It means the size is determined when you code out the application at compile time. So when you compile your code, the size is set. So that means if you put a 7 here, that's as much storage as you're going to get for that array. The downside to this is you might not know how much storage you need ahead of time. In the situation of guesses, you probably are going to know because you might have a random number from 0 to 200, for example. And in that situation, you can have 201 possible guesses, 0 all the way up to 200, which means you would need an array of size 200. You wouldn't need an array of size 201 because you don't actually need to store that correct answer once you get it. But if you wanted to store the correct answer, you could, and in that situation you would need an array of 201. But I'm getting into the weeds here. We're not talking about the particular size that we need. The point of it is you need to make sure that your array is large enough to store whatever you're going to put into it. If you fill the array and then you want to add more stuff to it, too bad, it's not going to happen. Now there are some ways around this if you do want to make like a dynamic array, and that is where vectors come in. You could also use dynamic memory if you want to make things real complicated, but that's the thing of C. You don't need to do that, you can just use vectors. So vectors inside of other programming languages are often known as lists or array lists. It's basically an array, but you can add more elements as you go. So if you don't know the size ahead of time, you can just leave it at the default size and you can just add elements one at a time. If it runs out of space in memory, it'll just make a new collection and it'll copy all your elements over all behind the scenes and you're not even going to know. So let me clear this off and we'll get an overview. So arrays are statically sized. Vectors are dynamically sized. This is the most friendly to work with. This is what I recommend. There was also that third type, which was templatized arrays, which we're going to be talking about later on. But basically, a templatized array is a normal array that's wrapped inside of an object. So we have an object that contains an array. And this just gives us some extra features. Specifically, it allows us to keep track of the size of the array, which is a little bit more difficult with the standard array. And that's another capability of vectors. This thing knows its size, meaning it understands how many elements it has. Arrays do not have any knowledge of their size, so you have to go through a little bit of extra work to calculate their size. And if you're working with functions, passing arrays around, you can actually lose that size and you have to pass it in as a separate argument. Not very pleasant, but it is possible. And if you're going to be working with other people's code, then there might be situations where you have to use arrays, so you definitely need to understand them. So here's what's going down. In the next video, we're going to be talking about arrays, basically go through all of the elements in the array. Then we're going to talk about how to pass arrays to functions and use them within a more complicated application. This is all practice to ultimately allow us to use this array to store our guesses for our guessing game. Then we're basically going to go back and do the same thing but for these other types, and by the end of this section you're going to be a collection master. Now there are some other collections inside of C++, there are even custom collections you can get that other people have developed, so you might hear stuff of like linked list or queues and stacks or sets. All of these different types of collections or data structures are a thing you can use, but this is kind of like the basis, and this will basically give you the foundation needed to understand all those data types. So I highly recommend you understand these three first, and that's what we're going to be doing. So hopefully this video was a nice and good introduction for you, and we're going to get into a little bit more in the upcoming videos. If you've enjoyed this content, do me a favor and subscribe to this channel. By do me a favor, I'm telling you to do it. You better do it. So yeah guys, subscribe, and I'll see you in the next video. Thank you.
Hey everyone, welcome back. This video we're going to begin our discussion on arrays and how to work with them. Now make sure you check out the previous video if you were just jumping in here. That's going to give you the foundational layer for collections in general. That's where we talk about arrays, vectors, and templatized arrays. So highly recommended you check that video out. But if you don't want to, that's fine. Let's just jump right in. So what does an array look like? Well, this is a brand new file, so you can just start with me typing this out. First thing, we need to make a main function. That's going to look like that. And you can put the return 0 if you want, but it will implicitly return 0 if you don't put that. Now, in general, I just include ifstream because I tend to use that in every single example. So we're going to create a collection, specifically an array. And by the way, the term collection is a more general term to include arrays, vectors, and basically anything that can store multiple pieces of data in one variable. So if I say collection, I could mean any of those things, but in this situation, we're specifically talking about the boring standard C arrays. So let's create one. It's going to look a little bit something like this. And it's usually a plural name, so it's clear that it's a collection. And then in here, you can put the number of elements you want to be able to contain. We'll go with 20. Now, a cool little trick, if you know the data ahead of time, you don't have to put this value here. You can leave that blank and you can assign it the values. So for example, we can put a 10, a 13, a 54, and whatever we want the data to be. So this is a great way to basically fill the array, but the thing is, it'll only fill it to fit the amount of data we have right here. So in this case, it's going to make the size 7. So it'd be the same thing as making the size 7 there. So this is a great option if you need to basically put all of the data in ahead of time, and you know that at compile time, maybe there's a select couple of options for some particular thing.
but usually you don't know all of the data ahead of time, so instead you need to basically type in that data there, and my battery is low, so I should probably get a plugin. Macs always tend to annoy me when it comes to battery because they give you about 30 seconds to get a plugin before it shuts down, or at least that's my experience. So here's what we're going to do. We're going to work with this guesses array as is, and then we'll go through an example where we don't pre-fill it with data. So when it comes to the variable guesses, the square brackets are attached to it when we create it, but when we reference that array, you don't use the square brackets. So for example, if you wanted to pass this entire array to a function, you would just use the keyword guesses. So if somebody asks you what guesses is, the answer is an integer array. But oftentimes you are going to see that integer array with square brackets and some number. And this is basically a way to grab an element by the index. So for example, if we put the value 3, that's going to grab the element with the index 3. This is 0, this is 1, this is 2, and this is 3. So it's going to give us the value 42. And this is an integer. So if somebody asked you what guesses index 3 is, it would be an integer. You may also hear this read as guesses of 3. So basically the square brackets in a number can be read of some number, but you can basically call it whatever you want. Just be clear that you're grabbing the element inside of guesses. And because this is an integer, we can use it anywhere an integer is expected, including inside of an output. So we can try it here. When we run this thing, we can see we get the value 42, so it seems that we did it just like we were expecting. We can also modify the elements using that index. So for example, I could go down here and say guesses of 3 is now going to be equal to 300. Outputting it again, you can see that that value will now be updated. It first spits out 42, and then it spits out 300. So next thing I wanted to talk about is how to work with the array when we don't have that data already there. So for example, let's say we have guesses and it has the size 20. Well, now we need to manually put that data in. I'm going to talk about filling an array from user input inside of a loop in a couple of videos, but for now, let's just do a single element. You can do that by saying guesses of 0 and assigning it some value, or you can get it from standard input. So for example, we can say standard cin, and store that inside of guesses 0. So now when we output, we could output guesses of 0 and see what the value is. When we run this, we put in a value 413, and you can see it outputs 413. So that is how you can assign a value if you want to assign each one manually in code, or you can do it from console input using this technique right here. Now, one downside with these stupid darn arrays is that you might have a size bigger than the total number of elements inside of the array. So you might have the size 20, but you might only fill 5 of those spots. So sometimes you're required to keep track of how many elements are in the array, even though the size is right there. So you might do that with another variable. Usually you wouldn't call it size, you would call it something like number of elements. And then that could contain 5. The reason you wouldn't call it size, because usually size indicates this value right here. It's the total possible size of the array. This is going to come up when we're working with loops. So now I want to talk about how we can iterate through an array and print out each element. So I'm going to assign this a bunch of elements. Here, let's just do it the nice and easy way. Like that. And now we're going to use a for loop. Typically you'll use a for loop for iterating through collections. We'll say int I equals 0, I is less than something, let's just call it size, and then I++. Now if you're coming from other languages, you might be used to seeing something like guesses.size or guesses.length, but that doesn't quite work when it comes to C-style arrays. Instead, we have to calculate that size. So what we're going to do is we're going to create a variable, call it int size. And how are we going to get this value? Well, we actually use this sizeof operator and we pass in guesses. That's going to give us the total size, which isn't quite what we want, but I just want to show you guys. We're going to output that. So we got the size and we're outputting it here. When we run this, we get the value 20. But there's 5 elements. So each element is taking up 4 of these numbers. So What are these numbers? These numbers are actually bytes. So the total size of guesses is 20 bytes. In order to get the number of elements, we actually have to divide this by the size of one element. So we could say divided by size of, you could say guesses of 0 if you wanted. Sorry, guesses, plural. And now we get the output 5. So that's how we can calculate the size. There's 5 elements, 1, 2, 3, 4, 5. Now inside of our for loop, it's going to correctly reference that size, and we should be able to output each element, like so. When we run this thing, you can see we get each element starting with 12. The 5 is not part of that, that's the size. So that's coming from this line, and then it starts on 12, 43, 23, 43, and 23. Cool, now the thing you got to keep in mind is that if the size of the array is larger than the number of elements, it's going to mess things up just a little bit. So to see this, I'm actually going to replace this end line with a tab just to make it a little cleaner. Keep it all in one line. When we run this thing, you can see we get 12, 43, 23, blah, 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 and then we get a bunch of these zeros. So that is basically just the default integer when the size is larger. And in this case, we have a size of 10, so it prints out 10 numbers. Oftentimes, these zeros are going to be useless and you're not going to want to use them. So we need a different way to keep track of where to stop. Size is not going to work in this case, so you might have a different variable such as int num elements, and that's going to be equal to 5. And then for our for loop, instead of comparing the size, we can compare it to num elements. And now when we run it, we only get the first 5 elements, even though the size tells us there's 10 elements. Another way you might see is to put a -1. If, for example, all the numbers are positive and a -1 would be unacceptable, then you might use a -1 as basically a flag to say we're done, and you can case on that and see if the value is -1. Not my favorite method. I'd prefer to keep track of the elements separately. But that is very similar to the way C-style strings work with using the null terminating character as basically a stopping point. So it's totally not unheard of. You might see that in your coding experience. So that, my friends, is my introduction to collections, specifically arrays, and how to use them. Hopefully that gave you a really clear picture of how they work and their limitations. One more thing I wanted to throw out here is that this size thing, although it works, it also has its limitations because that's not going to work inside of a function call. What do I mean exactly? Well, that's actually the topic of the next video. We're going to be talking about how to use arrays inside of functions. So be sure to check that out, and if you've enjoyed this content, do me a favor and click that subscribe button. It really helps out the channel, and you know, it's basically my value indicator, so yeah, go click it. Alright, thanks guys. See you in the next one. Hey, what's going on everybody? Welcome back. In the previous video, we talked about working with arrays. Nice and simple. Go check out that video if you need the basics, but this video, we're going to be talking about how to work with arrays when it comes to passing them to functions, because there's a couple things you got to know. Now, when it comes to defining an array, there's a lot of things you got to keep in mind because they're not exactly the most intuitive thing to work with. For example, we talked about how it's statically sized. We sometimes don't have enough elements to fill all of the statically sized sizing, if that makes any sense. And other things include we have to calculate the size using this weird sizeof operator calculation, and it's just a little bit clunky. But it gets even worse when we're dealing with functions. So we're going to create a function, and I think by the end of this we'll have a function that will print the array, but the main thing I'm concerned about is just parameters and arguments for right now. So let's just create the function. We'll just call it print array. And what is the return type going to be? Well, because this is doing something for us, it's not, oh, seriously, battery, why do you do this to me? So this function is going to print stuff, but it's not going to return anything, so we're going to make this function void. Now we need to talk about the parameters, and we are going to take an integer array. And what do we call it? Well, it's totally up to you. It doesn't have to be the same as the argument passed in. So we could just call it array, and then we put the square brackets there. So let's compile, make sure we don't have any syntax errors. It seems to be good. Now, how exactly do we call this? Well, first thing, let's just comment all this stuff out. We might use that later, but I don't want it for right now, so all we have to worry about is this guesses array right here. And I'm going to get rid of that size, so it's just size 5. When we pass this to print array, it's going to look like this. Print array, and then we just pass guesses in there without the square brackets.
Remember from last video I said this itself is the array. You only use the square brackets when you want to access an individual element, or when you are defining the array like so. Here we have square brackets because we're defining an array called guesses. Here we do not have square brackets because we're not defining an array, we're just using this array we already defined. And we want to reference the entire array, so no square brackets. Now the first thing I wanted to show you guys is what sizeof will give us outside of the function and inside of the function. So let's do an output, and what are we going to output? We're just going to say sizeof guesses. If you remember from the previous video, this should be 20. And I need a semicolon right there. We run this, we get the value 20. Now let's copy this and paste this inside of the print array. We also need to change the name of the array to array, because that is the variable right here. Now when you compile this, you're going to get a warning, which means we can still run it. It compiled okay, but it's just giving us a warning here saying that this is actually going to return the size of an int pointer instead of int array. So what that means is if we run this, the first time we get the value 20, and then the second time we get the value 8. So again, this is in bytes, so this is basically 64 bits. And that is the size of a pointer. And we haven't really talked about pointers, and there's not a huge use for pointers when we're just talking about basic C++. C++ did us a huge favor and got rid of the common usage of pointers that was common in C. So most of the time we can get by without using pointers, but in this case, we are actually using a pointer even if it doesn't look like we're using a pointer. And basically what's going on here is when we pass an array, guesses in this case, to a function, it decays to a pointer, to the first element in the array. What is a pointer? That's all it does. It just contains a memory address to some area of memory. The area of memory is the first element in the array. So if all that's a bunch of mumbo jumbo that doesn't really mean anything, basically what I'm saying here is that when you pass an array to a function, it loses its sense of how big it is. It no longer understands that information. So that means the sizeof operator is not very useful for us inside of this function. Now if we created an array inside of this function, sizeof would understand the size in that scenario. It's only when you pass an array to a function, inside of that function it's no longer going to know its size when you declare it as a parameter such as so. So enough of this theory stuff, let's just talk about how to fix this problem. Well, the easiest way is to have another parameter, size, and we're going to pass in the size to be used inside of this function. So we'll just get rid of this here, and instead of passing in guesses, we're actually going to pass in guesses and the value 5, which is the number of elements. You can also calculate that size if you would like. If you want to do that, just use the sizeof operator. We can assign that to a variable size. And remember, you have to divide it by the size of one of these elements to get the appropriate number. So to do that, you can say size of, and you can pass in the first element, or you could even pass in an integer because we know this is an integer array. That's probably the best way to do that. Now when we compile and run, what happens is, well, actually in this case nothing, but we don't have any warnings, so that's good. 5 gets passed to this array, and we can use that inside of here. So if we just output that, you can see that inside of the function we have that value 5. Cool. That allows us to work with the array as if we were in the main function, but we're actually inside of another function. So what we can do is we could take this for loop here, and we can take that and put it inside of our print array to iterate through that array. So I'm going to get rid of that line. Now we need to change this a little bit because we're not using number of elements, we are going to use size. So now let's compile. I have one error because I need to change the name of the array as well to array. Awesome. Now, haha, there we go. You can see we just printed that array. Maybe when we're done, we might want to do a new line. Beautiful. So that was a very long-winded explanation of how to use an array inside of a function. Fortunately, with some of the other collections, we don't have to pass in the size as a separate argument because it doesn't decay to a pointer. So once we get into vectors and templatized arrays, problem solved. Now we're going to do something very similar with our game we've been creating, our guessing game. But until then, let's just move on and learn a little bit more concepts. We're going to be talking about how to fill an array from user input. So the next video is going to be cool. Be sure to check it out and don't forget to subscribe to this channel. That would tremendously help me out. Alright, thanks guys. I'll see you then. Hey YouTube, what's going on? This video, we're going to be talking about how to fill an array from user input. Seems pretty simple, but there's a couple gotchas that I thought I'd share with you guys. So here's some code we have left over from the previous video. We have this nice function which will go through and print an array nice and pretty. My dog is drinking water, and he likes to do that when I'm trying to make a video for some reason. But anyways, inside of main, we have some of this other code. We're going to get rid of that, and we're going to keep this function call for right now because I wanted to show you something that is a little off topic, but it's important to know. So here we are initializing an array with some elements. So let's say we had the size be 100. If we wanted to print this out, pass in 100 as the size, here's what's going to happen. Nothing too crazy. We're going to have a bunch of zeros. So when you only initialize part of the array, all of the other elements are 0. But the gotcha here is that if you don't initialize the array and just put a semicolon, you're just declaring the array, the values of the elements are undefined. And what that means is the actual result is unpredictable. So when we compile this and run, you can see we get a bunch of garbage. That's just a side note that I forgot to mention when we were talking about the basics of arrays. Don't expect all of the values to be 0 unless you initialize part of the array. That might come up as you fill the array because you're probably not going to initialize it with some default values. We're probably going to just declare it and then start filling it one value at a time. Anything we don't fill, we can't assume that it's 0. It could be anything, as you guys can see. So as we work with this array, I'm actually going to take this size and put it in its own entity. We're going to make a constant. So let's say const int size. I'm going to use all caps, and we're going to set it to the value 100. And then instead of using 100, you just put the value size. And we can pass in size as the argument there. I don't actually need to calculate the size here because we are manually defining the size here. We're not initializing it with a list of values, so it's very easy just to have that value hard-coded and use that throughout our program. So I'm going to get rid of that line. All right, let's clear this mess out. And now let's talk about getting input and storing it in an array. Here's what it's going to look like. We're going to get it from console in, and we're going to store it inside of guesses. And now we need to do this inside of a loop because we need to go through all of the elements. So let's start with a for loop. I'm just going to leave this here for a second. So we'll say for int I equals 0, I is less than size, I++. Now we can take this code and paste that inside of the for loop. Oh, nice and pretty. Kidding. There we go. And then we need to put index I. All right, so let's just compile and run and just see what it looks like right now. When we run this, oh, shoot. Forgot that it was printing that array. Don't worry about all that garbage right now. We'll fix that up. It's just going to continually ask us for elements of our array, and it'll just keep doing it. And we can exit this with Control-C. I'm going to take this print array, I'm going to move it to the bottom, and then I'm going to comment it out for right now. So this seems to work, and this is the simple solution to your problem. So let's just go through an example with size 10, and we will print that array. Let's compile and run. We'll give it the values 1 through 0. And as soon as I hit 0, it prints all of those values. So it seems to be working. Awesome. There are a couple gotchas that I wanted to talk about. Specifically, when we're dealing with statically sized elements, we often make the size larger than it might need. That's because we don't necessarily know how much of the array the individual that's using it is going to need. If we're getting this from user input, they might only want to put 3 elements in there. They might want to put 300. It's hard to say. So what often happens is we make the size much larger than we might need. But the problem with this is that this for loop is going to go until we use all of these spots. We might want to stop at some particular spot. And there's a little trick I'm going to show you guys on how to do that. You can actually take this console in and put it inside of an if statement. So it's going to look like this. In the case that this is true, that means the input worked. In the case that it's false, well, actually, this means it was an invalid character. So what we can do is we could tell the user to just put in their numbers, and as soon as they're done inputting their numbers, they could push like Q, for example. It doesn't matter what the character is as long as it's not a number. So in that situation, we can actually break from that loop. So let's run this and see what happens. I'm going to comment out this print array for a moment. We don't need that for this example. When we run this, we can put in as many elements as we want, and as soon as we're done, we can put in something like Q and press enter, and you can see the application stops. So that's awesome. That's how you can stop the loop early with this if statement with the console inside of the expression. And if you're wondering why this works, well, it's a little complicated, but I'll try to explain. When you run this operation, it's actually going to return cin. And cin will only evaluate to true if it properly stored its value inside of whatever you're trying to store it in. So I guess that's not terribly complicated. Basically, this is just going to evaluate to true if it worked, and it'll be false if it did not work. And this is only going to work if we're working with numbers, because that's what we're storing it in. We're storing it in an integer array. Now, the only other thing is when it comes to this print array, we're passing in the size. But the size is going to be, in this case, 100, which is going to print the entire array. We actually only want to print a portion of the array, the number of elements that we actually input into the array. So what we're going to do is create another variable, and we'll just call it count, and we'll set that equal to 0. And each time we get a number from input, we're just going to increase count. So we can just say count plus plus, and instead of passing size, we can pass count. Uncomment this array, and now let's run it and give it a try. A.out, let's put some numbers in there. And when we're done, we can press Q. And you can see it works properly, printing 1 through 5. There we go. Now we made our input a little bit more effective. This program seems to work just fine, but there's actually one problem with it. When this evaluates to false, cin is in a non-working state. What that means is there was an error in the input. It wasn't the correct type. That is going to remain that way until we clear that state. So what we can do is we can say cin.clear. The other thing, when we put some junk here to end the loop, it's going to be left inside of the input stream. So what that means is next time we try to get some data, it's going to automatically grab that. So for example, what we can do is we can show you this. Let me just create a string. And what we're going to do is we're going to get this from console input, and then I want to output it. So when I compile and run this, and I put some data in here, and then I end the loop by just putting some junk in there, what happens is when I press enter, it doesn't even ask me for console input. It just automatically grabs this junk and stores it inside of that test variable. So the leftover stuff inside of the input stream is not automatically removed. We actually have to manually do that. One way we can do this is to say cin.ignore, and then what we're going to pass into this function is the number of characters up until the new line. So that is one way that we can clear the input stream, and now it should ask us for this input here. Let's give it a try just to make sure. Oh, I got an issue. This is not supposed to be a string, it's supposed to be a character, my bad. Now we compile and run. Let's put the same data in there, and now let's just put some junk in there. When I press enter, you can see it pauses and is asking me to put input for this test variable. So all this junk that was left over, that has been cleared, and now I can put something else in here. And you can see it works. Now there might be an alternative / better way of doing this cin ignore. You can see here this is going to ignore 10,000 characters, but you know, what if they put 10,050 characters? What's that going to do? Well, there's actually a way to clear all of the characters. The syntax is not as pretty, so I'm just going to paste it in here and you can paste it yourself, or write it down, I guess. And what this is going to do is it's going to remove the maximum number of characters. And no, I totally did not get this from Stack Overflow. I just intuitively knew how to do this. Now when you do this, you're going to have to include something, so go up to the top and say include limits. Awesome. Now we can get rid of this old ignore, and this should work just the same way, but I think it's a little bit more safe. 1, 2, 3, 4, 5. And then when we put some jargon in there, you can see it still asks us for the test variable. So it seems that everything is working, and we effectively made a loop to input into an array. So that is how you do that, guys. This is going to come up a lot also when we're working with other types of collections, so make sure you understand this content, and if you have any issues or suggestions, leave them in the comment section below. And don't forget to subscribe, you know, that helps out my channel and whatnot. Alright, peace out, guys. Hey, what's going on, everybody? Welcome back. This video, we're going to continue our discussion on how to create a guessing game. The thing we're going to be doing in this video is we're going to keep track of all of the guesses that the person has to guess, and then at the end we're going to basically spit them out and say, hey, here are the numbers you guessed. Basically a way to keep track of the progress through the game. Now when it comes to storing these guesses, you could store in any type of collection. The choice for this video is going to be an array. Later on we'll talk about how to do this with vectors as well as templatized arrays. But for now, we're just going to use the basic array, and that should work just fine. So first thing, how is the structure of the code? Well, we have this play game method, which if I collapse this, you can just consider that is the game functionality. When you first run the application, the person has the option to select 0 to quit the game, basically return from the application, or they can press 1 to play the game, and that will that'll jump up here to this function here. So this is where the actual game is, and you can go back and watch the video on how to create all this, but basically, when we run the application, here's what's going to happen. You play the game, and it's going to get a random number, and I'm outputting it here just so we can see it, but in the actual thing, you wouldn't want to output it to the screen there. And then as you guess numbers, it's going to say if it's too low or if it's too high, and eventually you'll get the number just right. So that's how the game works, and you can exit using 0. There you go. So now let's talk about how to create this array. At the very top, we're going to initialize the array. This is going to be an integer array, and the size for this thing needs to be at least 250. Now we do keep track of what the guess value is right here inside of this guess variable, but what we don't keep track of is the number of the guess, basically how many times it took them to get the guess. So in order to do that, what we're going to do is we're going to create a guess count, and this is going to be used as the index to insert data into the array. So we're going to start this at 0, since it's a 0-based data structure. Arrays start at 0. Now we're going to insert data into this array every time we make a guess. So after we put a guess, what we're going to do is we're going to say guesses, and then we're going to pass in the index of guess count, which is going to start at 0, and we're going to assign that the guess value. Now each time through this loop, we want to increment guess count. That way we're not just writing to the same spot in the array. So you can do that two ways. The first way is you could say guess count plus plus, like that. But another way you could do this, let me just space this out a little bit, is you could actually put the plus plus here and get rid of this statement altogether. And that should work exactly the same way. Basically, it's going to access index 0, and then it's going to increment the value of this variable. This is where the important concept of postfix versus prefix increments comes up. If you were to do plus plus guess count, that's not going to work the same way because that's going to increment first, and then it's going to assign guess to index 1 instead of 0 for the first time. So we want to make sure we put those pluses at the end, or do it in a separate statement if that's easier to read for you guys. The last thing is at the end of the game, we're going to output all of these values. So what I'm going to do is at the end, right after we do the while loop, we're going to just call a function to print the array. If I can type, there we go. And we're going to pass in guesses and guess count, which is going to basically be the count of elements. Remember, when we're working with arrays, we have to pass that as a separate argument. So let's go up to the top and define this function. This is going to be void since this is going to print to the console. It's called print array, and it takes an integer array and an integer count. Then all we have to do is do a for loop to increment through all of the elements. Int I equals 0, I is less than count, I plus plus. And then in here, all I'm going to do is output the array of I. So that's going to look like this. We're going to say array index I, and then I'll just do a tab character, like so. All right, let's run it and give it a try. When we play the game, we got the value 25 to guess. Let's say we guess 20, then we guess 30, maybe 27, 26, and then finally we guess 25. And look at that, it outputs all of these values. Now at first when I saw this, I was like, why is it printing this 0? But I see that it's actually just the actual menu being displayed, 0 for quit, 1 for play game. So that tripped me up for a minute. So what we need to do is we just need to do an end line here, like that, and that should fix the problem. Let's just make sure we got everything going good. We play the game, we guess 228, 230, and then 229. And you can see it outputs those values. So if you wanted, you could prefix this saying, hey, here is your sequence of guesses. It took you 3 tries, or whatever you want. Do something creative, try to make the game a little bit fun, make it very rewarding, trying to get less guesses and do better. So that's all I got for you guys in this video. Hopefully that was helpful. In the next video, we're going to flip our discussion and start talking about vectors, which are honestly a lot better than arrays. So look forward to it, check it out. And if you've enjoyed this content, please be sure to subscribe. All right, I'll catch you guys in the next video.
Hey, what is going on, everybody? Welcome back to your C++ tutorial series. This is, I believe, video number 50, so you're making pretty good progress, but don't quit. There's still a lot more we got to cover. So what are we going to be talking about in this video?
Well, it's going to be more on collections, but specifically vectors. So we talked a little bit about vectors when we introduced the concept of collections, but we really just dived into arrays and left vectors kind of unexplained. So that's what we're going to be doing in this video. This is going to be the concepts of vectors, and then in the next video we're going to go through some code on how to work with vectors. So what do we need to talk about when it comes to the concepts of vectors? First, what is a vector? Well, first thing, I'm not really entirely sure why it's called a vector. Maybe there's some reason behind that. Other languages often call the equivalent data structure a list or an array list. Very similar to an array in nature, but the difference is that the size is dynamic. And that is the big thing with vectors that you need to understand. So with an array, the size is static. So when you create an array, you put the size inside of square brackets, such as 12 for example, or you assign it something that would allow it to determine the size. So you might assign a sequence of values, and in this case, the size would be 2. With a vector, it doesn't work like that. You create a vector like this. It's in the standard namespace, and then you say vector, and then you use this caret, and then a closing caret, and you can put the type inside of the carets. So it might look like that, and then you give it a name, like so. And then you can also assign it a sequence of values like that, so you could say 12 and 13. A very common way of working with these is to use a special method that comes with vectors, and that would look like this. So for the items vector, you would say items dot push back. And then inside of parentheses is where you would put that value. So in this case, we're adding the value 100 to the vector. Now when the vector was first created, there was only 2 elements in it. 1, 2. So adding another element might go beyond the memory allocated for this vector. And if that's the situation, whenever you add an element and it goes beyond the memory that's allocated for it, what it's going to do is it's actually going to reallocate memory that's larger and can contain that new element, and it's all going to happen behind the scenes. So it's going to copy the old data and put it in that new allocated memory, and it's going to work exactly the same way. From our perspective, nothing has changed, but behind the scenes, it basically expanded how much memory this vector is using. And there's all kinds of different methods you can use with vectors to look at how much memory they're using and so forth. But the main thing we want to use is just adding elements and getting those elements back out. So how do we get elements back out of a vector? Exactly the same way as you would with an array. So all you would have to do to grab that 100 is you would say items, and then using array-like syntax, you would just say index 2. This is index 0, this is index 1, and then this is index 2. But you know what else is very awesome when it comes to vectors is they actually know their size. So if you remember when we were working with arrays, we had to calculate their size using the sizeof operator. Well, we don't gotta do none of that junk anymore. There is a special method attached to items that'll give us the size. So that will look like this. You just say items.size. So in this case, it's going to return 3. 1, 2, 3. Keep in mind, the indexes are always shifted 1 over, so the indexes are 0, 1, and 2, whereas the size is 1, 2, 3. So if you want to grab the last element of the vector, what you can do is you could actually say items, and then for the index to pass, what you could do is say items.size minus 1. So that is how you can dynamically grab that last element inside of the vector. I'll also briefly show you some of the other methods that are available for vectors because there's a lot more stuff you can do. But if you know how to add elements to it and get those elements back out and calculate the size, that's basically all you need to know how to do for the majority of applications. So very, very simple in nature, a lot easier than working with arrays. Now I did want to talk a little bit about this less than and greater than sign, or these carets, whatever you want to call them. This is something you're going to run across a lot when you get into some more advanced C++ development. And even not that advanced stuff. Vectors aren't that crazy, but they're starting to come up already. The reason that vector has these carets is because it's part of what's known as the standard template library, which is basically a collection of classes that give us functionality for C++ development. One of the functionalities it does is templatized data structures. What do I mean by templatized? Well, this is an example of a templatized data structure because we can pass in what data type
we're going to be working with. So we'll get into that more in the upcoming videos, but for now, all you should know is that when you have a data type that has the less than and greater than symbols, you will be passing in a type here, and the data structure, vector in this case, is designed to work with various types. So we're using an integer here, but you could use a string, you could use a custom type. We'll get into that in the next video. If you're coming from another language, you might know this concept as a generic. So a generic class in C#, for example, is the same thing as a templatized class in C++. So anytime we're talking about templates, you can equate those to generics if you know the term generics. Now, if generics is also a brand new term, then maybe we're just getting into the dirt here and we don't need to worry about all this. All you really need to know is that you create a vector by passing in the type inside of these carets. Here's how you add stuff, here's how you get stuff, and here's how you get the size. One last thing before you go is that when you're working with vectors and you have some function, let's say this is a function, and this function takes a vector as an input into one of the parameters, well, it's actually going to copy that whole vector into that new variable. That might be something you want, but that's not always what you want, so we need to talk a little bit about passing by reference, and we're going to be getting into that too. One beautiful thing though with vectors is that if you do pass it to a function, it remembers its size. If you remember arrays, the only way you could get the size using the sizeof operator was if you were in the same scope that the array was defined in. That's not the case with vectors. It's always going to know the size, so it makes our lives 1,000 times easier. It's worth it. So make sure you learn this stuff, guys. Thank you for watching, and please be sure to subscribe if you've enjoyed this content, and I'll see you in the next video. Peace.
Hey, what's going on, everybody? Welcome back. This video, we're going to get hands-on with the vector data type / data structure. So this is a great way to get started with dynamic collections. It's one of the most common ones inside of C++, and it's definitely something you're going to want to know. And if you're stuck using arrays and you're like, I don't need vectors, then just stop. Listen to me, guys, you definitely want to use vectors. When we want to work with vectors, we need to include vector. That's going to allow us to use vectors. And to create a vector, all we have to do is say standard vector, choose a type such as integer, give it a name, and we could even assign it some values. So we could say 1, 2, and 3. We could also add data to this vector by saying data, push back, and passing in a value into here. So we'll just pass in the value 12. If we want to output a particular value, all we have to do is say data, and then use array-like syntax with the square brackets and pass in an index. So we could pass in an index of 3 to get the value 12. Now when I compile here, I'm going to use the flag to say this is C++ 11. That's because vectors are part of C++ 11, and if you fail to put that on here, we get an error. It's actually a bit discouraging here because the error doesn't really indicate that you need to use C++ 11, which I guess that makes sense, but if you don't know to use C++ 11, you might be looking at this trying to debug it for hours. So make sure you are using C++ 11 when you are compiling, and that will allow your code to work. Now when we output, we get the value 12. So it seems to be working. Now instead of using the index 3, you could actually pass in here the length -1. So to do that, all you have to do is say data.size -1, like that, and we can compile and run, and we get the same exact thing. So size is a very important method to get how many elements are in the array. Now another method I wanted to share with you guys was pop back. That'll actually remove the last element in the vector. So we can call pop back here. Now when we call size, it should be 1 less, so we're going to have 1, 2, 3. And you can see we get the value 3. So the size is dynamic. If you expand it and then remove elements, the size shrinks, so it doesn't stay at the largest size. It will shrink with the number of elements. So that is pretty awesome because with arrays, you sometimes have to worry about there being some extra space at the end that's not being used. That's not really the case with vectors. We don't have to worry about that when it comes to the front end. On the back end of the memory, we don't have to worry about any of that. So if there's extra memory or anything like that, none of that matters to us. Now there actually is a series of methods that can be used to get more information about the memory that's being used. So here is a Geeks for Geeks article talking about size, max size, capacity, resizing, emptying, shrink to fit, reserve, basically a bunch of different arrays that do very similar things when it comes to working with the memory. But I basically showed you most of what you'll be using. You may also see some of these methods here, such as front, back. This will give you the first element this will give you the last element. This might be a better option than passing in the size -1. There's also some modifier methods down here, so we can swap data, we can insert new data using this inplace method, and much more. If you want to learn more, I'd encourage you to try some of these methods out, but basically everything we covered should get you pretty good working knowledge of vectors. In the next video, what we're going to be doing is we're going to be talking about how you can take vectors and pass them to functions and the things you need to know when that comes up. So be sure to check out the next video, guys, and please be sure to subscribe. Hey, what's going on, everybody? Welcome back. This video, we're going to be talking about vectors and passing them to functions. I'm going to tell you what you need to know to make sure you do that in the correct, best way. Now, when you have a vector and you want to pass it to a function, it's very simple. We're going to start by creating a void function, and all it's going to do is it's going to print the vector. Now, what you're going to pass into this is this vector, so we need to create a parameter to store that, which is going to be of the same type. So it's going to be a vector of type int, and you can name it whatever you want. It does not have to match this variable here. Now, inside of this function, we can access the size of this vector using a method. And that's one of the huge pluses of using vectors is they always know their size. So I'll show you that inside of a for loop. We'll just say int I equals 0, I is less than data dot size, I++. So that is the technique to iterate through this entire vector, and then inside of the for loop, we can output each element using cout and accessing data index I. And then I'll just put a tab character right there. Now when I compile this, you want to make sure that you put standard equals C++11. So when we output this, oh yeah, we should probably call that function, so what we need to do is say print vector and pass in data. So that is how you would call the function. Now when I compile and run, you can see it outputs 1, 2, 3. If you want to get this on a new line, all you got to do is output a new line right here. Just like that, beautiful. And there you go. Now the big thing you got to know with vectors is that this variable here and this variable here are two separate variables. The data here is actually copied into this variable here. That means any changes we do to the vector inside of this function do not exist inside of main. To show that, we can call a function pushback, so we can say data.pushback, and then pass some data in here. Let's just say the value 12, and then if this was the same variable, every time we ran this function, a new 12 would be added to that vector. But you're going to see that's not the case, because if I call this print vector a couple of times, it's just going to output the same array every single time. When we run this, you can see it's always 1, 2, 3, 12. That's because we add the 12, the function finishes, we call it again, and it starts from scratch. Adding the 12, printing it, and then going back to main. The way around this, if you want to share memory from this vector, all you have to do is add an ampersand or stand or whatever it's called, the and sign, right here before the variable name. Now it's going to basically copy the memory location, which is called passing by reference. Now when we run this, you can see every single time a new 12 is appended to the vector. When should you pass by value and when should you pass by reference? Well, if you have a huge vector, you might not want to copy by value because that's going to use a lot of memory. And if there's ever a situation where you want to change the original variable inside of the function, then all you got to do is pass it by reference. So that's all I got for you guys in this video. Thank you for watching. I have people waiting to walk in the door, so they're patiently waiting for me to finish, slowly squeaking on the floor. So, all right, see you guys in the next video. Yo, welcome back, everybody. This video, we're going to be refactoring our little guessing game to use a vector instead of an array. So just a little bit more practice with vectors, and they're honestly a better data structure, so I'm going to recommend them for this game, and that's what we're going to use. All right, so what do we got going on here? Well, we have this play game, and we have this guesses array, where we're basically storing a bunch of guesses as this game goes. So every time we try to guess this random number, it enters that value into this guesses array. Refactoring this to a vector should be very easy, especially when it comes to this function we created to print an array. It should work exactly the same. The only thing we got to do is change this data type for this parameter. That's because we can still use the indexing syntax for vectors. Everything else should work exactly the same. Additionally, we'll get rid of this count variable and replace it with the size of the vector. So it should be very simple. We talked about how to print vectors in the previous video, so go make sure you check that video out. So where is this array being used? Well, if you look in our code, first thing is we're storing this in a guess variable, and then we're storing that guess inside of this guesses array. So here's what we need to do. We need to replace this array with a vector of type integer, like so. And we can get rid of the size here. Now scroll down a little bit, and where we're assigning it to this value here, we don't have to keep track of this guess count anymore because the guesses variable will be able to determine the size itself using the size method. So actually where that variable is defined, we can just get rid of that. So that's nice. Now we get rid of this here, and all we have to do is say guesses dot push back. Well, okay, let me try this again. Push back. And now we just pass guess inside of there as an argument, and there you go. Now at the end, you can see we have print array. Well, what we're going to do is we're going to get rid of this guess count here and just pass in the vector. It would be more appropriately named print vector. So we're going to change the name of this function. Now we scroll up to that function definition, change it to print vector. There you go. Change this to an integer vector. There we go. And get rid of this count variable. And we also have to give it a name, so we'll just call it vector. Cool. Now instead of using count here, what we're going to do is use vector.size. Now let's compile, because I probably forgot something. Make sure I got all my syntax right. Alright, looks like I got a bunch of errors because I'm a noob. First thing I need to do is I need to include vector. That's important. Alright, let's compile. And instead of using array of I, we need to use vector of I. Well, there we go. Alright, I only had 2 errors. I guess that's not too bad. Now, let's play the game, make sure it works. Play game, and we have to guess some numbers. The answer is 79, so we'll go with, I don't know, 58, 99, 77, 79, and we got it. As you can see, it prints all of the values just like before. So this is a beautiful example of refactoring. The actual output and the functionality of the game is exactly the same, but the code is more elegant, it's more manageable, and it's just freaking awesome. Alright, so that's all I got in this video, guys. Be sure to check out the next one, where we're going to be talking about arrays, but not just normal arrays. We're going to be talking about arrays from the standard template library. So check it out, and be sure to subscribe.
Hey, what's going on, everybody? Welcome back to your C++ tutorial series. I have a beautiful message here left by my spouse for, quote, all of my fans from your amazing wifey poo. So, there you go, guys. Is that good? This video, we're going to be talking about STL Arrays, Standard Template Library Arrays. Now, when it comes to templatized arrays, it works very similar to normal arrays, but it's also very similar to vectors. So if we had a spectrum from hard to use to very easy to use, we would have arrays on one end, something like this, where this is very complicated, this is very easy. Templatized arrays are somewhere in the middle. So when you create a templatized array, it's going to look like this. I forget. It's in the standard namespace, and then you just say array, and then inside of carets, you would say the type and the size. So this is what I mean by templatized. It has a type inside of these template marks, or the carets, the less than and greater than sign. Anytime you see these, you can think of templates or generic programming. So let's look at some of the differences between arrays and vectors and where the templatized arrays fit in. Well, arrays are statically sized. Vectors are dynamically sized. The templatized array is on that side. It's statically sized. Arrays, when passed to functions, do not remember their length. Vectors, when passed to functions, do remember their length. Templatized arrays are on this side. They remember their length. Last thing is that when arrays are passed to functions, they're passed as pointers. Vectors are passed by value, meaning they're copied. Templatized arrays are similar to vectors in that they are copied. So hopefully that kind of helps you see that the templatized array is somewhere in the middle. It kind of acts like an array, but with some of the capabilities of a vector. Specifically, it knows its size and it is passed by value. So this would be an ideal data type if you're working with something that you know the size of. You know, for example, it's going to be 20 elements, but you don't necessarily want to work with this crappy array and you want something a little bit more beefed out. Then you might want to look into the templatized array. How does it work exactly? Well, it's essentially an array wrapped in an object.
So you can think of it like this. Here we have some object, and then inside of this we have an array. So we have all the normal capabilities of this array, but with a little bit extra features around it, which comes from the object that kind of wraps around it. So this is where understanding the size comes in. It's part of that object wrapping. So that's how you can basically understand how a templatized array works. It's like we're working with a normal array, but just has an extra layer of capabilities. Now we can use this array just like we would use a normal array or a vector. If, for example, this was called ages, and we could assign it some values. We can access these values using array-like indexing. So we could say ages of 0 to get that first element, 1 to get the second element, and 2 to get that third element. So actually using the array, it's almost identical to this array, or even vectors, because you can actually do this with vectors too. But the primary difference is you get a little bit of extra capabilities. Specifically, you can do stuff like this. Ages.size, which is a member function, also known as a method, of this ages object, which is a templatized array. So this will give you how many elements. In this case, it would return 3. It returns an integer, so you could output it, or you could pass it to another array, or just use it as if it was any integer. So very simple concepts. Hopefully that was nice and simple for you guys. In the next video, we're gonna get a little bit of practice working with templatized arrays. Very super easy, and it's gonna be a good video. So make sure you check out that part so you don't just get the concept, but you actually get some hands-on work with the array. And with that, I'll see you guys in the next video, and yeah, be sure to subscribe. Hey, what's going on everybody? This video we are going to be talking about standard template library arrays. So basically templatized arrays, it's a class. We're going to create an instance of this class and we'll be able to work with it as if it's a normal array, but there's a lot of benefits. That's what we're going to be talking about in this video. Alright, so how do we create an array? Well, I have this code from a couple of videos ago where we were working with vectors. The actual syntax for working with arrays is very similar to vectors. It's just the underlying structure is a bit different. So instead of saying vector here, we're just going to say array, and then inside of the carets, we need to put a comma and the size of the array. So this is still going to be statically sized. That means if you need a dynamically sized collection, then this is not for you. You want to stick with the vector. So what we're doing is we're giving it 20 spots and filling 3 of those with these values right here. Now in order to use array here, what we're going to need to do is go to the top and say include array. There we go. Now, if we comment out this function call right there and compile, it should work. Beautiful. So everything compiled. Here's how we create an array. And now we're going to go through the example of how to use the array. Fortunately, the array class here has a size method. So that's one of the benefits of using this over the normal array, the C-style array, is that it adds a little bit of functionality that makes our lives a little bit easier. One of which is the size method. So that means if I want to call this method, we don't actually have to pass in the size as a separate argument. So all we have to do to make this work is we need to change this method a little bit. So instead of taking a vector, what this is going to do is it's going to take an array, and this array is going to have the size 20. And I'm not going to pass it as reference for right now. Now, in our caller, we can just uncomment this and compile. Now I did get an error, but that's just because of a stupid example I was going through with vectors. We can just get rid of that line there, and basically this function is just going to print that array. And it would also make sense if instead of saying print vector, it would say print array right there. Now let's compile and run, and we get a bunch of data here. You can see it prints 1, 2, 3 and a bunch of zeros. So the actual code compiles, it runs. It may not give you the expected output, but it actually is correct. The reason that's correct is because it does have the size method, which is going to include all of the elements all the way up to 20. Since we're only using 3, if you wanted to only print 1, 2, and 3, you would need to pass in a separate argument and keep track of these separately. So for example, we could pass in a 3 here, and instead of using a size, we could take another argument, int size, replace this function call with just size, like that. Now when we compile and run, you see we get 1, 2, 3. Just like vectors, we can also pass these things by reference by using the and sign, capital 7. That's not going to change the functionality here, but it does allow us to change this array inside of the print array function.
So if that's something you want to do, you can. Another thing is if you have a huge array, this might save a little bit of memory because it doesn't have to copy that whole array into another variable. So what you choose is up to you. Just know that both options exist. You can pass by value or you can pass by reference. So that, my friends, is how to work with standard template library arrays. In the next video, we're actually going to go into our little game we are making to play a game or a guessing game, and we're going to replace this vector with an array. Now, is that the best choice? If it was up to me, I'd probably stick with vectors, but since we're getting some practice with these standard template library arrays, what we're going to do is we're just going to refactor this just to get a little bit more experience. So be sure to check out the next video, and thank you guys for watching. Oh, and don't forget to subscribe. Hey, welcome back everybody. In this video, we are going to refactor our guessing game, and what we're going to do is we're going to replace this vector with a templatized array. Now, would you actually want to do this? Probably not, but it doesn't hurt to practice because we definitely are going to run into these arrays, so we want to make sure we have them down pretty good. Now, first thing when you want to work with templatized array is you need to include them at the top. So what we're going to do is just say include and say array. Simple as that. Now the way this application works is we have this print vector function. We're going to change that to a print array function. We talked about that in the previous video. Should be very simple. And we have this play game function where we're using this vector. So we're just going to change this to an array, and we need to pass in a size. We'll say 251. That's because the random number can be anywhere from 0 to 250. So if you want to include all possibilities, you need to make it 251. That will also include space for the correct answer, so you can store that in the array as well. We're also going to need to define a count variable, which is basically going to keep track of how many guesses it took them to get it right. That's because although we might be able to get the size of the entire array, it doesn't necessarily tell us how many of those elements are filled with actual data. So this is the easiest way to basically say how many of the spots in the array are being used. So every single time through this iteration, we're going to increment count, and the easiest way to do that is within the insertion. So we're just going to say guesses, index, count, plus plus. So the first iteration, that's going to be 0, and then it will increment, and then it'll be 1, and so forth. So what are we going to assign to this index? We're going to assign guess. So we can just get rid of this line here. There we go. And now at the bottom, we have a function call to print vector. We're just going to also pass in the count. And instead of print vector, we're going to rename this to print array. Now let's go refactor that function to make sure it works properly. So let's scroll to the top. First things first, let's change the name. We'll just make it print array. And this is going to take an array of size 251. We can name this sucker array. We're also going to have that count variable, so we'll just go into, I'm just going to call it size in this case. You can call it whatever you want. Now instead of vector.size, we're just going to use the size parameter, and instead of vector of I, we're going to call array of I. So that should work, but let's just compile, make sure we got everything going. Now when we run, we can play the game and guess some numbers. Let's go 97, 98, 100, and then 99. And we get it, and it all prints out just fine. So that is how you would refactor this to use an array, specifically a templatized array. So once again, maybe it's not the best practice. I'd probably stick with the vector, but now I would say your experience with templatized arrays is pretty good. So what we're going to be doing in the next video is we're going to basically take the 3 collections we've talked about so far, give the pros and cons of each, the differences between them, and when you should use which. And then at that point, I'll say you have a pretty good solid understanding of the basic collections, and we can move on to something new. So check that video out because it's going to basically wrap up everything we've been talking about. It'll be tremendously helpful. And thank you guys for watching. Please be sure to subscribe if you've enjoyed this content. Peace, and I'll see you in the next video.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video here is going to take a lot of the information we've been talking about over the last 10 videos or so with collections and basically summarizing it. So we talked about what I would consider are the beginner collections. We talked about arrays, templatized arrays, and vectors. We've talked about their differences and when to use which, but maybe it's just been scattered across too many videos. I thought it would be ideal if I collected all that information and made a video on when to use which. So hopefully this video helps you clear everything up, and if you already got this stuff down, then you're free to jump to the next video. So up front, one of the big differences between arrays, templatized arrays, and vectors is whether or not you can assign one of them to another variable of the same type.
So for example, let's say we create a vector. We call this stuff. And then let's say you assign some values to it. You can do that. Then we take stuff and we assign it back to another vector. So this one is called things, and we assign it the value stuff. This is essentially going to copy that vector into this vector called things. You can do that with vectors, and you can do that with templatized arrays, but you cannot do that with the standard C-style arrays. It's not going to let you. So when it comes to C-style arrays, it's much harder to work with. If you already have some variable that contains data and you want to put it into that, you might have to iterate through that collection and assign it one at a time to this array. When you're working with vectors and templatized arrays, it's nice and simple. You can just do a copy by assigning the value to another variable. So that's the first big difference. That might come up, maybe not. Not really sure, but it's good to know. Now, when you start reading stuff on the internet, you'll find people saying, oh, this one's faster or this one's more optimized. And the majority of time, this is not going to matter. That's because where you are at in your learning, optimizing your applications should not be a huge concern. Usually, problems with your application speed is not going to come from what data type you used. Usually it's going to come from the way you designed the system and basically the architecture of your application. This is a concept known as premature optimization. It's a very common problem with beginners where you're basically trying to optimize your application for speed, usually on the things that don't make the biggest difference. So maybe if you're building some really large scale applications, you really need to think about it up front, but most of the times you don't have to worry about speed issues until you have a very obvious bottleneck in your application use. So what I'm telling you guys is don't worry about which one's faster when it comes to data structures. And these are all pretty much the same, but there are some other data structures out there you can use, some other data types. Don't worry about the speed right now, just worry about what is easiest to use in your application. So focus on ease of use and ease of developing over application speed. Later down the road, you can profile your applications, figure out what's causing issues, and you can speed up your applications. But for now, just focus on what's easiest. So the shortened version of this video, I know we're pretty far into it already, but just use vectors. They're overall easier to use and more scalable when it comes to managing a code base. So don't worry about arrays or templatized arrays unless you have a very specific use case where you need to use those, such as a project that requires them or a school project. Then you might want to use those, but other times use vectors. Now, if you're in the situation where you need to use the arrays and you have to choose between C-style arrays or the templatized arrays, go with the templatized arrays. Again, they are better than the C-style array. So far the templatized arrays and the vectors can be assigned to other variables of the same type. Another difference between those two and the C-style arrays is that the C-style arrays are passed by pointer. In other words, when you pass an array to a function, it decays to a pointer and basically forgets how large the size of memory reserved for that array is. So you usually have to pass an additional size. The significance of passing by pointer means that you can modify the array by default inside of the function, whereas the other ones, it's passed by value, so it's just a copy and you can't change the variable that you passed in by default. You have to pass by reference if you want to change those values. Both vectors and templatized arrays have a size method that you can use to get the size of the array or vector, whereas when it comes to arrays, the standard C-style arrays, you either have to have another argument if you're working with functions, or you need to calculate that size. You could use the sizeof operator, for example. So if you take the size of the entire variable, divide it by how large each element is, so size of whatever data type you're working with, then you'll get the length of that array. That's only going to work in the scope where you defined that array though. So overall you have arrays on one side, and then you have the templatized array and vector on the other side. The only thing is that when it comes to the templatized array, it is also statically sized. So that is one way in which it's similar to the normal standard array. So that's a lot of information, so let me just write it out and hopefully it'll be nice and clear. Alright, so here are the three types. Now let's distinguish. When it comes to static sizing versus dynamic sizing, we have static, static, dynamic. Now when it comes to passing these to functions, we have decaying to a pointer, value, value by default. You can do these by reference if you want. Related to how these things are passed is whether or not these types know their size. So for arrays,
they don't know their size when passed to a function. These will have the member functions .size, which will allow you to get the size. So this will return the number of elements, which is nice to have. This does not have that option. And last thing on here is what we talked about first, is that you can assign them to different variables, specifically these two. All right, there you go. That is the summary of the 3 collections we talked about so far. Hopefully that makes it nice and clear on when you should use which. Most of the time though, you'll want to stick with vectors. All right, that's all I got for you guys. Hopefully that was helpful, and be sure to subscribe to this channel as that really helps me out. And I'll see you in the next video because we're gonna start talking about something new. Finally done with these collections. We'll probably use them some throughout the series, but we're done talking about the concepts and how to use them, and finally we can move on to something new. So I'm excited, hopefully you are too, and I'll see you then.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video, we're going to be covering a new type of loop that we have not even discussed yet in this series, and it's called the range-based for loop. Now, what is it for? Well, it has a very specific purpose of iterating through collections, and you'll see exactly what I mean, but this is going to make your life a lot easier when you need to go through all of the elements in a collection, such as a vector. So where to begin? Well, let's start with a normal C-style array, and this is going to look like something like this. And we've been using ints this whole time for all of these data structures, but you can use whatever data type you want. So we're just going to call it data, and we'll just assign it some values. So to begin, let's start with a normal for loop, and then we'll compare it to the range-based for loop. So we start with int I equals 0, I is less than the total number of elements, which in this case is 6, I++. And then we can access these elements using data index I. And lastly, I'm just going to print a new line at the end. So let's compile this and see how it goes. So it prints all of our elements nice and pretty. Now the range-based for loop looks something like this. We still use the keyword for, and we still have the same structure, but inside of these parentheses, what we're going to do is we're going to say what data type each of the elements are, which in this case they're int. So we're basically going to say int, and we're going to create a new variable to temporarily store each one of these elements. We can call that whatever we want. Let's just call it n. The next thing you do is you put a colon, and you say where you're getting this data from, and we are getting it from the array called data. And now, through each iteration of this loop, n is going to contain each one of these elements. So we can just print n directly, like so. And what I'm going to do is I'm going to comment out this other for loop. And now let's compile and run. And it says range-based for loops is a C++11 extension, so just make sure you put standard equals C++11. Now when we output, you can see we get the same exact output, but the syntax is much nicer. You can see we don't have to use an index to get a particular element, just use the n directly because that's going to contain the data. Also, we don't have this complex stuff up here. All we have to do is say what the new variable is going to be called, the type of it, and where it's coming from. So it's a lot cleaner, it's a lot simpler, but the purpose of this for loop is much more specific. You can't use this for general loops, it's always to go through collections. Now in other programming languages, you might hear this known as a for each loop, or some variation of that name. It exists in pretty much every programming language, even C++ here, as you can see. You can do the same exact thing with a vector. So for example, if we had a vector here, we'll just use a vector of type int and call it data. You can see we can still compile and run. And make sure you are including vector if you want to use the vectors. Lastly, I'll show you an example with a templatized array. So just replace this with array, pass in the size, we'll just say 6, and you should be good to go. And when you run, you get the same exact output. So that is the range-based for loop. It's much more handy if you just want to iterate through every single element in an array. Now, a few things you might want to be aware of. If the size of an array is larger than the number of elements you're actually using, you might get a bunch of junk you don't care about. Here, I'll show you what I mean. You can see we get 1, 2, 3, 4, 5, 6, and then a bunch of zeros. Not so pretty. So with a for loop, you can be a little bit more specific about when to stop. That's a little harder to do with the range-based for loop. Another issue you got to worry about is if you're trying to do this inside of a function call with the basic C-style array, you're going to have an issue.
And just to show you guys that, let's just create a quick function. We'll just call it test. And what we're going to be doing is we're going to take an integer array, call it whatever you want. And inside of here, I'm just going to copy this for loop and paste it over there. So take that, paste it in here. Now when I compile this, and then I scroll up, you can see it says cannot build range expression with array function parameter data, since parameter with array type int, it's hard to read, with array type int array is treated as pointer type int pointer. In other words, when you pass an array to a function, it decays to a pointer and it loses its size capability. So there might be a way to work around that, but I do not know how. So this is really only useful for the normal arrays inside of the function that it was declared, or if you're working with a type such as a vector. So that is the range-based for loop. Hopefully that was a pretty good introduction. Overall, it's a pretty simple concept, but let me know if there are any issues. Leave them in the comment section below. Please be sure to subscribe and check out the next video.
Yo, what is going on, everybody? Welcome back to your C++ tutorial series. I am super excited because we are getting into a new section where we're going to be talking about input and output. Now, granted, this is a beginner series, so I'm going to give you what you need to know, but this is not going to be a deep dive of all of the details. So hopefully that's a good thing and not a bad thing, but maybe in the future we can do a deep dive. But for now, we're just going to talk about what you need to know for getting input from the console, and then we'll even talk about doing it from files here pretty soon. So input as well as output. Now we're going to start with the concept, and then we'll get some practice in the upcoming videos. Alright, so we have been using the cin and cout objects throughout this series, and these allow us to write to the console and read from the console. But I want you to think about this at a more conceptual level. When we are typing into the keyboard, and that keyboard typing goes into a variable, that concept is known as the input stream. We also have the output stream where we take data from our program and output it to the console. So you'll notice with this input-output stuff, there's a lot of plumber-like terminology. So there's streams of water, there's flushing the stream, all kinds of weird things like that. But it does help to really think about how it works. So let's try to just... Onyx, do you have to drink water? So let's go through some examples where we think about input stream and output stream and what they really mean. So here we have a beautiful keyboard. It's worth thousands. And this sends a sequence of characters to the console. So for example, if you said hello, you can imagine hello being passed through this stream into our program. So here is our running program, and then we could take that data and we could output it to some output such as the console. Cool. So when you type, you can think about it as one character at a time going down this tunnel. So if you said hello, you can think of it like this, where it gets H, and then it gets E, and then L, and then L, and then O. And these are flowing through this stream. That makes sense, and eventually the program's going to get H, and it's going to get all the characters, and then the world is happy. But there's one more thing that this is not exactly how it works. It's close. I kind of did that thing where I teach you wrong, and then I change it, which I cannot stand when people do, but I just did that. This stream goes into an area of memory known as a buffer. So this doesn't go directly into your program, it goes into this collection container thing known as a buffer. So this, my friends, is the buffer. So all of our data from the input stream goes into this buffer, and then at periodic times, this buffer, the data inside of it, will go to our program. So the program does not get each character one at a time, it gets sections or chunks of data from the input stream. So once this buffer is ready to go, it'll send that to the program. So I'm kind of running out of space here, but this whole diagram right here, this bottom half, and visualize that being right here. So from the keyboard, it goes into the input stream, gets stored in this buffer, and then at some point this buffer is given to the running program. So I'm going to clear this off, so make sure you get a visual photo, take a snapshot. I'm going to clear it now. The buffer, when it comes to console input, is the console itself. So as you're typing, it fills up in the console, and when you press enter, it takes the buffer and sends that to the program.
So none of the stuff in that buffer is sent to the program until you hit enter. So that is the indicator to when the program needs to get the data from the buffer. And if you're thinking this is all very fluffy and confusing, I agree, but I'm doing my best. So let's just go with this illustration. I have a good example on how you can think about this. I sometimes go to this water park and there's this kids playground area, which I totally still use because it's super awesome. And they have this giant bucket of water. So they have like this castle thing and you can play on it and stuff. I don't know what I'm drawing here, but there's like bridges and like squirt guns and all kinds of cool stuff like that, right? Designed for like 6-year-olds, but it's awesome. And then they have this giant bucket at the top. And I've seen this at a couple of different water parks. And basically they have this bucket being filled with water. And at some point, all of the water is dumped onto poor innocent children at the ground that get pummeled with water, and then they go cry and all that stuff. So all these people are waiting for this bucket to fall. Well, the stream here is kind of like the input, and this bucket is like the buffer. The buffer will be cleared when it's ready to be dumped on the children. In the context of a C++ application, the buffer is cleared when we press enter on the console. So we type in as much as we want through the stream, it fills the buffer, then we're done, we press enter, and that info is dumped to our program. So yeah, that was probably the worst illustration ever, but I have a feeling you probably understand how it works now. Now this concept can be expanded to not only the console, but files. So instead of coming from the console, this data can come from a text file or some kind of configuration file. Basically the same thing. The .text extension that you often see with files, at least in the context of Mac and Linux, doesn't really mean anything. It's just a convention. On Windows, file extensions actually change how the file is interpreted. Not really a thing in Linux and Mac. So you might be working with a .text file, or you might be working with some other file that just has some other name. More than likely, it's just a file full of text. And just like we have the cin object, we can create our own input object, but instead of getting it from the console, we get it from a file. So cin is an object of the, I think, ifstream class. Well, there is another class that we can use called ifstream, input file stream, and we can create our own custom object and we can name whatever we want. It's not already defined for us like cin, so we could call this input. And then we use input just as if it's cin, but we associate it to a particular file. So let's say we have this file over here and it contains like user information, for example. Well, we could just say input, use the extraction operator, the two greater than signs, and store that in some variable. And it works almost identical to cin, but now the data stream is coming from a file. Same thing with output. We can use a custom object from ofstream class, and we can do output and pass some data into it like so. So that is the fundamentals of working with input and output. You have a little bit of a better understanding of how it works in sections. I'm going to admit I don't know all the details of this. You could probably tell from my terrible illustrations, but I do get the general concept, and I hope you guys do as well. The main thing you need to understand is that there's custom variables that we can create from these types that we can use to not just output to the console anymore with cin or cout, but now to files. And that's what we're going to be working on in the next video, because we're going to start beefing out our application, making it a little bit more cool, you know? The cool thing with working with files is that it can store information. Every single time you run a C++ application, it is exactly the same. It starts from scratch. It just follows the compiled code, but we can make it a little bit more dynamic if the application reads data from a file. Right now we're just working with text files, but once you get this concept, I'm sure you could expand the idea of making applications read from files to databases, Excel files, and so forth. So this is the fundamentals. Make sure you get reading from text files down, and then you can learn how to read from all kinds of different files. So hopefully that was a really beautiful introduction to input and output inside of C++. Make sure you subscribe to this channel because I really need your help to, you know, get billions of subs, which I'm working on it. So be sure to subscribe, and I'll see you in the next video.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video, we're going to get some practice writing to files. And as a reminder, this is for the complete newbie, so this is going to be the basics, how to get started, and all that good stuff. So when we are writing to files, we need to include ifstream, which is a lot like IOStream, but instead of input-output, it's file stream. Now, when we are working with console in and console out, that is an object that's made available to us. So the object has already been created, it was instantiated from a class for us. Now, when we're working with files, that's an extra step we're going to have to do ourselves. So that's why this might look a little bit different than how we work with console in, specifically cout and cin. So what do you need to do? You need to create a new object, and the way you do that is you say standard ofstream, that is the class the object comes from, and the name of this object is going to be file. So this is how you instantiate a class into an object. So we're basically having an instance of ofstream, and that instance is called file. You can name it whatever you want. If you want to name it tacos or jelly bean, whatever you want. Now, the way you open a file, once you've created the file object, you say file.open and you pass in the file name. So for example, you can pass in hello.txt. Now the file extension there, that's just convention. You can do whatever you want. You don't even have to put anything. You can just say hello. That's perfectly valid inside of Mac and Linux. Windows is a little odd, and file extensions actually mean things in Windows, but inside of Mac, it doesn't really matter. It's just purely a convention thing. Usually we'll have .text for plain text files. Now you'll often see a similar way of doing this, and that is to just put this right after the file name. So that's going to look like this here. So either one, it's totally up to you. This is a little shorter, so this is what you'll see a lot online. Now when you're done with the file, sometimes you will see file.close. It's not super important to do this because it will do it automatically for you, but if you want to be very explicit, and there are some certain circumstances where you will need to do this, but those are not things that we're going to be encountering. But if you ever need to explicitly close a file, you can do it with the .close method. Now the cool thing here is that this hello.txt does not exist, but whenever you're writing to a file, it will automatically be created if it doesn't exist. So it's like a shortcut. So check this out. We can go into our files with this button over here on Visual Studio Code. Might be a little bit different for whatever editor you're using. And you can see we have this io.cpp. Now when I compile and run this, and I press enter, you can see this hello.txt just generates on the left. If you didn't see that, go back a couple seconds, watch it again. You can see this is just an empty file, has absolutely nothing in it. But we are going to start outputting stuff to this file. So we can just close out of that for now. We'll get back to that. Actually, you know what? Let's open it and let's just leave it open for now. All right. We'll get back to that, but we don't have to go back to our files. Once we have this object called file, we can use that as if it is cout. So all we have to do is say file and then use 2 less than signs and put whatever we want here, and it will go to that file. So for example, I could say hey. Now when I compile and run, check this out. You go to hello.txt, look what we got there, hey. That's pretty cool. So compared to cout, the only real difference is a little bit on how you create it. But once you actually have the file, you use it as if it's cout. You know, you would just be able to do standard cout just like that. But now instead, all you have to do is say file. Let's go through a little bit more of a complex example where we want to print a couple names to this file. Let's say we create a vector, and we'll make this of type string, and we'll call it names. In order to do this, we need to include vector, and we'll want to make sure we compile using C++11. Let's add some data to this names vector. So to do that, we just say names.pushback. And I'm just going to do that for a couple names here. There we go. So we have 3 names inside of this vector called names. And we can iterate through these and output them to the file. So we can use a range-based for loop for this. So we could say for, what is their type? Well, they are of type string, and we'll just call it name. And this comes from the names vector. Then inside of the loop body, all we have to do is say file and output the name to the file. When we're done, we can output an end line. So it will look like this. Now when we compile and run, let's see if it works. Oh yeah, I literally forgot to do the C++11 thing. There we go. All right, now when we compile and run, now let's check out hello.txt. And there you go, we got a couple of names in our hello.txt file. Now let's go back to our code. Just as an overview, we open the file, we add a bunch of names to this vector, then we loop through that vector and output them to the file. And then at the end, we close the file. Once again, this is technically optional.
The only real difference is it has to do with errors. If you get errors, closing the file manually will allow you to get those errors. If you want to know more info about that, look up the close method for file output and see what people have to say about it. But just to prove it to you guys, you can leave this off of here and you can still compile and run and it works just fine. Now we ran it and I want you guys to notice something. When we go to hello.txt, it did not add 3 names, it replaced the old 3 and wrote them again. So that is the thing. Every time you run this application, it's going to overwrite what is in this hello.txt file. There is a way around that. If you go back to your code, when we open this file, we can add a little bit of something right here. So if you want to append, you can have another argument in here, and that is going to be standard iOS app for append. Now let's give it a try. When we run this now, go to hello.txt, you can see it actually added those 3 names to the file. And every single time we write this, it's going to add 3 more names. Let's see how many names we can put on there. Yeah, so that's pretty fun. Now let's go back to the code. My computer's starting to heat up, so let me try to get through this before my computer explodes. When you open a file, you can actually check if the file was successfully opened. So to do that, you can do that inside of an if statement. And what you can do is say file.isOpen. This will return true if it opens successfully. And just to show you guys, we'll just do an output here. And now let's compile and run. And you can see we get that success. Now, if you want to simulate the file not being able to be opened, here's how you can do that. If you go to your files, right-click hello.txt, and reveal in Finder. Now here's what you're going to do. You're going to right-click, and you're going to click Get Info. And this is for a Mac, obviously. You can try to figure out how to do it. Oh my golly, scare me to death. You can try to figure out how to do this on Windows if you want, but this is for Mac operating system. All you have to do is click this little locked button. And now let's try to run this application. When we run this, you can see there is no success noob outputted. No matter how many times we run this, that's because it's not able to open the file. So in that situation, you might want to say error, unable to open the file, try again later, or something like that. Oh, now the last thing I want to talk to you guys is how to get the file name from the user. So in this case, it's hard-coded, but what if we wanted to ask the user what file name to open? Now we're not going to make a pop-up where they can select it or anything crazy like that. This is in the console. We're just going to ask for the name of the file. So the way we're going to do that is we're going to get input. So we could say standard cin and store that in a variable that's going to be of type string. We'll call it file name. And we're going to store the console inside of that variable. And we're going to do this before we open the file. Sorry about that, guys. So we want this at the top. And now we can open that file name. So instead of hello.txt, all we have to do is say file name. All right, now let's see if this works. When we compile and run, it's going to ask us for a file. And let's just go with tacos.txt. When we press enter, you can see on the left, tacos.txt appears over here. We can open that, and voila, there are our names. So very cool. Lots of useful information if you're new with working with files. That should give you what you need to start building some file-driven applications. Hopefully that wasn't too much in one video. I know it was a lot, but thank you guys for getting through it. If you've enjoyed this content or if it was helpful, please be sure to hit that subscribe button and check out the next video where we're going to be talking about doing the same thing, but instead of writing to files, we're going to read from files. So it's going to be a lot of fun. I'll see you then.
Hey, what's going on, everybody? Welcome back to your C++ tutorial series. This video, we're going to be talking about reading from files. So it's kind of a follow-up from the previous video where we talked about writing from files. So if you want to get the basics, check that video out because a lot of it's going to be very similar. Now, when you're reading from files, it's going to work very similar to using cin as we have used throughout this entire series. The difference here is that cin is an object that has already been created for us. When we're reading from files, we have to create our own object. So how are we going to do that? First thing, make sure you include ifstream. That is a requirement to do these things. And basically, I'm going to go through an example of reading from this tacos.txt file and getting these lines here. We'll just start with names and then we'll work on some other stuff here. So Caleb, Amy, and Susan. And I'm just going to clear out main and start from scratch just to get a little bit more practice. Alright, so when you want to read from a file, you need to make an input file stream object. To do that, you say standard ifstream and give it a name. We'll just call it file. And then inside of parentheses, you can put the file name such as tacos.txt.
Now, one thing you need to know is that when you're writing to files, if this file doesn't exist, it'll be created. But when you're reading from files, it will not be created if it doesn't exist. It'll actually not open successfully. Which makes sense, because why would you create a file to read, because there wouldn't be anything in there yet. So now that we've opened this file, we can use a loop and basically take these names and store them in a vector. So to do that, we're going to use a while loop. Now inside of the while condition, you're going to use your file as if it's cin. So you're just going to say file and use the two arrows and put it inside of a variable. So let's create that variable. We'll just call it input. Like that. Now we're going to store this in input. So this expression here will evaluate as true if the read was successful. When you use this operator, it's actually going to return the stream, so it's going to return file, and file will evaluate to true if the previous read was successful. So in other words, we can use this loop to basically read through the file until there's nothing left. So that is how you do that. Awesome. So we're also going to create a vector to store all of the names. So up here, we'll just create a vector, and let's give it the type of string, and we'll call it names. Now inside of the while loop is where we're going to add the names to the vector, so we're just going to say names.push back. And what are we going to push into this array? We're going to push the input. So the input is where the names are being stored temporarily. Cool, so I think that's all, but let's just compile, make sure the code has no errors in the code. Okay, and now what I want to do is I want to output these names to make sure we got them in there correctly. So we'll just use a range-based for loop to get a little bit more practice with that, and that's going to look like this. We're going to say for, and these are of type string, and we'll call it name, and this is coming from the names variable. Then all we have to do is say cout, name, and then we can do an end line. Compile and run, and voila, you get the names. So that is how you read names from a file and put those into a vector. Now when you're using this technique to read data from a file, it's going to interpret the input based on the destination. So in this situation, we're storing this inside of a string. So it's expecting a string, and it's going to stop at any invalid characters, specifically white space. So this will get one word. So that means if I go in here and say Caleb is awesome, it's not going to work quite the way we expect. When we run this, you can see that each word is considered a new name. Caleb is awesome, Amy, Susan. Understanding the way this works is important, because if we change the destination type, it's going to change how it interprets the file. So for example, let's change this to type char, and we have to change this in a couple places. So we'll change the vector, and then we'll change the for loop. So instead of using a string, we'll use a char. Now let's compile. And when we run, you can see that each letter is now considered a name rather than each word. Same thing with numbers. It won't interpret any number until it hits a character or a space. So make sure you understand what destination you are using, what type it is, in order to understand how this is going to act. Alright, so that is one way of doing input. There is another way you'll probably see, which is getLine, and actually there's another one, get. So let's go through an example with that. Here's what I'm going to do. I'm just going to clear out our code here and get rid of this vector. Get will look like this. You'll have file.get, and this is going to return a character, so we can store that in a char variable. We'll just call it temp, whatever, it doesn't matter. And then we'll just output that. When we compile and run, you can see we just get the very first character. The other common way is with getLine, which is not actually a method, it's a function by itself. So you just call getLine, and then you actually pass in the stream. So we're going to say file, and then you have to pass in the variable to store the line in. So to do that, we can just create a new variable of type string, like so, and we'll just put that in as an argument. Now when we output, we're going to want to output the correct variable, line. Now let's compile and run. You can see it grabs that first line, Caleb is awesome. Now the question is, if that was a Boolean, would it be true or false? I think that's all I have to say about reading from files. The only other thing is that in the previous video, when we were talking about writing to files and how you can check to see if it successfully opened a file, what we did is we locked that file to basically simulate it was being used or that we couldn't get access to it. The same thing can happen to reading from files if the file does not exist. So for example, if we call this tacos.txt, and if we have an if statement file.isOpen, this will evaluate to false because tacos.txt does not exist. So when I compile and run, you can see absolutely nothing is displayed, which makes sense because it cannot successfully open the file. Alright guys, that's all I have for you guys for reading from files. Hopefully that was a good introduction. I'm sure there's a lot more I could talk about this because this is just the basics, reading simple stuff. But definitely a good start. Thank you guys for watching. If you've enjoyed the content, don't forget to subscribe. And yeah, I'll see you in the next video. Hey everyone, what is up? Welcome back to your C++ tutorial series. What are we going to be doing in this video? Well, we're going to be working on our guessing game, and what we're going to do is we're going to store the best score in a file. So basically you can compete to get the answer in as fewest number of guesses as possible. Now, I don't really know what to call this. I don't know if it should be called the high score or the low score or the best score. So I don't know, it's just confusing, but basically the lower the score, the better. Very first thing we're going to do is we're going to replace this array with a vector. I know we just switched it to this array, but we're going to switch it back because I prefer vectors. We were just getting some practice with arrays. So this is just take a minute. If you've already got it as a vector, you're good, but just follow along if you don't. So basically we're going to store our guesses in a vector, and then we don't need to put them in the vector like this. What we do is we say guesses.pushback, and we pass in the value, so guess right there, and we can get rid of that line there. Now at the end of all of our code, we have this print array function. We can just pass in guesses, and it's not going to be called print array, it's going to be called print vector. Now let's go look at that function and change that up a little bit. So print array, that's going to become print vector. It's going to take a vector of type int, we'll call it vector, and we'll just get rid of this other parameter here, like that. Instead of comparing to size, we'll compare to vector.size method call, and instead of accessing the array like so, we're going to access the vector like so. Awesome. So that is all the refactoring I need to do to get that to a vector, but let me just compile just to make sure everything is good. Alright, so the code compiled, so I think we're good. So we got everything refactored. Now what's going to happen? Well, here's how things work currently. Inside of our play game, we're keeping track of the number of guesses using this count variable, but we actually need to increment this inside of the while loop. So what I'm going to do is I'm going to say count plus plus, and basically that's going to be used to keep track of the best score for this round. And then at the end, it's going to be compared to the total best score of all the rounds. Basically that's going to come from a file, and if it's better than that score, then it's going to replace that in the file. So what needs to happen? We need to read from the file and do a comparison. If the comparison evaluates to true, then we need to replace the best score value. So what we're going to do is we're going to go scroll down to the bottom, and at the very end of this, we're going to open a file. So this is going to be an input file stream, and we'll just call it input, and the file name, we'll just call it bestscore.txt. And we're actually going to create that file, so go over to your files, create a new file, call it bestscore.txt. And what we're going to do is we're just going to fill this with a large number. There's probably a more elegant way of doing this, but basically we're going to assume that the current best score is very terrible. All right, then let's go back into our code. We're going to get that number from the file. So what we're going to do is we're just going to say int best score, and then get that from input like so. And we're eventually going to do a comparison and write to that file. So what we're going to do is we're going to open an output file stream. Now you can actually just use ifstream and use that for writing and reading, but I'm more comfortable doing it this way. So whatever you guys want to do, if you want to know how to do it that way, look up ifstream and see how to do that yourselves. So we'll call this output, and we're going to open that same file, bestscore.txt. Then we'll do a comparison and say if count, which is the variable we're using to keep track of how many guesses it takes us, is less than the best score, what we need to do is we need to replace that file. So to do that, we say output and then direct the value from count. Now, if this does not evaluate to true, it's just going to delete everything in the file. So what we need to do is we need to say else. And if the else is hit, what we're going to do is we're just going to output the best score. So basically replacing the file with what was already in it. All right, let's compile and we'll run and just give it some testing to make sure everything works the way it does so we can catch any bugs. So when we compile, we get 2 errors. I believe that's because we need to include ifstream. Like that. Now let's try again. All right, it compiled. Let's give it a run. We play the game. Let's say we take a couple of tries. The answer is 12, so let's say it takes us a couple of tries here. We get 12 eventually, and it says we win. Now inside of bestscore.txt, the new best score is 6.
Now let's play again, but this time I want to get a worse score. So we'll play the game, guess a couple of times, and eventually we'll get the right answer. And you can see that the value inside of best score is not replaced. Now let's play once more, and this time we'll get a better score than 6. We'll just get it right away, 140, press enter, and you can see it is replaced with 1. So now we've got like the max score. It's kind of like when you're playing an arcade game and it goes to the high scores and it's just like 99999. That's the equivalent for this here. Now let's look to see if there's anything we can do to improve this. Let's go back to our code and scroll down here to the input and output. The first thing I can think of is that there might be a situation where it's unable to open these files. And there's a lot of different things you can do in that situation. The easiest is to just say, hey, you can't use this application. In other words, just return and go back to the main menu. Another alternative would be to write logic for it to try again. So maybe it tries reading from the file 3 to 5 times, maybe waiting a couple seconds in between, and so forth. There's a lot of different things you can do, but what we're going to do is just going to be the easiest. We're just going to return if it does not work. So what we can do is say input.isOpen, and this will return true if it does open, but we want to actually flip it. So we can put an exclamation mark at the beginning, and now it's asking if it does not open, then we can output an error. And then we can just return from this function. So that's going to break out of this play game and it'll go back to the main menu. We can copy very similar code for the output. So we'll just paste that here. And instead of input, we're going to use output. So that's one thing you can do. And just to simulate this, what we're going to do is we're going to lock the file. So reveal in Finder, get info, and click locked. Now let's try again. Let's play this game, compile and run, and when we play the game, let's say we guess it right away, 151, you can see it says unable to read file, and it just exits. So it still allows us to play the game, but it doesn't allow us to compare our score to the best score. So that's just some basics working with I/O. A couple of other improvements you could try to do is you could figure out a better way to basically start. Originally we had 99999. That's not exactly the most beautiful way to start, but that's worked for us. Additionally, we had to create this bestscore.txt. So inside your code, you could create some logic and say, hey, if this is your first time playing this, in other words, if best score does not exist, then we're going to create it and we're going to basically automatically write whatever score you get to the bestscore.txt file. In that situation, you wouldn't have to worry about setting this artificially high number to compare to. You would just do the logic to write whatever you get to the file. That's going to be a little bit more complicated than what we have here, and that's probably what you'd want to do. Cool, so that was a lot, guys. Hopefully that was helpful. The reality of this is reading and writing to files can get pretty messy pretty quickly. So you need to try your best to make your code readable and scalable. So make sure your code is written in a way that you can come back in a year and still understand what's going on. You can also consider breaking out certain pieces of functionality into their own functions. That might make it a little easier to read through your code, and you can isolate functionality. So that might be a good next step for you guys as well. Let me know what you think would make this code better, because clearly this is not the end-all be-all solution. And do me a favor and check out the next video, because we're going to be talking about a new topic. We're going to be talking again about functions and methods, but we're going to go in a lot more detail addressing some of the different kinds of methods and functions that we haven't talked about. So it's going to be pretty cool. Go check that out. We got a lot of new stuff coming up, so I'm pretty excited. Once you watch the next video about functions and methods, it's going to be really easy to refactor this code into function calls, which may or may not be what we're doing. I guess we'll just have to see. So thank you guys for watching. I'll see you in the next video.
Hey, what's going on, everybody? Welcome back to your C++ tutorial series. This video, we are going to readdress functions and methods. Part of it's going to be review, but we're also going to be talking about a couple new things, so it should be pretty exciting. Now, even if you have functions mastered, I would encourage you to watch this video and just stick it through. That's because this stuff is really going to be foundational for the upcoming content. It's really important that you got it down, so make sure if there's anything that you're confused on in this video, you spend a little bit of extra time studying it or watch this video a couple times to make sure you got it down. In this video, we're going to talk about 4 types of functions. So number 1 is the basics, a function. Number 2 is a method. Number 3 is a static method, and number 4 is a constructor. Now, let's first talk about 1 and 2. The only difference between 1 and 2 is that a method is attached to an object. So a function is freestanding, it's by itself, it's its own entity,
it's strong, it's independent, whereas a method is dependent upon an object. So let's say this circle is a function, a square is an object. When you put a circle inside of the square, it's known as a method. So functionality-wise, they are identical. The only difference is you access them through an object. Now, this is why I say this stuff is foundational, because we are going to be quickly transitioning into our object-oriented section of the series coming up here pretty soon, and methods are going to come up, but they're so close to functions it's not a huge leap of understanding. The only difference on how you use them is the way you call them. So for example, when we talk about object-oriented programming, we are going to create a user. And when you create a user, it's going to look something like that. And then you might say something like user dot, and then you put the function name. It doesn't matter what it is. Gosh, I can't think of anything. Something very descriptive, such as this here. This is a method. If we had that function by itself, we would just call it like this. Like so. Now, these three, number 2, 3, and 4, all deal with object-oriented programming. So don't feel like you have to master these right now. You should just understand the general concept of these three. Now, before we jump into number 3 and 4, I wanted to give you another example of a method. We used methods when we were talking about strings. So when you create a string, you're creating an object of type string. And string has a method, so we could say tacos.length. It's just a function, but it's attached to an object, and what it does is it does some functionality, but somehow it's related to this object. Specifically, it gets the length, how many characters is in tacos, which is 3. Now, the difference between a method and a static method is that a method is attached to an object. A static method is attached to a class. The difference between a class and an object will become crystal clear when we talk about classes and objects here pretty soon. But just follow with me for a moment. We start with a class, which is like the blueprint for how to make objects. When we create an instance of this class, it's known as an object. So when we create a specific string, such as tacos, we are creating a string object. The structure and the functionality that was once defined for these strings is defined in a string class. Every single time we create an instance, we create a new object. Sometimes methods are attached to objects. So for example, we could say tacos.length, or we could say user.whatever. Sometimes though, the method is attached to the class. And the reason this is because it doesn't necessarily describe an individual object, but it's somehow still related to that entity. So in this situation, if we had a custom type such as user, and we created a specific user, notice the difference here, this is uppercase, this is lowercase. This is the class that it was defined in. This is the object, the instance of it. A static method would be attached to this, and a method would be attached to this. Static methods are not dependent on a specific entity or an instance of the class. It's just tied to the class itself. So we might have user.speak, and then for a static method, we might say user count, which might get the total number of users. Notice the difference in functionality. This speak refers to a specific user, whereas count describes users in general, all of the users. And the last one is a constructor, which is a special function that is called in the process of instantiating a class. Now, we haven't talked about object-oriented programming, again, just mentioning that. So if this is like very cloudy and not clear, that's fine. Just follow along the best you can. The most important thing that you get from this video is the difference between a function and a method. These two will come later, but this is related because they are functions, so I thought I'd throw them in this video. When you create a class, you can create a special function called a constructor. You might see it shortened CTOR or just constructor. And the only difference between a constructor and a normal function is that it doesn't have a return type. So a normal function can return a string, it can return an integer, or it could be void. With a constructor, it doesn't give any of those options, it's just a name. And the reason that is because it's not going to return any data, it's going to create a new object. So you can kind of think of it as always returning an object.
of a particular type. So let me go through an example here. Let's say again we have that user class and we create two users. And let's say we're making some kind of game or something, and every time a new user is created, an announcement is made saying, oh, Caleb joined the game. So we create two users, and when they are created, this constructor function is called and an announcement is made. So that is what you would use a constructor function for. The only real purpose of a constructor is to do something when an object is created from a class. And we will have videos dedicated to constructors. We're going to get into those towards the end of the series. They are going to be used to make sure that our users are created in a proper way, that they're defined in a stable state, essentially. So inside of the constructor, you can set different data points related to the user. You could call different functions or whatever you may want it to be. So those are your 4 types of functions that you need to know about. Now, maybe towards the end it got a little bit more confusing for you guys, and that's totally fine. Don't expect to have all of that understood right now. Main thing you need to understand again is functions and methods, and then we'll get into these kind of like these special functions, the static methods and the constructor, which is kind of just like a method called when an object is created. We'll get into those in more detail once we talk about object-oriented programming. Now, there is a surprise 5th type of function, but you don't really have to worry a whole lot about it, and that is a destructor. It's very similar to a constructor, but it's called when an object is deleted. So constructor is when it's created, and when that user is no longer being used, the destructor will be called, and that will basically clean up all the memory and make sure that the user no longer exists. So that is another type of function you might want to know of, and we're going to talk about that as well in the future. So hopefully that was a pretty good introduction to the types of functions we're going to be running into in the upcoming videos. I'm hoping you guys are excited. Should be pretty cool. So yeah, that's all I got for you guys. Please be sure to subscribe and check out the next video. Thanks.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video, we're going to be talking a little bit about refactoring. Specifically, we're going to refactor our input and output to a function call. Talked about this briefly in a previous video, and now we're actually going to implement that. It's really only going to take a couple of seconds, so I thought I'd fill this video with a little bit more context and information on how to refactor code in the best way possible. Now, when it comes to code refactoring, you should have a couple of goals. One is to have a clean flow. So function calls over logic. And what exactly do I mean by that? When you're going through your code, and a good example of this is in our main function here. When you're going through your code, you just have a function call instead of having the actual logic to play the game here. So when you're reading through code, it should be basically English seeing exactly what's going on step by step as a series of function calls. Obviously, you can do this to the extreme where there's tons and tons of functions, or you can be on the other spectrum and not do it enough where all of your code is inline. I think there's a happy medium where you have a decent amount of function calls, but not too many function calls. Personally, I feel there can be too many function calls. People may disagree with me, and that's totally fine. I sometimes like just to have stuff inline because then you can flow with the code, the logic of the code. So you gotta find the happy medium, what works best for you. The third main goal of refactoring is to just focus on design patterns and not creating an application that's very specific to the problem you're trying to solve. As a general rule of thumb, as you get better with coding, you can start thinking more about the design of your application and less on solving the problem. And what do I mean by this? Well, it's very easy to write code that's very specific to the problem you're trying to solve. You know, you might end up having like nested if statements and loops like 3 or 4 layers deep, and it's very specific, it's very confusing to read, it's just a disgusting mess. Instead, you can look at a bigger picture and figure out how you can design the application in a way that makes the code nice and easy to read. Now, there are a lot of tools that will do automatic refactoring. So for example, usually an IDE, integrated development environment, such as RAD Studio, will have capabilities to extract functions and do a lot more. So if you want to know the refactoring capabilities with RAD Studio, just look up Refactoring RAD Studio. You'll find lots of examples. It's a great way to use tooling to help you develop and to amplify your coding experience. Now, what are we going to be doing in this video? Well, now that I've been blabbering for about 20 minutes, we're going to create a new function. So go up to the very top, and this is going to be called save score, and it's going to be a void function, and this is going to take the guess count. In other words, how many guesses it took us to get it correctly. So we'll just call it guess count, and here's what we're going to do. We're going to go into play game, and we're going to cut all of the logic about saving. We're going to cut this out of here and paste it in that function. So all the way down to here, cut that out of here, go up to the top, and paste that inside of our new function, save score. Make sure everything is indented correctly. And now all we have to do is call this function. So we'll copy the name here, go back down into play game. So we'll just pass in count. All right, let's compile, see if it's still working. All right, so it looks like we have a name mismatch because inside of the code for the function, we're using the count variable that we had earlier, but we renamed it to guess count. So I'm just going to change it back to count, and it should fix everything. There we go. And we can run the application, play the game, and we can make guesses and everything like that. Now it says unable to read file because the file is locked, but other than that, I think everything should work just fine. Now another thing you should consider when it comes to refactoring and building out functions is testability. Now we haven't really talked about software testing much in this video, but basically it's easier to test a function that's small and does one thing. So if a function is outputting and saving to files and doing all this crazy stuff, sort of like our function is doing right now, it's very hard to make an automated test. Generally, an automated test will do an input and see if the output is the correct output. And then we can automate that process and we can put that part of like a build process, for example. So basically we can create a collection of all these automated tests and we can go through each one, and if every single one passed, then we can deploy our application. Otherwise, we have issues and we need to go back and make sure our functions are correct. Automated testing is a huge thing in software, so that's probably a series of its own. I'm not really going to get into it much in this video, but when you're creating functions, try to think of them as simple, give it an input, and get the expected output. Let's go through a simple example of what I mean. So let's create a new file. We're just going to call this test.cpp, and we're just going to create a function in here that's very obvious on how it should work. So first, let's include ifstream and create our main function. This is going to return, let's say, a double, we'll call it squared, and it's going to take a number, we'll just take a double x. What's it going to do? It's going to return x times x. Very super simple. The way you could test something like this is you could do an if statement and say, if squared of 5 equals 25, you could say test passed. Then we can compile test.cpp and run. And you can see it says test passed. So what you could do is you could basically make a test collection where you have else clauses that would say test failed, and you would have numerous tests to make sure your functions are working correctly. So for example, if you pass in -5, you should expect it to also be 25. And you can see the test still passed. So a very, very simple example, but testing is huge. You definitely want to make sure you study on that. Testing and refactoring go hand in hand. That's because tests ensure that your refactoring truly works the same way, which is basically the key ingredient of refactoring, is you change the behind code, but the front end works exactly the same way. You can ensure it works the same way by running a series of automated tests. So before you refactor a huge application, you'll definitely want to make sure you have a pretty good suite of tests that can verify that the code is working correctly. So that's all I got for you guys in this video. Very simple. I know there's a lot of blabbering, so hopefully it was useful and not just, yo, Caleb's going on a spiel again. But that's all I got. Check out the next video and please be sure to subscribe. Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be talking about multi-dimensional arrays, how to use them, how to iterate through them, and everything good like that. Now, it first helps to understand a single dimensional array, which I'm not going to go over a ton because we've talked about them a ton in this series, but it's going to look something like this. And then you can put elements inside of this initialization. So the size of this thing is going to be 3. Now, a multi-dimensional array works very similar, but the only difference is you add another set of square brackets here, and you can add multiple sets of elements inside of the initialization. So that could be a set. Here can be another set, and here can be even another set. Now when you compile, you might get something a little weird. You can see it says array has incomplete element type int array. So we're basically making an array of arrays, and that outer array needs to know the size of the arrays it's going to contain. So to do that, we just throw the size in here. Now for a single dimensional array, it can infer that size from the elements you're adding to it, but for a multi-dimensional array, you have to put that second size explicitly. I'm not entirely sure why, but it is just one of the requirements that you need to do. If there's any way around that you guys know of, please leave a comment in the comment section below. But until then, we're just going to manually put that size because I'm pretty sure that's a requirement. Now the size here is going to be inferred by how many collections we have in here. 1, 2, 3. So this is going to be a 3x3 multidimensional array. The size is still static. It works exactly like a normal array. Now the sizes here are again the max size. You can have it larger than you need, and then you can implement basically different sizes of arrays within that. However you want to do it, that's totally up to you. There might be a better data structure out there if you're looking to do something more complicated. I really recommend this kind of 2D array if you're thinking of your data as if it's a table, where you have columns and rows. So let's go through the process to iterate through this array. We're going to have 2 for loops. So a nested for loop is needed when you want to iterate through a 2D array. If you had a 3D array, then you would need 3 for loops. So that's the outer for loop, and then this is the inner for loop. Now before we get to the for loops, I do just want to compile, make sure we have that array syntax down, and that everything is good to go for the for loops. So you can see we can compile, so it seems to be good. Now let's get back to those loops, and here's how I like to think about it. If you visualize this in a different way, each one of these collections is considered a row. So we're first going to go through this collection, then this collection, and then this collection. So each one of these will be one iteration, and we're going to do that in the outer for loop. The inner for loop will go through each of the elements in each row. So that will be the column. So we'll create a variable. We're going to call it R. You can call it whatever you want, but I'm going to call it R for row. A lot of people will still use I, and then they'll use K or J for the inner for loop, but I'm going to use R for row and then C for column. This is a little clearer for me. We're going to go until R is less than 3 and R++. Then for the inner for loop, we're going to say int C equals 0, C less than 3, C++. Now in here we can output the value. We're going to access grades, and we're going to pass in R for the row and C for the column. And then I'm going to do a tab character. Now after each iteration of the inner for loop, I'm going to output a new line. Beautiful. Now let's output this thing. It did nothing, and that's because I accidentally put this return at the top. Come on, Caleb. You should have this down by now. All right, so make sure that return is down at the bottom. I was like, what is going on? All right, let's try this again. When we run this, you can see it outputs our array exactly how we have it defined. Beautiful. So that is how you work with multidimensional arrays. You can also try other data structures. For example, you might try nested vectors, and I'll show you what that looks like. We're going to basically have a standard vector, and this is going to contain a standard vector of a particular type. We'll just go with int. This will be called grades, and we're going to assign this a value. What are we going to assign it? Well, we're going to assign it exactly what we had in the previous example. So here's how you would create a standard vector, and it kind of works the same way as a multidimensional array. In fact, you don't have to change the for loops or anything. Now we want to make sure that we include vector, and when we compile, we need to use the C++11 standard. There we go. Now when we run, you can see we get the exact same output, but now we don't have to worry about max sizes. It's not statically sized. It's a lot easier to work with. So that is how to work with multidimensional arrays and nested vectors. Hopefully that was helpful for you guys. If you have any questions, comments, concerns, or life stories, leave them in the comments section below. And don't you forget to subscribe, as that really super helps out this channel. And I need your help real bad, because it's just bad. All right, I need your help. All right, I'll see you guys in the next video. Hey, what's going on, everybody? Welcome back. In this video, we're going to be talking about the very special Const Modifier. Now, this is a little bit different than when we talked about constants in an earlier video, but we're going to dive into that and understand all the differences and when you would want to use the const keyword, specifically when it comes to functions. Alright, so here we have an array, and what we're going to be doing is we're going to create a function to basically print this array. And I know we've done this like a million times in this series, but you know, a little bit of practice can't hurt. Now, when you take an argument of an array, you create exactly the same data type. We just say int data and put the square brackets there. You can name it something different, but just for coherency, I often name them the same thing, but it's totally up to you. They're different variables. We'll probably also have a parameter for the size. And then what we'll do is we'll just go through a for loop. And then we could use that I variable to access each element. Now, where does the const keyword come up? Well, if you look at this array, it's only supposed to print the array. It doesn't actually change anything in the array, but there's no way to really guarantee that. So what I could actually do is I could actually increase the data elements by 1. So let's say we do data of I plus plus. Now the actual array is going to be modified, and that's because when you pass an array to a function, it decays to a pointer, and the same area of memory is accessible and changeable. So that means if I go down here and do an output, we'll just output data index 0. When we do a compile and run, let's see what happens. And before we do that, we actually need to call this function up here. So we're going to say print array, and we're going to pass in data size 3. Now let's compile and see if we got any issues. Yes, I forgot to do the return type for print array. We'll just make it void. Now let's compile and run. All right, so you can see the data is 2, 3, 4. So each one was increased by 1. And even outside of that print array function, when we access that data, it still has that same value. So the function essentially modified that data. And sometimes that's fine. You can create functions to modify your data. But there are particular situations when you basically want to be able to trust a function to not change your data. And the only way that's going to be possible is if the function has the parameter labeled as const. So if you guys remember what the const word means, it basically creates a variable that cannot change. So it's kind of like a constant. So it's perfectly okay for us to pass a non-constant variable to this constant variable. In the scope of this function, we will not be able to change data. And outside the scope of the function, this variable data still remains non-constant. So we can go and change it down here, but not inside of this function up here. So let's compile. And you can see we get an error. It says read-only variable is not assignable. So it's not going to let us do something like this. And this basically has to do with the integrity of the function. Clearly we could create a function that doesn't change data, and we wouldn't need that const keyword. But it's more of an integrity thing saying this is a promise to not change your data. Now this will also be important if there are other functions. Let's create another function, we'll just call it do something. And what this function is going to do is it's going to do something. And what we're going to do is we're just going to take an array, and inside a print array, what we're going to do is we're going to call that function. So we'll just say do something and pass in data, like so. And now compile. And what is going on? We got an error. It says no matching function for call to do something. Candidate function not viable. First argument const int pointer would lose const qualifier. Basically what that means is this parameter here does not have that const qualifying the data type. So that means this function is not able to call that function because it could potentially change that data, which would violate the promise to the caller. So this thing's labeled as constant here, which is basically telling main, hey, we're not going to change your data. But if it calls some other function that changes the data, then it's violating that technically. It's violating that promise indirectly, potentially by calling a function that could change that data. So in order for this to work, any functions you call also have to be labeled const for this variable. So when we compile now, it should work, and the application is going to work in exactly the same way. This will usually come up when we're working with arrays. That's because they're by default modifiable inside of functions. Other data types are not modifiable by default inside of functions such as vectors, so you don't have to worry about labeling things as const. Just don't pass things by reference and you should be good. And speaking of passing things by reference, we've talked about it here and there throughout this series, but the next video we're actually going to devote to that. We're going to talk about what it means to pass by value versus pass by reference, and then we'll go through some examples where passing by reference can do some cool stuff. So hopefully you guys are excited for that. Be sure to check that out and be sure to subscribe. Thank you guys, and I'll see you in the next video.
Yo, what is going on everybody? This video we're going to be talking about passing by value and passing by reference. Specifically, we're talking about passing arguments to functions. So make sure you watch my videos over functions so you understand the general idea, and then you should be pretty good following this video. Now this is the concept video. The code follow-up is going to be in the next video, so if you're looking for a hands-on example, make sure you get through this video to understand how it works, and then check out the upcoming video. Now let's say we create some function, and we take some argument. Let's just start with an integer. When we call this function in our code, we pass a value to this function. So we'll first go through an example when we just pass a value, such as 5. Well, this 5 is going to be copied into this variable, which can be used inside the body of the function. Now, what if you do a variable here instead of a value? So let's say at some point we define some variable
We can name it the same thing as the function, but it doesn't have to be named the same thing. They are two separate variables. But let's just call them the same thing in this situation. So we have some variable that was defined, int x equals 5, and then we pass in x. Well, here's the thing you need to understand, is that when you do this, the value 5 is copied into this variable. So that means somewhere in memory we have two variables. They both happen to be called x, and they both have the value 5. But they're two distinct variables, meaning if we change x inside of this function, and we say x now has the value 13, well, what this is going to do is it's going to replace the value here, and it's not going to affect this original variable. So that means after this function call down here, x is still going to have the value 5. And that is a very, very essential concept you need to understand when we're talking about functions inside of C++. Everything is passed by value. So this whole concept is known as pass by value. Now, the one exception to this is arrays. So if you create an array, and I'm hesitant to draw it out because I'll probably just mess everything up. If you create an array which contains multiple elements, when you pass an array to a function, it's not passed by value. If it was passed by value, all of the values in the array would be copied to this new variable. But instead, it's passed by pointer. So what that means, inside of memory, we have an array that contains some data, and when you pass that array to the function, it gets a pointer to that memory location. So what that means is, let's say this was an array, that variable now points to the same array. So that means any changes we do to the array inside of the function are visible on the outside. So far we talked about basically two ways of passing variables. One is pass by value, which is the default for everything. The other way we talked about is passing by pointer, and more accurately, it would be said as decaying to a pointer. So when you pass an array, let's say this is not an integer, it's actually an integer array, and we take that array and pass it to the function, it decays to a pointer, meaning it loses its type information. So inside of the function, it no longer understands that it's an array of a certain length. It only sees it as a pointer to the first element. So this is just going to point to that first element here inside of the array. Okay, so that's a lot of information. Now there is a third way of passing information, and that is passing by reference. Now passing by reference is very similar to the way arrays are passed, but it's not something that happens automatically we can't change. It's something we have to say that we want to do. So if we want to pass something by reference, it's similar to how an array decays to a pointer, but the difference is that we manually do it and it doesn't lose any type information. So let me explain, and in the next video we'll go over some hands-on examples. It'll be a lot more clear. Let's go back to the beginning. We have an integer variable x, another integer variable x, and then we call the doStuff function, and we pass in x. Well, if we want to be able to change that variable inside of this function, we need to pass by reference. And the way we do that is we prefix the variable name with the and sign, which my and sign drawing abilities have skyrocketed since the start of this YouTube channel. So I'm making some serious handwriting progress. So it's going to look something like this. Now you might see the and sign here, you might see it attached to the type. Doesn't really matter. As long as it's between integer and x, you should be good to go. Now in this situation, this x here and this x here are going to refer to the same area of memory. So if we pass in x value of 5, and then inside of here we assign the value 11, well, this is going to be replaced with 11, and after this function call, x will now be valued at 11. So that is passing by reference. This is important to do if we have very large data structures or if we want the functions to be able to modify the variables. So this is very common with vectors. If we have some function that we want to alter data inside of a vector, we need to pass that by reference. That's because only arrays are going to be changeable inside of a function by default. Anything else we need to pass by reference. So this x is essentially an alias, or in other words, a nickname for the same variable. It doesn't have to have the same name here. You could name it y.
It doesn't matter. All you need to know is that when you change this variable, you are changing this variable. All right, so that is your basics for passing things as arguments. The very first way to do it is pass by value, which is the default for everything except arrays. Now this is even if you're using a custom class type. So if you have an object of a custom type, that is still going to be passed by value, which is actually different than a lot of other popular programming languages. In C#, for example, objects are going to pass by reference by default, not the case in C++. So everything is passed by value except arrays, which decay to pointers. Then the third type is passed by reference. If you're working with anything that's passed by value and you want to be able to change it inside of the function, then you need to pass by reference by prefixing it with the and sign. Alright, so that is all I have for you in this video. Please consider subscribing if you've enjoyed this content, and if there is anything else you'd like to add or anything you're concerned or questioned about, leave a comment in the comment section below and I'll see what I can do. Thanks, and I'll see you in the next video.
Hey, what's going on everybody? Welcome back to your tutorial series. This video, we're going to be talking about passing by reference by going through a common example of swapping inside of a function. By swap, I mean we're basically going to pass in two variables, and when the function is done, I want each one to contain the other variable's value. So to begin, let's create a function. We'll just call it swap, and here's what it's going to do. It's going to take two parameters. We'll just call one A and one B. Now, we're going to go through the logic of swapping these values, and the first instinctive way to do it is actually incorrect, which is where you would assign B to A, and then the other way around you would assign A to B. But this isn't going to work because when you assign B to A, it's going to basically replace the value of A, and it's no longer going to be available here. So the solution to this is to use a temporary variable. So we can assign A to temp, and now, instead of assigning A to B, we can assign temp to B. So we're basically storing that original value of A in this temporary variable so we can reference it later. So that should be the logic to swap the variables, but it's not complete because we're passing by value. So inside of the function they'll be swapped, but outside they will not be swapped. Here is an output that you can use to illustrate this. In A it has the value 10, and in B it has the value 20. Now what we're going to do is we're going to call swap, pass in A and B. Now when we compile and run, the output is that A contains 20 and B contains 10. So the swaps seem to work, but the thing is, if we copy this line here and paste that inside of main, you'll see that everything is reverted after the swap. So it doesn't persist beyond the swap function. So inside of the swap, A is 20, B is 10, but afterwards A is 10 and B is 20. The reason that is because this A is different than this A, and this B is different than this B. So this function is changing this A and this B, but the original A and B are unaffected. So to fix that, we just need to pass by reference. So to do that, you prefix the variable inside of the function. So the parameter, you prefix it with the and sign, like so. Now when we compile and run, you can see it persists outside of the function. Now, when it comes to passing by reference, you'll often see it where the and sign is attached to the variable, but that's not a requirement. So sometimes it will be like this. That works fine too. Other times it will be attached to the data type, and that works as well. I personally like to attach to the variable, like that. So that is how you create a swap function by passing by reference. Hopefully that was helpful for you guys and a lot of fun. Pretty simple, but also pretty cool. So thank you guys, I'll see you in the next video, and don't you forget to subscribe.
Yo, what's going on everybody? Welcome back to your C++ tutorial series. This video, we are going to be talking about function overloading. This is the concept, and then we're going to get some hands-on stuff in the upcoming videos. So this is where we start getting into the really cool parts of programming. I'm super excited, and I hope you guys are as well. All right, so here's the thing. When you create a function, it's defined in your program. So here is an extremely practical function I just created that is going to do stuff for us. And this is established as a function in your program, meaning if you type it again, you're going to have a problem. So if in your code you do this, the compiler is going to complain that there is already, honestly, I'm not exactly sure what it'll say. It'll probably give you some really cryptic message, but it'll say something along the lines of, hey, do stuff has already been defined, or you're redefining a function that was already defined. But there is an exception to this rule. If you change the second version just a little bit, you can actually have two versions of the same function, basically the same name for the function, different arguments. So for example, we can create one that takes a string. Now the compiler is not going to complain because it basically sees these as two different functions. Now when you call this function, which one is it going to use? Well, that depends on the types of the arguments. So if in our code we call do something and we pass in hi as an argument, well, it's going to say, should this go to the integer one or the string one? Well, clearly it should go to the string one, and it's going to call that version of the function. This is the concept of overloading. It's when a function has multiple versions but the same name. So do stuff has essentially two versions of the function. It has overloaded functionality. Now, a common misconception, and this is not universal across all programming languages. So in C++, the return type is not part of determining if a function is unique. So the concept of having a function that's unique, basically, is this a valid overload? That is known as the method signature. So each one of these has a unique method signature. And again, the return type is not part of that signature. In other programming languages, it might be the case, but if you had two exact functions that had the same arguments and it had two different return types, that would not be okay. That would not be considered an overload. There has to be some other way to distinguish these functions besides the return type. So that is an important thing to know. That's for C++ specifically. Now here's an example of overloading. You might have a function to calculate the area of a square or rectangle-like shape. So let's say this returns a double, and it's called area. Now, what kind of shapes can this use? Well, tons of stuff has area. So maybe you could distinguish, instead of having a bunch of different functions like square area and rectangle area, maybe it'd be possible to distinguish different shapes based on the arguments. So for example, if you have a square, well, all the sides are the same. So if you have one argument, then it should be assumed to be a square. If you have a rectangle, well, you might have two arguments, like so. And in this situation, you might have the first overload being one argument of type int, the second overload having two arguments of type int, and then once you get into object-oriented programming, you might make a custom type known as a rectangle, which you can take as an argument. So there might be three overloads, and it would look like this. One with int x, or whatever you wanted to call it. You could just call it length, for example. One with two parameters here, the length and the width, which would be for a rectangle, and then another one with a custom type called rectangle. So this is just an example, and maybe you wouldn't want to do this because it wouldn't be clear which area you're calculating, but if you have a very small application and you are the one who's primarily using these functions, it might be perfectly clear enough. That's up to you. As a side note, and this might not become completely clear until a couple videos from now, overloading is not designed for optional parameters. So for example, if you have a function where if you don't pass in an argument, you want to default it to the value 10. That's not something you would use overloading for. You can actually use default argument values, and we're going to go through an example of how to do that in the upcoming videos as well. But since this is a concept video, I thought I'd throw that in as just a little sneak peek. And that's pretty much all I got to say about overloading. Super, super, super important. All complex functions are going to have overloads for different types passed in as arguments. So hopefully that was helpful. If you've enjoyed the content, please consider subscribing, and I'll see you in the next video where we're going to create this right here. So I'm looking forward to it. I hope you are too. Peace.
Hey, what's going on everybody? Welcome back. In this video, we're going to go through some examples of function overloading. It's one of the most important things in programming, so make sure you pay attention. Let's first start with this swap function here, and then we'll go through some other examples after that. And just in case you're not clear what overloading is, you might want to check out the previous video where we go in detail, but if you just want to watch this one, overloading is just creating multiple versions of a function. Now here we have this swap function that swaps two integers. What if we wanted to create another version that swapped strings, for example? So we can actually do that. We could say void swap, and this one is going to take strings. So we'll say standard string A and standard string B. Now make sure you include string. There we go. Now this is going to work in a very similar nature. We're going to make a temporary string. We'll assign that the value A, and then we'll assign B to A, and then we'll assign that temporary variable back to B. So when we compile this, you can see there's no errors. The reason there are no errors is because these actually have two separate signatures. This one takes two integers, this one takes two strings. If there was a repeating signature, for example, if we created a new swap and it took an integer and another integer, you can name it whatever you want, in this situation we'll get an error. And you can see it says call to swap is ambiguous. Basically, it doesn't know which swap to use. So when we pass two integers to swap, it goes and looks at the definitions of swap and it says, there's two exact copies of swap. The pass by reference doesn't actually matter here because from the caller's perspective, all it does is pass in the variables and lets the functions worry about everything else. So it's not able to tell which one to use. But in the situation with the strings, it can tell because we're not passing in two strings, we're passing in two integers. So it can easily tell that we want to call this one up here and not this one down here. But that means inside a main, we can call the other version using strings. So let's go through an example where we have two strings. We'll call one first name and the other one last name, and then we'll call swap and pass in first name and last name. Awesome. And when we compile this, you can see there are no errors. And when we do an output, we'll see that the names are in fact swapped. So we'll do first name first, do a space, and then we'll do last name. Let's compile and run. I actually have to pass by reference, sorry. So we need to go up here and make this one a reference and this one a reference. Otherwise, it's just gonna swap them in here, exactly what we talked about in one of the earlier videos. It'll swap them in here, but that won't persist outside of that function, and it'll be normal in main. So in order for that swap to persist, we have to make sure they're being passed by reference. All right, so now when we compile and run, it should work. And you can see it does say curry Caleb, so the swap works. So that's a perfect example of function overloading. Now I want to go through another example from scratch. So I'm going to create a new file, and this we'll just call it, I don't know, math stuff. Very creative. Then we'll just set up the basis. And here's what we're going to do. We're going to actually start working with what are known as structs. We'll talk about them in detail later, but just to get a little bit of, looking forward, here's how you would create a struct. It's basically a custom data type. We'll say struct, give it a name such as rectangle, and then we'll define the elements inside it. We'll say double length and double width. So that's kind of how you define a rectangle and the size of the rectangle. Now let's say I wanted to calculate the area of a rectangle. Well, we can do that with a function call. So let's create a function, we'll call it area. And here's what it's going to do. It's going to return a double first off because it's going to calculate that area from two doubles and return it. It's going to take two doubles as arguments, so we'll have double length and double width. And what it's going to do is it's going to return length times width. So now let's go through an example of using this. What we're going to do is we're going to create a new rectangle and we'll assign it some values. So we'll say rectangle dot length is equal to 10 and rectangle dot width is equal to 10 as well. And we can call this function by saying area and passing in rectangle dot length and rectangle dot width. And this is going to return a double, so we need to do something with it. Let's just output it. Now let's compile and see if we have any errors. Make sure you've compiled the right program here. And it looks like I forgot a semicolon after the struct, so make sure you put that there. Now when we run, you can see it gives us the value 100. But we could actually make an overload of this where we don't need to pass in the length and the width, assuming we're working with a square. A square is technically a rectangle, it just has the same length as it does width. So let's create a new version of this where we only need to pass in one argument. We'll just call it length. And all it's going to do is it's going to return length times length. So that would be ideal if the length is the same as the width. And we actually have that down here. So if we want to do that, we can actually just make a new version of this. And instead of passing both of these in, we'll just pass in length. Now we can compile and run. The first output we get 100 and the second output we get 100. Now I can actually make a third overload of this where we pass in the rectangle itself. So let's go through an example of that. What we're going to do is we're going to say double area, and this is going to take a rectangle, and we'll just call it rectangle. And what's going to happen is it's actually going to return rectangle.length multiplied by rectangle.width. Now how do we call this one? Well, inside of main, let's do another output. And instead of passing in a length or a width, we're just going to pass in the rectangle object like so. Now we can compile and run. And you can see we get 100 every single time. So here is an example where we overloaded the area function with 3 different overloads. And the way it knows which one to call is based on how we call it inside of main. So this is pretty cool. We're going to continue to work with this stuff in future videos, so be sure to stick around. If you've enjoyed this content or it was helpful, be sure to subscribe. Now I know we haven't really talked a whole lot about structs, but we are going to get into those in detail, so be sure to stay around for that as well. Thank you guys, I'll see you in the next video. What is up everybody, welcome back to your C++ tutorial series. This video we're going to be talking about default arguments. You may also hear them known as default parameter values or default parameters. Whatever it might be, that's fine, but basically it's a way to assign a default value to a parameter. Now this topic often comes up when the concept of overloading comes up, because often people will use overloading when they should really be using default arguments. So we're going to be talking about the differences between them and when you should use which. Alright, so before we start talking about default arguments, let's take a look at one of these overloads here. So basically we created this area function. One of them will take a length and a width, and the other one will take just the length. So in other words, it's just going to assume if you don't pass in the width, that the length is the same length as the width. Lots of lengths and widths going on here, but basically this is the one to use for a square, and this is the one to use for a rectangle. That's the difference. So we are essentially making this width optional. Now, another way to make parameters optional is to use default values. So in that situation, you can assign a value to width. It wouldn't quite work out in this example because we don't know what default value to use for width. Specifically, if you have a square, that width is always going to be assigned whatever that length is. So not exactly applicable here, but there are a lot of situations where you're going to create functions and you can assign a default value to a parameter. So let's go through an example where that might happen. Let's create a power function so we can use this function to raise a number to a power. So let's create this to return a double, and we'll call it pow. And here's what it's going to do. It's going to take a base and it's going to take a power, and we're just going to use integer powers here. And the algorithm to calculate a power is we're basically going to have a total. We'll start it at the value 1 so we can multiply by it and actually get a value. If we had 0, it wouldn't work. And then we'll go through a for loop. This for loop will start as 0 and it will count up until power. And each time we're going to increment I by 1. So if power was 3, it's going to iterate through this loop 3 times. Now what are we going to do in the body of this loop? We're just going to increase total by multiplying it by the base. So in this situation, if base was 3, you would have total equals base times base times base, which is a lot of base, or 27. And then once we're finally done, we're just going to return that total. So I think this should be right, but let's just go through an example to make sure we get the right value. I'm going to comment out main just because we don't want to have all this stuff here, but I might use that stuff later, so I'm going to keep it for now. And here's what we're going to do. We're going to standard cout. And what are we going to output? We're going to output power. And let's just pass in the value 3 raised to the 3rd power. Let's compile and run. And we, what? Alright, so we got 10 bits because this needs to be a multiplication. Sorry guys. I swear I'm not stupid. Alright, now you can see we get the value 27. Now what if we wanted to create another version of power where we don't have to pass in the second argument? You know, what if we just wanted it to raise it to the second power by default, so square the number? Well, what we could do is we could go in here and create a second power function, basically do it like this. It will only have one parameter, which would be double base. And then the algorithm here would just assume that we're going to raise it to the second power, so it would be base times base, and it would return that. So in that situation, we could call the same thing here, and then instead of passing 2 arguments, we could just pass in 1 argument, and it would be 3 times 3, or 9. Now when we compile, you can see we do in fact get 9. So that is how we use overloading to basically make the power optional, but a better solution to this problem would be a default argument. And the way that looks is you just put an equal sign after the parameter and give it a value. We'll default it to 2. Now we can actually get rid of this overload because we're not going to need it. And now when we compile, you can see it still compiles and it still runs. That's pretty awesome. Basically how this works is if we don't pass in that second argument, it's going to default it to 2. And fortunately, our algorithm works exactly the same way. It only goes through this loop twice, and the total ends up being correct. So that is how you use default arguments. So when should you use overloading and when should you use default arguments? Well, anytime you can put a default value in the arguments or the parameters like so, that is what you should do. You should minimize overloading because it's more complex. You'll often have repeating code and it's not necessarily necessary. So whenever you can design an algorithm to basically take a default value, that's great, and you don't have to go through the process of making it basically a copy that does exactly the same thing, but with just a specific number as one of the parameters. It's kind of redundant, you don't need to do that. So to conclude on that part, always do default arguments first. If you can't figure out how to do it with default arguments, then you can try overloading. For example, in our earlier functions area, I wasn't sure how to give width a default value in the case of a square because width would always be equal to length, and you can't seem to do that here. See, if I did width equals length and then basically width would be optional, you can see when I compile we get an error. If that was possible, then all you would have to do is pass in the length, and the length would also be assigned to width. So in this situation I saw it as better to do function overloading, and that worked in this situation. But you can see it is very code redundant. This is a very simple example, but it is possible to kind of overdo it and have repeating code. Now one other thing to keep in mind, and it doesn't really apply in this situation, there are scenarios where you might want to call another overload from a particular overload of the same function. So for example, this area function could call this area function as long as you're passing in the right arguments. That might be useful if a particular function provides most of the functionality, but maybe you just need to add or subtract something. And in that situation, you wouldn't have to repeat the entire code base. You would just have to repeat part of it and then call the appropriate functions. So hopefully that was nice and clear. This stuff can get pretty complicated. It can be a bit confusing. It's hard to know when to do what and how to keep it organized. But with practice, this will come. So stay at it, don't give up, and check out the next video. It's going to be a lot of fun because as you can see, we're starting to build up this function library here where we have a bunch of these different functions. And I want to actually take these and export it into basically a function library in its own files, and we can do multiple file compilation. It's going to be really cool. It's the juicy stuff with C++, so be sure to check it out. And thank you guys so much for watching. And don't forget to subscribe. Alright, I'll catch you guys in the next video.
Hopefully this is in focus. Welcome back everybody. In this video we are going to be talking about multi-file compilation in C++. So this is like a huge step in your C++ development because this is where things really get complicated, I'm not gonna lie. But I'll do my best to break it down, make it simple. Now when you're working in another programming language such as C# or Java or something else, you can easily create new files, you can put your classes in separate files, and when you compile, it all works nicely. Unfortunately, C++ is kind of a nightmare when it comes to multiple files, but they're still essential. Oftentimes, as you get larger programs, it's going to make sense to break some of that stuff off into multiple files to keep things organized. You can put certain stuff over here, certain stuff over here, and that way it's not just one giant, huge program. That would not be maintainable and is really just not ideal. So, the first step is to just break up your program into 3 files. Then as you get more complex programs, you understand the concepts and you can scale that to more and more files. So the bare minimum, a program that's split into multiple files will probably be these 3 files. Number 1 is a header file. Number 2 is an implementation file. And then number 3, I don't really have a name for it, but it is where you use these files. So I'll just call it the main file. This is where your main function exists. So you can kind of think of it like this. You can think of it like this. Here is your program, and you can utilize this function library. And this function library consists of 2 pieces, a header file .h and an implementation file .cpp.
So basically we can break off our functions into separate files, and then we can use those in our application by just including them. So just like you would say include IOStream, we can include our custom header. It'll look a little bit different because we'll actually put it in double quotes instead of the carets. So it'll be something like this. Include, and then in quotes, the file name custom.h, for example, end quote. So that is going to look in the same directory for the file. So right now we're just doing this with simple functions. Eventually we'll be able to do this with classes. We'll break off into multiple files, and you can often have multiple header files and multiple implementation files. But you're always only going to have one main file. And that is if you're making an executable. If you're just making a function library, basically a collection of functions, that main function is not necessarily needing to be a part of it, and you could just have these two, and then anybody who wants to use your function library can get this code here and include it in their program. Another way to think of how this is split up, you can think of this as the declarations, this as the definitions, and this as the callings. So here's where we declare our functions, here's where we define them, and here's where we call them. As for actual file extensions, this one, the main file, is going to be .cpp or C or CC, basically a C++ file. Same for the implementation file, so that is also going to be of the same file extension, in this case CPP. The header file is going to be .h. So these two are going to contain C++ code that gets compiled, and then this header file is just going to basically be like an interface on how to work with this implementation file, and you'll see what I mean in the next videos. Now the header file needs to be included in both of these source files. So you can also visualize it like this. We have a .h file, and then we have two CPP files, which are going to both include this header file. The header file is just going to be like the structure of your functions, the declarations, and once we get into classes, it'll be the structure of your classes, but it doesn't actually have any executable code. There's no function definitions in that file. Also, in the header file, there's going to be what's known as a preprocessor directive. And basically, when you compile your program, there is another step that happens, which is known as preprocessing. So we need to basically send a message. This sounds really stupid and weird, but follow along for now. We have to send a message to the preprocessor saying, yo dude, we created this header file and we want to include it in our code, but we only want to do this one time. So that means if multiple files are including this header file throughout our large application, we don't accidentally include it twice. We don't want to basically redeclare everything that's in the header file. And in order to send that message, we use what's known as a preprocessor directive. And it looks like this. At the beginning of your file, you're going to put a £sign and say if ndef, if not defined, and then you make up some name. And that name can be whatever, but usually it's the same as the file, probably in all caps. So it could be like custom_h, anything just to make it unique. So when we're including this, we're basically uniquely giving this file a name inside of the code. And basically the preprocessor will look at this, see if we have included it already, and if not, it will proceed. So if it's not defined, what we're going to do is we're going to define it. And then at the end of the entire header file, we're going to end that if by just saying end if. So this is a little funky, and it's probably not anything you've really seen in other programming languages, and it's just something you got to get used to. Everything that goes in the header file goes in between these lines of code. That's all you got to know. Now the final thing when it comes to multiple file compilation is how to actually compile these files, because you have multiple C++ files. So to do this, you need to change the way you're compiling. Now this is for G++, that's the compiler I've been using, but this is going to vary depending on the tools you're using or the compiler you're using. So it might be different if you're using Visual Studio or Embarcadero Rad Studio. Whatever it is, you just got to figure out how to do that in that tool. I can't go over all of them, so this video is going over G++, but it shouldn't be too complicated. Just look up how to do multiple file compilation in whatever tool you're using. But it might look something like this. file1.cpp, so that could be the one with the main function in it, and then a space, and then file2.cpp. So it's really not that complicated.
You just have to add another file in that file compilation list, and it should still give you the output a.out. Now there are some possible extra steps you can do with this, but this is the bare minimum. If you want to know more details, check out the upcoming videos because we're going to talk about object files, how to automate this process with Makefiles, lots of juicy content, so make sure you watch the upcoming videos and be sure to subscribe. Thank you for watching. Again, this is the theory. I like to just go over the theory so you don't just dive in, copy and paste, and try to make things work. That's the sloppy, messy way to do it. It's best to understand the concepts. And I admit the concepts are very complicated. So just take it slow and we'll figure it out, hopefully. Maybe.
Hey, what is going on everybody? Welcome back. This video we are going to be talking about multi-file compilation and how to take a file with all the code defined in one location, how to split that up into multiple files, and get it to work somehow still. So make sure you watch the previous video if you need the behind the scenes conceptual stuff on how this works. This video is going to be more hands-on. If you need a little bit more background, that's the video for you. Alright, so first thing I did was I separated our code into two folders. Basically this one called math, which is where we're going to put all of our files for this video, and then this other folder which contained all of our previous files. That's just a little bit for mental clarity so we don't have to look at all that junk. The other thing is I changed into the math directory. So the way I did that is just cd math, and then it brought me into that math folder. And when you say ls, this is how you can see the files in that folder, or you can just look up here in this folder right here. Alright, so first things first, when you create multiple files, it's a lot of steps, it's really confusing, and can take some practice. So we're just going to try our best and do this one step at a time. So first thing in here, you'll notice we have this main function, and then we have a series of other functions that have been defined in this file. So these functions have the declaration and the definition in one spot. And that's totally fine. Oftentimes when these are split up across multiple files, the declaration and the definition will be in two separate spots. So what we're going to do is we're actually going to take all of these functions besides main, we're going to leave main in this file, and we're going to cut them. And there's accidentally two IO streams here, we don't want that, so delete one of those. So one IO stream should be inside of this mathstuff.cpp. Now we're going to create a new file, so click this new file button, and we're going to call this mathutils.cpp. So this is going to be another C++ file, paste everything in there, and you'll want to make sure that if any of your functions are outputting to the console, that you include IOStream or do any other includes that are required for this code to work. The next thing we're going to do is we're going to create what's known as a header file, and it's going to be very similar. It's going to have the same name, mathutils.h, and this is kind of the interface to working with this code. So we're going to paste everything in here as well, but what we're going to do is we're going to get rid of all of the bodies, gets me every time, and then replace them with semicolons. So yes, just keep doing this, go through the process to clear up this code. So now we're just going to have the declarations for the functions in here, and the struct will stay here as well. In the C++ file, mathutils, we can get rid of the struct. That usually will stay in the header file. So now all we do is have the function definitions, and the only other thing is one of our function definitions uses a default value. You don't want to do this for the function definitions, you only want that for the declaration. So we're going to get rid of that and just leave that int pow. Inside of the header file, that's still going to be there, so int pow equals 2, it's still going to work the way we expect. Now what we're going to do is in both of the C++ files, we're going to include this header file. So go back to the main and say include, and in double quotes say math_utils.h. Now the reason we're using double quotes is because that will search in the current directory, which is where that header file is defined. Inside of the mathutils cpp file, we're going to do the same thing. So open that, scroll to the top, and make sure to include that file. Now we want to be careful we don't include the same file twice, and there is a protection against that. So inside of the header file, we can use what's known as a directive and just say if ndef, which says if not defined, and then make some name up. We can say math_utils. Then what we're going to do, if it's not defined, we're going to define it. So we just say define mathutils. And then at the end, you can end that if statement by saying end if. So that's just a little bit of the preprocessor directives, which will be processed before the code is compiled, which will prevent us from including this code twice. Now, how exactly do we compile this?
I think we got everything right, but I may have missed something. So to check, we can compile and see if the code works the way we expect. So G++, and then you just put the names of the C++ files. So math stuff.cpp, mathutils.cpp. And note that these are both in the same command. That'll give us one output using these two files, and it will appear as a.out. And then we can run that, and voila, we get the same output we originally got when we created this code. So here's how it's working. Inside of mathstuff.cpp, we have this main, which is calling this power function, which comes from the header file and is defined in the mathutils CPP file. So going there, we can find that power function, and voila, here it is. Having your files split up like this can be confusing, so just make sure you're paying really close attention to where things are defined. Generally, the function definitions will be in the mathutils, the declarations in the header file, as well as default arguments, and any data types such as structs. Then you will have one file which will just have the main function and the general flow for the program. So we're basically creating a utility file, mathutils, mathutils.h. Then we can use that inside of our mathstuff.cpp and treat it as if it's just a bunch of functions made available to us. Now there is another option that you guys should know about when it comes to compiling, and that's going to look like this. If you go up to the previous statement and we add another flag in here, -c, what this is going to do is it's going to produce two new files, mathstuff.o and mathutils.o. These are known as object files. When you open them, it's nothing that you could really read. It's just a bunch of jargon. This is compiled C++ code, and this is another option that you can use. Then, if you want to compile using this object code, it would look like this. mathstuff.o, mathutils.o. And you can see we can compile just the same way and execute our program. So when would you want to compile using CPP versus .o? Well, it depends on what you're trying to use your library for. If it's a library you're trying to distribute but you want the source code itself hidden, then you would want to use the .o files. If you're creating an open source project and you want people to be able to get the original source code, then you might distribute the CPP files. Which to use is totally up to you. Most of the time you can just compile directly from the CPP files and you don't have to worry about the intermediate step of creating the O file. But when it comes to distributing a library, you're probably going to be distributing the .o file. .o files are also going to come up when we go into Makefiles, which we're actually going to be talking about in the next couple videos. So be sure to check those out because Makefiles are huge. It's basically a way we can automate the compilation process, save us time, make it super awesome. So be sure to subscribe and check that out. I'll see you guys in the next video where we're going to learn about the concept of Makefiles.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be all about Makefiles. It's the theory behind them. In the upcoming video, we're going to go through a walkthrough on how to create one. So if you just need to jump in and learn how to do it, you might want to check out that video, but I would recommend you understand the concepts which we're going to go over in this video. Now, Makefiles, their purpose is to basically automate the build process for a C++ application. This is going to be important if you're on Mac or Linux. It's not going to be exactly the same with Windows, but you can look up alternatives to Makefiles for Windows, or you could just buy a Mac machine or a Linux machine, or you could just skip this video and the next one. But it is still good to know, so I'd encourage you to stick through it. All right, so what in the world is a Makefile? Well, in previous videos, we talked about how to compile when we are working with multiple C++ files. Generally, we just put G++ and then we list each file name. But there's a lot more that can be done to optimize this process. Mainly, as we build larger C++ applications, we don't necessarily want to have to recompile everything when there's just one little change. We only want to have to recompile what we need to recompile, and then once we compile all the individual pieces that have been changed, we can relink those things together. So that's what we're going to be doing in this video. So if we wanted to visually see the best compilation process, it might look like this. All right, so we have two C++ files, file 1 and file 2. Now when you compile these, you can compile directly to an output. So a.out or awesome application, whatever your output file name is, you can compile that directly. But you can also do an intermediary step or an intermediate step of getting object code. So it would look like this.
So file1.cpp becomes file1.o, file2.cpp becomes file2.o. This is compiled C++ code. Then what we can do is with these files, we can link them all together and get our output. This is where the header files, I believe, jump in. So these would be combined as well with the header files, and we would get the output a.out, or whatever you decide to call the output. Now let's say in theory we changed file1.cpp. So this is changed. If we just did the general compile everything, well, we might just do g++ file1.cpp and file2.cpp. We go through that whole compilation process and get the output. But we don't have to do the whole process. All we would have to do is compile this one to get file1.o, and then we just relink the files to get a.out. So you can see in this situation, we don't actually have to touch file2.cpp. We don't have to do any compiling there. All we have to do is link the files together. So there is still a lot of process here, but there's less. And in such a small project, it doesn't make a huge difference. But if we have a project with lots and lots of C++ files, we don't need to recompile everything anytime we change anything. That would take forever and would be terrible. So we're only going to do the bare minimum. But it's easiest if we use a Makefile to automate this process. So what the Makefile is going to do is it's just going to check the dates of the files and compile a portion if needed. So in this situation, it would notice that file1.cpp has been changed, so it would compile it g++ file1.cpp with the C flag, which would give us the object file, and then it would relink things using g++ file1.o, file2.o. Don't worry about the exact commands, we'll get into that in the next video. The main thing here is that you just have to realize the Makefile is basically a way to describe our compilation process and which files depend on which files. So we would basically describe that this one here depends on this one here. So if this one's changed, this one needs recompiled. And this one here depends on both of these. So if either of these change, then we have to relink. Whew, lots of concepts. It's very surreal without actually going through an example, but it is important just to think about what a Makefile is for. It's to minimize the amount of compilation that is necessary, and we don't actually have to manually type out any of the commands. When we create a Makefile, it's just a description. It has its own syntax, and we'll go over that, on how to do the compilation process. And then when we want to compile, all we have to do is in the terminal, just say make. And it'll just do everything for us and give us the output. So let's just go through a very simple piece of a Makefile, just so you guys get the idea of what the syntax looks like and how to create one. So very first thing is we create a file, and it has to have a very specific name of Makefile with a lowercase or uppercase m, does not matter. And then in this file, it's just a text file, and here's what it will look like. We define what files are there and what their dependencies are. So for example, we could have file1.o. This is an important file for our project. We need that to execute our program. Where does this come from, or what does it depend on? Well, you put a colon and you say the other file for it to look out for, which is file1.cpp. So if file1.cpp changes, then file1.o needs to be regenerated. Then what you do is on the next line, you indent and say how we generate file1.o. So how do we get from here to here? So it would look like this. We just put the compilation command, and then that's it. This is just one rule, but inside of a Makefile, there's going to be a series of rules for each one of your O files, as well as your final project, a.out, or whatever you decide to name it, which will define the linking rules. In the next video, we're going to create a Makefile with all of these rules. It's going to be a lot of fun, and we'll show you how to execute it and all that good stuff. So please be sure to subscribe and check out the upcoming video. It'll be a lot of fun. It'll make your day. So dumb. Anyways, I will see you in the next video. Peace out.
Hello everyone, welcome back. This video is going to be the walkthrough of creating a simple Makefile. This is a follow-up to the previous video where we talked about the concept of Makefiles, how they work, all that. We'll get into some of that in this video, but overall this is just going to be a step-by-step, here's how you create one. So when it comes to creating a Makefile, here's what we're going to do. We're going to click New File, and it's going to be called Makefile. It can have a capital M or a lowercase m. I'll go with, I don't know. Let's go capital M. No, I don't like that. I changed my mind. I'm going to do a lowercase m. It doesn't matter. Just overthinking. I'm going to make sure this is in the same folder as all of my math files I've been working on. And what I'm going to do is I'm just going to do a little bit of cleanup. I'm going to delete these object files. And I'm going to delete a.out. Cool, so all we have now is our source code. Now when we're creating a Makefile, what we're going to do is we're going to put the file we're trying to create and how it comes to be. So this is actually a good time to talk about how you can change the output file name. So when you compile some code, you have the option of using the O flag. So if you just put -o, you can define what name you want the file to be. So since we're going to be making a more complex application, you might want a prettier name than just a.out. So what we're going to do is we're just going to call this math. And then you put a colon. And now the syntax here, it has to be exact, so don't cheat. Don't put anything else, it has to be a colon here. Then what we do is we say where this file comes from, or what it depends on. And I'm going to use object code, so we're going to need two object files, one from mathstuff.cpp and mathutils.cpp. So mathstuff.o and mathutils.o. Those will come from the CPP files once they're compiled. So you can kind of think of it as this. This is the destination and this is the source. The next line, we actually say how we get from the source to the destination. So if you press enter and then hit tab, and yes, you have to hit a tab, the syntax is strict. Now we're going to put the compilation command to get from these O files to the math file. So to do that, we say g++ mathstuff.o mathutils.o, and then we can use the output flag and give it a name. We will call it math. So that is the way we compile these files and get the result math. So this is the name of our file. Now what we can do is we can repeat that process with these files. Where do they come from? Well, let's go down 2 lines and then go back to the far left and say mathstuff.o. Well, this clearly comes from mathstuff.cpp. How do we get from mathstuff.cpp to mathstuff.o? Well, we do a compilation g++ mathstuff.cpp. And whenever we want to get object code, we want to use the C flag, so -c. Then we do the same thing for the utils, so we say mathutils.o, and this is going to come from mathutils.cpp. And the command to get from the source to the destination is g++ -c mathutils.cpp. Cool. So this is our Makefile. Now we can also do another command here, clean, and this will just remove any files that need cleaned up. So for example, sort of how earlier I removed the object files, if we wanted to do that again, we could say *.o. The asterisk will grab any file ending in .o. And let's also get rid of the compiled file altogether, which is called math, by putting a space and putting math. This is a Linux command. If you guys need a little bit of work on that, I talk about how to do these kinds of commands in my C programming series, so check that out if you need help. Oh, okay, so I think our Makefile is done and it should be ready to go. How do we actually use it? All we have to do is say make. And what this is going to do is it's going to basically look at this and figure out any of the dependencies and make those as well. So hit make and watch the files over here on the left. When we press make, all of these commands are executed and a bunch of files appear on the left. We have the math file, we have the object files, and we still have the source files because those are not going to be touched. So when we're working with such a simple application, this whole process seems a little over the top, but it's very good to know this stuff because as we get into more complex C++ applications, we don't want to have to go through this crazy compilation process every time we want to do anything with the code. A Makefile really keeps us in check because not only does it do the work for us, but it also does the minimum amount of work. So if we only change one file, it's not going to recompile everything. It's just going to compile what it needs, relink the stuff together, and then give us the executable. If we want to execute this, all we have to do is say /math. And you can see we get an output. You can illustrate this using the touch command. What this will do is it will update the timestamp for a particular file. So let's say we changed mathstuff.cpp. When you run make, it's going to notice that the CPP file has been changed and it's newer than the O file. So it's going to recompile the O file and then it's going to regenerate the math file. So let's run make. What commands are executed? Well, this one right here, g++ mathstuff.cpp, and then it's going to relink everything back together using this command right here, which is where we take all the object code and put it together and generate the math file. So that's really cool because nothing even happened with this mathutils.cpp. It didn't recompile. That's because we didn't change that file. And then if you ever want to start from scratch, all you have to do is say make clean. And it'll run this remove command right here. Voila! So that is Makefiles. Super, super cool. Not so useful right now because it would be easier just to compile ourselves. But as you get more files and more work, it's going to make your lives a whole lot easier. So make sure you guys got this stuff down. This is probably one of the harder pieces to really grasp. At least it was for me, but now I think I finally got it, at least the basics. And let me tell you, these things can get pretty complicated. You can introduce variables, and all kinds of different stuff like that. So if you want to know more, look up Makefiles and let me know some cool tips in the comments section below. Now what we're going to be doing is we're going to be taking a break from Multifile Compilation and Makefiles, and we're going to be talking a little bit about namespaces. And this is kind of our transition into object-oriented programming and some other cool stuff like that. So we just got a couple more things to finish up before we get into object-oriented programming, and then we're going to dive into that stuff. So check out the next video and please be sure to subscribe.
Yo, what's up everyone? Welcome back to your C++ tutorial series. This video is going to be all about namespaces, the concepts behind them, what they're for, and how to use them. If you need some hands-on experience, that's what we're going to be talking about in the next video, so be sure to stick around. Alright, so the easiest way to understand a new concept is to go through an example. So one namespace that we have used in the series is known as standard, the standard namespace, shortened STD. So when you get something from the standard namespace, you prefix it with std : : So we just say standard : : and then whatever is in that namespace, such as string or vector, whatever it may be. Now the purpose of this is to basically give a scope to the identifiers in this namespace. So string belongs to the standard namespace. It's a grouping. So think of this as a namespace, specifically the standard namespace, and inside of it we have string. We also have vector, and whatever else might be part of the standard namespace. Namespaces are essential when it comes to avoiding naming conflicts. That's because there's a limited number of possible names for things inside of a programming language, and we try to use names that make sense. That means from library to library there might be conflicting names. For example, there might be two libraries that decided to use the word string. Now we got an issue because how are we supposed to know which library string comes from? Well, we just have to prefix it with the namespace. We talked about this when we talked about the using keyword long ago in this series. Basically, the issue with saying using namespace standard at the top of your program is that you don't have to prefix anything with standard anymore, and it increases the risk of naming conflicts. But I'm not really here to talk about the standard namespace. We have talked about that enough. The point of this video is creating our own namespaces. Creating your own namespace is super easy. Literally all you do is say namespace, give it a name. I'm just going to call it utils, short for utilities, and then use curly braces, and everything defined within these curly braces is now going to be part of that namespace. Now, when would you want to use a namespace? Let's talk about that now. The first reason is for common functionality. And this is in addition to potential naming conflicts, which we just talked about. Another benefit is to group things of common functionality. A second way is to group from a company or a particular division of a company, or a particular project. And a third reason is you can actually have categories of things, and you could basically change which one you want to use depending on the namespace you use. So you could have a category of members in this one namespace, and then another namespace over here with similar members, same names, but from different namespaces. And for example, one could be threaded and one could be unthreaded. So depending on which one you wanted to use, you would just have to change the namespace. In other words, you can use namespaces to classify your classes and your functions. So earlier we had that utils namespace. Let me just recreate that real quick. So if we have this utils namespace and we define something in here such as a function, let's just say we have some function double, multiply, and some arguments or whatever. I'm not too worried about that. What I want to tell you guys is how do we actually use it? Well, inside of your main function or wherever you want to use this, you just prefix it
with the namespace. So you would say utils : and then whatever the member is, such as multiply. And you can pass some data in there, like so. So namespaces, they're very simple, very easy to use, and we're gonna be showing you guys how to create them in some use cases in the upcoming video. So be sure to check it out, and don't forget. Yo, what is up everybody? Welcome back. This video, we're gonna be talking about namespaces. Now I am back in this collections.cpp file. It's a file we used a while ago. If you don't have it still, it's fine. All it is we create an array, and then we call this function to print the array. So what this video is going to cover is how to use a namespace and then how to do it across multiple files, which we talked a little bit about Multifile Compilation a few videos ago and Makefiles. So we're going to go back in that project and add a namespace there. Alright, so creating a namespace is super easy. Literally all you gotta do is say namespace, give it a name. We could just call it something stupid like utils, basically for a bunch of utility functions, and then you're going to take all your code and put it inside of that namespace. And you want to make sure your indenting is correct. There you go. And now when you want to use this function, all you have to do is prefix it with utils, like so. Now to compile, first we got to get to the right folder, so we need to change directory. And then compile. And you can see we can still output. It seems to work just fine. If you don't want to prefix this stuff with the namespace, you can just go up here and say using namespace utils. And then you should be able to remove this prefix. And this using is actually going to need to come after the namespace definition. So this will come before main, but it will come after this namespace definition. All right, now let's try compiling and seeing if it works. Indeed it does, and we can output our code. Now we talked about whether doing this was a good idea many videos ago. Generally, I prefer not to because it kind of defeats the purpose of namespaces. The purpose of a namespace is to organize your code and reduce the likelihood of naming conflicts. So by using the using keyword here, you are essentially increasing your risk of naming conflicts because multiple namespaces might have a print array function. So in general, I prefer not to do that. And I would prefer to prefix, like so. Now, when it comes to doing this across multiple files, let's move over to our project we were working on earlier. This is basically a program that has a bunch of math utility functions, and we're going to put these within a namespace. So let's get rid of collections.cpp, and let's change directory to the appropriate location, like so. Now you're going to need to put the namespace in two locations, in the header file and the implementation file. So we have mathutils.cpp, which is the implementation, and then mathutils.header. So the namespace, I'm going to put it around all of these functions, but I'm not going to put it around this struct. So I'm just going to say namespace utils, and then cut all of this stuff and put it inside of that utility namespace, right there. Then I'm going to do the same thing inside of the implementation file. So at the very top, I'm just going to say namespace utils, and I'm going to cut all of this stuff here and paste it inside of the namespace. And you may want to indent right there. All right, now in the usage file, math stuff cpp, we can see how to use this namespace. So here we have this power function call. We just have to prefix it with utils. Same for power. Utils. And if we want to create a rectangle, it's not in that namespace. So we can just keep it simple like this. Here we're creating a rectangle and giving it some sizes. And then when we want to calculate the area of the rectangle, all we have to do is prefix these with utils. There you go. Now we can just say make. Oh, I have to get rid of this second half of the comment there. Now let's try this again. Make. It made the output file math, and all we have to do is say ./math to run it. And you can see we still get output like we expected. So that is how you work with namespaces. The main purpose is to separate a section of code from the rest of the world. This is very common when you are working with some kind of utility library, some function library, and so forth. So hopefully that was helpful for you guys. If you have any questions, suggestions, concerns, life goals, or favorite snack foods,
leave them in the comments section below, and please be sure to subscribe and check out the next video because we're going to start talking about function templates, which is a very cool way to basically beef out our functions, make them more useful for various data types without having to make a bunch of overloads. So it's really cool. Check out that video, and I'll see you then.
Hey, what's up everyone? Welcome back to your C++ tutorial series. Really appreciate you sticking through this. This video, we're going to be talking about something a little new, function templates. So the whole idea of templatizing is something that C++ introduced. You may also hear it as generics in other programming languages. Now, this can be tied to functions, and it can also be tied to classes. The context of this video is function templates. So if you're looking for templatized classes, this is not the video for you, although this might give you the foundation for the concept of templates. So you might still get some use out of it. So here's the thing. When you create a function, you have to determine what types you're going to accept as arguments. So you create those parameters in the function declaration or definition. Now, if you want to accept different types, then you have an issue, right? Because the function can only take certain types. So this is where overloading comes in. And we did videos on overloading. It's a super valuable thing. So although I'm going to suggest an alternative to overloading, this is not necessarily a replacement for overloading because that's still going to come up as you'll see in a few videos here. But the thing with overloading is it allows us to make basically multiple versions of the same function with different signatures. So specifically, we can take different arguments for these different versions of the function. So the example I gave earlier is we have an area function. One takes an integer x, and the other one takes an integer x and an integer y. You can name them whatever you want, it doesn't really matter. The point is, this one takes one argument, this one takes two. Or you could do the same thing where you take doubles, and that's fine. In fact, the double one would still be able to take an integer value because an integer can easily be converted to a double. So maybe you could make one that takes a double x, then you can make another version that takes double x and double y, and then maybe you could take one that takes a certain custom type, such as a rectangle type, or whatever it might be. I think you guys understand the concept of overloading, so where does templatizing come in? Well, the thing is, you might have to make lots and lots of variations of this function using a bunch of different overloads. But the general concept or the purpose of the function is often very similar from different variations. So one really good example of where this might show up is with the swap function. We worked on creating a swap function before, and it looks a little something like this, where we take two reference variables, and in this case they're integers. Not too concerned about the type, just understand that we're taking two variables, x and y, and they're of a particular type. And then you might want to create a swap that does it with strings, and then a swap that does it with custom objects. You can see that the amount of overloads can quickly add up. But what if we could create a version of this function that did not specify the type, but was more generic? Instead of saying int, we just said t. And this t is basically a placeholder for any type. Doesn't matter what the type is, as long as this type and this type is the same. Well, that, my friends, is where the concept of templatizing comes in. We basically made a template for this function, and this will work for integers, it'll work for strings, and so forth. But the thing is, when we put a t here, the compiler is just going to assume we're trying to accept type t, as if it was an integer or a custom type. It doesn't quite understand that this is a generic or a templatized function. So in order to say, yo, this is a templatized function, you have to do one more thing. Up here you specify that this is a template, and then inside of carets you say type name. You may also see some people put class here, but I'll go with type name and then t. So this is basically specifying what that generic type is. In this case, it's t. So when you look at this, you should understand that t can be substituted for any type. And it's a template, so it can be basically an overload that can work with any type. So basically think of it as doing all of the possible overloads for all of the different types, if that's one way to think about it. Now inside of the function body, we can use t as if it was an integer or a string. So we could create a variable of type t by saying t and then giving it a name such as temp, and you can assign it x and so forth. So t is just used as if it's any other type. It makes sense in the context of a template, even though t is not an actual defined type.
It's not like we created a custom class called T or anything like that. All right, that's all I got for you guys in this video. In the next video, we're going to go through this process by creating a templatized function. Should be pretty helpful, so go check it out if you want to get some hands-on experience with this. Thank you, and I'll see you in the next video, and don't forget to subscribe. All right, peace out.
Yo, what's up YouTube? Welcome back. In this video, we are going to go back to the basics of this swap function, but we're going to beef it out by templatizing it and allowing it to work with other types. So if you have no idea about templates or function templates, check out the previous video. That's going to give you the foundation. If you got that down, then you should be able to follow along with this video, which is kind of like the code walkthrough. Now, first things first, let's make sure we got the code we currently have down and we understand it. So first, looking at the calling, we pass in two variables A and B, and we want to see that the values are swapped. When it comes to doing this with strings and integers and anything that's not an array, we need to make these passed by reference using the ampersand, or I still don't know what this thing's called, the and sign. We currently have a swap which will swap to integers, and we have a swap which will swap to strings, basically assigning the first one to a temporary variable, assigning the second one to the first one, and then assigning the temporary back to the second one. I like to think of a swap function visually. I see everything shifted over one, and that leftover one rolls around to the other side and is assigned to the end. So maybe that helps, maybe it doesn't, I don't know. Anywho, here's what we're gonna do. We're going to templatize this by saying template, and then saying type name T, like so. Now, instead of using a type such as int, we're just going to use T, which is very generic instead of specific, which is basically the underlying concept of generics and templates. So instead of int, we're going to use T, and same for this here. And then instead of an integer here, we're going to say T. Cool, and I'm not going to output anything in this function, so that would make sense. Generally, functions should only do what they're supposed to do, which in this case is swap. That output was more for an illustration. Cool, now what I want to do is I actually want to get rid of this swap. I'm going to keep it here, but I'm just going to comment it out. Now here's the thing. We're calling swap with two integers, and then we're calling swap with two strings. All of the output happens at the end, but I'm actually going to do the output for the integers right after we swap them, and then we'll do the strings after. So here's the section for integers, and then here is the section for strings. So let's compile. As a reminder, I have been jumping back from folder to folder, so make sure you are in the current right folder with the swap file in it. It seems to compile right, so let's run it and see if it works. Wow, no way, it actually worked. We just got rid of one of the function overloads and replaced it with a templatized function. Now this function is capable of working with more than just integers. So that's it. I mean, that's how you templatize a function. Super easy, super useful, and it saves us a lot of code, as you can see. It saved us, in this case, only about 5 lines, but if you had a really complicated function, you might be able to basically get rid of a bunch of variations and keep it all in one templatized function. Now, just because we can use templatized functions doesn't mean there's no use for overloaded functions. In fact, in the next video, we're going to be talking about overloading a templatized function, and that's going to be pretty cool, so make sure you check that out. And if you've enjoyed this content, please consider subscribing to help out my channel. And now, check out that next video. Hey, what's going on everybody? Welcome back. This video, we're going to be talking about overloading templatized functions. Now, this is going to be a pretty cool video because this is where we're getting into some pretty juicy stuff. So this swap function will work for most basic types, but what if we wanted to create a swap function that was a little bit different? For example, if we wanted to swap all of the elements in 2 arrays. Well, this function here is not going to work. First off, you can't just assign an array to another array. So what I'm going to do is I'm going to create another version of swap that's also templatized, but this time it's going to be templatized to work with types of arrays rather than just plain types. So we're going to say template, type name T, void swap, and in here it's going to take A and B. Now we don't need to pass by reference because they're arrays and they will decay to pointers, so we can automatically alter the elements inside of these arrays. One thing though is I do need to put the square brackets to indicate that these are arrays. Sorry about that. And we'll also need the size of the arrays. So you can use n, you could use size, whatever you want. Now what we're going to do is within a for loop, we're going to swap each element. So we'll say int I equals 0, I is less than size, I++. Now individual elements are going to be swapped, so what type are these going to be? Well, they're actually going to be of type T, Because if you think, pretend we have an integer array, this would be an integer, so that would be the same thing. You would also create an integer down here. So the type here does not refer to integer arrays, it just refers to integers, and we're doing a collection of those using an array. Here's what we're going to do. We're going to say ttemp and assign that the value a of I, and then we're going to do a of I and assign that the value b of I, and then we're going to do b of I and assign that the value temp. So that should be it for swapping arrays, but now all we have to do is go through an example to see if it works. First, I'm going to compile, make sure I got all my syntax, and it seems to be good. Now let's go into the main. Here's what we're going to do. We're going to go to the bottom here, and we're going to create two arrays. One will be called nines, and this will be full of nines, which I guess would make sense. And let's say there is 1, 2, 3, 4, 5, 6 of them. Then let's do it again, but this time we're going to use ones. There we go. Now what I'm going to do is I'm going to output these arrays before and after the swap. So let's go through a for loop. Int I equals 0, I less than 6, I plus plus. And here's what we're going to output. We're going to output nines of I, a space, and then ones of I. Then I'm going to finish this off with a tab character to separate each group. And then when I'm done, I'm just going to output a couple new lines. Cool, so that is how we will output the arrays. And then what we're going to do is we're going to do the swap. We'll pass in nines, ones, and size 6. Now passing in this extra argument is essential, otherwise it's going to try to do this version of the swap because it takes 2 elements, which is not what we want. So if we don't pass in that 6, you'll see what I mean. When we compile, you can see it says int 6 is not assignable because it's trying to assign an array to another array, which is not allowed. So make sure you remember to pass in that size. And if you would like, you can make that a constant and then use that instead. So totally up to you, just giving you guys some options. There we go. So that should work just the same, and you can see it compiles. Now what I'm going to do is I'm going to do this exact same for loop, but after the swap. So it's going to look like that. Now let's compile and run. I forgot to put the backslash for the T, which is making the output all weird. Let's compile and run again. Now when we run this, the first time we get 9, 1, 9, 1, 9, 1, and so forth, and the second time around we get 1, 9, 1, 9, 1, 9. So it seems that the swap worked, and that's really cool because we only have one swap function name, but this is going to be 2 different templatized versions of the swap, so we just overloaded templatized swap functions. Very super cool and exciting, so hopefully that was helpful for you guys. Let me know if there's any questions, comments, concerns, or your favorite animal. Yeah, that's a question for the day, just for fun. Alright, now let's move on to the next video, and don't forget to subscribe.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. I'm betting that this is the video you've either been super excited for, pumped for, or the exact opposite, this is what you've been despising. So my goal here is to make this exciting because object-oriented programming is a huge piece of C++ and programming in general. So this video is going to be all about the introduction to object-oriented programming, and this is what we're going to be talking about in basically the next huge section of this series because it's a pretty big topic and it's essential, vitally important, so pay attention and try to have a little bit of fun. So if you have ever programmed in C, you probably know that it's kind of terrible, but that's besides the point. It is very cumbersome to develop in C. In C programming, there is no real concept of classes or object-oriented programming. Now they do have something known as structs, which kind of is a big piece of object-oriented programming in C++, similar concept in nature, and that definitely made C programming a little bit more doable. But for large-scale applications, it definitely helps to have a more structured object-oriented programming concept inside of a programming language, which C did not have and C++ introduced. And it really set the foundation for a lot of the other programming languages, Java, C#, and basically all the C-like programming languages all have the object-oriented programming component in them. So learning this stuff is not just for C++, it's for everything.
But the way you do it in C++ is definitely a little bit different than the way you would do it in C# or Java. So we're going to get into the specifics of C++ object-oriented programming. It's not just going to be general concepts that you could apply to anything. We're going to get really specific, so I'm excited, hope you guys are as well. So there's a lot of info about object-oriented programming, but I think one of the big struggles people have with it is the why. Why do you need object-oriented programming? And that's one of my big goals that I hope to basically explain to you guys. But first, before we get into the why, let's talk about the what. Object-oriented programming is based on the concept of classes and objects. Here we have a class, and we define a class in code. It basically defines a structure. It's the blueprint. It's the cookie cutter. And we can use that cookie cutter to make many instances, and these instances are known as objects, like so. So class is used to define an object. This is the structure. Think of this being like a user, and each object being a specific user. So we might have Caleb, Amy, and Sally, or whatever the names are, it doesn't really matter, just users. Now, why do we structure things this way? Well, because most applications we do are built around data. And data is a very general term that can mean anything, but usually our applications are data-driven applications. So we basically can describe data or real-life things using objects. If someone creates an account on our application or creates a user, then we can describe that as an object. It's basically a way to group information and keep things organized. So within one user, we can have the person's name, their email, and so forth, but it's all grouped within one object so it stays nice and organized. Another way you can think about object-oriented programming is a table. So no, not like a dinner table, we're talking like an Excel table or a database table. Usually we have columns. So we might have a column for their ID, their first name, and their last name. Well, these column headers, you can consider them to be the class. It defines the structure. And then each individual row is like an object. So this person might have the ID of 7, have the name Caleb, last name Curry, and then some other information. Here is one object. We can have another object with the ID of 8. This person can be Amy, last name White, and so forth. So once again, the columns are like the class defines the structure, and every time we create a new user, a new object, it's like adding a row. Now this might be a weird way to think about it, but that definitely helps me because I have a strong database background if you've watched any other of my videos. So if you've watched my database videos, maybe this is helpful for you guys. Or you might just want to go back to the cookie cutter example where a class is a cookie cutter, and every single cookie we make with that cookie cutter is an object. Alright, so what we're going to do now is we're just going to talk about some of the basic concepts of OOP, object-oriented programming, before we dive into each one in individual videos. So the first thing we're going to talk about is structs. Structs are very similar to classes, especially in C++, they're almost identical, but by convention, structs are used for smaller things, maybe coordinates that have an X and a Y, or a small piece of data, where classes are reserved for much larger things. So that's just a convention, but you can do it however you want. Once you understand structs, understanding classes is super easy, and vice versa. If you learn classes first, learning structs is very, very easy. 15 seconds max, it's almost identical. Other programming languages, that's not entirely, gross. Other programming languages, that's not entirely the case, where Onyx, quit gagging. Other programming languages, that might not be the case. Oh my gosh, I'm so annoyed. Are you okay? Other programming languages, that might not be the case. Gosh dang it. Other programming languages, that might not be the case. There might be a larger distinction between classes and structs, and that's fine. We're in C++, so I don't know why I keep talking about all these other languages, but it is helpful to know. The next thing we're going to be talking about is members of classes, which includes basically data members, which is like variables inside of a class, methods, and constructors, which we talked briefly about when we were talking about functions and methods in a couple videos ago. Then we're going to dive into encapsulation, which is one of the 3 big pieces of object-oriented programming. It's basically where we can hide the inner details of a class and just have basically a public interface for how to interact with this class. Or more appropriately, any instance of the class, how to work with an object.
Again, this will all be cleared up once we go into this in more detail. I just want to give you guys the overview if you have any OOP experience and you just want to know what we're going to be talking about. Next thing, we're going to talk about inheritance, which is where classes can inherit from other classes. And then lastly, we'll touch on polymorphism, where classes can be kind of interpreted as other classes, their parent classes. So that will be really cool, lots of useful stuff, and that'll basically cover all the main pieces of object-oriented programming, at least in the big side of things. And we'll get into some other stuff, but we're not going to super duper deep dive. This is just to get you started with object-oriented programming. We'll build some classes, build some objects, talk about inheritance, and we'll even get into some cooler stuff like operator overloading, friend functions probably, and some other stuff. So stay focused and stick with this content because it's going to get pretty cool. All right, that's all I got for you guys. Please be sure to subscribe and peace out. Check out the next video. Welcome to your C++ tutorial series. This video is dedicated to the concept of structs. Now, this is the first video where we're going to be talking about some details of object-oriented programming, but this is not specific to just structs. This will also apply to classes. So if classes are more what you're familiar with, don't worry, that's what we're going to get into as well in this video. Now this is the concept, this is the theory. In the upcoming video, we're going to create a struct and eventually we'll create a class. Fortunately, in C++, structs and classes are essentially the same thing. Alright, so in C++, a struct and a class will do the same thing. So they're both going to create an object. So the difference between a class and a struct is mainly conventional. They can be used to do the same exact thing, but people choose to use structs for generally smaller structures and classes for more larger structures. So you could use a struct to create basically the blueprint for a person, for example, and then very easily that can be converted to a class. So don't be caught up in struct versus class. I will show you the syntactical differences in this video and the upcoming videos. Very, very easy. So let's get into that. What is the difference syntactically between a class and a struct? Well, it has to do with what are known as access modifiers. When you create a class or a struct, the things inside of it are known as its members. So assume this box is a class or a struct. Well, these members will have access modifiers, and there's three possible options. We have public, private, and protected. Now, protected is really not going to come up until we talk about inheritance, so don't even worry about that right for now. Focus on public and private. The difference between public and private is that when we create an object from the class, the public members can be accessed on that object. The private members will not be visible and can only be accessed within that class definition. So when you are defining this box, you can work with those private members, but once we create an actual instance of this, so let's say this was a user, when we create a user such as user1, we can only now have access to the public members. It kind of makes sense in theory, but it definitely will make sense once we do the hands-on stuff in the next video. Protected is very similar to private, but it will extend down to any class or structure that inherits from it. So again, that's not going to make a whole lot of sense until we talk about inheritance, but protected will come up in the future. Now, the only difference when it comes to structs and classes is that structs, the members are by default public. So struct, with classes, they are by default private. Class. Public struct, private class. Now you can change the access modifiers for the members, but you have to specify that. So to do that, you would just say private and then put a colon, and then anything inside the class that comes after that private will have the private access modifier. So I'm pretty sure that is the only difference you have to worry about. Classes are by default private, structs are by default public. That's it. Other than that, everything is exactly the same. They're both passed by value, they both can contain methods and data members, they can both use inheritance. Pretty much everything is exactly the same. The end result is always going to be an object. So in C++, the difference between a struct and a class is very similar. They're very close together. The only difference is the default access modifier. In other languages, this distance is much farther. So if you're going from C++ to other languages, or you're coming to C++ from other languages, you might not be used to the idea that structs and classes are very similar. You might expect them to be very different. For example, in C#, structs are value types, classes are reference types. C++, they're the same thing essentially. Other languages, not so much. So do keep that in mind. Now, by convention, structs inside of C++, people will often use them for plain old data structs, so pods. And what that means is, by convention, they are only really used to contain data members, meaning variables. So inside of that struct definition, you can put variables such as int x, but you can also put methods. But in general, you will try to avoid any kind of functionality inside of a struct and just use it to store data such as a coordinate x or a coordinate y. Very simple, variable-based things. So that is what pods stands for. You might see that when you're doing research on the internet. That's purely a convention thing, and I would recommend adhering to that. So the next video, we are going to create a struct, we're going to instantiate it into an object, and then in the upcoming videos, we're going to take that and basically convert it to classes and add more juice and substance to it. So it should be pretty fun. I'm really excited. Hopefully you guys are as well. Please be sure to subscribe if you've enjoyed the content, and I'll see you in the next video. Peace out.
Hey, what's going on everybody? This video is where we start getting hands-on with object-oriented programming. We're going to create our own struct in this video. Now, when it comes to file structure, I've been kind of tinkering with the files, so maybe I lost track of where you guys are, but basically I'm starting from scratch in this OOP folder, and then I have this main.cpp, and this is all we have. So you should be able to get to this point pretty quickly, and then we can work together on building some complex applications. Creating a struct is pretty easy, and to start with, it's easiest if you just do it all in one file. So all of our code is going to go in this main.cpp, and then later on you can branch this out into multiple files if that helps for organization structures. But for simple applications, there's no need in making it extra complicated, so we're just going to do it right here. To create a struct, all you do is say struct, and you give it a name. Now by convention, I use a capital letter here. All of my custom types, I start with a capital letter. Now we can put our data members inside of this struct. So what does each user need to have? So for example, we can create a string variable called first name, maybe another one last name, and then let's say we have another one status. And when you're done with the struct, I always forget to do this every single time. You have to put a semicolon to end the struct. At least this time I remembered before compiling it, so I'm making progress. Now this is defining the structure. It's like defining the columns of a table, and each user is going to give a value for first name, last name, and status. We don't assign the values here inside of the struct, although it is possible to give default values. In general, we will want to do this on a case-by-case basis, and to do that we need to create an instance of this struct, aka an object, like so. We say user, and then we give it a name. In this case, we use the same word, but this one has a lowercase. Or if that's confusing to you, you can use something else, such as me. That's what I'll go with in this video, and then all you have to do is say me.firstname, and you can assign it a value. And then just do that for all of the data members. And there you go. That is how you create a struct, and then instantiate the struct and assign values to the data members. We can access these values the same way we did here. For example, you can say me.firstname and output that here. So now let's compile. And we didn't get any errors, so we're doing pretty good. And then when we output this, let's see what we get. We get first name is Caleb. Now this first name here can be accessed because its access modifier is public. By default, things inside of structs are public. We can change this by defining something as private, like so. We just put the private keyword, and then generally we'll indent everything after the private keyword. Now when we compile, we're getting an issue. That's because we're trying to set the value of status, but we can't because it's private. When something is labeled as private, we're not able to access it from the object. So if it's private and we can't access it from the object, when would we ever use it? Well, oftentimes we'll have methods inside of here that will need to access this private data. It's basically a way for us to store information without exposing it to the public world through public access through an object. And that'll make a little bit more sense once we start talking about objects and methods. For now, structs are usually just to contain data. So that means variables of a particular type They're usually not for methods. Oftentimes, people will switch from a struct to a class once they start wanting to use methods. But just for giggles, let's put a method in here just to get a feel for how that works. Now, do we want this to be after the status, or do we want it to be up here? Well, we actually want it to be up here because we don't want it to be private. So you can define it here, or you can define it after the variables. That's totally up to you. All you have to do is say what the return type is, the name of the function. We'll just call it getStatus if I can type. And then all we're going to do is say return status. And here you can see the use of private variables. We can access that private variable here, and that's totally fine because we are still within the struct definition. So status is accessible here inside of these curly braces, but it's not accessible down here outside of those curly braces. This is not going to work, so we're just going to get rid of that line. Now, to use this method, all you have to do is on a particular object, just put a dot and then put the function name, so getStatus. For example, instead of saying me first name, we could say me.getStatus. Now this ain't gonna do much because status doesn't currently have a value. So when we run this, you can see it just has a blank, and we should probably change first name to status. Now it just says status and it's blank. You can assign a default value to this up here. For example, we could say the default is gold. Now when we compile and run, we should get gold. Looks like we got a little error because the inline assignment is actually reserved for C++11. So what we want to do is just say standard equals C++11. And there we go, now we can run, and voila, status is gold. So that is your introduction to creating structs. We just covered the bare basic minimum. Once we get into classes, we're going to get into a little bit more detail, some of the different things you can do. But for now, you understand data members and you understand methods. And you have a little bit of a feel for access modifiers, specifically the difference between public things and private things. So thank you guys for watching. Be sure to check out the next video because we're going to start talking about classes and objects. Structs are similar to classes in that they will also produce objects, so there's not a huge difference. It should be a pretty easy learning curve. So go check that out and have some fun. I'll see you guys in the next video, and please be sure to subscribe.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. Now, if you're watching this video, you've probably gotten here from one of two ways. One, you've been watching this series from the beginning as a good boy or girl, or two, you're searching stuff about object-oriented programming in C++ because you probably weren't paying attention in class or you're failing at work, and now you need me to redeem you and save your soul. Well, that's what I'm going to try and do, but this video is going to be some review from what we talked about in previous videos. So if you have been watching the series all the way through, you can watch it if you're struggling, or you can just jump to the next video. We're going to talk about classes and objects very similar to structs, so a lot of the same material, very similar in nature. Now, when I was just a little boy many years ago, I was talking to my neighbor, and at the time I was studying addition in school. And I was kind of getting it. I was struggling, but you know, I figured out how to do it. You know, you could add these things together, basically represent how many of things you had. But he was saying how he was learning multiplication. Now, when he said this, I was upset. I was bitter because I knew as soon as I finished learning about this addition junk, I was going to have to figure out multiplication. And I was like, when are we ever going to use this multiplication junk in real life? Seems like a pretty silly story, especially now looking back, I understand the value of multiplication. Well, object-oriented programming is very similar in nature. When you're learning it for the first time, you're like, ugh, what the crap is all this complexity useful for? Why do I need all this junk? But as you look back, once you understand object-oriented programming, you're thankful you put the time in to understand it. So the moral of the story is to stick with it, stay with it, because object-oriented programming can kind of be a pain in the butt when you're first learning it, but it is extremely valuable, and I'm going to do what I can to make it nice and simple. So this video is going to go over some concepts, and then in the next video we are going to go hands-on coding some stuff on the computer. So if you need some hands-on practice, check out the following video as well. And now, after all that blabbering, let's finally get into the concepts. Let's get started. The first thing you need to understand, what is a class? Well, a class basically defines the structure or the shape of some data. So think of it as like a cookie cutter. Am I drawing Patrick or something? Okay, let me try this again. Let's do a tree. All right, so we made this beautiful cookie cutter, and you can use this to cut cookies. And the cookies that you create with the cookie cutter are known as objects. So here's a cookie, it kind of resembles a tree, and here's another cookie.
This one didn't quite turn out quite as nice, and so forth. So the process of going from a class to objects is known as instantiation. It's a pretty cool word. You can use it at the local hangout spot to pick up chicks. Just start talking about classes and objects and instantiation, and you'll be like the ladies' man, all right, trust me. Now this is kind of a silly example with cookies, but let's make it a little bit more concrete. Let's say we're trying to describe a user for our application we're building. So we would create a class such as user with a capital U. That's by convention. You can use a lowercase u if you want, but don't do that. And then the objects you can name them whatever you want because they're essentially variables. So you could say, we're going to create a variable called user with a lowercase u, and let's just call it user 1 and 2. And I prefixed it with user because this is the type. So when you create a class, you're essentially building a new type. What? Yeah, that's right. So when you do something like int x or string y, these are all examples of types. Well, we just created our own. It's called a user. So we could say user z. And we can create functions that take that custom type or return that type. We can build vectors of this type. We can treat it as if it's any other type, and that type's functionality is defined by the class. Now I wanted to throw something out there. If you're coming from another programming language, you might see the keyword new. So you might see something like this, like so. And this is very common in other programming languages, but this is not the C++ way of doing it. No, you don't do this. You don't do the right half. In these other languages, this is the way to call the constructor and create a new user, but you don't do that in C++. When you just leave it as this, it'll automatically call that constructor and make a new user. Which brings me into constructors. What the crap is a constructor? It's just a special function that's going to give us a new user. So inside of our class definition, we have a special function that has the same name as the class, and what it's going to do is it's going to create a new user and make sure its state is appropriate. So we can set the person's name, we can set their email or whatever inside of this function. So that's going to be called every single time a new user is instantiated. It's a special example of a method, which are just functions attached to objects. So we can create other functions on here like speak, like as if it's a dog or something, but whatever. You can say speak, or you could say jump, or whatever you might want it to be. So those are methods, but you can also just have data members. So for example, you could have a string called name, and that can be used to store data, the person's name. Now a really cool thing you can do is operator overloading. For example, if you do 5 and then do the comparison operator with 5, this makes sense because 5 equals 5 is true. It makes sense to us logically. But what about this? What if we wanted to compare user 1 to user 2? Now it doesn't really make so much sense. But what we can do is we could actually overload this operator to basically describe how to compare users. So we can basically make our type work as if it's any other type and define that functionality. So we might be able to say, hey, these two are equal if they have the same first and last name, or if they have the same email. Whatever you want it to be, it's totally up to you. That's just one operator overload that I've talked about, but you can also overload the plus operator, or any other operator you might know of. So that's what we're also going to be getting into. It's very, very cool and very important. And the last thing I wanted to talk about is static members. Static members are not associated with each object, but instead describe the class in general. So if we wanted to have something that described all of the users, we could label it as static, and it would stay associated with the class. So for example, you could have number of users. So and then anytime a user was created, we could increase that, and anytime a user was destroyed, we could decrease that. Kind of think of it like if you had a cookie cutter and etched on the side of it how many times you made a cookie. That would essentially be a static member because it's tied with the cookie cutter, the class. So yeah, this is very conceptual content, but hopefully in the next video we can make this concrete by going through some examples. Now, if you watch the videos on structs, this is probably me saying the same thing for the 5th time, but structs and classes are very similar. but by convention we'll use classes for things that are more complex and structs for things that are very simple. So generally, if you're going to use methods, you would use a class. If it's just some simple data, you can use a struct. So now that we've talked a little bit about the convention between structs and classes, let's go into the next video and create a class and give it some features that might be unique to classes, something you would see with classes, specifically methods and getters and setters and stuff like that. That's what we're going to be getting into here soon, so check out the next video and please be sure to subscribe if this video helped you out. And let me know if there's ever been a situation where at the time you thought something was completely useless, but looking back you're thankful you paid attention and learned it, such as multiplication. Alright, thank you guys, I'll see you in the next video. Peace!
Alright, welcome back. This video we're going to be talking about creating classes. Now, in my personal recommendation, I'd check out the video on structs because classes are going to be extremely similar. In fact, we're not even going to start from scratch. We're going to take this struct and kind of morph it into a class because it's so similar. Now, when it comes to creating classes, here's what you need to do. You need to change this struct keyword to class, and anything that is labeled private, it's automatically going to be private in a class, so you don't need that private keyword. But what you do need is anything that was originally public, you need to label those as public. So what I tend to do is I usually take the private stuff, put it up top, and then I'll label the rest as public, like so. And then just indent it. So that is how you would morph a struct into a class. All you gotta do is change what was once implicitly public and make it explicitly public by labeling it public, and anything that was once explicitly private, you can just let it implicitly be defined as private up at the top. So it's just a little change of words, a little bit of flipping things around, and that's pretty much it. So that is our class. So now I have a class that can be used to create users. And if you're just jumping in and you didn't watch the video on structs, let's just go through the pieces of this. These are known as data members. They're just variables inside of our class. The ones that are private cannot be accessed when you create an object. So for example, this me object, there's no way for this me object to access this status member. So the object can't access the private members directly, but maybe they can indirectly by exposing them through methods. So for example, this status is being exposed through this getStatus method, and we can call that from the object because it's labeled public. So if we go down here, we look at our code, we have me.getStatus, and we should be able to compile and see the output of that. When we run this, you can see the status is gold because it's getting a default value assigned to it directly. Now this is a pretty basic class, it doesn't really do a whole lot, and there are a lot of design techniques and design patterns when it comes to building classes and doing object-oriented programming. This is far from a beautiful, sexy class, but it does get the job done and allows us to basically encapsulate different variables inside of a particular object. So rather than having separate variables for all of this information, we're able to hide that all within one object called me. And anytime we can scope a variable to something, whether that's an object or a namespace, that's really good because it doesn't pollute the entire environment that it's defined in. So that was a pretty simple video. Hopefully it makes it clear the difference between structs and classes when it comes to syntax. Check out the next video because we're going to get some practice working with objects and it should be pretty fun. So be sure to subscribe and I'll see you in the next video. Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be real nice and simple. I just wanted to give you guys a little bit more practice working with objects. So specifically, I just want to make sure that it's clear that when you create a class and you instantiate it into an object, you basically have an entity of this type we created, in this case, user. So we're defining a custom type when we create a class, and you can use it as if it's any other typed variable. So we can create a collection such as a vector using it, or we can pass it as arguments or return it from functions and so forth. So it shouldn't be too complicated, it should be pretty simple, and let's just get to it. All right, so here's what we're gonna do. We created this user class first thing, so make sure you got that. And then inside a main, we're going to create a user, just like that. And you can assign stuff to the data members of this very easily, and nothing too crazy. But you can actually create a vector of these users. So this is going to be of type user, and then you could just call it users. Now when you're using vectors, you need to make sure at the top you include vector, so make sure you type that out. I always forget to do that, but I did it ahead of time for this one, so I'm ahead of the game. Now what you can actually do is you can add this user that we just created to this vector. So you can say users.pushback and pass in user. Then what we can do is we can access that as if it was any other element inside of this vector. So we could say users, and then index 0, and then we can access the members. So we could say first name. So this should output Caleb. Make sure you're compiling with C++11, and when you get the output, you should get Caleb. Cool, so that's one way you can add people to vectors. Another thing you can do is just call the constructor directly. So that would look like this. You might see that, and basically what's going on here is we're creating a user inline, so this is a different user than the one we have here. This is going to instantiate it to the default state because we're just calling the basic constructor here. So it's just going to have a blank first name. So when we compile and run, it's not going to output anything, it's just going to be an empty string. Now just to get a little bit more practice, we're going to create a function, and basically what I want it to do is I want it to insert a user into this vector, but only if that user doesn't already exist in the vector. So it's basically a way to enforce uniqueness within this vector. So let's just jump in, let's call it add user if not exist. It's kind of a long function name, but it's very clear what's going on here. And we'll talk about the return here in a second, but for now, let's just make it an integer. And what are the parameters going to be? Well, we're going to pass in the vector, and that's going to be of type user, so just like the type we defined down here, and we can call it the same name if we want, and we can pass it as reference. That way we can change this vector. Otherwise, we're not going to be able to add a user to the vector and see it outside of the function itself. If we want to be able to see the users that have been added down here, then we'll want to make sure we pass as a reference. The other thing we're going to take is a user, like so. So it's a variable with the name user of type user. And here's what we're going to do. We're going to do a for loop and basically iterate through each of the elements inside of users and see if any of them have the same data as this one here. So int I equals 0, I less than users dot size, I++. Now we can do a comparison, and if they match, then here's what we're going to do. We're just going to return the index of that user. So we'll just return I. So then in main, we can reference that index to grab that element. Now, if it goes through the entire vector and no user is found that matches the data, then here's what we're going to do. We're going to push back and add that user to the vector. So we'll say users.pushback, and we're going to pass in that user. And then for the return, all we have to do is pass in the length of the vector -1. So we could just say return users.size -1. That'll give the index of the element we just added, which is exactly what we want if we're adding it to the end of the vector. All right, cool. The only thing here is the match. We need to figure that out. So how do you compare to see if these things are matched? Well, there's lots of different ways you could do this, and it really comes down to what you want to do. So what I'm going to say is if the users have the same first and last name, I'm going to consider them the same entity, and then I will just return the one that already exists. So what I'm going to do is I'm going to say users of I dot first name equal to user dot first name, and users of I last name is equal to user dot last name. So if this user has the same first and last name as this user right here, then they are considered a match, and then we'll return the one that already exists. All right, so that should work. Now let's just compile, make sure we don't have any syntax errors. We don't. Now let's do some testing in main just to make sure it works. Let's get rid of this here, and what we're going to do is we're just going to create 3 users. So we'll say user, user1, user2, user3. This also shows you can create 3 of them on the same line, and that's perfectly legal. All right, so I just gave data to each one of these users, user 1, 2, and 3. And now what we're going to do is we're going to basically create another user, which will be the one we want to add to this vector. But before we do that, let's add each one of these to the vector. We'll just say users.pushback and put each one of these in here. Now let's create a new user. We'll just use the name user, which actually hasn't been used because we just have 1, 2, and 3 attached to each of them. So this one should be fine. And then what we're going to do is let's make the first and last name Jake and Johnson. All right, so there we set up the data, and now what we want to do is we want to call that function. Let's just make sure we get the name right. It is add user if not exists. Add user if not exists, and we're going to pass in user, and as well we're going to pass in the vector users. Now this should return an index, so let's just output it. Now let's compile and run and see what we get. All right, we run and we get 2. Let's scroll up a little bit. So the reason we're getting a 2 is because we're actually passing in an empty user here to the pushback method, which I did earlier. We actually don't want to do that because that's going to mess up our results. I really just want 3 users, this one being index 0, index 1, and index 2. So the result that should be returned is 1 because this has a match to the user down here. So let's compile and run and make sure we get 1 as a result. And we do. Now if it's a situation where they do not match,
let's say we have Jacob, it'll add that element and return its index, which should be 0, 1, 2, 3. So if we input it now, we should get the value 3. And indeed we do. Now at this point, the vector should be changed. So from this point on, that vector size is going to be 4. So if we say users.size, let's just make sure that the value is indeed 4. When we run and output, you see we get the value 4. Awesome. So that's just a little bit more practice with objects. There's all kinds of stuff you can do with it, and this is just a very specific example. Maybe it's helpful, maybe not, but as long as we got some more practice, I think that's good. And now I think you're probably ready, assuming you understand all this stuff so far, to move on to the next section where we're going to talk about constructors. We talked a little bit about them when we talked about functions, but now we're going to talk about how to create them and the different types of constructors and so forth. So check out the next video, it should be a lot of fun, and be sure to subscribe.
Hey, what's going on everybody? Welcome back. This video we are going to talk about the concept of constructors. Now if you've been following along, you probably know what a constructor is, but we really haven't used them a whole lot. A constructor is a special method that is called when a class is instantiated into an object. So in the example of a user, when we create a specific user such as user1, there will be a method call to the constructor defined inside of this class. Now here's the thing, when you create a class such as user, you don't have to create the constructor function, but somehow you can still make a user. So how does that work exactly? Well, the constructor is actually created implicitly, meaning we don't actually have to explicitly type it out. It'll automatically be created for us. So that's pretty cool, but the implicitly defined constructor does the absolute bare minimum required to create a new user. What that means, if we want to do anything extra, we need to explicitly create that method and type out exactly what we want the constructor to do. So when you create a constructor, it's just a method, but there's two special things about it. One is it's the exact same name as the class, and two, it has no return or return type. So the method would literally look like this, and then the code would go in here. So note, same exact name here, and we do not prefix it with a return type. That is how you distinguish the constructor from the other methods in the class. The default constructor is the one with no arguments here, meaning when you say user1, this is the constructor that gets called. There is the option to make custom constructors that take parameters. So in that situation, you can actually change the calling, and instead of just doing the default constructor, we can call a different constructor. So it allows us to basically instantiate our user in different ways. For example, we can pass in the person's name here, and you can see in this situation we have two arguments, Caleb the first name and Curry the last name. In this situation, the default constructor would not be hit, a different constructor would be hit, one that would look like this. In this situation, I just called first name F and last name L just because I was running out of space, but this is a real possible constructor that we could create, and then inside of our code, we can take these parameters and assign them to the class's members. So the class could have members such as first name and last name. So we could do that in here. We could say first name will be assigned the value F, and we could do it again. Last name would be assigned the value L. Now here is the thing you need to realize and understand. The implicitly defined default constructor will only happen if we do not define any other constructors ourselves. And this is weird, but it makes sense. Because imagine I wanted to create a class where you had to call a custom constructor. Well, if they always created this default constructor implicitly, then there would be no way to enforce that. So if I want to enforce that, all I have to do is create the custom constructor and then do not create the default constructor manually. So in this situation, if this was all the code we had, we would only be able to instantiate a user by passing in their first name and last name. So it's a way to basically force required things to be passed in by only having constructors that take arguments. If I wanted the default constructor, which would basically not require us to pass in a first name and last name, I would need to define that explicitly myself by typing it out like so. And then I could do whatever I wanted in there. Now the only other thing is the destructor, very similar to the constructor, but it's called when the object is destroyed. That's going to happen automatically. We don't have to worry about destroying the object manually,
but we can, if we want, create a custom destructor. It will also be created implicitly similar to the default constructor, but the destructor we usually have to worry a lot less about. But there might be a situation when you might want to override it to do an output or some logging or to clean something up. In that situation, you do exactly the same thing as the constructor, but you prefix it with a tilde, squiggly, what are they called? With a squiggly thingy. And then you just put the class name and the parentheses and the curly braces. And then the code for the destructor goes in here. That'll be called, and if you want to see that, you could put cout destroyed, and then every time you create an object and it's destroyed, it would call the destructor and do some output. So I'd encourage you to give that a try, and that, my friends, is your introduction to constructors. Hopefully that was nice and handy, and in the upcoming videos we're going to get some hands-on practice, so go check that out, and please be sure to subscribe if you enjoy this content. But if you hate my content, don't subscribe, alright? Because I want subscribers that actually watch my content, because that's important to me, right? So yeah, be sure to subscribe, and I'll see you in the next video.
Hey, what's going on, everybody? Welcome back to your C++ tutorial series. This video, we're going to talk all about constructors. Now, a constructor is a special function that is called when a class is instantiated. So, when we go down to our main function, you can see I am creating some new users here. When we do this, that method is being called. Now, there's no obvious output because the function doesn't really do a whole lot, but we can explicitly define it and tell it to do whatever we want. So if we go into our class definition, inside of the public section, we're going to create a new function, no return type, and it has the same exact name as the class. So in this case, it's going to be user. And what we can do is we can just output constructor. So every single time this method is hit, it'll output constructor, and we'll be able to see when it's happening. So let's compile and run. And we get a couple calls to constructor. It looks like 4 of them. Well, looking at our code, each time we create a new user here, it is called, and then down at the bottom, we're creating another user, so it's called there as well. So this is what is known as the default constructor because it has no parameters. We can create additional constructors that take parameters. So for example, we can take ones that take the first name and last name. We can use this constructor to make sure the object is instantiated properly and in full. So specifically, we can pass in the first name and last name here, and we can assign it to the data members up here. So that way we know that as soon as the user is created, it has a first name and a last name. So to do this, we have a little issue. You can see that this has the same exact name as the parameter. So if you want to specify this one, you can do it with the this keyword, and that's going to look like this. Then you're going to draw a little arrow and then say first name and assign it the value first name. Then we do that again for last name. So this one here refers to the first name of the object. This one here refers to the argument being passed in, and you can see it highlighted a little bit there if you look really closely. So now when we create a user, here's what we can do. Inside of our code, let me just clean some of this up. We can say user and pass in some values such as Caleb and Curry. And when we compile, it looks like I have one little issue. Let me go back up to our method, and we just need to add a semicolon right there. Now, when we compile, we should be able to immediately output that value once the application is ran, and you can see we get Caleb. So going back to our class, we have the option to get rid of the default constructor, and in this situation, it's not going to implicitly create it. So that means if I go back in our code and I say user me, and I don't use any parentheses and pass in the arguments, we're going to get an error. And you can see candidate constructor was not viable. Requires 2 arguments, but 0 were provided. So if you want to get rid of the default constructor, that is the proper way to do it. So constructors allow us to initialize objects with particular values. So that's one way we can do that. Another way is inside of the class definition, we can assign default values here in line. When should you use which? Well, if you're wanting to assign values on a case-by-case basis, you will want to use the constructor. Constructors are also a way for us to set the initial state for some of these private data members. So for example, in here, I could take the status, and we can assign that to this object. All right, now let's go back to our code, and we're going to change this call here, and we're going to pass in silver. Now when you output user.getStatus, it should output silver. Oops, make sure we add those parentheses there because it's a function call. Now when we run this, you can see we get silver, but we're not able to access status directly. So when we say user.status, no matter how we use that, that's going to cause an error.
So if we try to output that, it's not going to work. All right, so that is your basics of constructors. Now I'm going to mention briefly destructors. So here's what I'm going to do. I'm going to scroll up to our class, and I'm going to minimize this function because it's driving me crazy. And we're going to say user, but we're going to preface it with a squiggly. And here is the constructor. We can output destructor. And you can see when we run this application, it's going to call the destructor and output that automatically. So if you need to do something special inside the destructor, that is how you would do that. So thank you guys for watching. That's your introduction to constructors and destructors. Hopefully it gave you what you need to know, and of course I'll see you all in the next video where we're going to talk about encapsulation. So that's going to be pretty cool. See you then.
What is going on, everybody? Welcome back. I'm really excited for this video. It is going to be the video dedicated to the concept of encapsulation, which is one of the three big pieces of object-oriented programming. We have encapsulation, inheritance, and polymorphism. We're going to get into all three of these, but we're going to start with the basics, which is encapsulation. And I've challenged myself to keep this video nice and simple, short and to the point, because I don't want this to become an overcomplicated concept. Overall, it's very simple and very easy to understand, so I'll try my best not to get into the weeds of things and make it more complicated than it has to be. The whole idea behind encapsulation is that you do not need to expose all the inner details of a class to the public world, meaning you can have stuff that's private that still affects how the class functions, but outside of the class structure, you don't have to see that stuff. A good real-world example of this is a car. And to keep this nice and simple, I'm going to even draw pictures for you guys. Wow, am I awesome or what? One day, maybe you guys can be as awesome as me, but it's going to take lots of practice. And don't even think that you can beat me at drawing, because I'm pretty much the best. Alright, so here we have this super hot sports car. It's flying down the street, and this has nothing to do with encapsulation right now, so let's just get to the point. Inside of this car, we have an engine and a bunch of inner workings and other car stuff that I probably don't understand. And we have in here a driver. So the driver does not need to understand all of the details about the car stuff. All the driver has to worry about is how to use the car. Think of the steering wheel and the pedal as like the public interface of using this car. So draw a wall here. We have the driver, and then we have the car stuff. So the engine and all that good stuff. Now the only thing the driver needs to worry about is a few things that are exposed. The steering wheel, the pedal, and blinkers and a couple of other things. So you can think of it as an interface. They agree to communicate using these tools, the steering wheel and all that stuff. Now the inner workings, the car stuff, that can be swapped out. You could switch the engine with a different type, you could turbo it, whatever you want to do to make it more beefy, more cool of a car. So the inner details of the car are hidden. This is the idea behind an abstraction. We basically abstracted away the inner details, and all you have to worry about are a couple things here and there. So the two big things with encapsulation are one, an abstraction, which we just talked about. You don't have to know all the inner workings to use a class. The other thing is the other thing is control. The second thing is control. We can control what people who are using our class can see and what they can do with our class. So we want to stay in control. Control is good in programming. The reason we want control is not only to take over the world, but also just to ensure that people using our class are using it in a proper way. They don't need to understand all of the details. Think about it. If everybody had to understand all of the details to drive a car, they had to understand all the intricate, detailed parts of the engine, nobody would be driving. It'd be too complicated for the general user to accept. Same with classes. We want to make our classes very simple to the public eye. We achieve encapsulation in two ways. One is with access modifiers, which we talked about. That's how we can label certain things public, protected, or private. The other way is through getters and setters, which we'll be going through an example of those in the upcoming video. But this is basically methods that'll give us fine-tuned control of how our private data members are being accessed. So let's say we have some data member, and we don't want just anybody going in here and tinkering with the status, setting it to whatever they want. We want to be able to control what values go in here and how this value is presented. That is the appropriate thing to do to make our class user-friendly. So what we do is we have a getter and a setter.
The getter will allow us to get that value, and it makes sure that it's presented in the right way. The setter will allow us to set that value and will ensure we're setting it to an appropriate value in the right way. So for example, we can make sure any value we're assigning to status is an appropriate status value. You know, maybe these possible values are bronze, silver, or gold, or registered or unregistered. Whatever it might be, we can control that inside of the setter. When it comes to the getter, we can change how the thing is presented. So maybe internally, status is represented as a 0 or a 1. But after the getter is executed, it is presented as unregistered or registered. So these are functions, and we can call them. Now the getter is going to return whatever type this is. So let's say it will return a string. The setter will take a string to set the status, like so. In the upcoming video, we're going to go through an example of creating getters and setters. It'll be nice and simple. Now, do you always have to use getters and setters? No, you do not. It's usually just if we need really strong control over a particular data element. It's very easy to pollute our classes with a bunch of unnecessary methods that don't really help us a whole lot. So my methodology is keep it simple, stupid, KISS. Don't make it complicated, don't make it more than it has to be. So that's all I got for encapsulation. Hopefully that was nice and juicy, and in the next video we're gonna get some hands-on practice, so go check that out, and peace out.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be all about getters and setters, which is the C++ way of doing encapsulation. So when it comes to getters and setters, all they really are functions that will allow us to have access to private data members of a class. For example, we had this getStatus method which will return the status. The method itself is public. You can see that it's within the public section, but the status data member is private. The method will have access to status because it's defined within the class scope, these curly braces right here. But when you try to access status directly outside of this class, such as when we define a user, it's not going to work because it's private. So this is a getter. Now let me show you what a very simple setter would look like. The setter is going to be void, and it's going to be called setStatus. And it's going to take an argument, which is going to be the status we want to set it to. So we'll say string status. Now because this is named the same thing as this private data member, then we need to figure out how to distinguish them. And I think I mentioned earlier that you can use this with an arrow to refer to the data member and then say status and assign it the value of the argument passed in, whatever this parameter has the value of, which would be status. Now you may hear me say that getters and setters are special functions designed for encapsulation, but that's not entirely true. Although they are used for encapsulation, there's nothing special about them. They're just normal functions that are attached to a class. They're just methods. You don't have to say getter or setter anywhere. Even this get and set is totally optional. It's just by convention that we're putting that there. The main thing that you need to understand is that methods defined inside of the class can access the private members, but you cannot access the private members when you try to access them directly through an object. Now, just as a side note, other programming languages might have the concept of what's known as a property, which is very similar to a data member and very similar to getters and setters, but they're kind of combined into one, and it's basically a way to enforce encapsulation without having to create two functions. Although C++ does not have that kind of thing, this is the way you would do that, and if you ever go to other programming languages, you might run into that. So properties are kind of like a replacement for getters and setters. Just throwing that out there in case you ever run into it in your future programming adventures. Now, of course, this is really not adding anything, because if you look at it, it's just going to return the status and allow us to set the status. So it doesn't add any extra capabilities. If we didn't want to create these functions, we could create the status here. Just like that. And then we could just comment this out and comment these functions out. And our code should compile the same. We have one issue because we're calling that getStatus method. But now we should be able to compile just the same as long as we use the C++11 extension. So you can see I compiled my application, and now we're in the situation where we could access that status directly. We don't have to call these functions, and it works exactly the same way. So you might be wondering, what in the world is the purpose of these getStatus and setStatus functions? Why would we do that when we could just put it as a public member and access it directly? Well, that's the whole idea behind encapsulation, is that whatever is happening behind the scenes, we don't necessarily have to expose that to the public. In this situation, nothing is happening behind the scenes, so it doesn't add any value. But if we would like, we can change the functionality of these functions to make them a little bit more useful. So let's back it up, put this back as a private member, and now let's modify the functions just a little bit. Alright, so this is back as a private member, and what we can do is we can say inside of the set status, we could make sure that we set it to either gold, silver, bronze, or maybe invalid or undetermined or something like that. So we can do an if statement in here and say if status is equal to gold, then what we can do is we can set that status. But not only do we want it to be gold, but we also want to allow silver and bronze. Now if status has any of these values, it'll allow us to assign it to this data member. Otherwise, we can assign it something else. We'd say this status has the value no status. Alright, now let's give it a try. Inside of our main function, here's what we're going to do. We're going to create a user, and let's make sure we're calling the right constructor. So let's just look up here. Again, we have a constructor here which takes all three of those arguments, and then let's just create the default constructor that we're going to use. So let's just use the default constructor for this. So back in main, let's just get rid of all this stuff and just use the default one. We don't even need those parentheses there. Now what I'm going to do is call user.setStatus, and I'm going to pass in the value tacos, which is the best status, the elite status. And then inside of this, we're going to call getStatus and see what we get. Whoops, I accidentally did an assignment operator. I did not want to do that. We want to do the comparison. All right, now let's go back and we'll compile. All right, now let's run it. And you can see we have no status. So that is how we basically control access to that data member. We're not just going to let people assign whatever they want to it. We're going to make sure they assign something that's appropriate. You can do the same thing with the getter. So you could make it say, hey, if the status is gold, make it be displayed as G, or whatever. You can basically modify the way it's presented. Now, if you're just developing an application by yourself, why would this add value? Well, it wouldn't add a lot of value because you're probably going to make sure that you're going to put the right values in there. But as you get into a more complicated application, it's easier to forget standards and make mistakes. And especially if you're working with other people, then they might not know the exact correct values. And instead of putting silver in here, you might put S. And that might not be a valid value and it might throw off your program. So you just want to do this as an extra layer of protection to enforce that your class is being used correctly. So that is your introduction to getters and setters. Hopefully it was helpful. We didn't get into a ton, but let me tell you, the getters and setters can be an essential part to making your class effective and useful. One other thing I'd like to add is that we are using the same name for the parameter here and the data member. You may see that the data members that are private have some kind of prefix, maybe an underscore or something like that. If you want to do that, that's totally up to you, but I'm just going to keep them the same because it's cleaner for me. So now when I look at this, I know clearly which one's part of the class and which one is the parameter. So it's up to you guys, but that's all I got for you. And please be sure to subscribe and check out the next video. All right, peace out. Hey, what's going on everyone? Welcome back to C++ tutorial series. This video, we are going to talk about the keyword static. We're going to be creating some static data members, talk about how they work, and just get a little bit of practice with that. So when you create a member that is static, it's no longer going to be associated with each object, it's going to be associated with the class. So what data should be static? Usually stuff that describes the entire population rather than each individual entity. So one common example is you might want to keep track of how many users are in existence. Well, we can easily do that with some static data members. The reason they would be static is because each individual user doesn't need to have that information. It's rather describing the entire user population, so it should be associated with the class instead. So there's always going to be one class, but there's going to be many objects. So make sure you organize this in the appropriate way. Now here's a couple things you need to know. When you label a data member as static, you can only access other static members. The other thing is that static members can still be both public and private. So it works just like any other data member, you just can't use them to access non-static data members. And you'll see what I mean here in a moment. So here's what we're going to do. We're going to create a new private data member and we are going to call it user count. So this will be an integer And the way you basically make this static is you just prefix it with the static keyword. Nice and simple. Now what we can do is we can create a static method, which works the same way. It's just going to be associated with class user that can access this data here. So going down here, let's just find a good spot for it. Let's put the static ones at the top. That's what I'm going to do. So we're going to say static int get user count. And all this is going to do is say return user count. And let's compile. No errors, so our syntax looks good. Now let me explain what I meant about only accessing other static members. If I said, for example, return first name, well, this doesn't really make sense because the entire user population does not have one first name. So when I compile this, we should get an error. And you can see we did. Invalid use of member first name in static member function. So in order to do that, first name would have to be labeled static. But fortunately, we're not trying to do that. We're just using user count, so we should be good to go. Now, how exactly do we increase or decrease the value of user count? Well, the easiest way I can think of doing this is in the constructor and the destructor. Again, the constructor is called every time a user is created, and a destructor is called every time a user is destroyed. So let's find those constructors. I believe I created them earlier. So we have one right here, the default one. I'm going to put one in there, so all you have to do is say user count plus plus. So every time a user is created using the default constructor, this will happen. And then we have to do it again in this other constructor because that might be called sometimes as well. So we'll say user count plus plus. Now, one other thing is the destructor. So inside of the destructor, we can say user count minus minus, and that'll decrement user count. So this seems to work, but as you can see in the terminal, things aren't going so well. And that's because you have to actually assign a value to user count. So how are we going to do that? Do we just go up here and assign it a value here? Actually, no. You see, if I assign this to 0 and compile, I still get an error. And it says non-const static data member must be initialized out of line. What it means out of line, it's not saying like when you get out of line at the store and you call someone a mean name. It's not what it's saying. It's saying like you can't define it in line. When you define it in line, you just put the equals and put the value right there, sort of like we did with status. You can't do that with the static members. So here's what we're going to do. Actually, outside of the class, we can just minimize these curly braces. We're going to create that same variable. So we're going to say int, and we're going to say user, so we have to prefix it with what class it's coming from, and then say user count, and assign it the value of 0. Alright, so that's a little weird, I'm not gonna lie. Why exactly is it that inside of the class we can assign values to this stuff, but when it comes to static stuff, we can't? And I'm going to try to explain that in the best possible way. Probably end up slaughtering the explanation, so I apologize, but I'll see what I can do. So here is why you have to assign the values outside of the class. When you create a class, you're basically defining the structure of these objects you're going to create when you instantiate this class. So whenever you do that, you have to allocate some memory for values. So for example, this here is going to get some memory. All of the data members are going to get memory. That happens when you create a new user. Now when it comes to static stuff, the class itself does not actually become usable until we define some memory for it. And that does not happen when we create the class structure. It doesn't happen until we create a variable like so. So when we do this, we're allocating a spot of memory for this user count, and now it knows what the value is. So in other words, static members need memory as well, and we determine when that happens by defining the variable somewhere inside of our code. So yeah, that is my understanding of it. Hopefully that's correct. It is a little funky that you have to do that, but just make sure you remember to define the variables outside of the class once you label them as static inside of the class. So how do we actually use this data member? Well, let's go to our main function and get a little bit of practice. Let's minimize this class, and I'll just go down to main. And here's what's going to happen. We're going to create a new user, and what I want to do is I want to output the user count. So to do that, you prefix it with the class and say get user count. So let's compile and run. So we have 1. I'm going to get rid of this destructor text just to make it a little cleaner. So I'm going to go up to the class, scroll down to the destructor, and just have it do user count minus minus right there. So we created a user and we output and we get the value 1. Right there. If we create multiple users, let's just say in the same line here, we could say user 1, user 2, user 3, user 4. Every single time we create a new user, that number is going to go up. In this situation, it's 5, which makes sense. There's 5 users here. And then if we call the destructor, the way you can do that is actually to say user dot, and then use the squiggly, and then say user, like so. Now when you output, we should get the value 4. And indeed, we do get the value 4 the second time around. So that is how we can use a static data member. Nice and simple, very easy to use. It is a little bit confusing getting it all set up and understanding the details of it. But once you got that good, you just gotta make sure you prefix it with user and everything should work just fine. So that is your introduction to static data members. In the next video, we're gonna talk about something new with classes, specifically operators and operator overloading. It's a super huge, cool part of C++ programming and it makes it a lot of fun. So I'm excited, hope you are as well. Please be sure to subscribe and I'll see you in the next video.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be all about operator overloading. This is going to be the concept behind it, and in the upcoming video we're going to go through some examples. So what is operator overloading? Well, if you think of an operator, let's just do a quick 5-second refresher. 5 plus 5. That plus is an example of an operator, and it does stuff with operands. The 5s are examples of operands. Now, this makes sense in the context of integers, but what if we had a custom type? Let's say we defined a point type which contained an x and a y. So basically a coordinate, or coordinates, or would it be a coordinate or a coordinates? I think coordinates because it has an x and a y. Anywho, that's not the point. We defined a point which has an x member and a y member. Now, let's say we created two of them, point A and point B, and we do A plus B. Well, does this make sense? Maybe to us, because we might think, oh, just add the x's together and add the y's together. Or maybe it means something else. Well, that's the thing. With operator overloading, we can define what the plus sign means in the context of our custom types. So it's a really, really powerful way to basically change the way we write code. So rather than always using functions and function calls, we can use operators and make things a lot more easier to understand and cleaner for us. The computer is not going to understand what to do by default, which is why we overload the operators and tell it specifically step by step how to do these operators on these operands. Now when you do this, you define it inside of the class, so inside of the point class. And you can kind of think of an operator sort of like a function. So because this would be defined inside of the point class, you can think of the operand on the left being the point, the home point that we're going to start with, and then you can think of adding B to A. And that's kind of weird, but just trust me here for a minute, it'll make sense in a second. So we're taking B and we're adding it to A, and this is defined within the point class, so we can access the members of A directly. So how do we actually overload an operator? It's very similar to a function. Think of what this is doing. It's taking B as an argument, it's adding it to A, and it's going to return a new point where the x and y's have been added together. So it's going to look like this. We're going to say operator, and then we put what operator we're overloading, the plus sign, and we take one point as an argument. You can call it whatever, we'll just call it pose for position. Such a stupid variable name. And this is going to return a point. So here is the signature for defining an operator overload for the plus operator. Then inside the body, here's what we're going to do. We're going to create a new point, and now all we do is define the x and y and return it. So point.x is going to be assigned the value x plus pose x. Now this can be a little bit confusing because there's a lot of x's here. Point.x refers to the result, what we're trying to get once we add these together. The x here refers to A. Now pose.x is coming in as an argument, which is B. Then we do it again for y, and we say y plus pose.y. And then once we're done, we got that point made, we just return it. And bada boom, bada bang, we just overloaded this operator. Pretty awesome, I know. And I can't spell, I'm pretty sure there's supposed to be an E there. I don't know. So in summary, when you use operators, you can just think of them as a different way of writing functions. In the next video, we're gonna get hands-on with some operator overloading. I'm pretty stoked, you'll definitely wanna check that out. And yeah, Let's do it. All right, subscribe and I'll see you in the next video. Peace.
Hey, what's going on everybody? This video we're going to go through some hands-on examples with operator overloading. Now if you've been watching along, I'm starting in a brand new fresh file. So make sure you are in the folder that you are working on. In this case, I'm working in a file positioning.cpp and you should be able to compile. I'm just saying that just because I have this bad habit of switching folders and then I end up compiling the previous files or I'm in the wrong position and nothing's working right. So make sure you're in the right spot. So here's what we're gonna do really quickly. We're going to create a class for a position. So basically XY coordinates. These are going to be public and we're going to say int x equals 10 and int y equals 20. I'm hesitant to say equals because this is the assignment operator, but you guys get what I'm saying. So these are the default values. If you do not override them, they will have the value 10 and 20. So then inside a main, we can create two positions. So we'll say position pose 1 and pose 2. And let's say we want to create a third position. So we'll just say position pose 3. And what we want to do is we want to assign it pose 1 plus pose 2. Now, if we were using integers, this would make sense because you could say int x equals a plus b, for example. And let's assume this is 5 and 5, then this would have the value 10. But it doesn't make sense in this context because the compiler doesn't know how to add two positions. So when we compile, we should get an error. And you can see it says invalid operands to binary expression, and also that I forgot a stinking semicolon after my class. Oh, it gets me every time. We all have our flaws. That is like my Achilles heel, but you know, I'm working on it, guys. So what we need to do is we need to overload this operator to basically teach the compiler how to add two positions. So how's that gonna look? Well, inside of the class, all we need to do is we need to say position, operator, and what operator are we overloading? Plus, and then inside here, it's going to take the right position. So this is going to be what's passed in as an argument. So we need to say position pose or whatever you want to call it. It doesn't matter. All right. So basically what's going on here is that this is defined within the position class. So inside the instance pose 1, this method's going to be called operator plus, and pose 2 is going to be passed in as an argument to this parameter here. When it's done, it's going to return a value, and that's going to be assigned to pose 3. So that's why we're returning a position. So a lot going on here, but let's just type it out and hopefully it makes sense. So what we're going to do is we're going to start defining this position here. So we can just create a new position and we'll just call it new pose. And we can start assigning it values. We can say new pose.x and assign it the value x plus pose.x. So this x here is going to refer to this instance's x, and then this one here is going to refer to the parameter here, which is going to be position 2. And I'm going to clear this error, it's driving me crazy. All right, there we go. Now we're going to do that again for y, so we'll say new pose.y equals y plus pose.y. And then all we have to do is say return new pose. All right, so let's compile now, see if we got any errors. And it looks like we need to compile with C++11, which is my second biggest weakness, so make sure I always remember to do that, guys. So we're going to say standard equals C++11. Oh my golly, my typing. C++11. All right, there we go. Cool. So let's just make sure it worked. Let's do an output. We will output position3.x, a space, and then position3.y, and then we'll just do a new line. Compile and run, and you can see we get 20 and 40. So it seems that it worked because originally we had 10 and 20, and when you add those up, you should get 10 plus 10, which is 20, and 20 plus 20, which is 40. Awesome, so we just taught the compiler how to add positions. Very cool. Now what I want to do is I want to overload the comparison operator. So I want to say if position 1 is equal to position 2, I want it to output they are the same. I also want to output that I really love tacos and pizza. All right, now let's compile. Oh, what? We get another error. Invalid operands to binary expression. So now we have to overload this comparison operator, and we will do that up in the class as well. So now let's see if you can do it. Give the video a pause, type it out, and now that you've done that,
let's do it. So what we're going to do is we're going to say this is going to return a Boolean because it's a comparison. It needs to be true or false. So this is the operator equals equals, and this is going to take a position on the right. Now, when it comes to how to space this out, sometimes you'll see these crunch together, and that's totally fine as well. I don't really care how you guys do it, just be consistent, and yeah, that's basically it. So now inside of here, we can do an if statement. We will say if x is equal to pose.x and y equals pose.y, we will return true. Now, if this does not get hit, then we can just by default return false. You do not have to put it in an else, although you can if you want. That would work exactly the same way, but anytime you're going to get to this line, you already know it's not going to be true. So this is a little bit cleaner in my opinion. All right, now let's compile, see if we got any syntax errors, and we do not. So what I want to do is I want to run this and see if it outputs this here. And indeed, it does say they are the same. Now, if we were to change some stuff, let's say position2.x is equal to 30. Well, now let's compile and see what happens. When I run this, you can see I do not get that output. So it seems that our operator overloading has worked, and that's just great. The cool thing about operator overloading is you can define the functionality, right? If you want to just see if they're the same by x and not including y, you can do that. Or any kind of custom functionality, you can define that inside of your operator overloading. These were just the most logical ways of doing these operators for me, but you might have some different way of basically comparing them or adding them up. Now the next thing I want to do is I want to overload the insertion operator, the two less than signs. So I would like to just be able to say, for example, cout, and then we just pass in position 3. And then it just doesn't output the way we expect it to. Now I think I'll do the overload for this one in the user class we were working on earlier, but we got a pretty good foundation with the comparison and the addition operator, so you should be able to pick it up pretty quickly for a more complex example, such as a user. So let's go to that video. Please be sure to subscribe, and let's just go have some fun. All right, I'll see you in the next one. Hey, what's going on everybody? Welcome back to your C++ tutorial series. In this video, we are going to overload the insertion operator. So basically that will allow us to basically output a user directly. So for example, we've been outputting data members such as method calls or values, but what if I just wanted to output user1? This is a user here. Can we output that and then just get a pretty output in the console? Well, you actually can, and that's what we're going to be talking about in this video. Now, please make sure you watch the previous video. That's going to give you the foundation of operator overloading. That's because this video is going to get a little bit more complicated. Unfortunately, overloading the insertion operator is a little bit more of a step, but we should be able to do it if we work together. So let's just put our brain power together, focus on solving this problem, and I think we'll get through it. So first, let's clean this up just a little bit. Here's what we're going to do. We're going to have one user, and what I want to do is I just want to output this user. So we can say cout user, and then I'll put an end line at the end. So make sure you're in the right folder and then say g++ main.cpp, and I'm going to use the C++11 flag, like so. All right, we got an error, that's great. So if you scroll up for like 10 years, you'll see invalid operands to binary expression, the same error we got in the previous video. So how do we go about overloading this? Well, it's a little bit different because in the previous video, we were doing the plus operator and the comparison operator. And if you remember, it looked a little something like this. We had pose1, and then we would compare that to pose2. And you can see that on both sides of the operator, we had entities of the same type. These were both positions. But now it's a little bit different because in this scenario, we have cout on one end, and we have a user on the other end. So they're not of the same type. So we're not going to end up defining this the same way, and at first we're not even going to define it inside of the user class. We're just going to define it right here. So this might look a little bit funky to begin with, but follow along with the syntax and I'll try to explain myself. So this is going to return an ofstream, and the reason it's going to return an ofstream is because cout is an object of type ofstream. And once we are done with this, we want to return cout so that we can append more stuff to the expression. So if we didn't return ofstream, then we wouldn't be able to connect things using multiple operators here. So make sure you return ofstream, and we actually want to return a reference to the same object so we don't make copies of it every time. And we can do that by putting the ampersand there. All right, I am correct. It is ampersand. All right, back to what we were doing. Now the operator we are going to overload is the two less than signs, also often known as the insertion operator. And this is actually going to have two parameters inside of the parentheses. The first one is going to be cout, the one on the left, and then the second one is going to be the user object, the one on the right. So we're going to have another ostream here, and we're going to take it by reference, and we're going to call it output, and then we're going to have that user object here. All right, so that is how we overload this operator. Now right away, if you want this to just compile, just to see if your syntax is right, you can just say return output. It's not going to work, but it will at least compile. And we still have that code down here that we don't want, so let me get rid of that. All right, now let's compile. All right, so no errors. It seems our syntax is correct, and we've effectively overrid this operator. Just out of curiosity, let's output and see what happens. It does nothing. All right, that's not surprising. And let's just make sure that this user has some data. We'll say user first name is equal to Caleb, and user last name is equal to Curry. We'll also set the status to gold. Obviously, I'm going to be a gold member. I'm premium. All right, so what are we going to do in this operator? Well, we just treat output as if we are working with cout directly, and then we can just define what we want it to look like. So up here, we'll just say output, and then we'll just output user.firstname. We could also put a new line and do the last name as well, if you would like. User.lastname. There we go. So that is the output. Let's compile and see if it works. Whoops, I'm treating this function call as if it's a value member, but it's not. So this is actually a function call, so I need to pass in gold as an argument. Sorry, it's an error unrelated to our problem here. All right, now when we compile and run, you can see we get first name Caleb, last name Curry. So we've effectively overridden this operator, the insertion operator. Now at the end, we return output so we can continue the insertion and we can put the end line there. Usually I'll leave that up to the caller to do because we might not want to put that end line, so I'll try not to do that inside of the operator overloading. Now you want to make sure you spell things right. There you go. Now user is not going to be changed, so in these situations of operator overloading where there's no changing, you can always label things as const. That's up to you. All right, and you can see it still compiles. Now let's do the same thing with the extraction operator, which is this same thing just pointing in the other direction. So what if we want to take user input and store it in a user object? I'm going to challenge you to try to figure that one out, or at least figure out what the method signature will look like. So pause the video and do that now. All right, let's code it ourselves. First thing, let's go about what it would look like using it. We'll say standard cin, and we're going to insert that into user. So this is what we want to be able to do. Now let's overload the operator. What we're going to do is we're going to say standard ifstream, which is the object type of the cin object. That's going to be a reference. And what operator are we overloading? We're overloading this one, the extraction operator. This is going to take two arguments, an ifstream reference called input. You can name it whatever. And then it's going to take a user object. And then just to begin with, we're just going to return input. And make sure you finish your type there. All right, return input. And all you have to do is use it like it's cin, so we'll just say input and insert that into user.firstname. And then we'll do it again with user.lastname. This will work because this insertion operator, when we're working with a cin object, is going to skip spaces. So basically all we have to do is say Caleb Curry with a space. The first word will go to this one, and the second word will go to this one. So let's compile and give it a go. Here's what we're going to do. I'm going to comment out these assignments here and see if our program compiles. And it does. So let's run it. Now we can put Caleb Curry, and when we press enter, it does not work. Uh-oh. Let's figure out what's going on here. The reason this is not working is because we have to pass the user as a reference. So when we do that, it allows us to change this user object. So hopefully you guys caught that when we were writing this out. I actually quizzed you guys and then I ended up giving you the wrong answer. So I'm being one of those annoying teachers that really don't know what they're doing, but that's fine. Let's try it again and see if it works. Now when we output it, we can put Caleb Curry, and you can see it does output it. So awesome. We just overloaded those operators and it seems to work just fine. Now the downside here is that these operator overloads do not have access to any of the private data of the user. So we can't access like the status, for example. So this video, we just talked about how to get the public stuff. So all of the public parts of the class are accessible, but now in the next video, we're going to teach you how to access the private parts.
Oh, scandalous, I know.
Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video is going to be all about friend functions and operator overloading in the context of friend functions. Specifically because I really want to take this operators here that we've been overloading, and I want them to be able to access private data members of the user class, which is one of the parameters here. So before we jump into all that junk, let's just go through a very simple example of a friend function, because we didn't actually go over the concepts of these in the previous video, so this might be all brand new to you. Well, basically the idea is we can create a function that's defined outside of a class, but it can access the private data members of the class if we grant it access. So here I have this user class, and at the very end of it, what I'm going to do is I'm going to define a friend class. And this is in the public section, so if you scroll up a little bit, you see public right here. All right, so here we're just gonna go through a stupid example, and then we'll apply this to the operators we were working on earlier. So what we can do is we can create a function, we'll just say void, and we'll call it output status, for example. And this is going to be labeled a friend function. Now it's still going to need to take a user as a parameter, so it doesn't have direct access as in these other methods where you can just access the elements of the object like this. We're not going to do that, we're still going to define the user as a parameter. So that's one difference here. And then we're going to put a semicolon, and we're going to put the actual definition outside of the class. So we can go after the static portion here. This was a static value we assigned earlier. And what we're going to do is we're going to say void output status, and this is going to have the user parameter. And then inside of here, we're going to access that status, which is actually a private data member. So if you scroll up to the top, status is in here as private. Now we did create getters and setters for the status, so it would kind of make this friend function kind of useless. But let's just go through the example, pretend we don't have these getters and setters and we're not exposing this private data member. Basically, when we want to create another function that can access private data members, but outside of the class. So what we're going to do is we're just going to output user.status. Now typically this would not work because it's private, but in this situation it should compile and allow us to execute this. So it does compile, awesome. So let's go to the main function, and I'm going to clear this up. And what we're going to do is we're going to create a user. Now realize when we say user.status, this is not allowed. That's because it's a private data member, just to be really super clear. So let me output this and see if it works. It won't, just as a heads up. So when we compile, you can see we get an error. It says implicitly declared private here. So we cannot access it directly. And also note that the function we created, output status, it's not a member function either. So if we call this is not going to work. So it says no member named output status. So output status is not defined inside of the user object. It's a standalone function. So because output status is not a member of the user object, we just call it directly. So for example, we could just say output status and pass in that user, like so. And it's a void function, we don't have to put it inside of outputs. So we'll comment that out and we'll run and see that when we execute this, we get gold. So that is your introduction to friend functions. The primary benefit is it allows us to create functions that work with users, but it doesn't pollute the list of public functions. There are plenty of arguments for and against friend functions. That's not really the point of this video. I'm just showing you how to use them, and you can decide whether they're good or bad and do your extra research. Now what I want to do is I want to use this concept for these operators, because I want these operators to be able to access the private data members of the user. So before we use the friend keyword with these operators, I just want to make it clear that if there's ever a situation where you need to access the private data members of the class, it might be best just to go through a getter and just throw that inside of here, call that function, and it should work just fine. That's because you could say like user.getStatus or user.setStatus, and that would work fine. But there might be a situation when you can't do that and you need to access those private data members directly. So in that situation, here's what we need to do. First, let's copy this whole thing right here and go inside of the class. I'm going to get rid of this output status. We're not going to need that anymore, so let's just clear that off and just give us some mental space. I'm also going to get rid of this function we created a while ago. Now what I want you to do is I want you to paste that inside of the class and prefix it with the friend keyword and then put a semicolon. Now inside of main, we need to clean this up because we have this output status we were using. Let's get rid of that as well. So now when we compile, we get no errors. So we created this as a friend. Now inside of the definition, we should be able to output the status. So I'm going to output a new line and then say status and then output user.status like so. And when we compile, we get no errors. So let's give it a try inside of main. We have this user here and let's give it some data. So we assign it the first name, last name, and set the status to gold. Now we first overloaded the insertion operator for output. So what we can do inside of main is just say standard cout and output the entire user like so. Compile and run, and voila, look at that. It says Caleb Curry status is gold. So we just created a friend function operator overload so that we can access the private data members. We can do the same thing for this overload here as well. So I'm going to copy this here, and right after this friend function, we're just going to create another one like so. And make sure you end it with a semicolon. And now we should be able to get that from the input, so we'll store the next thing into user.status. So we should be able to clean up our main code by getting rid of this and just saying standard cin and inserting that into the user. So now let's compile and run and see if it works. So we can just say Caleb Curry and this person is a gold member. And look at that, first name Caleb, last name Curry, status gold. So that is the conclusion of friend functions and operator overloading. The first thing you might notice is that this is starting to get really messy. And what we're going to be doing in the next video is we're going to be talking about how you can take your classes, separate this content across multiple files. It's very similar in nature to how we did it when we talked about function libraries, but it's going to just have a little bit more information in the context of classes. So this is an important video to check out because as you start scaling your application, doing it all inside of one file is just not very practical. So check that video out and please be sure to subscribe and I'll see you there. Hey, what's going on everybody? Welcome back to your C++ tutorial series. This video, we are going to take our giant, huge, I think 69 line program and split it across multiple files. Now it's not a huge important thing to do right now, but as we start growing our application and adding more classes, it's going to become pretty unbearable if everything is in just one giant file. So we need to split this across multiple files to make sure we can scale our application. It is quite the process and I'll do my best to make it nice and simple and hopefully we get to the end result. Alright, so the very first thing you should do is make sure you're organized. So be inside of a folder. If you're mixed with a bunch of other projects, it's going to get really disgusting really fast. So make sure we are in a folder and all you have is main.cpp or whatever your application is called. Then what you want to do is you want to create a new file for this class here. So we can call it user.cpp. And then we're going to create another one and it's going to be called user.h. User.h is the header file that's going to contain all of the declarations. User.cpp will contain all of the definitions. So what we're going to do is inside of main, we're going to take all of this except the main function. So leave main inside of this file here. And we're going to cut it. And we're going to paste it inside of user.cpp. So we're basically going to offload all the function definitions to the user.cpp file. Now inside of main, I'm going to re-include those files. So we're going to say include iostream and include string. Now as you build more complex applications, you'll need to be more particular about what you're including, particularly if you're working with a large team. But for this small project, it's not a huge concern, so if you include something more than once, or include more than you really need, it's not the end of the world. It's better to have those includes than to have a bunch of errors trying to get everything to work. So the next step is inside of user.cpp, here's what we're gonna do. We're going to take that class, so at the top we have this user class, and we're going to copy it. Don't cut it, leave it inside of user.cpp. And we're going to go over to user.h and we're going to paste it in here. Now what we're going to do is we're going to get rid of any function bodies and replace them with semicolons. So this is just saying that these functions exist, we're not actually defining them here. So when you're done, it should look a little something like this. Beautiful. Now I'm going to minimize this just to give us a little bit extra space, maybe that'll help it to be a little bit more readable. So that is our class here. Now what we're going to do is we're going to include this header file from all of our C++ files that need it. So inside of main.cpp, we're just going to say include user.h, and we're going to put the same line inside of user.cpp. Now to protect us from including this twice, we can actually put some protection here using preprocessor directive. Just say if and def for if not defined. What are we going to define? We're going to define user_h. So if it's not defined, what we're going to do is say define user_h, and then at the end we're just going to say and if. So if this is all completely new to you, I did have an earlier video on multiple file compilation. You might want to check that out because that's going to give you a lot of the context for this. So that's basically going to prevent including this file multiple times. Now we are going to go back to the user.cpp file, which is going to have all of our function definitions, and we are going to change some of the stuff that is in here. So first, let's open this class. First thing, we're going to get rid of the actual class keywords and the curly brace, so go up there at the top and remove it, as well as down here. We're also going to get rid of any data members, so we don't need these here. We just need to keep the functions, so get rid of anything that's just a variable. We don't need this public keyword either, so get rid of that. Basically, we're just going to define each of the functions in this file. Now we also don't need this static keyword, so get rid of that. Anything that's static, you can get rid of that static keyword, which to me is a little bit confusing, but just do it anyways, as well as friend. And then last thing is we're going to prefix each one of these functions with user. So up here we can say user with a capital U, because that's the class name, colon, colon. Oh, this is quite the process. Yes, even the constructors and the destructors we are going to prefix with user. Alright, now let's compile. There's a 99.99% chance I missed something, so let's just see. We'll say g++ main.cpp and user.cpp. And make sure you use C++11. Wow, it actually compiled. So let's run it, see if it works. And what is actually going to happen, it's going to ask us for an input for the user, and then it's going to output that user. So we'll just run this and say, our name is Caleb Curry, and we are a silver member, and it outputs it. So it appears as if everything works the original way we had it, but now look how clean our file is. There's no pollution, and we can just kind of ignore user.cpp and user.h, just consider those as resources we just pull into our application by saying include user.h. So it's a nice simple way to keep your files organized, and it's going to make you be able to scale your application much more. Now going from a single file and splitting it up is a very complicated process. If you start from scratch with a new class, it might be a little bit more organized and clean. So basically what you need to do is you need to create an implementation file, which is the class.cpp, and then the header file, which is the class.h. Inside of the header file is where you create the class as well as all of the members, but you don't actually define them, you just declare that they exist. Data members, specifically these variables here, will go inside of the header file. All of the function definitions, the bodies of the functions, are going to go in the implementation file, which is the user.cpp in this situation. Each one is going to be prefixed by the class name so it can associate it with the declarations from the header file. That is how it works when we remove keywords like friend and static. It still works the same way because it basically makes an association to this function here. Any related functions that are not necessarily part of the user class, those can still go in the implementation file. So you could, if you wanted, define some extra functions down here, similar to how we did with these operator overloads. But those were, in fact, friend functions, so it would be appropriate to put them in this file. But feel free to add other functions that might be related to the user in this file if you want. But if that's too confusing for you, then you can definitely make a user function collection and store that inside of another file. So the next appropriate step for multiple file compilation would be to make a Makefile. We talked about Makefiles earlier on in the series. If you want to know the details of that, I would challenge you to try to make a Makefile for this application just to get a little bit more practice. That's all I got for you guys in this video. In the next video, we're going to talk about inheritance and polymorphism, which is a huge part of object-oriented programming, and I am pretty excited, so be sure to go check that video out. Be sure to subscribe as well, and I'll see you in the next video.
What's going on, everybody? This video, we're going to be talking about the other two pieces of object-oriented programming. We talked about encapsulation, now we're going to talk about inheritance and polymorphism.
and it's going to be awesome, so I'm hoping you guys are excited. Now again, my goal here is to keep it simple, so this video is not going to go into intricate details and into the weeds. My goal is to help you understand what these concepts are and how they work inside of C++. So yeah, let's just get started. So first, the concept of inheritance. With inheritance, you can basically make one class inherit the members of another class. So you kind of have like a parent-child relationship here. So the purpose of this is you might have an overarching class that describes the basics, and then you might have some specific children classes that are slightly different. So for example, we might have a user class, and this might have first name, last name, status, email, or whatever we want to contain about a particular user. And then we might have what are known as subclasses that inherit from this user class. Let's say we're making an application for teachers and students. You might have a teacher class, and you might have a student class. Now, if you think about it, teachers and students have a lot in common. They both got names, they're both humans, and so forth. So why have duplicate content in both of these classes? If you need to describe teachers and students separately in separate classes, but the majority of the content of the class is shared amongst them, you can put it in what's known as the base class. So here is the base, and here are the subclasses, or more appropriately, derived classes. So this is a pretty good example, but you might also have animal and then dog and cat, because those have a lot in common. But they're probably distinct enough that it would be appropriate to have their own classes. Depends on the application. You might also have media file, and then video file, photo file, and then maybe a text graphic file, like when you type on like a video editor or whatever. The actual entities that we're describing is less important, and the concept behind it is what is more important. Basically, the teacher is going to get all of the stuff that's in the user, and the student is going to get all the stuff from the user as well. So when you define the teacher, it's going to look like this. You're going to say class teacher, and you're going to put a colon, and then say public user. So that is how you establish that connection. You're going to inherit the stuff from user. Now the public there, you don't really need to worry about that, but you can put different access modifiers there if you want to basically change the way the members are inherited, change the access of the members. I'm going to keep them all at default, so to do that, we're going to put public. So even if this class is empty, we could still create a teacher and call things on this teacher. So we could say teacher.firstname. That's because this first name is probably defined in this user class. You can do the same thing for student, get the first name from the user. Now, why would you do this? Why not just make them both users? Well, probably because there's some distinguishing factor between teachers and students. For example, inside of the teacher's class, you can have a collection of classes teaching. Inside of the student class, you could have a data member such as the student's major, if this was a college. You can distinguish these entities, but share a lot of common things by deriving from a base class. So that is the concept of inheritance. Now, polymorphism is hand in hand, very similar in nature because it kind of comes from inheritance. The idea behind polymorphism, you can treat a teacher as a teacher, or you can treat the teacher as a user, because the teacher is both a teacher and a user. It's kind of confusing in nature, and when I say it out loud, I kind of sound like a psychopath. That's because a teacher qualifies as a user, and a student qualifies as a user as well. Now, this seems like such a simple observation, but it's really useful because we can actually talk to all the derived classes as if they are users, and they will do the appropriate thing. So for example, we could say, users, get to work. And what's going to happen is the teachers are going to go teach stuff, and the students are going to start studying. Now, C++ has something known as multiple inheritance, meaning a class can derive from multiple classes. This is not something you can do in like C#, for example. C# has the concept of interfaces, which is another common object-oriented programming technique. But don't worry about all those differences. The main thing you need to understand is the concepts of inheritance and polymorphism. Once you got that down, you can go learn about the different techniques for implementing object-oriented programming in the different programming languages. Because this is just like the basics, we're not going to get into that. We're just going to inherit from one class. And maybe if you guys are good, I'll do a special video on multiple inheritance later on.
So that's all I got for you guys to understand the concepts of inheritance and polymorphism. Hopefully that was helpful. And now let's go do some practice exercises. All right, peace out and be sure to subscribe.
Hey, what's up everybody? Welcome back to your C++ tutorial series. This video, we are going to go through some examples of inheritance. So we're going to create a base class and then a derived class or subclass. So to start off, we have this user class over here, and it looks a little something like this. But the thing about a user is it's very general. We might want some more specifics too. Let's say we're creating an application for teachers and students. You might have a class for teachers, and you might have a separate class for students. A lot of stuff is going to be the same between these two classes, so you might derive from user and put the common stuff such as first name and last name, and then anything that's differentiating such as classes being taught, well, that's going to be specific to a teacher. And then maybe hours of studying, that's going to be specific to a student. So teachers teach, students study. They're different, but they both have things in common, so they should both inherit from user. So the first thing we're going to do is we're going to create separate files for teachers. So we're going to go with the Multifile Compilation route. So what we need to do is we need to create a new file, call it teacher.h, and then a new file, teacher.cpp for the implementation. And I'm going to get rid of the user stuff. We're not going to need that for right now. So just to clear it up, we're just going to have teacher.h, teacher.cpp, and main.cpp. Now inside of teacher.h, we're going to create the class. So what we're going to do is we're just going to say class teacher, and this is going to inherit from user. And you prefix it with public to say you want to inherit all of the members just as they are. Now after the class, you're going to put a semicolon. Oh, I got you. I always forget that, but I got it this time. Now inside of here, we're going to have some public members. Specifically, let's create a vector of classes being taught. So the vector will probably just be of type string, and we'll just call it classes teaching, like so. And we'll also create a method. So let's create a method. It's going to be real simple. You could go into operator overloading and all that stuff, but let's just keep it real simple for us. We'll call it output. So this will just output some information about the teacher. Now here's one area of confusion I've done research on it, but I haven't really figured out a solid answer. So maybe if you guys have a layer of expertise in this, you could help me out. Sometimes it's not really clear where you need to include particular header files. So for example, I can go up here and include header files, but I could also do stuff inside of CPP. Should I do it in the header file, the CPP file, or both? So that's pretty confusing for me. Let me know what you guys think if you have any struggles with that, or if you know a good way to know where files need to be included. But for me, I basically just go with the fact that if it's compiling, it should be pretty good to go. It's probably a terrible way to do it, but what we're going to do is we're going to include vector here, and when we compile, we want to make sure we compile with C++11. We'll also include string, just because we're using strings as well. All right, so that is the header file, but as you know with header files, you want to put the preprocessor directives to basically prevent us from including this content more than once. So that's going to look like this. If not defined, if in def, give it a name, we'll say teacher_h. Then what we're going to do is we're going to define teacher_h. And then at the end, all we have to do is say and if. So that's just another layer of protection for us. Now we're going to include teacher.h inside of teacher.cpp and main.cpp. So inside of here, we're going to say include teacher.h, as well as inside of main, we'll say include teacher.h. Now one other thing inside of the header, because we're inheriting from user, we're going to want to include user.h, like so. So this is the header file. Now we actually want to do the implementation. So inside of teacher.cpp, we can reference that method by prefixing it with teacher. So we can say teacher and then say output. And this is going to be a void return type. You gotta make sure you remember to do that as well. All we're going to output is, we'll just put output for now, nothing crazy. We can always go back and add more, but let's just keep it simple for right now. Now inside of main, let's go through an example of using a teacher. At the end of main, we'll just say teacher, give it a name of teacher lowercase, and then we'll just say teacher.output. All right, now let's compile. To do that, we're gonna say g++ main.cpp. We'll also need user.cpp because we're using that inside of this main. And then we'll also need teacher.cpp. And of course, don't you dare forget C++11. All right, we got one error. Let's take a look. That's in teacher.cpp. I think we just need to include iostream. So up here, we'll just say include iostream, and now we'll compile. So to touch again on the include files, let me show you guys an example. You can take this include file and you can cut it and put it inside of teacher.h, which works because it's going to be included right here. So when we compile here, it should still work. And indeed it does. So my question to you guys is, should we include iostream inside of the header file, or should we include it inside of the implementation file? That is the question. I'm not entirely sure. Either way, I don't think it's going to make a huge difference. I'll leave them in the header file for right now. All right, now let's run the application and see if it works. So we run it, and this is going to ask us for a user. So let me just put some stuff in here. So that is for the user, and then it goes and outputs output from the teacher. And you can see it says output right there. So it seems that teacher is working fine, but the cool thing here is that teacher should still have a name and everything like that. So we could say teacher.firstname and assign it the value of teach, and we should be able to output that. And when we compile and run, you can see it outputs teach. So we inherited first name as well as some of the other data members from the user class. Now there is one more thing I wanted to show you guys before you go, and that is the chain of calling when it comes to constructors. So let me just explain what I mean. Here's what we're going to do. We're going to go into the teacher.h file, and we're going to create the default constructor. So that's just going to look like teacher. It's going to have the same exact name as the class itself. And then inside of the implementation file, all we got to do is say teacher : teacher, and that'll be the method. And we can give it a body. Let's just do an output and just say teacher created, like so. And then I want to do the same thing inside of the user, which if you remember, teacher inherits from user. So let's go into our files and open user.cpp, and there should be a constructor right here. All we're going to do is we're going to say standard.cout user created. All right, that's all we should need for those. Let's go back to main.cpp. And let's just clean some of this code up. Let's get rid of this. And let's just, all we want to do is create a teacher. And now let's compile and run. When we run this, you can see it says user created and then teacher created. So it calls the constructor of the user and then it calls the constructor of the teacher. So basically what's going on, when you create a teacher, it first creates a user and then it creates a teacher. So teacher is in fact also a user. And that's going to come up inside the next video where we're going to talk about polymorphism. But basically what you need to know is that there is a base object created and then a subclass object created as well. And that teacher is also considered a user. All right, that's all I got for you guys in this video. Hopefully it wasn't too crazy. And I'll see you in the next video where we're going to talk about polymorphism and get some hands-on practice with that. So check it out. It should be pretty fun. I'll see you then. Hey guys, what is going on? In this video, we are going to be talking about polymorphism inside of C++. We're going to scratch the surface. This is a pretty complex topic and it can get pretty intense. But what we're going to do is we're basically going to teach you how to create teachers, but use them as if they're users, but they will do the teacher stuff. So that probably makes absolutely no sense without the context of basically going through an example. All right, so first thing, you might want to check out the previous video because there I talk about inheritance and how a teacher inherits from a user. But a teacher is also considered a user. Kind of think of it as like, you know, if you had a class for an animal and a class for a dog. Well, a dog is also an animal. That is how the inheritance hierarchy works. So compared to that video, I did a little bit of cleanup. So the teacher header just looks like this. All we have is this class is teaching and this function output. And then if you want to see the actual output for that, all you have to do is go to the CPP file and see it says that I am a teacher. Now inside of main, we create this teacher. And what we can do is we can make a reference to this teacher in a similar nature to how we can have reference parameters. So those variables are just references to the arguments we pass in. So we can do a similar thing here, but we can make it of type user. So it might look something like user. We can name it whatever we want. We can just call it U. And we'll assign that the value teacher. So this is making a reference to a user, but the thing is, teacher is actually of type teacher. But because a teacher inherits from user, if you look at the class, you can see teacher inherits from user, this should work. So when we compile, we shouldn't get any complaining. So let's just give it a try. And I think I accidentally removed include teacher here. So teacher.h. All right, now let's give this compilation a try. Awesome. So the thing is now u is of type user, but it's going to act as a teacher. So when would this actually come up? Well, what we could do is say u.output. And if you look at the teacher class, this is one of the methods inside of the teacher class. So let's compile and see what happens. All right, so we're getting an error, no member named output in user. So it's not quite working, and that's because u is still technically a user, so we need to create this function inside of that user object. So if we go over to user.h, what we're gonna do is we're just going to say void output. So that's that function, but we're going to add a special word before it, virtual. And that means we can basically override it in the subclasses. Now we're also going to create the function for if you're just working with a user. So inside of user.cpp, we're going to go in here and say user : output. And this is a void function, and what is it gonna do? It's just going to say, I am a user. Okay, so now let's go back to main and compile. And you can see that it works, and when we run, we get I am a teacher. Wow, that's pretty cool. U is of type user, but it's printing I am a teacher. Now, if we went to the user.h file and changed virtual to not virtual and compiled and ran, what's going to happen now is it says I am a user. So that virtual is an essential keyword to enabling us to do polymorphism. Basically, it enables us to override that function in the child. So make sure you put that virtual keyword in there and don't forget about that. The cool thing here is that you can create other subclasses of user, and they will always do the child version of the method call. So in other words, we can create a bunch of subclasses that all inherit from user. We can treat them as users, but they will do the subclass versions of the methods. So to go through another example of this, I created another file, and this is a student, and this is what it looks like. Very similar to the teacher. In fact, it's almost identical. It inherits from user and has a function output. The only difference is I did get rid of classes teaching because that doesn't really make sense in the context of a student. If you want to see the implementation, well, student.cpp, all it says is I am a student. So if you wanted to see this in action inside a main, all we'd have to do is say include, and we could say student.h. Now we can make a student as well. And we can treat it as a user. So what we're going to do is we're going to make a reference. We'll just call this u1 and u2. And we'll make this one assign the teacher and the second one assign the student. Now what we're going to do is we're going to say u1.output and we're going to say u2.output. So these are both users, but when we run this, make sure when you compile you include the student.cpp. Now when we run this, look what happens. The first one says I am a teacher and the second one says I am a student. But because these are user objects, you can treat them as user objects. So for example, we could create a function and we could just say void do something, and this can take a user. And then what we can do in here is say user.output, and it's going to output basically the same exact thing, but you can understand the concept of passing a teacher and a student to a function that requires a user. So then instead of saying u1.output, what we can say is do something and pass in u1 and do something and pass in u2. Now when we run this, it's going to say I am a user, I am a user. So what is going on here? Well, we actually need to pass this as a reference in order for this to work, so that way it points to exactly the same objects, which are typed as teacher and student. So now when we run it, it says I am a teacher, I am a student. Alright, so that is the basics of polymorphism. I hope that was helpful for you guys. The main concept is that you can change the type of something depending on how you look at it, whether you look at it as a teacher or you look at it as a user. So thank you guys for watching. That kind of concludes our section on object-oriented programming. I know there's much more to cover,
but maybe we'll save that for a part 2 of this series. We'll see. Thank you guys for watching. Please be sure to subscribe if you've enjoyed this content. It would really mean the world to me, and I'm super grateful. Alright, I'll see you in the next video, guys.
Hey, what's going on, everybody? Welcome back to this very special video inside of the C++ series. This is where we are concluding everything we've talked about to this point. Now, we did not cover everything, obviously, so what I'm going to do is I'm going to direct you on the next steps to study. And if you guys are good, I'll even consider doing a second section of this series if you guys would like to see videos 101 to 200 or like 101 to like 1,000 or something. Alright, let's think small. Anywho, the first 100 videos have been good and we went through a lot of information. I know it can be very overwhelming, and C++ is probably one of the more challenging programming languages. That being said, there are a lot of perks to studying C++ because I feel like you learn computer science and just the theory behind everything at a much more intimate level because of the challenge behind C++. So the fact that you went through all these videos and have understood the material, now if you ever go to other programming languages, I would say you probably have a pretty good understanding of how things work and basically the roots of it all, which is how things originated inside of C++. Now, what other topics would I consider studying if this was the end video or if we go into section 2? Well, the first thing is I would learn object-oriented programming at a much more intimate level. We scratched the surface, but we didn't really talk about multiple inheritance, and we didn't talk about a bunch of the gotchas with object-oriented programming or the design principles of object-oriented programming. There's a lot when it comes to object-oriented programming, and you could probably spend half a series just talking about that alone. But I'll try not to do that to you guys, but I would encourage you guys to study that a lot more. So make sure you have a really good understanding of the keywords such as virtual and how to work with friend functions, and make sure you understand the access modifiers, public, private, and protected, as well as the access modifiers. When you inherit from a class, you can say, oh, teacher inherits from public user. Well, you can change that access modifier as well, which changes how things work. So those are just some basics with object-oriented programming that I would look into. Another big thing I would study is different types of collections. So we talked about arrays, templatized arrays, and vectors, which are kind of like the basic three, but there are a lot of different other collections you should know about, and I'm sure people have built their own custom libraries of special collections optimized for a particular purpose. So go study into those. The next thing I would really study is debugging. We didn't really talk about that at all in the series, and honestly my strategy for debugging in this series is just to do outputs when I can't figure things out. And that's fine, but that's really not a scalable solution, so you need to understand the concepts of debugging, breakpoints, and all of that good stuff. So research debugging inside of C++, and debugging is usually a built-in capability of common IDEs such as C++ Builder. The next thing, I would look into software testing and how to test a C++ application. This will basically ensure that your code does not break as you refactor it or expand upon it, and learn about the different types of testing like regression testing, integration testing, and just unit testing. All those different things. We could get into all of that, but we really just don't have time in this video, so maybe in another day, but please leave a comment section knowing what you guys will be interested in knowing about, and I'll try to see if I can fit it in. Now, another topic that is not as important in C++ as in C, but it still can come up, is the concept of pointers and dynamic memory. We really didn't talk about these a whole lot because in C++ a lot of this stuff is managed for us. We can just use the classes and everything just works. But as you get into some more complicated stuff, you might need to use pointers or some dynamic memory, so that might come up and you might want to study on that. Another topic is templatized classes. We talked about templatized functions and how to do that, but we didn't really talk about templatized classes, which could be useful for you guys if you need to work with some more generic style programming. And I'm sure there's about 50,000 other things that I'm missing because C++ is huge. There are a lot of resources. I'll try to leave some in the description for, like, I have a good book that I'd recommend for C++. Check that out and let me know what you thought of this series, and please consider subscribing for future series, as that would tremendously help out my channel, and it would also put a big giant smile on my face, which I'm sure you guys want. Me and my spouse pretty much did slave labor non-stop getting these 100 videos out for you guys, so the least you can do is subscribe. So yeah, that's all I got for you guys. Thank you so much for watching. It's been real, it's been fun. I'll see you in the next video. Peace out.